Welcome back, everyone. I've got some good news, or maybe some good news. We are done with our CSS content. Listen to those children cheer. They're so happy for us. So yeah, we are done with our core CSS content at least. We'll pick up a couple of things here and there. This section is still CSS related, but it's pretty different. We're going to talk about a library, a third-party tool called Bootstrap. So Bootstrap is CSS that someone else, well, multiple people, have written that we can incorporate into our own code. And the way that we use it is quite different than anything we've done so far. So it is CSS related, but we won't actually be typing any CSS code, or at least it will be minimal new CSS code. So what's important here is really not the Bootstrap stuff, to be honest with you. There are many similar tools to Bootstrap, things like Bulma and Foundation and Semantic UI. Those probably don't mean anything to you at this point, but they accomplish the same goal. So you can swap them in and out. That's not important. What's important is that you understand the role that Bootstrap plays, what these CSS frameworks do and why they can be useful, why some people choose not to use them, basically the pros and cons, and you should be equipped to make that decision at some point. We also will learn how to include third-party CSS. How do we include code that we did not write ourselves? But everything else, all this Bootstrap stuff, it's nice to have, really. But I do want to differentiate a couple of things. So I'm going to put some things in important, but this is stuff that is particular to Bootstrap. And if you get a job and they don't use Bootstrap, well, you're not going to use any of this. Or if you decide to make a project and you don't want to use Bootstrap, you're not going to use any of this. And if you decide to use a competitor like Bulma, you're not going to use any of this. So I don't want you to, enter this section thinking that all of this really matters. What matters is just exposing you to one of these frameworks. And I'm actually going to show you more than one throughout this course. We'll play with Bulma later on. Okay, so what is most important from Bootstrap is really the grid and responsive Bootstrap grid that allows us to make really great responsive layouts easily. So that's really the big advantage, the reason a lot of people like to use a CSS framework. Other things, navbars, people like icons, typography, forms, buttons. I'll say that's nice to have, but these are the big things that people get out of Bootstrap. So remember, don't treat this as some crucial part of the curriculum. The specific Bootstrap content could be swapped out, and it may be swapped out in the future with some other similar tool like Semantic UI, Foundation, Bulma. They all do pretty much the exact same thing. What matters is the thing they do, not the specifics of how they implement it. Anyway, I don't know. I think I'm confusing everyone. I have good news, though. I'm done with this video. I'm going to stop talking. What do you think, kids? Yeah, okay. So let's begin with an intro to Bootstrap. What is it? Why maybe should you care about it? Why might you want to use it? Well, Bootstrap calls itself the world's most popular CSS framework. So we know some of those words. We know all of them except maybe framework we have not talked about. What is a CSS framework? Well, you can think of it sort of like a physical framework for something you're constructing in the real world, whether it's a building or a sculpture, a papier-mâché sculpture where you build something up, and I don't know, this is getting stretched a bit thin here, this whole metaphor, but maybe you've built something like this before. You build the skeleton, or you can actually buy those skeletons. For example, I took a taxidermy course earlier, I guess it was a couple of years ago, and I didn't realize this, but most taxidermy is done using these pre-existing forms you can buy out of foam and different materials, and then you construct everything else on top of it. So here is a bird form for a raven. It doesn't look like much, but you can use this to create all sorts of really interesting things, ranging from very odd choices to somewhat, some people might say, very nice looking or beautiful taxidermy, or revolting, depending on your perspective. The point here, though, is that these tools exist to help speed up the process. You could make something without this. It might just take more time, and it might be a little bit more difficult. Bootstrap does the same thing, but for websites. It helps us quickly create nice-looking, responsive, modern websites. So we don't have to write as much CSS as we might. It provides the framework or the starting point for all sorts of different websites. So to get more specific, it really consists of two main things. It consists of a collection of components, different pieces that we can use and just insert into our app. So a button. there are pretty nice looking buttons that are pre-made. Nav bars, it's probably the most commonly used one. But then there's also this thing called the grid system, which we'll spend a good amount of time on, which helps us lay out our websites. So let me start by showing you some examples of the components. I'm on the website getbootstrap.com. It's their main website. On the left side, we have a whole bunch of different components. So things like buttons, as I mentioned. Here are some of the buttons that you can get very, very easily. You don't have to do anything except include the Bootstrap CSS in your document, and then create a button with a particular class name. So no styles have to be written in order to get these buttons or these buttons. We also have things like nav bars, as I mentioned. That's a really common one. So here are some examples. Nav bars with forms, but more importantly, these nav bars are responsive. So as I resize, you'll see that they collapse, and then we get this hamburger icon, and these responsive nav bars that open, they expand as a drawer. So creating that requires a lot of CSS, a good amount of JavaScript. You have to know what you're doing. It takes time. It's a decent amount of code. But if you use Bootstrap, you can get it for free. There's also forms, nice looking forms and different inputs, things like responsive forms. Let's see if this one is responsive as I resize. There we go. Can you see how everything stacks? So this is all stuff we could do on our own. It's just that it's faster, it's simpler if we use a tool like Bootstrap. That's not to say you should always rely on something like Bootstrap, but it's important that you understand they're out there and feel comfortable using at least one of these tools. So there are many. Bootstrap, things like Foundation, Semantic UI, they all serve the same purpose. They all give you this foundation, this basic set of tools to create websites. So now let's talk about the grid system quickly. One of the most annoying parts of creating modern websites is laying out your content, divvying up space. I mean, if we look at this here, there's actually some content, a small amount of content on the left, a larger piece in the middle, and a smaller part on the right. And we've talked about this with Flexbox, but you can see it. This actually disappears or probably goes below at some point. I'm not sure where it goes. It goes somewhere else though, and this takes up the remaining space. And then as I continue to shrink this down, at some point that all collapses into the nav bar, and the whole layout changes, right? It's all changing as the screen size changes. The grid system is a bunch of CSS that is pre-written for us, where we can rely on these particular classes like row and column, or more detailed ones like, if I keep going down here, column-4 or column-small-4. And these all have to do with the size, the amount of space that we want certain elements to take up at different screen sizes. So I can very easily say, I want this thing to take up more space on a large size and less space on a smaller size, or vice versa. Let's look at these rows right here. Just look at the top one here. Column medium 8, column 6, column medium 4. We're going to decode all of that. But as I resize, hopefully you can see, eventually, there we go. This thing takes up its entire own line. This thing doesn't. It's only going part of the way across. Or if you take a look at these, there are 3 things sharing the space equally. And then as we shrink down, now they each take up half the space going across. So 50%, 50%, 50%. If I go all the way back to a larger size, 33%, 33, or 33.3333, and so on. Okay, so that's really the point of the grid system, is to help you lay out your websites and have them have pieces take up space and redistribute that space depending on screen sizes. So we're going to spend more time with this. The last thing I want to mention that always comes up, people ask, aren't our websites all going to look the same if we're all using Bootstrap? And the answer is absolutely they could, but also they don't have to. This is just a quick preview of certain sites that use Bootstrap according to Bootstrap's documentation. So I didn't actually verify that they still use Bootstrap, but all of these at some point have used Bootstrap. Gosh, this website's a real headache. I do love that game, but oof. So some nice looking sites, right? And they all look different. They might all, have a nav bar, and they might all have buttons, but things can be customized with Bootstrap. You can change the colors of the buttons. You can change how they look entirely. You don't have to use the buttons. You could just use the grid system. You can change how the nav bars work, but they all, whoops, I'm trying to resize that. They all are fundamentally sort of doing the same thing. They're using Bootstrap to divide up space or to allocate. I want this thing to be, I don't know, 50% of the screen width or 20%, and then go all the way across on a small screen size. So you can see here, they all go all the way across sort of in a column layout, and then they share the space here. So we can do that with Flexbox, but Bootstrap is going to make it a little bit easier, a little faster for us to do that. Here's a few more examples, and one more. Very different content, very different designs, subject matter, colors, fonts, everything's different. But these all at some point have used Bootstrap to help speed up the development process. So our goal is to spend some time with Bootstrap, right? We're not going to be an expert. I have courses on Bootstrap that are 15 to 20 hours. There's a lot to cover, but fortunately, most of it is very, very easy. So we're going to focus on the essentials so that we can get building nice, responsive, modern websites relatively quickly. Okay. All right. So the first thing we need to do is learn how to include Bootstrap. Just like we would include a style sheet in our own documents, just like we've been doing. Like I have an app.css, right? We include a link to app.css. That's essentially the same thing that we're going to do, but instead of a style sheet I'm writing, it's going to be a style sheet from Bootstrap. Now, there's a little bit more to it because Bootstrap actually does come with some JavaScript too, but the core mechanic, the most important piece, is a single style sheet. So if we go to the documentation here, and you go to, where is it? Getting started, introduction, here we go. There's a couple different options for how we include the Bootstrap style sheets and the JavaScript scripts. One option is to download everything onto our machine and link to it just like we do here. App.css, that exists on my computer, and I'm linking to it using a link tag, and it needs to be in the same folder, or it needs to be, accessible. I need to write the correct path to find that file. The other option, and there's nothing wrong with downloading, by the way, but the easier option to get started right now is to use something called a CDN. CDN stands for, I think it's a content delivery network or distribution network. It's essentially a hosted version of a style sheet that we can access remotely. I don't have to download it on my machine. So if I copy this link right here, you'll see it's a link tag. It has an href, but this time the href is to an actual website. And I can actually go to that URL. And this is a very large style sheet. It's been compressed down, so all the white space and everything is removed. But you can see definitely CSS in there, right? We've got text decoration, border radius, font family, different things that we recognize. It's just a massive chunk of CSS. So I can just link to this URL, and that will download the correct script that I need. So I'm going to copy that entire thing from Bootstrap. A couple things just to note. There are different versions. As of recording, I'm on 4.5. If there's 4.5 point something or 4.6, the differences are not going to be very large. Now, if you're on version 3 point something, that is significantly different. So do worry about that. Okay, so I'm going to copy that. You can also click that button, and I'm going to put this in my document in the head, and I'm going to put it before my custom style sheet, my app.css. That way, I can write my own styles, and they won't be undone or overwritten by Bootstrap, or they have a better chance of not being overwritten. For example, if, Bootstrap makes all H1s 50 pixels, which it doesn't, but if it did, here I might make them 40 pixels, and this will win. Okay, so if we refresh the page, we shouldn't see anything, but if I add some content in here, I'll just do some placeholder stuff, placeholder H1, maybe a paragraph with some lorem, and I guess we'll just start with that. If I refresh, it doesn't look like much, but this is different than our normal default style sheet. So if I comment out the Bootstrap link, I'm just going to delete that for a moment, or comment out both lines, and I refresh, we notice different fonts. Hopefully you saw that. And some of the margin and padding is different. Now that's not all that important. We can change all of this, of course, but this does tell us that Bootstrap is working. Now, the other thing we should mention, there are these scripts from the quick start, these three script tags. We have not really covered scripts at all, but of course we will, that we do need to include if we want access to every part of Bootstrap. So certain components require JavaScript, and we can see them here. If we want an image carousel, if we want the collapsible nav bar, if we want tooltips and popovers, if we want drop-down menus, we're going to need these scripts. So you don't need them for buttons and the grid system and all of that. But just to be comprehensive here, I'm going to put them in there. And again, we haven't talked about scripts, but we just copy these. And I'm going to put these at the very bottom, right before the closing body tag. And we'll learn more about why we do that later. But honestly, it's just copying and pasting at this point. So we shouldn't see anything different. Okay, so that's what we need to do to get set up with Bootstrap. Every time you want to use it, you need that CSS file. Remember, it's just a CSS file written by someone else or by a team, and it's hosted online, but you can download it. Definitely, you can download it. It's just a little bit more annoying when you're starting out. But the advantage, of course, is that you have that on your machine. There's a world where this could go down. This URL might change, or the hosting might just disappear overnight, and it doesn't exist anymore, and our file is gone. So for a real production application, I would definitely download it. Anyway, we now have Bootstrap, I don't want to say installed, but we have it included in this document. So now let's take a look at our first component, our first piece of Bootstrap syntax. We saw that there are some default changes, the default font changes, the size or the margin and padding on certain elements changes, but most of what we do in Bootstrap is enacted through classes. So every component that we see here, let's take a look at, dropdown. If you look at how it works, we're writing a bunch of class equals something. Lots of classes often. And these are all classes that have been predefined in our Bootstrap or in Bootstrap's style sheet. As we saw, there's a lot of classes in there. Just like I can define my own class in here called, button, and then make everything red or, change the font size. And then I can use that in my markup. We're doing the same thing. It's just we didn't write those classes. So the first element that we'll look at, or the first component rather, is under layout. It's a very simple one, but a very important one. It's called a container. So a container, as they say here, is the most basic layout element in Bootstrap, and it's required when you use the grid system. We'll get to the grid system. So what a container does is that they contain and pad content within them. Basically, it's a quick way to get some space and contain your content. Right now, our content goes all the way across the screen, and usually that's not what we want for a website. We might have different pieces of content, right? It doesn't just go all the way across. So the container class, the simplest possible container, gives us a responsive fixed width container. And we'll talk about what that means, but let's just try it now. So class equals container. Now this does not have to be a div, by the way, but the docs do use divs a lot. So I'm going to do that here, dot container tab, or if you don't want to use Emmet, just div with a container class. And then I'm going to close that around all of my content. Not the scripts. I mean, it won't make a huge difference, but they don't need to be in there. And I'm going to refresh. Okay, so what do we see? Well, there's a bunch of margin now around my content. And as I resize, you'll see that that space does change, right? There's breakpoints in here. So it starts to shrink down, and then there's a specific, where are you? Right there, breakpoint, and then there's another one right there, and then there's another one right there. And those breakpoints are predefined. You can see them here actually. As part of Bootstrap, these are very common. So there's different sizes. Extra small, which is anything under 576. We've got small, medium, large, extra large. We'll come back to these when we learn more about the grid system. But another thing I'll show you is container fluid. And container fluid is going to be a full width container, and it will span the entire width of the viewport. So basically all the way across. Unlike what we have here, this container doesn't go all the way across except when we're on small screens, or I guess extra small right there. So I'm going to change this to container-fluid just so you can see this. And now as I resize, I've already refreshed, our container goes all the way across the screen the entire time. There's still some margin, so it's not like there's no container at all. It still makes a difference compared to what we had without the container, but certainly it's not the same as just container. And then the last thing I'll show you is that there are actually these responsive versions, container-small, medium, large, and extra large. And what these will do is allow us to say we want the container to be all the way across the screen, 100% wide, until you hit the small breakpoint or the large or the extra large. So I'll show you that very quickly. Container-, let's do medium. So we start, all the way across the screen, all the way across, and then we're going to hit that breakpoint right there. And now it goes back to acting like the original container, just a plain container. So this is getting a bit in the weeds, but I didn't want to have to make a separate video around containers. They're very simple, and for the most part, we're just going to use container or container fluid. And the default container, as you can see here, is full width on very small screens, and then it adds a bunch of margin on other sizes. So we're going to always work within a container. You don't have to for most of Bootstrap, but for the grid system, you do need to work in a container. All right, so that is the basic idea of setting up Bootstrap. And then probably the most boring component, but an essential one, the container, is just class equals container. Next up, we'll talk about buttons and colors and a whole bunch of other stuff. Okay, so moving on to some more exciting components. Containers are important, but I know they're a bit bland. If we go to the components section, so documentation, components from getbootstrap.com, make sure you're on 4.5 or 4.5 and above. And then on the left side, we have a whole list of different components that we can use. Now remember, almost all of this is done through the class attribute. So if we take a look at any of them, a carousel, for example, we're going to see a lot of class equals something, class equals, and the docs are very, very thorough. They're great documentation. I guess that's grammatically incorrect. They are great documentation, sure. They have great documentation. They've created great documentation. Lots of examples. You can copy the code very easily. You can see the examples. That's one of my pet peeves is certain tools will have code examples, but they won't actually show you the end result, and you have to copy it and paste it yourself to see what you're doing. And then for each page you're on, let's say we're looking at forms, on the right-hand side we have all the subsections of forms. So we're going to begin with buttons. So Bootstrap comes with its own sort of default button, different styles, just like everything else here. We can alter them. We're not going to talk about how we alter them, just at least not yet, but we're just going to use the defaults for now. So buttons. Everything we do for a button involves this class, btn. So we've got btn and then different variations. I'll keep going down. We'll still see btn. Here's how we make a large button. It still has btn as one of the classes. Outline buttons, they still have btn. Okay, so let's just pick one of these to start. Literally just copy it and just make sure it works. So I'm going to copy this over here. I'll just put it under my H1 to begin with and refresh, and there is my button. So very different than just a typical button, right? If I just add a default button like this, refresh, not so attractive. This definitely looks nicer. Now, what's up with button primary and secondary and success? So Bootstrap comes with these different semantic colors, these different labels like primary, secondary, success, danger, warning, info, light, and dark. And these are used all over the place. We'll see alerts in a bit. Alerts have the same set of variants. Primary, alert, success, alert, danger. If you look under utilities, which we'll come back to, we have a set of color utilities so that we can make different background colors, for example, and they all have those same labels, primary, secondary, success. So these colors are not set in stone. You can change them. The point of, having a success is not to have a green color necessarily, or having danger is not supposed to be red or doesn't have to be red. Those are just the default colors that come with Bootstrap. And the point really is semantics or meaning. So it's pretty common for a website to have a primary color, like a brand color, and then some secondary color that goes along with it. And then some color that is used to indicate something is going horribly wrong or a danger versus something being successful versus something being a warning. It's not the same as danger, right? So the default is like a yellowish orange color for warning and a bright red for danger. You can change them all up. As an example, this navbar from Bootstrap, I believe their primary color on the Bootstrap website is purple. So they changed that, and that's something you can do. If I inspect this button, we'll probably see button primary on here somewhere. And yep, there we go. You can see primary right there. So don't get hung up on the specific colors. A lot of people aren't crazy about them. They're just built-in options that we can totally customize. We'll see how to do that. And really, it's just about the meaning behind those terms, those labels. So instead of assuming every website is going to have a red and a green, so there would be a button red and a button green. They instead just go with some primary colors, some warning colors, some success. Okay, I think that's enough around the colors. So let's play around with this. We can make all of these different variants, BTN and then BTN dash one of those semantic colors. So I've got a primary button. Let's just duplicate this and change them to be, how about a success button and a button info. Refresh. Now they all say primary, so I'm going to change that. Success and info here. And I won't do every single option, but we have danger, we have warning, we have light, we have dark, we have secondary. And then we also have a BTN link, which is still a button here, but it doesn't look like a button, it looks like a link. It's just styled to look not like a button. Further down, we have different options. For example, they show that you can use these classes on an anchor tag to make what looks like a button, but it's actually a link. You can do the same thing on an input where type is button or submit or reset. So these aren't technically button elements, but this one is a button element like we've just seen. And then we also have these outline variations, which are nice. So same colors, right? Primary, secondary, success, blah, blah, blah. But the syntax or the actual class name is different. So we still have button, BTN, but then BTN dash outline dash one of those colors. So let's try one. Let's do a warning. So button with the class of button. By the way, this type equals button attribute from the docs is not a huge deal, at least for now. It's just indicating that this is not a submit button or a reset. It's just a button that has no default behavior. Okay, so class equals BTN, and then I'm going to do an outline. So BTN dash outline dash, let's do warning, and then let's do warning outline as the text. Refresh, and there we go. So we get this nice inverse effect when I hover. Let's do one more. We'll do a danger. So BTN outline danger, and then we'll change that text to danger outline. Cool. So one thing I need to make very clear around Bootstrap is that whenever you're using it, unless you're super experienced and you have an amazing mind for memorization, you're going to have to consult the docs. That's just part of it. So don't get hung up trying to, memorize this. Just like I've mentioned with CSS, but especially with Bootstrap in particular, there's just a lot here. You didn't write this, these class names. They might not make perfect sense to you. For example, in the past, I have mixed up the order, if it's BTN-outline or outline-BTN. And, if you apply the wrong class, you're not going to get an error message or anything, right? If I misspell this just slightly, we don't get any of the effects from that class. So sometimes you just have to keep your eye out for that. Copy and paste is totally fine. And then the other thing we can do here is actually change sizes. And these are mix and match. So we can put these in with any of the classes we've already added. So to make a larger button, it's BTN-LG. To make a smaller button, BTN-SM. So let's try one of those. Let's do an outline info. So just take a look at what it looks like. Info, outline, there it is. And I'm going to make it larger. So I'll add BTN-LG. And it's larger. So it's not massive, but it is larger. And let's do one more. This one will be a non-outline. So we'll do BTN, how about secondary? Secondary, just like that. And then we'll do BTN-small, SM. So we'll do small button. Refresh. And there's our small secondary button. So small, large, and just normal, non-sized button. We also can do block level buttons, so you can make your button block without having to actually change the display property yourself. But that's all that it's going to do for you is set display to block. We have active state versus disabled state, so you can make a button disabled by simply adding the disabled attribute, so it has different styles. And this is nice. It will sort of reflect your current color. So if I make the success button disabled, just like that, it gets slightly grayed out or just less saturated. So I'll put that in there on one of them. Let's just do, maybe I'll copy that success button, put it here, success disabled, just so you have this as a reference, and I'll put that attribute in there. So that's all styles just coming from Bootstrap. Once again, it's not even a class there. So that's it for buttons. Remember, these colors can change. It's the meaning behind them that matters. And they're just labels, right? So they're like slots for, different colors that you can fill in at will and make your own palette. Okay, so different variations of buttons. That's our first example of using the sort of Bootstrap mechanic of just a bunch of classes. We see BTN and then some option for color. Is it an outline? Is it small? Is it large? Is it block? And that's it for buttons. So next up, we've got quite a few more components. Next up, we'll talk briefly about typography in Bootstrap. So actually, this is not under components. These are all standalone, components, things like, making a button or making a navbar or a carousel, an image gallery. I'm going to go to Content, Typography, and this is where we'll begin. So this tells us a bit about some of the global changes that have been made, the font that has been changed, the global font size that's been defined, the background color, all the stuff that we see, just the fact that, this font has changed. This is different than our typical font. But if we keep scrolling down, there are a couple things I want to call your attention to. First of all, these display classes. So these display classes, there's only 4 of them, display-1, 2, 3, and 4, are used to make large headers. It says when you need a heading to stand out, consider using a display heading, a larger, slightly more opinionated heading size. Keep in mind they are not responsive by default, but you can change that. Okay, so let's try using one of them. Just class equals display-1, and that makes sense to use on an H1. So instead of saying placeholder, let's do something like display1 on an H1 with the inner text of Bootstrap Playground, maybe. Okay, and then let's add some other ones. So let's do an H2 for our buttons, and that's a normal H2. Or I can do, display 1, 2, 3, or 4. Now these are just different sizes here, so that they don't have to indicate meaning. Like, an H2 should be a subheader of an H1. It should be the second level of headings. But if we're just using a class with display of 2 or 3, let's do 4 though. We don't have to have a display 2 and a display 3 like we would with H1s and different headings. Okay, so we've got different sections. I'm now going to make another one. So I'm just going to do an H2 with a class of display-2. Actually, I want 4 for typography stuff. So there's our buttons. Here's typography. Okay, so aside from what we just saw there, another thing is the lead class. It actually really does not do a lot. They say it makes a paragraph stand out. If you add the class of lead, let's see what happens. So here's our paragraph. I'm going to add class of lead. Watch this right here. I'm going to refresh. I think it just gets a little bit larger, honestly. We can inspect and figure it out. I don't want to waste too much time, but let's see. Yeah, it changes the font size, and it changes the font weight. Okay, that's it. Not a huge deal, but I guess it does stand out. So that's supposed to be for like a tagline, I guess, or the lead text of a page. Other than that, I want to show you block quotes. So block quotes are an element in HTML. We can just make a block quote. So let's do that right here, block quote. Inside of there, we'll do a paragraph. I'm just going to do lorem for my block quote. Okay, so that's what it looks like. But then I can give it a class of block quote. And this is coming from CSS. So this is supposed to be, just in general, if we haven't covered the block quote element or you haven't seen it, it's supposed to represent some quotation, right? That goes on its own line usually. So I'll refresh, and it gets a little bit, I guess, heavier, bolder, and slightly larger maybe. But then what's cool is that we actually have an easy way of adding in a footer, a bit of a source. It just is a class of block quote dash footer. So let's do that right there. They use a footer element for semantics. You could do what they do in the docs. So block quote dash footer. And then let's see, someone famous in blah, blah, blah. Let's just do, let's say this is coming from Mr. Lorem. Is it Ipsum? Yes, it's right there. I don't know why I needed to ask. Okay, so let's see what that does for us. Ooh, check it out. It's grayed out. And it gives us this little dashy hyphen thing, the horizontal line, and we didn't have to do anything, right? We didn't create that. I didn't tell it to be gray. That's just the default styles. Now you might be noticing this here, MB0. We can put that in here. We haven't covered it yet. This is an easy way of adding margin on the bottom, or actually in this case, removing it and setting it to 0. Watch what happens. That margin on the paragraph on the bottom disappears, and now this is right almost touching it. Okay, so not that often that you really need a block quote, but it's cool that we have that option. Next, we have these different utilities, different ways of aligning text. So if I want something to be centered, it's very easy. Just add text-center. If I want it right aligned, text-right. So let's do that on the entire block quote, text-right. Refresh, and there we go. Now I could easily achieve that through my own CSS, right? It's nothing revolutionary. Let's make my H1 right here centered as well. So there it is, text-center. It's just a class that I'm adding on just to make my life easier. But obviously we could do that on our own, just like we could do any of this stuff on our own. We could make something gray. We could set margin bottom to 0. But the idea of Bootstrap is to make it faster and easier for us to get those styles. Next up, I'm going to go to utilities right here. And we're going to spend more time talking about utilities in a little bit, but I'm going to go to colors. So these are all things that, well, they're utilities. They help us quickly center something or change the color or add a border or change its display property or position attribute, or position property rather, or add a shadow. They're not necessarily components. They don't stand alone. We add them onto something. And we're going to start with color. So we have a lot of different classes to change the color of text, text-, and then any of the semantic color names we've seen. So if I want to make something, I don't know, I like the info color, I can do text-info, or primary, I can do text-primary. So I'm going to do that for my H1 right there, text-primary. And refresh, and now we get our primary color there, which happens to be the default blue. We have all the other ones, right? Text, success, danger, warning, info. Hopefully that's self-explanatory. We also have the option to do background colors. So I can use BG- any of them. So BG- primary, BG- secondary, BG- danger. And then often we'll use a light text on top. That's just text- white. So let's make something have a background here. It's not going to be particularly pretty. Why don't we do, what's our block quote going to look like if I give it a background color? Let's see. So I'm going to just give the whole thing a BG. How about light? That's a color. Can you see that there? It might not show up on the screencast very well. It's a very light gray. Let's do something different then. How about BG- info? Oh, hideous. But it is a background color. I guess I'll leave it at that. Nothing's going to look very good with the background color right now, but we easily can add them, and we can mix and match. So I could give something a dark background color and light text, or hopefully not, but I could give something, danger background color and warning text, and I guess it would look like a McDonald's logo, red and yellow. All right, so those are some utilities, color utilities, background color. You can use those to change text and change the background color of anything. And I think I'll stop this video here. So we learned a decent amount around certain text utilities, text alignment. We saw the display classes, block quote, honestly, not a huge deal. And then all the text utilities for color. Next up, surprise, surprise, more components. The first one is very simple. It's a badge component, and it's typically used for displaying a count or some sort of, I guess, what do they call it? A label. And that's kind of all that you use it for. So you can mix and match it in a heading. You can put it in a button. Here's what I mean by a count, right? A number of notifications, number of, updates on your profile or something. And that's kind of all there is to a badge. You can make one that's rounded. All that they are is a span with the class of badge and then a color. Badge secondary gives us all of these. Notice that they scale based on the element that they're inside of. So I could add where should I do it? Right here maybe with our buttons. I'll add a badge right after that. So in our display 4, it's an H2. Span with the class of badge. And then I'll do badge dash, how about success maybe? And then we'll put a number in there maybe like 8. I don't know how that will look. It doesn't look great honestly, but there's our badge. So it's badge and then badge dash success. Or badge dash something else. Maybe we'll do new instead. That might look better. No, it doesn't. It doesn't look great. What's cool though, and where I commonly use badges is in a navbar situation if there's an alert, or in some sort of button, to display number of notifications or updates or changes. So let's do an example of that. Let's do a button here. Maybe we'll do just a primary button with a badge inside. So we'll do button, and what should our text be? Updates, and then we'll do a span with the class of badge, and then badge dash maybe light, badge, there we go. And then let's give our button the class or classes of btn and btn dash primary. Let's see how that looks. Oh, looks like I didn't put any text in my badge, of course. So updates, let's do maybe 9 updates. And there we go. There's our little badge. So we also have the ability to make one of them a pill, or any of them a pill badge. It just gives a border radius on the corners. So let's try badge dash pill on one of them. We could do it just on our big guy up top. Badge dash pill, refresh, and there we go. Okay, so that's all there is to badges. Very simple. Another component we'll take a look at now, it's relatively simple, is the button group component. It will group multiple buttons together into a group. So this is pretty common. You can use this to make nice looking selects where a user picks one option basically in place of a radio button or a group of radio buttons. But for now, we're not worrying about how you make that work. That actually involves some JavaScript. We're simply going to take a look at the syntax. So if you have 3 buttons or 2 buttons or just more than one button, and you group them, and you put that container, or you give that containing element the class of btn-group, it's going to pretty significantly alter things. So let's try an example here. I guess I'll do it under our buttons. Let's do maybe what should we do, an H3? Button groups. And then let's make 3 buttons. So button, btn, and then btn-primary. Should we do primary? Maybe we'll do some warning just to mix up the colors. So I'll just do 1 as our text. It's not very pretty, but there's 1. And then I'll duplicate this. We'll have 2, and we'll have 3. So no group yet. They're all separate buttons. Now I'm going to group them together with that class of btn group. And I'll use a div, just like the docs, surround the 3 of them, btn-group, I'll save, refresh, and now they are a single group. It changes what those buttons look like, right? We don't have margin in between them. The border radius changes. They're not curved on the inside. It's just the outside edges now have that curve. So that's kind of cool. And this could expand as many times as I want. I could change the colors. I could have a danger in there. I don't know if that looks very good, but whatever. So that's button group. There is some important stuff around accessibility that you should be aware of. If you are going to use these buttons in a group to make some sort of fancy radio button or select, instead of just having 3 separate buttons, but if they're somehow associated in a way where you're only supposed to pick one, or these are different options for something, you should give the element, the containing element, role of group. It's just going to indicate to screen readers that this is a group of buttons. What else can you do? You can make toolbars, and there's a couple other examples down here. You can nest them, actually. You can make drop downs. You can change their size. Button group large, button group small. Now, these aren't, something we need to spend a ton of time on, but they're here, and that's just your brief intro. So that's button groups. The final component we'll look at in this video is the alert. So an alert is supposed to provide some sort of feedback to your user. Typically, after some action or when the page loads, this was saved, or this failed to save, or you don't have permission to do that, or welcome back, or logging you out, that sort of thing. It can be used for other purposes, but that's the main goal, is to alert a user to something important, or it doesn't have to be crucial, but alert a user to something, bring their attention to some piece of information. So the way that we do this, very similar to buttons, we need a div or some element with the class of alert, that's the base class, and then the color variant, alert primary, alert secondary, just like buttons. And that's the simplest one. So let's add one in here somewhere. Maybe after button groups, we'll do another H3 alerts. And then right here, we'll do a div with the class of alert, and then alert dash danger. And then inside, we can put text. We can put other elements actually inside of an alert if we wanted to. We could have buttons in here, but I'm just going to put some basic text like danger, you are about to end the world as we know it. Okay, save, refresh, and there is my alert. So that's one option. Of course, we can change these to do, success. And there we go. But what I want to show you here is that actually we can make them dismissible. Also, you can add additional content as they show you here. You can have an alert heading. So maybe we'll do that. Let's put that in right there. Alert-heading is the class. Oh no. Okay, so there's our heading. And this is what I want to show you, dismissing alerts. So we can make an alert that has this X button, and we can make it so that it actually dismisses the alert. Now that involves some JavaScript. Fortunately, we don't have to write any of it, but we do have to do something we have not yet seen. So we'll build this up one piece at a time. All that we need to do to begin with is add in our button. And this button could be anything. Like it could look like anything, but typically we'll use an X. And the X is not the letter X, it's a close icon. And you can just use the letter X, but what a lot of people like to do is use the entity code to make the times symbol, that X there. It's different than the actual letter X. I don't know enough about typography to explain the exact difference, but this is like 90-degree angles. I don't know, whatever. It's the button or the shape that a lot of people like to use. So we can put that inside of a button. So let's make a simple button. Put that span in there. Now you might see this here, ARIA hidden. This is saying that on screen readers, this does not need to be showing up at all because a screen reader does not know what this is. I don't actually know 100% how it handles this, but it probably just reads this out loud, which doesn't make a lot of sense to most people. So we can hide that span, and instead what we can do is add an ARIA-label to our button. This is what the screen reader will read out loud. All of these ARIA prefixed attributes have to do with accessibility and screen readers. So hide this on screen readers, use this as the label, close. And then the most important part, well, first, if I just refresh this, it looks pretty bad. So we can add the class of close, which comes from Bootstrap. So we'll do that. Class equals close. Now it looks better, but it's still not going to close it. So in order for that to work, we need to add this data-dismiss attribute and set it to alert. So this is just coming from Bootstrap. This is not something that we have access to, on any button that we make. This is particular to Bootstrap. And if I refresh, it does work. Right away, I'm able to dismiss. But there is another thing that we can do. We can actually add onto this alert, this alert-dismissible fade and show classes. And that's going to move that X up to the top right corner, and it adds a nice little fade out instead of it just immediately being removed. So this is a reasonably large amount of classes compared to what we've seen, but it's just from the docs. And we're still actually missing this role equals alert, which is another important thing for accessibility. It indicates to a screen reader that this is important information. Often these alerts will show up on the page after the page has loaded. You'll do something, and then an alert appears. And if we're looking at it, it's easy to see that there's new stuff on the screen, but most screen readers are not going to read out content that changes or that just shows up unless we add on this role of alert. All right, so again, you can copy and paste from the docs at any point if you ever are confused or you're not sure how these alerts work or how any of these other things work. Just remember data-dismiss equals alert, and you don't even need to remember that. I don't know why I just said just remember. You don't have to remember it. You can access this on the docs whenever you need to. When we click that X, it dismisses the current alert that it's nested inside of. So it's a button inside of this div with the class of alert. Lastly, if we don't have JavaScript, the Bootstrap JavaScript files down at the bottom, then this is not going to work at all. We still get the alert, but it doesn't dismiss anymore. So that is all thanks to the Bootstrap JavaScript file and then these two other dependencies, don't worry about that for now. So just keep that in mind. If you didn't include those scripts and you're trying to make a dismissible alert, it won't work unless you do have those scripts. Okay, so we covered a few different components here. Next up, more components and the grid. Next up, we're going to take a break from the component side of things to talk about the grid system. So we still have more components like form components and inputs. We need to talk about nav bars, but the grid is a nice distraction. It's easy, but it's also really, really useful. So I'm just throwing it in here instead of waiting until the end. So the grid system helps us lay out our content on a web page when we're using Bootstrap. And it helps us actually create responsive layouts where the division of space might change depending on a screen size. We've seen this before, but watch as I resize the left and right little sidebars go away. Well, they don't disappear, but they move down below, and things completely shift around depending on the screen size. So the grid system works upon a couple of really important concepts, and the first thing you have to understand is that it only works inside of a container. So we have to have a container or more than one container on a page, but there's got to be a container class anytime we want to use the grid. The next thing you need to know is that we need to create a row using the class of row. So nice and easy. I've got a new pretty empty HTML document. I have Bootstrap included. I have a container. And I have a heading here. Now I'm going to add a row. So div with the class of row. Now that's not going to do much for me at all, but my content will go in here. And this is the most important piece to understand. Every row in Bootstrap has 12 units of space to divvy up. So 12 units. So if we have 3 equal columns like we have here, this gets 4, this gets 4, and this gets 4. If we had something else like 50%, 50%, this is 6 units and this is 6. Or we can have different layouts, right, where this takes up a lot more space. Or something like this, where we have 8 and 4. But the total is always 12 units. Okay? So the next thing to know is that we need to create columns in our row. So every piece that we want to divvy up in a given row is going to be a column. There are a couple different classes that we'll see, but they all start with COL. So just as an example, COL SM4. Column 4, or just col SM. These are all column classes. They begin with COL. All right. So I'm going to show you the first most basic way of doing this, of dividing up space, is using classes, COL dash, and then a number. So if I want 50% and 50%, if I have 12 units, I'll do COL 6 and COL 6. I'm going to add some text in here. I am 50%, or why don't I do 6 units? And I'm going to give it a background so we can see it. BG, this is one of those Bootstrap utility classes. How about success? And I'm going to refresh the page. Okay, so this is taking up 50% of our container of the row. Now let's do another one here. BG info. It's also 6 units. There we go. So that's all 12 units. Now I could shift this around. I'm not going to change my text right away. But I'll change the class names. What if I did 4 and 8? Okay, let me do a little bit higher contrast. Why don't I do danger? There we go. So this is 4 and this is 8. Or I could do 2. And if I just did 2 and 8, we're going to have extra space over here that's not being used, which is fine. We'll talk more about what we do with extra space and if we can center things and add that space between our different columns. But you can see now, I've got 2 and 8. I could add another one that's 2 units at the end. So this still adds up to 12. So we'd have 2 sides, 2, 8, and 2. So I could have another row down below and have something entirely different. A row is just 12 units going across the screen, and I can divide it up however I want. So let's do this one as... what do we have? 2, 8, and 2. Why don't I do, let me just change this. 2, 8, and 2. How about I do 3, and then 6, and 3. So 3, 6, 3. And that still adds up to 12. Okay, let's take a look. There we go. So I'm 3 units, I'm 6 units, I'm 3 units. Very ugly, but we can put whatever content we want inside of these columns instead of just a background color and text. We can put form elements if we want a nice form that we can lay out. We can put images. We can put other components we have yet to see, things like cards. I'm just illustrating the basic concepts. Now we can actually even get a little bit lazier. If we want equally sized columns, we can just use the class of column, C-O-L, col. So if there's 2 of them, they will split the space, 6 and 6. If there's 3, they split the space, 4, 4, 4. It will automatically figure out how much space each one needs. So let's do another example here. We'll just do COL, COL. Why don't we just do 2 to start? And I'm just going to say I am auto sized. Just copy that. And I just gave them 2 different background colors. I'll refresh. And there we go. They split up that space evenly. Now if I double the number of them, they still share that space. So we've got, 3, 3, 3, and 3. That's just all done automatically. So that's the basic idea, the basic principle here. Now what's cool is that I can actually call one of these out and give it a particular width or a particular size. Like, how about column 9? So this one, I'm saying, don't auto size, you are 9. And the others need to figure out how to share the space after it or around it. And so that's what we end up with here. This one takes up 8. And then what do we have left? Or no, it takes up 9, sorry. We've got 3 units left, so we've got 1, 1, and 1. Notice the height, right? My text is not responsive in any way, so everything's stacking inside, and so this individual row is taller, but the other ones do that too once we get to a much smaller size. But that has nothing to do with what I just did, other than the fact that I took up a lot of space. So that just shows we can do a mixture of auto-sized. Let's do something a bit more manageable. How about 5 here? And I'll get rid of this one here. So we've got 5 and then 2 auto-sized ones. Okay, let's switch it up just a tiny bit. Let's go with maybe, I don't know, how about 8 here? And then we'll get rid of that last one. Refresh, and you'll see that these 2 resize automatically to share the leftover space. All right, so to recap some of the basics here, you need to have a container. Now that container can also be a fluid container, which is a full width container. We can nest containers inside of containers. I'll just show that very quickly. Do another container here around this one row. And it gets a little bit of margin on the sides, and that's kind of all there is to it, right? Containers aren't beautiful elements, but they're essential for all of this to work. And then we create our rows. And a row is just something with the class of row, typically a div, could be a section or something like that. It doesn't really represent anything itself. It's just there to help spread out or structure the content or lay it out is a better way of putting it. And we have 12 units within each row, and we can divide those up however we want. We use col dash some number to create our column sizes, or just col to create an automatically or auto-sized column that will share the space that is left over if we have some already divvied up like I do right here. So next up, we'll see how to make this responsive. All right, so now we get into the meat of the grid system, the most important or most exciting part, which is how we can create responsive layouts and shift content around based upon the screen size. So the way that we do this hinges upon the built-in breakpoints in Bootstrap. We briefly talked about these. There are different sizes that have been predefined. So we have small is from 576 pixels up to 768. Anything below 576 is considered extra small. Then we have medium, we have large, and we have extra large, anything greater than 1200 pixels wide. So these are different sizes that are predefined, and we can reference them at any point using the grid system. So I could have a 50-50 split on large and extra large screens, but then on medium, small, and extra small, I might have 12 units and then 12 units. In other words, 2 full rows instead of sharing any space. So there are a bunch of classes that help us do this, and they all use these breakpoint sizes in the class names. So we have things like column-8 we've already seen, but we also have column-small-8 or column-large or medium, and not just -8, but 6 and 4 and every number between 1 and 12. So let me just demonstrate this simple principle. Well, I say simple principle, but I've seen a couple of students confused about this early on. So what I'm going to do is just make a new section here. So I'll put in, what do we have there? That's display 1. So let's do a display 2. and it will just say responsive grid. And then below, I'll add a row. And in this row, I'm going to have two elements that are 50-50, so 6 and 6. So I'm going to have a row and then column 6. And then in there, what should we do? Maybe just some lorem ipsum text this time. Okay, let's just see what that looks like. Okay, and then let's get our second one going. I'm just going to copy that. So duplicate the whole thing, just like that. All right. This is a bit large, isn't it? Maybe I should go with display 4. All right, so they're sharing that 12 units, 50-50, 6 and 6. But what if I want maybe on the, what breakpoint would make sense? Maybe the small, maybe the medium breakpoint and below. I want them actually to just go all the way across on their own. And I don't want them to share space. Well, what I can do is use, instead of column 6, column dash, I'll do medium 6. And the way we would read this is after the medium breakpoint and up, you should take up 6 units. Everything below is assumed that you just go all the way across. So you'll see what I mean here. I'm going to shrink all the way down. Take a look. They stack. And then once we hit that medium breakpoint, which is right about here. Nope, I totally am wrong. There it is. Right there, they now take up 6 units of space. So it might be easier if I give a background color to the paragraphs, or to the columns rather. So how about BG info and BG success? Did I misspell success? Yes, I did. Or I misspelled BG. Okay, so now you can see what happens. They stack. They start out stacked on an extra small and small. And then once we get to medium, they take up 6 units each. So we have all these different sizes. Maybe I actually have more than just 2 of these. Maybe I have 3 of them or 4 of them. So why don't I take a look at 4 of them? So right now I'm going to have, 2 and 2 because I said column medium 6. So 6 out of 12, 50% each. But then when we go all the way down, each one goes all the way across. But maybe I want to change this. So, at medium, 2 by 2 is okay. But maybe at large, I want to go larger. I want, maybe I want 3 in a row or 4 in a row. Well, I can do that using these different breakpoints. Instead of medium, I can add on another class. Column, let's do extra large. If I want to do 4 across, that would be 3 each. So let's copy that in a couple places. Paste that in, refresh, take a look. We start at extra small. They go all the way across. That's the default assumed state. If you don't specify, which I'm not specifying extra small, I'm not specifying small, I'm specifying medium and above, and then extra large and above, which is just extra large. So here we go. They go all the way across. We hit small, nothing happens. We hit medium, and now they go 50%, 6 and 6, 6 and 6. Then we keep going. Large, nothing changes. We hit extra large. Now they all share a single row horizontally. We've got 4, 4, 4, and nope, I can't do math. We have 3, 3, 3, and 3. 4 times 3 adds up to 12. Now, if I overflow that, if I were to say, actually, I only want you to take up 4 units, or I want you to take up 4, not 3, right? There's not going to be enough space for them to fit. So then we end up with 2 rows, and this one takes up 4 units down here. But still, the same principle is applying, where we're going from extra small to medium to large to extra large. And along the way, I can specify sizes however I'd like. But often what we do is, have them get smaller or take up less space as the screen gets wider. It's not that common to have the inverse relationship. Usually on a wider screen, your elements don't need as much room. Versus on a smaller screen, you'll have them take up more units of space across the row. So let's do one more example here. I've actually added in 3 images. I just didn't want to make you watch me copy and paste a bunch of URLs. These are from unsplash.com. So, no, not those images. Here we are. I just searched for bird. These are free images that we can use. Don't have to worry about licensing and all of that. A really great source. We've already used it in the course before, but I always like highlighting this website. So right now, no grid system, nothing fancy involved, no Bootstrap, just 3 images. Now, I'm going to put them in a row, and I'm actually going to use a new class that we have not yet seen for responsive images. It's called Image Fluid, and it's pretty straightforward. It just makes an image scale based upon the size of its containing element. So if we put a fluid image or image fluid inside of a column, and that column changes size, the image will change size too. So here's what I'm going to do. I'm going to give them all these 3 images, class of image-fluid, and then I'm going to put them inside of a row. So I'm going to make my row, and I need each one to be in a column. So I could just start with the basic dot, or just COL, so they're all just equally sized columns, not necessarily responsive in any way, or at least nothing will be changing based upon the screen size. But we can begin with this. So I have 3 columns. There are the 3 images side by side. A quick note, if you are using different images and they're different heights, they're not all going to just magically be the same height in your row. You can change, how your image displays and cut part of it off or stretch it or something like that so that they all are the same height. But I'm just using 3 square images. But we're focusing on the width anyway, the amount of space they take up horizontally. So what I'd like to do is maybe have them go 3 in a row on extra large and large, but then here I think it gets a bit cramped. So maybe I'd like it to go 2 across, and then further down, right about here, I think I'd like it to go just 1 across. Probably. We'll play around with that. So remember the way that this works. We have these different breakpoint sizes. So I can do something like column extra large and above. I want each one to take up 4 units, right? Because that should give me 3 in a row. So extra large and above. XL 4. So shrink down. We have all the way across at extra small, small, medium, large, and then we'll hit extra large, and they go to 3 across. So I want something in between there. I'd like for them to go, this is a bit excessive, right? Not quite what we need. Also, I'm hitting the max size of the image, by the way, if you're wondering why it's not getting wider. The images I think I have are like 800 pixels wide. You can actually see in the URL from Unsplash, 800 pixels for W or for width. But otherwise, they would stretch or they would expand to fill this entire row. We just don't have that much of an image. So what I'd like to do is, at extra large, 4, at large, so I'm just going to get multiple cursors going by holding Option. Column large and above, I want them to take up 6. I might change that to medium. Let's see. Yeah, because right there, that's where we hit large, but medium is still quite large. That's a bad way of putting it, but it's still excessive. So I'm going to do column medium and above. I want you to be 6. So that gives us 50% across. Let's get there. Here we are, 50, 50, and then we'll hit extra large right there, and then we go to 3 across. So that's pretty good. We do have an odd number, so it looks a bit weird down here. We'll learn a bit more about how we can handle that. Maybe we want this one to be centered, for example. There are utilities we can use, but for now, this is good. So we have full width all the way across on really small screens, or extra small and small. Medium, we go 50%, 6 and 6 units, 6 units. Keep going, and we get to 4 units, 4 units, 4 units, based upon that screen width. Okay. Now, one other thing I'll just mention, you can probably see these gutters here, the spacing. There is a variation of the grid, or of the row, rather. If we go to Layout, Grid, and you look for gutters over here, I'm totally missing it. There it is. We have a class we can add called No Gutters, if you want to get rid of that. So on our row, No-gutters, and that will just eliminate that space between. I kind of like having that space, though, so I'm not going to use that. All right, so that is our brief intro to the responsive classes for our grid system. Remember, 12 units, we can divvy them up however we want, and we can do that on a breakpoint or per breakpoint basis. So from small and above, I want this, or rather from medium and above, take up 6 units. Actually, from extra large and above, I want 4. So it's always from this breakpoint and above, unless you specify something else. All right, so next up, we've got some grid utilities. We'll learn more about how to center things and what happens about vertical alignment and a whole bunch of other stuff, and we'll get more practice. But this is the core mechanic. These class names might look a little crazy, but they're incredibly useful when we're making our responsive layouts. So next up, we'll take a look at some helper classes, some nice utilities that we can use to align our content. So a couple things up front. One, remember our Flexbox. We talked about Flexbox and terms like align content, or align items, rather, justify content. Look at me, mixing it up already. Those are actually used in Bootstrap. Bootstrap uses Flexbox terminology because it's actually built on top of Flexbox. So you'll see what I mean. But let's actually get something to align. Right now, I've made 4 new columns, equally sized columns in this single row. These weren't here in the last video. And they're all just lorem ipsum. They're exactly the same height. But I'm going to make one of them twice the height, maybe the success one. I'm just going to do another lorem. All right, so now we've got some extra space. And you'll see that they're all growing to take up that same height as this green box. But maybe that's not what I want. Maybe I want, all of the other ones to be aligned to the top and to not stretch to take up that whole height. Or maybe I want them to be centered, or I want them to be aligned to the bottom. Well, fortunately, we have these classes we can use: align-items-start, center, end. These are all different options that we can apply to vertically align our content. So think back to Flexbox, how align items works. It works on the cross axis, and our grid is built using Flexbox already. If I inspect it, you'll actually see that row, the class equals row, has display set to flex. So I didn't do that. That's just from the class of row. So I could manually go in and set the actual CSS that says, align items center or align items start or something. Or I can use the Flexbox helpers. So that's what I'm going to do. I just need to find that. Where are you? Here we are. I'm going to find the row and set align items. How about end? And there we go. That content is aligned along the cross axis at the end. So top to bottom, so it's aligned at the bottom. Or I could do start. There we go. Or I can do center. And center is actually used pretty frequently. If you have especially content that is not exactly the same size, maybe you're making like a product card. You may have seen that before, where there's like 3 subscription choices and there's information about each one. We can center align them together. So if I made one of these even larger, how about this one here? Lorem times 2. There we go. Center aligned. Looks decent enough for what it is, which is basically nothing. Just lorem ipsum text and random background colors. So that's align items. Just like in Flexbox, plain old non-bootstrap Flexbox, we can also control the alignment of a single column using align self. So we have align self start, center, and end. So I'll just show that briefly. Why don't we align the blue one to the end? So let's find you right there. Align self end. And just to reiterate what's happening behind the scenes, if we look at it, it has align self set to flex end. So we could do that on our own, just like we could do all of this on our own, but the point of Bootstrap is to simplify that process. So this is why I taught Flexbox first. Otherwise, this terminology is kind of confusing if you don't know what align self or justify content is. Speaking of justify content, we have a set of utility classes, justify content, start, center, end, around, between, that we can use to control the horizontal spacing. So right now, there's not a lot for me to control here because these are actually taking up 100% of the space. But let's do something slightly different. Let's make another row. So I'll do an H3, justify content, and then I'll add a row. And then in here, let's do a column that takes up, how about, 4 units, okay? And we'll give it a background color, BG info. No, let's do primary. And then just lorem ipsum. I know it's boring, but it gives us something nice and easy to work with. Okay? So right now I have a lot of extra space. I can actually add a border to my row. Bootstrap gives us a class called border, and it looks like this. It's not terribly impressive. You can see all that extra space. And I could add one more in, right? I'll just duplicate this. Where are you? Right here. We have primary. Let's do info. Okay. So we've got this extra space, and the default is that our elements are just aligned to the start of the main axis, just the left side of our row. But if I wanted them to instead move to the right or to split that space between them, I have justify content helper classes. So justify content start, it's already what's happening. Let's do center. So this is on the row. Justify content center. Okay, they're centered. Justify content end. There we go, between, and just like with align items, this is just adding regular old Flexbox properties that we already know. It's just an easier way of doing it. We don't have to touch our style sheet, right? We haven't written anything. I have an empty app.css. It's still not pretty, but we're laying things out without having to touch CSS. You just have to use the right classes. Now, what I haven't told you yet is that all of these utility classes actually have different variants for different screen sizes or different breakpoints. So justify content is not just justify content start, but we could also specify that we want start on small and above, and then we want center from large and above, and from extra large and above, we want justify content around. So there's all these variants that we can use, because sometimes it's not enough just to say, I want this to be centered always. You might want to dynamically change that depending on the size of the screen. So I'm not going to show a ton of examples here, but I'll just demonstrate this. And the same applies for align self, for align items. All of these have these different breakpoint variants. So let's take a look at what we have right now for justify content, these two. Right now I'm using space between. So I'll start by giving them, how about column medium 4? So that on smaller screens, they just stack in a column. Okay, but then we get here, and maybe I want them to start centered. I don't want them to have space between. So I can start with justify content center. And this is going to be from all sizes, extra small and above. So they're centered. Now it doesn't matter here when they're stacked, there's no space to distribute, but here we do have, nope, not yet. Here we have space. Now, maybe I want them to move to the left or space between or space around at the large breakpoint. So let's do left, sure. So justify content, and then I can specify the breakpoint. So I'm going to do large, and then start. So large and above, I want them to move to the left side or the start, flex start. And then once we get to extra large, I'll go for space between. So these get kind of long. Justify dash content dash XL dash between. There we go. So they start out. There's no space, no horizontal space to worry about. Then we start by centering them right there at medium and above. And then from large and above, they go to the left, flex start, and then extra large and above, space between. So the same thing holds true for the other utilities for alignment, for align self and for align items. They all have these variants where you can specify different versions at different breakpoints or different sizes. So they're not all that commonly used, but there might be times where you need to redistribute that space depending on the size. So that's pretty much it for the grid at this point. There's a lot to it. But you'll get a lot of practice, and we'll build some more layouts, we'll build some projects and that sort of thing. So you'll get more comfortable, hopefully. Next up, let's talk about forms in Bootstrap. So there's a lot of different components we could cover for forms. I'm just going to show you the basics, some of the most important ones. Forms are annoying, or they can be annoying to style, to make look nice and to lay them out, but Bootstrap makes it very easy. So the first core component, the first class name you need to know, is called form control. And this is what we put on the input itself. So if we have a text input, an email input, a password input, a number input, whatever it is, we use class equals form control. And that's going to give us a nicer looking form input. So we get these custom styles that are coming from Bootstrap. You can change them and override them, but the defaults look pretty good. So why don't we play around with that first? And while I'm here on the docs, you'll see another class called form group that is used to group together a label and an input. It doesn't do a whole lot. If you scroll down, I believe they explain it somewhere on here. It's a flexible class that encourages the grouping of labels, controls, help text, form validation, messaging. It's just going to apply some margin, so it doesn't really do a whole lot, but it just groups things together. So let's make a simple form here. I've got a new document. It's just forms, an H1, nothing else. I've got Bootstrap included. I'm going to go ahead and add in a form. So we can do an actual form if we want. I'm just going to have it go nowhere. And then in here, I'll start by adding in a form group div. And then in there, let's add a label. What will this be for? Let's say we're doing just an email. So for email, and then we'll add our input where type is email. We give it class of form control. That's the Bootstrap class. And then I'm going to give it an ID of email and a placeholder of email as well. All right, so there we are. This is our email. I don't know, that placeholder looks kind of weird. We've got our first form control. Now notice it goes all the way across. It takes up the entire width of whatever the containing element is. That might seem odd, but if you think back to the grid system from one video ago, this means that we can use these form inputs, these form controls, and lay them out using the grid so that we can create forms that look nicer, where we could have, inputs sharing a row or 3 inputs across. So we'll play with that in a moment. Let's just make one more form group here. Let's do password. So form group, this will be for, let me just replace all password just like that. Let's see what that looks like. Here's our password input. Okay, so just form control once again. So we can actually use form control, the same class, to make a select, a multi-select, a text area. Let's do a select, maybe for state. We'll have people pick a state. So we just need to use form control on the select, and then a label and a form group. Those aren't mandatory, but they're always a good idea. So let's do that here. Form group once again, and then we'll have a label. Let's go with state, and for will be state. Then we have our select. Name will just be state for now. We're not using that. ID is state. Oh, I butchered that. Jeez. Okay. And then we have a couple of options. And I'm just going to populate this with, let's see, Alabama, Alaska, Arizona. Okay, we'll just go with Alabama and Alaska to start. So we're not going to do all 50 options. All right, so right now I do not have, lovely. I don't have form control set on my input on the select, but if I give it class equals form-control, refresh, there we go. Looks significantly better. All right. So that's how we can use form control for selects. Same thing for creating a multi-select text area. I think you can figure that part out. We can make inputs larger and smaller using form control large, or LG, and SM for small. We can do that for selects as well. Now checkboxes and radio buttons are a bit different. So without going into too much detail, changing the appearance of a checkbox in your browser is not as easy as you might think. You can't do things like change the border size or the color or there's just different things that are very challenging to do compared to a regular input like a text input or a password input. So we have one option, which is to use basically the browser's checkbox. You use a class called form check. This just sets the spacing slightly differently. I'm just going to copy this so we don't waste too much time. I'm just going to show this to you. Let's put this down here. Our label will say, sign me up. Okay, so it's just a class of form check for the div, the parent. And then we have our checkbox, and then we have our label. And they each have a form check label and form check input class. And this is what that looks like. Now there's another option. If we go down, just find over here for custom form inputs. Bootstrap comes with its own customized versions that are brand new elements that are completely different than the browser defaults. So this may not look radically different, this checkbox, but it is. If you see that animation, there's a little bit of that glow. It animates in and out. The icon is different, the rounded corners. This is a customized checkbox, and there's a lot of work that goes into making that because what actually happens is that there's a hidden checkbox, a regular browser default checkbox that you can't see, and then there's this customized thing on top, and they're linked together. So without going into too much detail, I don't want to bog us down here, we'll just copy this, and you'll see that we use a class called custom control, custom checkbox, 2 classes. Then we have our checkbox, then we have our label. So I'm just going to copy that, paste it in so we can compare. Here we go. Here's the default checkbox, and here is the custom checkbox. So a nicer experience, in my opinion. It's just more work. Fortunately, with Bootstrap, we can just reference the docs and copy what we need and tweak it. So let's use that one. We don't need the default. Let's go with sign me up. And then we'll just do ID of maybe register or terms of service or something like that. I don't know. TOS. And then label will be for TOS. Okay. So lots of classes involved, right? Custom control input, custom control label, custom checkbox, custom control, but it's worth it. Now the same thing goes for radio buttons. So we can get custom radio buttons that have that same little glow effect. They look nicer. I'm not going to go into detail here. We also can do switches. Now those are nice. They're built on top of a checkbox as well. So input type equals checkbox, but you're not going to see the checkbox. You're going to see the custom switch that Bootstrap adds on top for you. So that's nice. There's also customized selects. So they have a slightly different interface. What else is there? We've got a customized range input. So there are lots of options. You know, I have a course on Bootstrap, and we spend like an hour plus just talking about forms and inputs and custom inputs, but I don't want to bore you to death. You can always find what you need on these docs. Now, the last thing I do want to show you is creating form layouts. How do we break this form up so it's not just, everything on its own line, a super long form? There's probably a better way of doing this. So there is. We can use the grid system. Let's say I want email and password to go side by side. Those look way too long. So let's start there. It's as simple as just putting them in a row and using column classes. So for example, I can create a row here. I'll just group those two, email and password, and then each of those form groups, I can give them a column. I could just do COL, and they'll just share that space. And there we go. Now there is a different class that we can use. It's called form row. It's super similar to row, just regular row. It just changes the default spacing, that gutter size, so that our forms are a little more compact. Here's a regular row, here's form row. So let's do that instead. Okay, so they go closer together. So let's expand upon our form. I'm just going to add another one, another input here for address. So address, just like that. Our placeholder will be something like, 923 Chicken Ranch Street. And ID will be address. And I want this one to go all the way across. Let's say street address to be more specific. And type will be text. So I'm not even going to bother putting it in a row. I don't need to, although that looks a little odd. What should I do? Oh, I gave it the column class. It's not in a row, so I don't need column. Now, what I probably want to do is, this is getting a little cramped. I may want these to go on their own row, take up a full line of space on small sizes. Well, we know exactly how to do that. Instead of just column, I could just say, where would I want that to happen? Small, maybe medium. We'll play around with it, but let's say medium 6. Anything below that, it will take up the entire line. Once we hit medium, it should take up 6 out of 12. So there we go. Takes up the entire row. Then we'll hit medium right there, and they share the space. Looks pretty good. Okay, so we've got state here. That's way too large for that. I'm also going to add in city. So let's add in a city input, which will just be a text input. So just put city right there. Placeholder, I don't know if we need a placeholder, honestly, for now. It takes up its own line, but what I want to happen is for it to share space with state. And I'm also going to add in zip code. And I'm going to do that after state. So this will be zip. For zip, this will be zip code, class form controls, ID is zip. All right, so now I want these guys to be in a row together, and they're going to share the space. So I'm going to create a form row around them. Form row. End it right there. Okay, and now I need to distribute them. So I want city to take up the most space. I'm not sure exactly, maybe 7 units. Let's see what that looks like. Might be a bit large, maybe 6. And then state doesn't need a whole lot. Let's do column, 3 maybe. And zip can be 3 as well. I think that could work. Of course, that's going to be quite cramped on small sizes. So I'm going to have that happen probably at medium, just like we did for the others. Now we could play around with that too. Let's see how that looks. Yeah, we could probably have state and zip code actually share that space. So, slightly more interesting. We'll just go with column 6 and column 6 for state and zip code. So now they share that space 50-50 on all sizes and up, except, nope, from medium and up, they're now 3 and 3. So here we go. Looks definitely better. It's responsive. It looks decent on mobile. It's not amazing, obviously. We're still missing a button. We should put that in there. But yeah, it's pretty good. Let's add in a button right at the very end. So we'll do should we do input type equals submit? Now let's just do a button. Button type equals submit. Class equals, let's do BTN primary or success maybe. And let's go with register. It's a little bit cramped here, and that's because I don't have a form group. So dot form group around that checkbox. I mean, there's other ways of getting some margin there, but that's the easiest way in a form, just to keep the spacing consistent. So there we go. We've got a relatively nice looking form using Bootstrap. It's responsive. We laid it out exactly how we wanted. We could change the size of these inputs. There's really a couple of core concepts, the form group class, and then the form control class, which we apply to most of the standard inputs. And then we can get fancier with custom inputs like custom checkboxes and radio buttons and toggle switches. But this is really the core stuff that we need to know for now. So that's a rough intro to forms in Bootstrap. So next up, we'll cover one of the most important components, probably the signature Bootstrap component aside from the grid system, which is the navbar. Navbars usually are pretty much found on every website these days, and it can be a lot of work to make your own, especially if you're making a responsive navbar that's also accessible, that also looks good. So, if you watch some of this here, this navbar, the purple one, changes shape a bit. Some of the content moves around and shrinks, and then it stacks. But then if you watch this navbar come into play, this search, there's this expandable drawer or collapsible drawer, however you want to think about it. Let's find another quick example just on the navbar docs. Notice all of the different variations for navbars. So we can have a simple one where we don't have much going on and we just have a couple of links. We can have ones that have forms embedded, and this is the behavior that is most important, that collapse right there where we move into a drawer shape. Further down, we have other options, different ways of collapsing, changing colors. So like everything in Bootstrap, we could do this on our own. It's just a lot of work. So you can customize these. You can change the colors and the fonts and the height and everything. But the core mechanic of having a collapsible navbar that works well on small screen sizes and large screen sizes is what draws people to using the navbar component. Now, with that said, for as commonly used as the navbar is, I will say in my experience, over, 5-6 years of using them, I can never, ever remember the syntax. So there's no shame in that, at least not for me. Don't feel pressure to recall this compared to, the grid system or a button component in Bootstrap. Those are simple. They're easy enough to remember after some practice. Navbars, look at all of this. I can never remember the specific class names. We've got a whole bunch of different things: navbar, navbar brand, navbar light, collapse, navbar, nav item, nav link. There's just a lot here. But let's start nice and simple. Here is how we can make the most basic navbar. It has a navbar brand, which is a class we use to create the title, the main branding for your navbar. Often there'll be a logo next to it, like that right there. So all we need to do is create a nav. It could also be a div, but a nav makes a lot more sense with the class of navbar. And then we need to choose if we're using a navbar light or navbar dark, and then pick the background. And why don't I just copy this over so you can see. I've got a new document, totally empty, except I have Bootstrap included. At the top of my body, I'll put this navbar. So I'll refresh, and there it is. So there's nothing in there, nothing to collapse, but there is this brand. Now there's another way of doing this navbar brand. You can use the h1 class to make it larger. I'll just keep it as an anchor tag, but I'm going to show you another navbar. This time we'll do navbar dark. Now what does that actually change? You might think that changes the background, but it does not. It's simply changing the text. And then we can change that background to be whatever we want using CSS, or I can do things like BG primary. And now I have a dark-ish navbar, it's blue, and then I have the light text. So this class here, navbar light, navbar dark, is for the text of the navbar. It is not for the actual background. Okay, so then if we want to add, images in for a logo, we can do that. You can just embed an image inside of that navbar brand anchor tag. And then we can add a bunch of links in. Now, this is really common, right? For navigation, we have nav links. There are a couple of ways of doing this. You can use a UL with a bunch of LIs, or what I like to do that's even simpler is to use just a div with a bunch of anchor tags inside of it, just because the markup is shorter. But even though it's shorter, there's still a lot here. So if we look at some of this stuff, we've got a div with the class of navbar nav, and then each element, each anchor tag has nav item, nav link, and then some of them you can add on active, right? This is supposed to show which link you're currently on. You can disable one so it's grayed out. So if I try this here, I'm just going to add this on somewhere into one of my nav bars. We'll do a div with a navbar-nav class. And then inside of that, we're going to have nav item, nav link on our anchor tags. Nav item, nav link. Come up with an href. Let's just go with home. And then duplicate that a couple of times. We'll go with about and contact. Sure. Okay, refresh. Not quite what I was hoping for. So what's going on here? Well, we're missing a couple of things in order to make this work. As you can see, I skipped over some of this markup. So we need to wrap this in a collapse, navbar collapse div. Now that seems a bit excessive, but let's just do it. Collapse navbar-collapse. And this is the syntax I'm talking about that I can just never recall on my own. Let's refresh. Okay, well now our content is just gone entirely. What happened? Well, this has to do with what this collapse class does. The collapse plugin as part of Bootstrap, we can use it to collapse things and show and hide them. For example, make a little accordion, or keep going down here. Here's another example. It's also used for navbars to show and hide content to collapse that drawer or to collapse a navbar. So what we need to do now is add in a class, navbar expand, and then some size. And this is going to indicate to Bootstrap when we want the collapse to stop. So right now it's collapsed here. And then when do I want it to expand? Large or small or medium or extra large. So we add that to the navbar. So I'll do that here. Navbar-expand. Let's just do large for now. Refresh. And there's our links, but they go away on extra small and medium. We hit large, they show up. So if I change that to small, for example, now I go to extra small, it's gone. I go to small and they appear. Medium, large, extra large, they're here. All right, so we're still missing an important piece though, which is how do I get that drawer toggle thing to work? How do I see the content? Well, what we need to add is our navbar toggler button. So this is going to create that, what people usually call a hamburger icon right here, that will toggle the navbar open and closed. And then the way that we do this is a little bit complicated, or it's a little different than what we've seen so far. So we can create our button with a class of navbar toggler. We put a span inside with the class of navbar toggler icon. So we can do that. Nice and easy, hopefully. So button, the class of navbar toggler, and then a span with the class of navbar toggler icon, just like that. Refresh. Let's shrink down. Okay, it appears, but it doesn't do anything. Why is it not working? Well, we need to connect it to this div right here, the thing that's collapsing. We need to connect this button so that when you click, it expands. So we need to connect them in a way. And the way we do this is by setting a data target attribute and a data toggle. So we say data toggle is collapse, and data target is the ID of something that we want it to expand or collapse, which is this div right here. Notice there's an ID, navbar nav alt markup, data target, navbar nav alt markup. So on this div, the whole parent of our navbar nav, right in there, I'm going to add ID, and I'm going to do something obvious, something like expand me. And then on our button, we add data target equals, and then expand me. So now they are connected. I also need to set this data toggle to be collapse. Again, this is the syntax I never remember. Don't feel like it has to make perfect sense. Let's see what happens now. So it appears, I click, and there we go. It's working. Cool. A couple of things I'll point out. You must have JavaScript here, right? If you don't have the Bootstrap JavaScripts included, I refresh, it's not going to work. So that's one example where you need those scripts, and now it works. The other thing I'll point out is that we can put other content in there. Anything that goes in this div right here that has the class of collapse, anything in here is going to be added to that drawer. So you can add drop downs, which we haven't covered, but they're simple enough. You can add forms if you wanted to. We could do that here. Actually, I'm just copy this form to make it nice and quick. Let's put this after our nav right there. Let's see what it looks like. Okay, it looks all right, but maybe I want to move it to the right-hand side. So there's a couple of ways of doing this, but the easiest one is to use a special class we have yet to see, so I'm jumping ahead, margin left auto. So it's just going to set margin left to be auto on this whole form, which we could do on our own. We've seen how to do, margin auto just via CSS, but let's see what happens. We hit collapse, and now they stack, and it looks okay. Maybe we want this to be a little, I don't know, it's a bit wide there, in my opinion. Maybe they should share the space on a small screen. I don't know. We can figure that out. But I would change this button so it's not success. Maybe button outline light. Let's see what that looks like. Expand. Yeah, that looks better. Search. Yeah, it's pretty good. So the last thing I'll show you, there's a lot more to nav bars. You can make much fancier nav bars with a lot more content in them. You can create custom color schemes by setting your background color on the nav bar itself. Or what I want to highlight is that we can place them differently. So we can have a nav bar that is fixed at the top of the screen. So I'll show you what that would look like. Right now, we can't really get a good feel for this, but if I add a bunch of content, just down here, I'll add a container. And that reminds me, you can add a container inside of your nav bar, which looks like this here, so that your content is constrained a bit inside the nav bar. Ours goes all the way to the edge, but I could wrap everything in a container. Container, and then move that down to the end of my nav. And that looks like this. So it doesn't look great. The other thing you can do is put your nav bar in a container, and it will be constrained, or it will have more spacing on the sides. It won't go all the way across the screen. Okay, so I'm going to add a bunch of content down here. Why don't I just do, I don't know, what should we do? Lorem ipsum times 100 maybe? Okay, so now I've got some stuff to scroll through. So the default is that my nav bar just goes away as I scroll, but we have some options here. I can change the placement to be fixed dash top, for example. So on the nav bar itself, I'm going to comment out this simple nav and give it fixed dash top and refresh. Now check it out. It's fixed to the top as I scroll. It's pretty nice. The other option, well, there's a couple other, but another one is fixed bottom. So this is less common, but sometimes you do want a bottom nav. Now it's fixed on the bottom, right? So I could have a header and a footer that just stay there if I wanted to. Or not a header and a footer, but a nav on the top and bottom. And the last one is a little bit different. It's a sticky nav bar, sticky dash top. So if I add that class in, sticky dash top, we're not going to see anything really at all change. It looks like it's just fixed to the top, and it is. But if we add some content before our nav, I'll do maybe an h1 with the class of display one. I don't know, nav bars. Let's also center it. It doesn't matter, but let's center it. Refresh. Okay. So what do we see here? Well, my content is not fixed to the top. There's stuff above it. But as I scroll, now it gets stuck. It sticks to the top, hence the term sticky, and it stays there. So you may have seen things like this. Sometimes there'll be like some sort of header with an image, something nav bars, and then maybe we could have a smaller display. How about H2 with display of 4? R, so cool. And then a paragraph with the text with a class of lead, lorem. I don't know. We could have a little header up there. Well, none of this is centered. It doesn't look good at all. But as you scroll, it gets stuck. Design is not really what we're talking about right now. Just mechanically how this nav bar works. So that can be cool. And again, all of this is stuff that would be a lot of work on our own to recreate. So I'm just going to leave it at fixed top. But just remember there are those different options. And there we go. It stays up top. All right, so that's a lot of content around nav bars. And again, if you ever want to do something more complex, you want to add a drop down, you want to change a color, there's just different features you want to add in, different buttons, different components. Take a look at the docs. They're very thorough, lots of examples. And like I said, I have to refer to the docs pretty much every time I do anything with a nav bar and Bootstrap. I just never remember it. Cool. Next up, something a bit different. I'd like to introduce the Bootstrap icons, which is actually a completely separate section of the website. It's under icons, and this is a newer part of Bootstrap. I believe it's actually currently, still in alpha. So these are a free set of icons. I think there's a couple hundred of them that range from, they're pretty commonly used things like chevrons or arrows, trash cans, delete icons, pencils, questions. And you can see them all here. There's quite a few of them, and these are all free for us to use. And the way that we use them is a little different than anything we've seen so far. Let's try and find one. How about a delete icon? Okay, so we've got a couple different options for delete. Let's just do the trash can icon. And then we have a couple of those. We've got this trash, trash 2 versus trash. And then we've got filled, and then, so just like a dark variant versus a light. You can change the color of any of them, so they don't have to be black, for example. Let's go with just trash. So I'm going to click on it. And what we see here as we copy this code looks kind of insane. If you're new to this, this is an example of an HTML element we've not seen yet. It's called an SVG. It stands for Scalable Vector Graphics. If you're familiar with things like Adobe Illustrator, you may have come across SVGs before. I'm not going to go into it now. SVGs are they can be an amazing tool to building really modern, artistic, cool-looking websites and animations and games and stuff. So I'm not going to go into much detail here because honestly, all you need to know is copy this, paste it, and you'll get a trash can icon. But you should know a little bit about how SVGs work. This information here describes the actual paths that we see right here. So this is not an image. This is not something that's been exported or saved as an image or something like that. It is just information that describes the shape here, the different paths at play. So they are scalable. We can make them bigger and smaller without losing quality. We can change their color. It's a path. It's almost like a piece of your font, like a letter. So I'm going to copy that. I'm going to make a button. I'm in a new document once again. Let's just do an H1 display 1 icons. And then down here, let's do a button, the class of BTN, BTN large, and we should probably do BTN danger. Delete. Let's see what that button looks like. Okay. And then let's put the icon in there. So it depends on where we want this to go, but I'm just going to paste it in here. There it is, right after delete. Refresh, and there's our delete icon, right next to the delete text. You can position it differently. You can change the font size, by the way. First of all, you can see it has a width and a height set to 1em. You could change that right here, absolutely. But what's nice about this, since we know how ems work, is that if we change the button font size, like button small, it's going to give us a smaller font size. The icon scales down as well. So it's not hard-coded. Its font size responds to the size of its parent. Okay, so there's one icon. Let's just do one more example. We'll do something slightly different. Why don't we use a music note? So I just search for music. Here we go. We've got music note beamed. I'm going to copy this entire SVG. And why don't I put this in my H1 right there? I'll refresh. There's our large icon, our music icon. If I change the color of this H1, like the text color, for example, text, let's do text primary. Notice this changes as well. Now you can also change this via CSS. We're not going to go into much, really, anything with SVGs for now, aside from the fact that we can incorporate them. While we're talking about icons, one element that we commonly use, or one component where we commonly use icons, is the input group. So an input group is some sort of input that has been grouped together with a label, some text, a button, a drop-down. So they can look like this here, right? Or they could look like this, or this. Or there are some other examples where there's multiple. Here's buttons. So we could use an icon there, for example, to make a search field. So if I wanted a search field, we just need to look at how we do this. So we'll copy this first example. We have a div with the class of input group, and then another div with a class of input group prepend. That's how we get this little thing at the beginning. Input group append goes at the end. And then what else do we have? We have our form control, and then we have our input group text. So let's just do this very quickly. I'll do this, where should we do it? I guess after everything. So right here, I'll make my input group, and then input group prepend, and then input group text on a span, like this. And for now, I'll do a $sign. That's not a $sign. There we go. And then, got to refer back to this, we need our input. So input type text, give it a class of form control. Let's see what we end up with. Okay, so there's our $sign. Now let's make this a little bit less wide. So we'll put it in a row, in a column, maybe medium 6, just like that. Okay, takes up less space. It's still a bit large, honestly, maybe 4, but this doesn't matter. And now let's get an icon in there. Let's do a placeholder for search. And then let's get a search icon. So let's go back to icons. We will search for search. And there we go. Copy that. Put it over here where we have our input group text. Put that SVG in there, refresh. And there is our search icon. It looks decent, right? Nothing amazing, but it's a nice icon, free to use. And there's a bunch of them that come with Bootstrap. Well, I guess they don't technically come with Bootstrap, but there's a bunch of them that are on Bootstrap's website that we can use for free. We don't have to worry about licensing or anything. On the topic of icons, there are other icon libraries and tools out there. Probably the most popular, or definitely the most popular, is Font Awesome. And I recommend Font Awesome. It's a great tool. It has way more icons. Just show you some of them here. And it has a lot more features. So almost 8,000 different icons. A lot of them you have to pay. You can see the grayed out ones are the paid ones. But if we just take a look at one of them, we have access to different versions, a regular, a light, a duotone, where we have 2 colors. And you can change those 2 colors. I mean, just look at how many building icons there are. Wow. Now, I'm not going to use it right now, where I might have in the past, but now it requires an email address to sign up. It used to be free. It still is free. The free tier exists, but it's obnoxious, and I don't like making you guys sign up with your email. But if you do want to check it out, it's worth it. If you're looking for icons that you can't find on Bootstrap, for example, the social media icons, if I want a Facebook icon, we've got a bunch of Facebook icons. If I want an Instagram icon, I can find that here, or Twitter. You know, those are pretty commonly used. Bootstrap icons currently don't have anything like that, but they're still worth using. Okay, so that's icons in Bootstrap. They're SVGs. What are SVGs? We don't really need to care, but they're scalable vector graphics. We can copy them, paste them, and they kind of behave like text in our applications. And that's pretty much it for now. So next up, we're going to focus on a really useful set of utilities that Bootstrap gives us. So these are not components. They're not things that necessarily make a huge impact right away, but they make our life a lot easier. And we've seen some of them already. There are quite a few, and just like everything in Bootstrap, we don't have time, and I don't want to bore you to death. I probably likely am already boring you to death, but we don't have time to go over all of them. I'm going to highlight them. What all of these have in common is that they are quick ways of applying some CSS styles, whether it's turning a border on or off, or adding a border radius, or changing the display property, or adding margin. Those are all things we can do with CSS. These utilities allow us to do them with a single class that we can add to our elements. So first up, we've got a border utility. If we want to add a border to all 4 sides, we can add border. Border top just gives us the top, border bottom, just the bottom, and so on. We cannot control that width through Bootstrap. We have to actually set a width. There's a default, whatever thickness that is, 1 or 2 pixels. We can use a subtractive version, so we could turn the border off on the top or on the right, or all 4 sides with border dash top 0, border dash 0. And we can change the color, border, and then border dash primary. And we can change the border radius, and this is super useful if you need to make something circular. Now, this won't magically make a circle. It's going to require a square to act upon. But there we go. We have these different options, and we have a different size. Oh, interesting. This is newer. Larger or smaller rounding of the corners. So let's just make something really quick. I'm in a new document, by the way. Let's make an H1, display one, utilities, and then below, why don't we add in, we've got a button. It's a bit boring. How about just a paragraph of text, or let's do a row with a column, I don't know, medium 4, like that. And let's put some text in there. Perfect. There we are. Let's add a border around that. So I can just do border, just like that. And we get this light, very light gray border. If I want it rounded, we have rounded circle, rounded pill. I'm just going to do rounded. Rounded. Okay, so there's our rounded border on all 4 sides. Again, if I want to turn one side off, I can do border top 0, for example. Now we don't have that, but let's keep it. And then let's change the color. Let's do border, I don't know, primary, success. I need an extra S there. Okay, so some simple utilities for adding borders and changing them. Next up, we've already seen the color utilities for text and for background, right? We also have the shadow utility, which I'll show you now. Just to quickly add a shadow, you don't have a lot of control at all, but we can do things like shadow none, shadow small, shadow, or shadow large. So let's do one of those here. Let's do shadow. There we go. There's our shadow. We can add, a button and do shadow small. Let's add a button in here. Button, BTN, info. Sure. Shadow. So it does not have a shadow right now. Oof, that looks horrible. But then what I can do is give it shadow small. Let's do SM. Can you see that? There's a slight shadow there. It's a little tricky to see, but it's just another option. Okay, now on to some other utilities that I think are even more useful. They have to do with spacing, with margin and padding. Now, these are a little bit dense up front. They consist of a lot of letters, and they may not make a lot of sense immediately, but these are really, really commonly used. So here's the formula. We have 2 properties, M and P, margin and padding. And then we have a number of sides that we can choose from. Are we adding margin to the top or to the bottom, to the left or to the right? Are we doing it on all 4 sides, or are we doing top and bottom, left and right? So we have different options here. And then we have the amount of margin or padding that we're adding. We're not going to spend time going into detail about what these amounts actually are, but we have 6 options. Well, we have auto, I guess, so 7. But 0 to 5. 5 being the most space, 0 being none. Now, if you really want to get into it, to the nitty-gritty here, there's a spacer, this predetermined spacer size all of these sizes are a multiple based upon. So whatever this is, let's say it's 2 ems or 20 pixels. We're going to have 20 pixels times 0.25 for 1, all the way up to 20 pixels times 3 for 5. Now, you can change that spacer. We're not going into it. Let's just keep it nice and short. So let's play around with this. They all start with M or P, margin or padding. And then top, bottom, TB, LR for left and right, X for left and right at the same time, Y for top and bottom, and blank if we want all 4 sides. So why don't we start with that? Let's add padding to all 4 sides. I have a couple of buttons I've made, right? They're all the same currently, except they say something different in their inner text. So I'm just going to do P-0 on this first one. And that's a very easy way of saying no padding on all 4 sides. This one will be P1, this will be P2, this will be P3. Okay, let's do 4 and 5, P-4 and P-5. There we go, all the way up to a lot of padding. Okay, so we don't have control necessarily over, give me 25 pixels of padding or 90 pixels or 1 em, but we have 5 different levels or 6 levels, including 0. Okay, so I've made a couple more buttons so that we can see the different sides. We can do padding top, left, bottom, right, X, and Y. I've set them all to have padding of 0 everywhere. So now I can go in and say padding top, PT-5. And that's maximum padding on top. We've got PT- this is L. What am I doing? PL-5. There we go. Same thing for the bottom, padding bottom 5. We'll do padding right 5. All right. And then we have X and Y. So if we do px5, that's going to give us left and right. And if we do py5, that's top and bottom. And of course, you can change this number 0 to 5. I just wanted to show you the most extreme example. Now, to make things extra complicated, you can actually do this where it varies from one breakpoint to the next. So we can do the property, like padding, the sides, like top, then a breakpoint, then the size. So just as a quick example, I could say, I want this one, let's make a new button here. Or should we do a button? Sure, just do one more button here. Button with a class of btn, danger, and then I'm going to give it some text in here, I change. And then I'm going to give it padding 0 on all sizes to start, and then I'm going to say, actually, I want you to have padding on small and above of 1, and then padding of medium and above of 2, and padding of, what do we have next? Large and above 3, and let's jump to 5. Padding of extra large and above of 5. All right, so I shrink it down, no padding, level 1, level 2, level 3, level 5. And we're applying it to all sides, but I could also do it just on one. I could say I want padding top, large, 3. So the syntax is kind of confusing when you're starting out, but this can be really useful. We often want things to have different amounts of padding, or especially margin, on different sizes. As things shrink down, we might want less, margin. So let's just do one more example with margin. We haven't done any, but let's do an example. Let's add some margin to this row of buttons. It's very easy. It's the same exact syntax we've already seen, except M. So I can just give this div a class, margin top dash 5 will give me margin on top. 5 is our highest level. I could also do it on the bottom, or I could do both, margin Y, which is top and bottom, and now we get extra space there. Same thing, I could go to this H1 and give it a margin bottom of 3. And that adds a bit of space, or I could do 5 and that will add more. Or I could remove the margin entirely on the bottom, margin bottom 0. And there we are. Okay, let's go back to 4 or 5. So that's a brief rundown of some of these utilities. They take some practice and some getting used to, but they are incredibly useful. Nothing that we can't do with plain old CSS, just a shorter way of achieving it. And these margin and padding ones in particular take a little bit of time to get the syntax down, but just remember M or P, and then the sides, and then the size. And optionally, we can specify a breakpoint if we want our classes to only apply on certain sizes. All right, so to wrap these utilities up, I'm not going to go over the next couple in detail. I'm not going to show examples, but I'll just point them out that they exist. So we have some nice display utilities. This one is actually pretty useful. We can use this to change the display property, right? Make something inline or block or flex, but also we can set something to have display of none. And that can be really useful. D-none will hide an element, but we can do it responsively. We can change a breakpoint where we show something on a large size and then hide it otherwise. So they show you how to do that here. If you wanted to hide something on extra small, we set display to be none, and then we say, actually, once you get to small, set it to block. And this is a way of showing and hiding something depending on the screen size. So that's commonly used. We have flex utilities. We've already seen these. We can change flex direction, flex row, flex column, and all of that. We can do it based upon the screen size, justify content, all of these. I showed you them based upon the screen size, align items, blah, blah, blah. Very useful. We have the ability to change the size of elements. So the width, like W-25 or 50 or 75 or 100. So we can't do W-80 to get 80%, but if we want something to take up 50%, W-50. And that's pretty much it. There are others, but they're not as commonly used. So it can be a bit overwhelming. Don't feel like you need to use them all right away, but it's important to know that they are there. And if you plan on continuing to use Bootstrap, which is a choice you have to make at some point, it will definitely help you to get familiar with all of them. All right, this will be a quick video. I just want to run through some of the other components we have not talked about. I'm not going to write any code or show them to you in any detail, but I just wanted to highlight some of the ones that you may want to know about. There are some pretty niche ones I won't go into, but the first one, card, is pretty commonly used. It's just a generic sort of content holder, a content container, where we can mix and match. We often use these in the grid system. So we can have a grid of cards. We have the options to add titles, subtitles, images on top. We can add what's called a list group, which is another component I'll show you in a moment. Here's an example with all those pieces together. You can add a special header and a footer. So lots of stuff you can do with them. They're very flexible, and they're basically a box with a border with some special pieces inside, a title, a header, a footer. And they're all optional, but you can create nice grids and display your content nicely using cards. Okay, next up, carousel. Carousel is a bit more complicated. It's how you can make a slider, like an image gallery or an image slider. There's a lot of parameters. You can show the, the controls and the indicators down at the bottom, or you can just have an automatic slider where everything's hidden and the user doesn't do anything. You can add fades versus a slide effect. So behind the scenes, this involves a lot of JavaScript, but the way that you make this work is by connecting your controls. So for example, this right arrow right there is created right here. Using this carousel control next, you set its data slide to be next, data slide to be previous on the previous button. And then we need to make sure that we're using our carousel class and the slide class, and then something called data ride equals carousel. This is another one like a nav bar where I always have to consult the docs. So feel free to do that. I mean, feel no pressure, hopefully, to memorize any of this, but especially not carousels. So those are useful. Drop-down menus we did not cover, but they look like this right here. So we have different sizes. We can attach them to buttons. They can pop up versus popping down. They can pop right and left. We can have different stuff in the menu. We can have different alignments. There's a lot here. But honestly, I think that's all I want to show you is the fact that they exist. Okay, spinners. Not essential, but nice to know about and super easy to make. Just spinner, and then there's different options. So spinner-grow or spinner-border makes us this rotating round border. There's progress. I don't even know why I picked that one. I almost never use that, but it exists. Then we have modals, which are basically pop-up dialogues. So they involve a lot of JavaScript too. You need to figure out, or you have to specify what should launch it, what should close it if there's a close button. And there's different options. You can make a scrollable one like this, where you scroll in the container, or one like this, where your entire page scrolls. You can center them vertically. You can use the grid system inside of them. So there's a lot to them, but that's all I'm going to show. They exist. So we've seen a lot of Bootstrap, but honestly, maybe 50%. Although if you weight it for what's most commonly used, then we probably saw 80%. So there are lots of niche things, and not even niche things. So, like a drop-down menu is useful, but you may not need it on every single website. And if you do, we have the tools now. Hopefully you feel confident enough just to look at the docs and honestly copy and paste and tweak whatever you need. All right, so I'm going to go away. It's been great talking about Bootstrap. Hey everyone, just a quick note about the upcoming section here. It's a project section, a code along. We build this website. I'm calling it the Museum of Candy. That's not what I'm here to tell you about though, even though it is kind of fun. It's responsive, it uses Bootstrap. What I am here to tell you about is that this section is actually the only section currently in the course that was also part of the original course. So this Museum of Candy code along, I added to the old version of this course towards the end of its life. And when I uploaded and published the new version of this course and removed all the old stuff, a lot of students were asking what happened to this and if I could still include it. It's still up to date with Bootstrap. It's still relevant, so I decided to add it back in. Completely optional. Everything here is optional, but it's just a chance to practice Bootstrap. I'm not really showing you anything new, right? If you want to skip it and just go into JavaScript, by all means do that. But if you're somebody who likes the projects and the code alongs and you were looking forward to this, here you go. I'll explain more about how it works. Again, it's just Bootstrap with some CSS, some fancy images, some fonts. So that's really all I have to say. This has been added to the course after the fact, after I redid everything. It's been brought back from the dead. So watch it if you'd like, otherwise skip it. Okay. All right, welcome back. So we're going to start a new project here using Bootstrap. I wanted to make something that didn't look very bootstrappy. And the whole idea of this website, it's called Museum of Candy. It's for a fictional Instagram museum. I'm doing air quotes, but you probably can't see me do that when I say museum. There are these things, at least in the big cities in the US, that have been popping up where you pay money and you wait in line. and you walk through a couple of rooms that are decorated in lots of colors and different props, and you take pictures, usually for Instagram. And I'm not a huge fan personally because I'm kind of disappointed by them because they have names like Museum of Candy. That's a fictional one. But then it's not really a museum of candy, and I want to go to a museum of candy. I love candy, or whatever the other things are. So I'm kind of disappointed in that. It's not. I'd love to go to a real museum of candy and try a bunch of them, learn the history. But no, it's just a bunch of photos. But to be clear, Museum of Candy is not a real company. It's fictional. Here's the website. I went for sort of a trendy look, minimal, light pastel colors, some nice photos that I found that we can actually use for free. So the site doesn't really say much as far as the content. The copy is very basic. It's just lorem ipsum, actually, aside from this block of headers here. But it is very responsive. You'll notice there's a nav bar up here. It changes color as I hover, but it's transparent at the moment, and as soon as I scroll, it fills in. So that's a nice little trick. It also is fixed to the top. It's not terribly difficult to do. Then we have, this heading section just with the title of our Museum of Candy. Fancy little trendy slashes. We've got this photo on the right. Then the main layout of the page is these large square photos that we force to be square. And then on the right, we have text and an icon and some more text centered vertically as well. And that's pretty much it. But then you'll see that it's nice and responsive. And at some point, this text completely goes away. And we end up with this taking up 100%. It looks nice. And keep going further. So you can see that our content scales relatively nicely. And then we hit this breakpoint here where things stack. So our text goes above the images. Text goes above the images. And that actually requires a little bit of work because you'll probably notice here, for example, the image is on the left. It comes first. And then we have the text. Then this text comes first before this image. So they're sort of alternating. But then when we collapse it, you'll see that the text always goes on top of the corresponding image. So that involves a little bit of work. Bootstrap makes it easy to do that, but we have to add some classes to change the order once things collapse. And in addition, the navbar does shrink down and collapse into this. We could add a background if you prefer. I thought it looked kind of nice because we have this dead, empty, negative space here. And that's honestly it. So it's not terribly difficult, but it's not that obvious that it's made with Bootstrap. There's none of the default components, none of the fonts, the colors, none of the buttons. The only thing I guess is the icon right here to toggle it. But otherwise, everything is pretty customized. And even if it's simple, I think it looks pretty nice and trendy these days. These photos, by the way, are from a website called Unsplash. I've mentioned it before. Great resource, free, and they're open to be used for whatever purposes, commercial or non-commercial. I put some of my own photos up there. And yeah, I just highly recommend checking it out. So that's our goal here, to create this layout where if we think about the grid involved here, it's not that challenging, or it doesn't seem challenging. This is 50%, 50%, 50%, 50%. One thing I didn't hit on yet, this icon does disappear right there. See, it goes away. It takes up too much space, so I just got rid of it, and we get to use that display utility to take care of it. Anyway, we're going to start in the next video with the navbar and the background color. Let me just quickly run through the starter code. So here's what you have in this folder, Museum of Candy. There's the final and the starter. So we're working with the starter, and it contains index.html. I already gave you Bootstrap, but I also included the font we use. It's called Nunito, however you pronounce it. I included the font, and Bootstrap is in here, and there's a custom style sheet that is currently empty. I just added it in so we have a place to work. And other than that, it's just a plain template to start on. There is an images folder that contains the images. I don't think they're going to load in here, but there's this first image. We'll go over them. And there's also an image for the icon right here. So in the next video, we'll start the project, but I just wanted to introduce it here. We're going to begin with the navbar and getting it to become transparent, change the font. There's a bunch of things we have to do to make it look nice. All right, that's coming up. Welcome back. In this video, we're going to start on the navbar for Museum of Candy. So I have the index.html open. and I'm going to open it up in my browser as well. Currently nothing to look at. So let's start with an easy win. Let's give the body the background color. So I'm going to open up my app.css as well. I want both of these open. So in app.css, I'm just going to select the body, and the background color is a hex code, which is F5D9DF. F5D9DF. And we'll save and refresh. All right, we officially have the pink background going. Now let's get to work on the navbar. So the markup for the navbar, I always struggle to remember. I'm looking at it right now on a different screen, so I'm cheating. Don't feel bad if this doesn't come naturally. So we make a nav, and we're going to give it a couple of classes. The first is just navbar. And then because the text is light on this navbar, especially if you can see it better here if I scroll, we want to give it the class of navbar dark. And then if we give it BG dark just to start, so we can just see what we're working with, we're going to remove this, but it will make it easier to see what we're doing. Then we have to decide where it should expand. And if you watch this navbar, it shrinks, so it's collapsed on extra small and small. Then we hit medium and it expands. So that's what we want to do. So that's just navbar dash expand MD. And then we can start with that, not stop. And I like to give my navbar an ID because sometimes you might have more than one. It's not that often, but you might have a fixed one at the footer. You might have a sidebar. So I'm going to give it the ID of just main navbar or something like that. Then inside of it, we have our navbar brand that just says candy. Then we have home, about, and tickets, which are different links. Okay, so we'll start with the navbar brand. So A with the class of navbar-brand. And we'll leave the href just with the hash sign for now. And we're just going to type candy in all caps. Now we have the problem of the navbar toggler markup, and there's a lot that goes into that. So we're going to make a button, and this is just coming from the docs. That button has a class of navbar-toggler. I think it used to be toggle. Now it's toggler in Bootstrap 4. Then we're going to tell it data toggle equals collapse. So this just says that this is going to collapse something. Then we have to tell it what it's going to collapse. So data target. Well, we don't have that set up yet. So we'll come back. The next thing we're going to do is add the span that has the class of navbar toggler icon. Navbar-toggler icon inside that button. So now we should at least have a button showing up at the right size right there. It's just, it's not working because there's nothing for it to collapse yet. We have to fill this in. So after that button, I'm going to make a div, and I'm going to give it the class of collapse, and I'm going to give it the class of navbar-collapse, and then also an ID. And then I'm going to reference that ID as the data target. So what would make sense as an ID for this? I would just say nav links maybe, because that's what is collapsing, right? It's these links here. You can't see them anymore. So we'll go with nav links. And then up here, I need to say data target is nav links. It needs to match, and I need to say that it's an ID because we don't have to do it through an ID. Okay. Then we're going to go and add in our actual nav inside of this navbar. So just 3 links right here. And the markup for that is we can do a UL. We could do a nav. It's up to us. I'm going to do a UL with the class of navbar-nav. Again, this is mainly coming from the docs. And then inside of it, I'm going to add in an li with the class of nav item. And then inside of each one of those, we gave an anchor tag with the class of nav link. So the first link was, what is it? Home, about, and then tickets. So we'll start with home. It's all caps. Technically, we could lowercase everything and then uppercase it using CSS or using even Bootstrap, but I'm just going to leave that. So home, about, and tickets, and save. And we should at least have some content collapsing. Cool. So that part's working now, and it should expand. We're getting our content. We'll worry about the CSS as far as the font, the color as well, and then also the size. You'll notice that these links are larger than what I have here. We also changed the hover color and all of that. One thing I do want to do is go to the button and make it more accessible. So this navbar button, it doesn't actually have a label to explain what it is. There's no text on it. It's 3 lines. And to human eyes, we understand what that means. But if we're not viewing this website with our eyes, if we're using a screen reader, for example, this is not very meaningful at all. We don't know what clicking this does. So what we can do is come into here to the button itself and add in a class, called aria, or it's not a class, add in an attribute, aria-label, and then we'll just say what it does. Toggle navigation or toggle navbar or something. And functionally, there will be no difference that we can perceive, assuming I don't mess up the quotes. There we go. So it looks the same. It's just to make it a little easier to understand what it does. All right, so that's it for the markup portion. We now have to go in and deal with all the CSS. And the first thing we could do is remove this background color. The only problem with that is that this pink is so light, it's kind of hard to tell what's going on. Compare it to this blue, which some people might still think this is a bit difficult to read. And in that case, we could darken this image in Photoshop or something. We could even do an overlay on top. But this, or you could just change the text color, of course. But I think it looks okay. But this is a little harder to read. But let's go to CSS. So our app.css file, we've already changed the background color of the body. Now we have a couple of things to alter. First, our main icon here, that's not even an icon, the navbar brand is red. And it's also a larger font size, and also the font of everything is different. So why don't we start by changing the font? So in the body, which we've already changed the color of, I'm going to say font family is the Google font that I imported already for you called Nunito, something like that. And we'll save, pay close attention here. It's kind of hard to tell, but the font did just change. I promise it did. Next, we're going to alter the brand, which is supposed to be, if I zoom out, supposed to be larger and red. So the navbar brand, instead of altering all navbar brands using that class, I'm going to say inside of my main navbar, we gave it that ID, if you remember, the navbar brand inside of that, navbar-brand. So a nested selector like that. And then I'm going to change the color, first of all, which the color is EA1C2C. EA1C2C. It's a nice red color. And you can see that that's already taking effect. I'm also changing the font size. So the font size is 1.5 rems. It's a little bigger. Now the last change, it might be hard to tell on the screencast, but the font weight itself is lighter here. This is a very lightweight font, and this is thicker. So we can change that to do font-weight 100. Oh, refresh the wrong page. There we go. So now it's a lot thinner. Now I'd also like to get this to change font weight as well, and font size. And this works well, except for the fact that I also want to make these larger. You notice that they are all the same size, and these are lighter weight as well. So instead of doing navbar brand and then separately doing the font size and font weight to do the same thing for the actual nav links, what I can do is just say everything in the main navbar should have font size of 1.5 rems and font weight of 100, and I can remove it from here. We still need to keep the color here for the navbar brand because it's the only red thing. Okay, so now we're getting on the right track. I guess that's what I'm saying. It's looking a little better. You'll notice that this kind of bothered me. The default color when you do navbar dark is not white. It's like a transparent white, and you hover and it turns white. So to make them true white, we need to manually select them. So I'm going to put this first here, and then it doesn't matter at all, but I'm going to say main navbar and select those links, which if you need a refresher, each link is nav-link. So I'm going to do nav-link inside of main navbar. I'm going to set the color to be white. And now they are fully solid white, but we can't tell when we're hovering. So I'm going to make them turn this color when we hover. So I'm going to duplicate this, but then add in the pseudo selector hover, which if you're not familiar with that, it just says whatever is in here, you should apply when we hover over this element. So if I did something like background purple, as I hover, the background changes to purple. But what we want is just to change the text color. So color is this red that I copied from the navbar brand. And now I hover and it turns red. Cool. So what else do we have to worry about? There's a small thing. It might be hard to tell, but this has less padding. If we actually inspect the navbar here and where it actually, I'm going to go full screen, where it takes up the space. Let's go to the navbar. Here we go. Notice that it's all blue with a little green on the sides. I don't know if I can't point that out very easily. But now if we look at the navbar over here that we're working on, if I inspect it, there's also padding on top. See that green on top and bottom? So I'm going to remove that padding on the top and the bottom so that we get a narrower navbar. And that's easy because we now have that padding utility. I can go to my navbar and just say padding P, and I want Y because that's top and bottom. I could do padding top 0, padding bottom 0, or padding Y 0, and that does both of them for me. Watch closely here. You'll see as I refresh, it just shrinks down a bit. It's closer to the top. There's not so much padding. It's a very slight change. It's not very obvious, but it is one that I did. Now there's another thing that we can't really tell at the moment. This navbar is not fixed to the top. This one is. As I scroll, it stays up there. Well, I don't have content to scroll through right now, so it's not going to stay at the top. Or I'm sorry, it is going to stay at the top no matter what. But if I added some content in, just to show you, you don't need to do this, but let's just say I add a div, and inside of this div, I add like lorem 1000. Is that going to be enough? Nope. Let's see. I'm trying to make this work better. How about I add a container, I add a row, I add a column 6 or maybe 4, and inside of that, I'm going to do a ton of content, lorem 1000. Again, you don't need to do this. But now you see I scroll and my navbar is not fixed. So in Bootstrap, there's a really easy way to make it stay at the top. We just say fixed top and refresh the page. Now we have this problem. Our content goes on top. We'll worry about that in a little bit, but you'll see that it stays up there. Now it's kind of weird because this is all on top of it, but our content is working, or our content is working. That makes no sense. Our navbar is fixed to the top. That part's working. And it looks good enough. So I'm going to now delete all of this at the bottom. And I'm going to leave the video off here. We do still have to tackle this little thing where it changes color, but I'm going to wait because we actually have to write some JavaScript for that. And don't worry, you don't have to be good with JavaScript. It's just a little thing that you can copy and paste in. But I want to wait until we have more content to fill out the page anyway, so that we can trigger it. So that's it for the navbar now. Let's just make sure it collapses correctly. We have our icon here. Still get the hover effect. The font is lice. Oh my goodness, I need to take a break. The font is nice and light, not lice. And we change the color. It's transparent. Yeah, it's looking good enough to start. Next up, we're going to tackle the rest of this sort of heading section, including this Museum of Candy monolith. Welcome back. So now that the navbar is mostly done, let's tackle the next bit of content, which is this top section here, where we have this image on the right with the gloved hand holding a donut for whatever reason, and then this series of headings over here, and they scale, so that's going to be some work. You'll notice the font size actually changes right there. So that involves some non-Bootstrap CSS media queries to do that. Then also the text just disappears entirely and this image takes up the entire space at one point. And other than that, I guess the fact that it's centered vertically we have to pay attention to, but it's not too bad. So that's what we're going to get to work on. And we'll start by adding in our index.html underneath the nav, we'll add in a new section. And we need to use a container because we're going to be using the grid system here. But remember that a regular container goes only part of the way across the screen, and this content goes all the way across. You can tell over here. I'm using a fluid container. So a fluid container works the same way. You can use a grid system inside of it with a row and columns, but it goes all the way across. So that's what I'm going to use. So I'm going to do a section, the class of fluid-container, or is it container fluid? It's container fluid. I always mess that up. And then in addition, inside of that, we have one row, and they're splitting it 50-50. So this is 6 out of 12, and this is 6 out of 12. So let's begin with let's just make those two. So let's make the row. It's a row, which is a div with the class of row. And then inside of that, we have 2 columns. So div with the class of column 6, and then another column 6 below. And in the first one, let's just put some placeholder text. Let's just do like an H2 that says Museum of Candy to start. That's not going to be our end all be all. So you can see right off the bat, we have a small issue. Let's get the image in first before we worry about anything else. So this column 6 on this side, we have the space designated, but there's nothing in it. We're going to put an image, and the image we want is included in the images folder. It's called hand2.png. I know it's not a great image. I had a hand1 and I deleted it. So it's hand2. Hand2.png. And if we just leave it like that, it's inside of the images folder. IMGS. You'll see we have a small problem. First of all, this is huge, but it is going 50% across the screen. What we can do is give it the class of image fluid. This is a Bootstrap class to make images responsive. If you look here on the docs, it mentions to make an image responsive, you can give it the class of image fluid, and it just changes the height property to be auto and max width to be 100%. It just makes it easier to work with images in the grid system and make them scale so that it shrinks down at different sizes. All right, so we're gonna have to fix the fact that there's still 50-50 here. We'll get them to stack. But we also have this issue on the side. If you inspect what's going on, it's kind of hard to see here, but the container, where are you? Container fluid has padding on the left and right, just a little bit of padding. So we're going to get rid of that. On the left and right, the way that we do it is by going to the container and saying px0, padding x, which is the same as padding left and padding right, 0. Refresh the page. That padding is gone. Now our content goes all the way over, including this. Next, let's talk about how we align this content vertically. So if we look at what's going on, we have this image going all the way across the row vertically. It's taking up all the space. Over here, we have all of this empty space, and Museum of Candy is just at the top. So the property we want to use to align it vertically, if you watched a couple videos ago when I talked about Flexbox and the grid, the property we want is align items. So align items is going to, depending on what we tell it, like if we did align items on the row, end and refresh, our content now is aligned at the bottom here. But I want center. And you'll see that our content is now centered. Next, we want to make sure that our text is centered, and that's easier. We can just give it on the actual H2, the class of text center. We're going to have to rebuild this content anyway, but we're sort of approximating the content. So this will fill in with this in a little bit, but we have some content on the left and our image on the right. Now we need to tackle this problem of getting it to collapse. I want this entire thing to go away and have this image take up all the space once we get to, let's see, which breakpoint was it? Right here. So I believe this is large. So extra small, medium, or extra small, small, and medium, there is no heading over here. This is gone. So to get that to work, we need to go and change our classes. We only want this to be column 6 at size large, and this to be column 6 at size large. Now if we refresh, okay, it's sort of working where they are side by side, 50-50, and then once we get to medium and small, they stack. But we don't want to see this period. It's not that we want it to stack, we want it to go away. So to get rid of it, we can set the display to be none using those display utilities. So I'm going to start, make this a little easier. I'm going to make 3 of these, and then I'm going to wrap them in another div so that I can hide them all together like this and indent them properly. There we go. So now I can say something like, first I could do text white, for example, and they're all going to be white. Second of all, I can get rid of this text center on all of them, delete that, and center them all because of this div. So I'm just reducing duplication to start, and they're centered, which doesn't look any different from before, but now we only write text center once. But the most important part, I can say, hide yourself, don't show up, but then I'm going to say, all right, you can show up once we get to large. So we say D large block. So hopefully that's a review from earlier when we talked about the responsive display utility. There's no extra small size, so we say display none from all sizes except large and up should be block. So now we have most of this working. Our content, I actually kind of like how this looks too with these smaller text. You could leave it at this, change the color. You don't have to make it large like this, but we're going to because I promised we would. And if we shrink it down, everything's still centered vertically. And then down here, our image is now underneath our navbar, and it looks really nice in my opinion. Keep going, get it to collapse. Yeah, it looks pretty good. Okay, so next let's focus on the text. First of all, if we count how many of these we have, 1, 2, 3, 4, 5, 6, 7 Museum of Candies. So let's go ahead and duplicate. Well, actually, let's make one of them correct first, instead of doing all of them and then changing them all. So we have a couple things to tackle. One is the font size and the font weight. This is thicker text. This is light text. Also the slashes. So we need to single out those slashes and make them red. And this part's a little annoying, but I'm going to make a span for each one and put a slash in the middle of it. So we have that span, and then we're going to do another span. So museum /of/candy. And then we can go into our CSS and style those spans. And you could give them a class, honestly. It's going to clutter your markup a bit. Or we can just selectively, we could say, give this an ID. Let's call this heading. And then, or let's actually go with heading group. That's more specific. And then I can say in my app.css, inside of heading group, all spans, we're going to make them red. So rather than just making every span red on the entire page, because we might have more spans later on, this is more specific, only inside of that heading group. And if we refresh, cool, we're getting that Museum of Candy with the red slashes. Next, let's work on the font weight. So what I did, we don't have to do this, but I used the display2 class on the H2. So we've seen that display 1 through 4. It just makes it larger. And am I zoomed in? Okay, so this is a little bit too large, as you can see, and I scaled it down, which we will tackle in a bit. The next thing we'll do is change the font weight. So we'll come back into our CSS and select, it's up to us how we want to do this. We can select all the H2s, which now that I'm thinking about this, it might make more sense to make these H1s because they are the largest piece of text on our page. And then I'm going to go in and select the H1s in the heading group once again. And so I'll just duplicate that. Heading group H1, instead of changing the color, we're going to change font weight to be 100. So it's thinner. So that's the first step. Next, I'm going to give them a size, a font size, which is 4 rems. And I just did some trial and error to arrive at that size. Now let's make 7 of them. So I'm just going to duplicate 3, 4, 5, 6, 7. Save. There's our content. And you'll see that it's a little cramped up here. So I went and added in some margin top to the heading group. So just here, margin top -5, refresh. We have a bit more breathing room up there. And you could tweak that number and play around with it. So this looks good, except we run into a big problem right here. Our text is not scaling. We need it to shrink down. So if you look at my version here, I have it shrink right there to a different size, scale it down, and then it disappears. So we can do that pretty easily, but we have to take advantage of a media query, which we haven't really chatted about very much. So media queries allow us to selectively apply styles based off of different screen sizes. And the screen size that we're going to use is right about here where it starts to get ugly, about 1200 or so pixels. So the way we write it is at media, and then we're going to say max width, and then a screen size, like 1200 pixels. And then inside of here, whatever we change, let's say we make the body a different color. Let's say color, I don't know, orange. And this should be background color. All right, so let's take a look. Once we hit less than 1200, it's right there. So we can play around with this number. So imagine this is our size of our content. At what point do we think it's too crowded? I think it looks okay still. Still looks okay, but then maybe, yeah, right? Honestly, that's about the point where I would change it. So change it to be smaller font size from then on out. And the way we can do that is in here, instead of changing the color of the body, we're going to select those H1s inside of the heading group and change their font size to be maybe 3 rems. Let's see. Is that going to work for us? Right here. There we go. It shrinks down. And it looks good. Yeah, that looks great on all sizes. Now we could add another one in if you think that it's a little too cramped right here. We could change it to be like 3.5 rems because right now it's 4. But it's just one little breakpoint that's problematic. So I think it's okay, honestly. So here looks pretty good. Looks good in all sizes. That's our first introduction to using a media query. And I'll leave it at that for now. Our heading section is complete. We have the image. It's responsive. It looks good. Next, we're going to tackle these 3 sections down below, which are all pretty similar. They're just in reverse order. And then we're almost done. Welcome back. Next, we're going to wrap up the Museum of Candy website by adding in these sections at the bottom where we have some text and an icon and then a large photo, and then they alternate sides, different images. The text is all the same for now, but this would be content that varied depending on what you were actually, this would be information about the Museum of Candy and hours or local address or whatever. And remember that the icon here does disappear. There it goes. So it comes and goes. Things stack, so we'll have to play around with the order a bit. I already mentioned that. Where here, the text is on top of the image, and then the text is on top of its corresponding image. But when we expand it, this image actually came before this in the row. So we'll play around with reordering things. Anyway, here's what we have to start. So let's go ahead and open up our code and go to our index.html. And after our heading section, which is right here, I'm going to come down and I'm going to make another section. And this one, I'm going to make a container fluid again, which is just like what we did up top to make this section. We want our images to go all the way across. Well, not all the way across, but we don't want any spacing on the side. So container fluid, and we'll do the same thing where we add in the px0 just to remove all padding from the side. There's a tiny bit we get for free. Inside of that, we're going to make a row. So let's do that now. So a div, give it the class of row. And then if we look at how it's broken up, it's just 50-50 again. So we'll worry about the spacing later, this extra margin, but 50-50, so that's going to be 6 and 6 units. So we'll have our row, and then inside of the row, we're going to have a column 6, and 2 of those actually, div column 6, div column 6. And in the first one, we're going to put this image, which is called milk.png. So that's inside of that first row. We'll do an image, and it has the source of images/milk.png, and we're going to give it that class, if I can spell class, of image fluid, just like we did up top. And save, and we should at least have the image taking up 50% of the screen. It looks good. Now, right now I have it to be 50-50 always, and we're going to need to change that. So if we look at the breakpoint where it's happening, they're stacking, or they're stacking small, extra small, and we hit medium, they expand. So let's change this to be column medium 6, both of those, and refresh. Now once we hit small, there we go, it stacks. Now we need to add in some text on the right side. So the way that I did this is a little tricky because if you pay close attention, you'll notice this is divided in half. So this is half, and this whole square of space is the other 6. But this content doesn't go all the way across. Actually, if we inspect it, you'll see that it's contained in a box inside of that 6. And I did that because I didn't like how it looked when the text went all the way across and it was really sort of thin. Well, thin is the wrong word. It was very short as far as its height, and it went all the way across. It just didn't look good. So what I did is I used the grid system again. I nested a row inside of this column. So if we have 6 and 6, then ignore all of that and just focus on this square over here. Inside of that, we have 12 units again. And I said this should take up 8 units out of that 12, and it should be centered. Then as you shrink it down, I thought that was too narrow. So I actually, you can see right there, it grows, and this is 10 units out of 12 now. So it's kind of hard to tell, but I'm going to show you what it looks like. Let's put our text in there first without actually any of the nested stuff that I was talking about. So inside of this column medium 6, we could just start by adding an h2 with the class of, well, we need to center the text, but we can actually center everything together. So I'm going to just do an h2 for now, and it says Museum of Candy. And then below that, there is the icon, which is an image, and it's called lolly_icon.png. So it's images / I'm not sure how you spell lolly, if it's supposed to be with a Y, but that's how I spelled it. Apologies if that's confusing. And then we'll worry about getting it to display or hide and show in just a bit. And then below that, we have a paragraph with the class of lead. So lead just makes it stand out a little bit more. You could get away without doing that. And I'm just going to steal the block of lorem ipsum I had, or you can just type whatever you'd like there and save. Let's see what we get. Okay, so first of all, nothing is centered vertically or horizontally. So the text center part is pretty easy. We can just come to our row and say text center, and now the text is centered. Now, as far as making it centered vertically, the property for that, if we're talking about the Flexbox utilities, is called align items. So we have all this space here. How do we distribute it vertically? We use align items. If we had excess horizontal space, it's justify content. So we're going to want align items center. So we'll come up to our row, align-items center. Refresh. Now it is centered. But notice how it looks here. I wasn't a fan of this. Maybe if we had more text, it would look good, but I don't like how this looks. So what I did, and same thing here, I want a little spacing, but not a ton of spacing, but a little, as you can see on the sides. But then as we grow it, there's even more spacing on the original. So I ended up nesting another row inside, as I've already mentioned. So we're going to do that now. Basically, I'm going to take all of my content right here. I'm going to cut it out for a moment, and I'm going to make another div with the class of row. And inside of this, I'm going to make another column. So when I say class equals row, I get 12 new units of space to work in, and I'm going to use up 10 of them to start. So it's going to be column 10. And put my content in there and save. And if I refresh, you can see now that I'm basically using 10 out of 12 of these units, but it's not centered where I want it to be. So we're using 10, and then there's 2 over here. What I want to do is have those 10 be in the middle. So what I could do is just make another column 1, not colt, column 1 right there, except it has to be a div, of course. So like this, and then an empty one before, and then an empty one afterwards, like this. But I don't really like that approach, but it is centered now because we have 1, 10, and 1. But the better way is to just use the flex utilities to center it horizontally. And to center it horizontally rather than vertically, it's justify content center. That's how we control, well, okay, it doesn't look any different, but if I remove it, you'll see it's not centered. I add it back in, or let's change it to justify content end. It is centered, or it's not centered. It moves to the end. Anyway, so justify content center is what we want. So I think this spacing actually looks fine, but if we look at the version that I did, I even had it narrower on the large and extra large sizes. But then as it shrinks down right there, nope, right here, it goes to 10 units. then I actually had it grow or shrink to 8 units to keep it sort of more compact. Again, just a stylistic thing. You don't have to do that. But what I did to make that work was I came over here and I made it column 8 on large and greater. So extra small, small, medium, it's 10 out of 12. So we won't notice a difference. But as I grow it more, once we hit large, which is back there, it now grows, or it shrinks down to be 8 out of 12 units. And so that's what it looks like. Next, we have to tackle the styling, of course. So the color of this header, we got to get this to hide and show. So that part's easy. It disappears once we hit medium and small and extra small. So the way we do that is we come to the image right here, and we can give it the class of display none. So that's going to hide it always. And it's just D none, not display. So it's gone on this one, or it should be. There it is, or there it isn't. And then we go and say, once we hit large, make it inline. So you'll see now it's gone here, but then it reappears there. Okay, next there's one thing we have to do before we start changing colors and font weights and that sort of thing. What we need to tackle is the ordering of everything. So when it shrinks down, this image is coming before our text, and that doesn't really look good on mobile. I want the text to come first. It's more important. So what we do, we didn't really talk about this, but there are classes in Bootstrap that we can take advantage of that have to do with order. So I can actually assign order to my pieces. So the first thing is this column 6 with the image, and the second one is this one right here. So what we do is use the classes order dash and then give it a number. So let's give this one order dash 2 to say it comes second, and this one order dash 1. And if I refresh, you'll see they swap. And that's not actually what we want, because now they're always swapped. But then I shrink it down and it goes the way that we want it to work. So what we do instead is say order 2, except once we hit medium, now you become order 1. And this one, once we hit medium, you become order 2. So it says this one is always second, except after medium, it becomes first. This one is always first, except after medium, it becomes second. And if we refresh, now, because we're after the medium breakpoint, this one is first, but I shrink it down, and they swap. Next, let's go ahead and style our text, and we'll add in some of this spacing here. So let's go to our app.css, and if you remember, we're using an H2 to make this Museum of Candy. So we could either select all H2s, we could also give this a class. Let's just say all H2s for now, that's fine. I'm going to give them a color, and I'm going to give them, let's start with that, H2s. The color is that red color we've been using already, EA1C, 2C right here. Whoops, I just deleted the color part. All right, so that should change the color. There we go. They are too thick. We need to change the font weight. Same thing that we did right here. Where is that? Font weight 100. So we can copy that. We do have a little duplication going on. You know, we're assigning this color to multiple things, although the hover is one that we can't really refactor. But for example, assigning it to the spans, if you wanted, you could make a class called red or something and apply it to all these elements, but I'm okay with a little extra code. So font weight 100, refresh. All right, so we're getting the thinner. That looks good. We also are going to change the font size a little bit. I think it's too small. If you compare it, this is larger. And I happen to know that it's 2.5 rems. So I just played around with that. So H2's font size, 2.5 rem. Refresh, and it's larger. It's the same size as that. Cool. Next, we have our text in the paragraph, which we gave the class of lead. So it's up to us how we want to select that. We could say all paragraphs, but we might end up using other paragraphs instead. So I think I'm going to come to my index.html here and give each of these divs that contains the text a class. I'm going to call it like blurb or something. And then that way I can say, instead of all H2s in total, just say all H2s inside a blurb. and I need to make that a class. And then I can also say all paragraphs inside of a blurb. That way I'm just not selecting every paragraph ever. Okay, so all paragraphs inside of a blurb, I'm going to say color is a light pink color, which is F498B8. F498B8. And we refresh. All right, so that's the correct color. But there's a couple of other changes to make still. The first one is font weight, which is going to be 100. Next, we're also going to change the font size to be 1.125 rems. And if I refresh, you'll see it gets thinner, and the font size also shrinks a little bit. And then I also want to space out the lines a little bit. You can see this is longer lines. Is that the right term? There's more space between lines versus here it's more condensed. So on these paragraphs, I'll also say line height is 2.0, or I think I can just get away with 2 without the 0.0. There we go. So that's looking close, right? That's the same, well, I'm zoomed way in, but it's the same colors, the same sizes of things. Now we have to worry about the margin between our sections. You'll see that there's not very much room there. And what I ended up doing, it doesn't really work to use the Bootstrap utilities. I mean, you can add a little bit, but they're not made to add like 100 pixels of margin there. So instead, I'm going to do it through CSS. So what are we adding the margin to? Well, it's between, right now, between this section and this section. So we have a couple of choices for how, when we actually duplicate our sections and make 2 more to round out the rest of the website, do we want them all to be inside of the same container? Do we want a separate container for each one? It's really up to you how you structure it. I like to make different sections, assuming that the content is different. So if this is supposed to be the about section, I would make this about. If this was the contact, but we could also do it all inside of the same thing and just make a new row for each one. So I might do that instead. So let me just show you what I mean. I'm going to duplicate this entire row. So we have 2 of them. If I refresh the other page, there's 2 of them. And I'm going to give each of those rows another class. What do we call it? Let's give them each the class of content or something. So I'll give this one content, and then this second one as well, right here. And then I'll duplicate it later. And so now I can come over here and just say content, give it a margin bottom, for example, or margin top, either one, of 100 pixels. And we refresh, and now we have that spacing between them. So this one we do need to reverse, and we'll get to that in just a moment. But this is looking good. I'll leave it off here for now. In the last video, we're just going to change the images and make our nav bar do this little fill-in effect as you scroll with a little bit of JavaScript. And that's pretty much it. There might be 1 or 2 polishing touches we have left. So the next one will be nice and short. Welcome back. In this video, we'll wrap everything up. I lied. I said the last one was going to be the last video, but I ran out of time. All right, we're almost done though. This one will be quick. So we have this second section we've already duplicated, but we need to change the image out and also swap the order there. And that will be nice and easy because we don't have to worry about any of these order classes anymore because this is the order we want. The text is already first, so we don't have to do any rearranging of it. So let's come over to my code and find what we're working with. So this is the second row. What we're going to do, we can get rid of this order stuff entirely and take this and just move it after the text row. So just move it down here and then change the image. So instead of milk, the next one I believe is called gumball. Let's check. Okay. And then we still need to remove the order classes from up here as well. I only did it from one place. And now the order is restored to our world. This is looking exactly how we want it to look. We have the image on the right this time, text on the left. Cool. Next, we can take this row again and just duplicate it. So take that entire thing. We want the first one because that one already has the order switching and it's exactly what we want. We just need to swap the image. We don't have to change anything else. So where do you end? Right here. And then we'll paste that in. Cool. And the name of this image, instead of milk, I think it was sprinkles. Double check. Is it working? Awesome. Other than that, one thing I did change is on the extra small size, I wanted more space here. If you notice, I added some margin in. Compare that to our version, it's all cramped on the bottom. So I should have done this before we duplicated everything. Poor planning on my end. But we can go find the divs that have the text inside of them. So all of that is right here, basically. Let's find the first one up top. So this one right here. And we can just give it some margin bottom, like margin bottom 5. We can start with that. Let's see how that looks. This will be on the first one. So where are you? Right here. But we don't always want there to be margin bottom 5 because it looks okay. But then here we're adding in unnecessary margin bottom and it's not centered anymore. If you compare it like to this one, which is centered close, or it's closer to being centered, this one has that extra margin bottom. So we're going to get rid of that margin bottom at some point. So let's say margin bottom 5 and then margin bottom at medium is 0. So removing it. And I'm going to copy that over to each one of these. Just the 3 bits of text that we have, the 3 sections. And so now they stack with, when they are stacked on small and extra small, we get that extra space. So things aren't running right up against one another. And it looks better, in my opinion. But once we expand it out, it goes away and we don't have all that extra margin down here. Next, let's get to work on the navbar scrolling effect. So this part doesn't really take advantage of anything we've learned so far. It's just to make it look a little cooler, in my opinion. What we're going to do is in our CSS, we're going to define a class that is going to be applied when we scroll. So really all that we're doing is giving it a background color. So we're going to make a class that says background color is that purple shade. Then through JavaScript, we're going to detect when the user has scrolled, and we're going to apply that class to the navbar. So let's define the class first in our CSS. I'll call it scrolled. So let's do that. Let's do it towards the bottom before the media queries. And I'll say navbar, when it has the scrolled class on it, we're going to give it a background color. And the background is, let's see, what color was it? For some reason I have this one in RGB values. I don't know why, but it's 222. This is annoying to do while trying to type 192.222. We could also convert that to hex. And we're going to save. Then we're going to go to my index.html, and I'm just going to add my JavaScript at the bottom rather than as a separate script file because there's not very much to add, and because we haven't really talked about JavaScript. So I'm going to make a script which looks like this, and I can type code inside of here. And if you want to copy and paste this, it might be easiest. I'm just going to type something first. It looks kind of crazy if you don't know JavaScript. And then inside of this, I'm going to say document.scroll. So this code says when there is a scroll event, when something is scrolled or when the page scrolls, we're going to check the nav. So we're going to select the nav. So if we look at our nav, how could we specifically pull it out? Well, we could give it an ID like main navbar. Let's use that. So we'll say $nav is just a name for a variable. Again, don't worry about any of this if it's confusing you. And I'm going to select based off of an ID called main nav. So now I'm going to say toggle class on that nav, toggle class called scrolled. That's the name of the class we defined over here, scrolled. But when do we want to toggle it? When, this is kind of crazy, but this dot scroll top is greater than the nav, $nav dot height. There's a lot going on there if you don't know JavaScript, but I am finding the nav bar, finding this bar, and saying anytime the page scrolls, we're going to check if the top of that scroll is greater than the nav height. So basically, once we scroll past the height of the nav, which is, I don't know how many pixels that is, let's say 50 pixels maybe. Once we scroll 50 pixels, then we're going to toggle the class scrolled. But then once we scroll back and we are less than the height, remove that class. So this is JavaScript and jQuery together. All these $signs, things like scroll, things like toggle class, that comes from jQuery. But I don't want to bog us down with JavaScript. What we'll need to do we can test this and see if it works. We'll see. Okay, we're not quite there. Now I believe what's actually happening is that if I do scroll and we inspect our nav bar, where are you? Main nav, right here. That's why we called it main nav bar. And I was referring to it as main nav. So main nav bar. All right, let's try again. There we go, it's working. Cool. So one thing you might notice though, this is a very sudden transition. It's just appearing versus the original version fades in a little bit. So we can do that really easily using CSS. We don't need any JavaScript. So we're done with the JavaScript. For some of you, it might have been easiest just to copy and paste that. But up here in our scrolled class right here, navbar scrolled, we can say transition on the background. And if you're not familiar with transitions, this just means when the background property changes, which it is changing right here, we want it to take however many milliseconds. We could say 500 milliseconds, which is longer than what I actually ended up going with, but you can see it takes half a second now. We could even make it a lot longer. You can also use seconds if you do 1s. So now it takes a full second, which that's not too bad. The one I went with in the original is 200 milliseconds, but you might actually prefer something longer. I'm not positive what I like the best. Let's go with 500 milliseconds. Let's see how that looks. Half a second. Yeah, there we go. It makes it look deliberate enough, but it's not so painfully slow. And with that, we're basically done. One thing on the solution that is different, I did add some space at the bottom. If we want the space, we can just add some margin bottom. So where we're actually applying the margin, where are you? Margin top. We could do margin bottom, 100 pixels too on each one of those sections. And now we have both top and bottom margin, so we get this extra space. Cool. All right, so that is the Museum of Candy website. It's, I guess it took a little while to make, although when you think about it, in terms of how long all those videos add up to, it's maybe, an hour to make this? And we could probably do it a lot faster if we weren't explaining everything as we went. So it's pretty simple, but it doesn't look very bootstrapped, in my opinion. But it takes advantage of things like the Flexbox utilities, the grid system. We nested the grid, and nice colors, great photos, in my opinion, coming from Unsplash. Really great website. Thanks to the photographers who post their work there. I recommend you check it out if you haven't. We use it later in this course again. Really great resource. Anyway, talk to you later. Bye. Welcome, and thank you all for joining me today. We're gathered here to have our second graduation. Our first graduation was from HTML to CSS. Now we take an even bigger step forward. We graduate from CSS to JavaScript. In preparation of this momentous turning point in our lives, I've prepared a special song.
JavaScript, 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 JavaScript.
There we are. Okay, I'll give you a moment to collect yourselves and wipe your tears away. And we're back. So this is our first JavaScript section, and it really is a big turning point in the course. Yeah, it's a big topic. We've got a lot to cover, and it's another one of those topics that will stay with us from here on out. The thing about JavaScript is that it's a much larger topic to cover than HTML and CSS. So I want to set your overall expectations for the next 10 sections at least when we're covering the very basics. Actually, it's more like, 6 sections of pure JavaScript before we go back to HTML and CSS. So I want to set your expectations that it takes a bit of time. We're not going to be making anything beautiful or all that exciting right away because we have to learn the basics of the language. And there's just a lot more to learn at that fundamental level. That doesn't mean it's hard. It just means that we're kind of going to be on a JavaScript island for a little while. If I was teaching this in person, it's about a week of full-time content. if you're doing it in person. So keep that in mind. This is probably going to be slower. Anyway, I don't want to scare you away. I just want to set your expectations as always, but especially here that, we've got a lot of JavaScript, pure JavaScript content that will feel like you're kind of off on your own and you might miss HTML and CSS, but we will reunite them, I promise. So this section is an intro to JavaScript. So pretty much actually every single thing in this section is going to go under crucial. We can't avoid it. There's no way around it. We're going to talk about the very basics, making variables, different data types, primitives, how we name our variables, different standards or conventions for working in JavaScript. All the topics are green here. It's the very basics of JavaScript, hopefully pretty light. Some exercises, some quizzes in here. Okay, so let's begin our journey with
JavaScript.
All right, I'm excited to welcome you to JavaScript land. This is the beginning of the rest of your developer life. But really, this is a big milestone, getting to JavaScript. It's going to take time and practice, and you'll probably get frustrated. But once you get through JavaScript, the world of possibilities, the things that you can do, just expands drastically. HTML and CSS are great, but on their own, you're kind of limited to making static websites, maybe some animations or a hover effect or something. You can display information, and you can make it look nice. But with JavaScript, we can do so much more. So keep in mind that it's absolutely worth learning. This is a big turning point in the course. We'll use JavaScript from here on out, but also JavaScript requires more attention and practice and time to truly master. So don't get frustrated. I'll say that a lot. Compared to learning CSS or HTML, where it's kind of like painting by numbers, if you want to put an image somewhere or an H1, it's pretty much always the same. You might change the text or the image source, but it's just this simple process. JavaScript is a lot more logic heavy. It is a lot more creative in some ways. There are many different ways of achieving the same end result. And so it's not as cut and dry as just put an H1 or make this thing red. We have a lot of options. Okay, so just to recap the sort of intro to these three tools, HTML, CSS, and JavaScript are the three main tools that your browser can understand and do something with. So when we request a web page, google.com/search, and we're looking for chickens, we're searching chickens, there is an HTTP request that is sent to Google servers. Eventually it makes it to, hopefully, one of Google's servers. Google's server is going to parse what I'm asking for, go and do all the hard work to find chicken search results. It builds the web page for me, and that web page consists of HTML and CSS and JavaScript. It's sent back to my browser, and my browser can render that for me. So JavaScript, so returning to this grammatical analogy where we have HTML as the nouns, CSS is the adjectives, JavaScript is the action, the verbs, the stuff that happens on our web page. So I'll show you a couple of examples of what JavaScript can be used for. So I'm going to start with some simpler stuff and then we'll work up. So here's an example. This is a code pen for an Africa map quiz. I didn't choose it because it's particularly amazing. Well, to be clear, it's not bad or horrible or anything. I'm just not picking it to impress you. I'm picking it just to show you a simple example of what we can do. So this is, let's see, Africa map quiz. It's interactive. We've got a map over here. We could make that with HTML and CSS, or it might just be an image. I didn't even look. And then we've got a button to start the quiz. And now this thing just appeared. Now there's a timer over here, and the instructions aren't very good, but I think I'm supposed to, let's see. So I type countries. Yeah. So as I'm typing, right, it's showing me if I get one or if I don't. So let's pick something that's not in Africa, like France. Okay. Nothing happens. It's not recognized. That's all done with JavaScript. There's logic, right? When I hit enter. So let's do another country in here. How about Tanzania? There we go. It's recognizing as I hit enter. I think if I hit enter, it might just recognize it as I type it. It figures out if it's valid or not. It shows the correct outline of the map, or it colors it in. It gives me a score. All of that stuff is happening dynamically on the page. Here's another example. This is more just a nice user interface. JavaScript is used to animate this plane as I scroll and to change its orientation and to add some nice effects. So as I scroll here, right, it comes into view, it rotates basically in 3 dimensions, then it moves around. It's pretty fancy as I scroll. Ooh, look at that. That is nice. That's pretty cool. So all of this is done with JavaScript. Without JavaScript, we would still have the basic elements on the page. Ooh, that's pretty cool, honestly. I like this. I never got to the end on my own. Without JavaScript, I can turn it off here or just comment it all out. Let's take a look at what we end up with. we've got the content here, right? But we don't have any of that fancy scrolling effect. We don't have things showing and hiding and moving around as much. And my scroll is scrolling the page, but I'm not actually moving stuff. I'm not causing animations. I'm not interacting with anything. Versus when JavaScript's there, when it's actually activated, I might have to refresh on this CodePen. Now I scroll, right? I'm not just scrolling the content. I'm actually affecting a change. So it's pretty cool stuff. Here are some more examples. This is just, I've never used this site, but I searched for stock market live updating, and here we go. Hopefully not, well, might be somewhat depressing, but we've got these stock market numbers that I think the market's definitely close. But we've got these charts that are updating on the right side. It's just changing on its own. I'm not actually doing anything. You'll see that it just changes. Watch these numbers here. These will update. And then as I select, let's go to Asia, we should be able to see, I think the Asian markets are open right now. Things are actually updating live. The charts should be changing. This is all happening with JavaScript. So we can make this content. We can change the color. We could show a graph even, really without much JavaScript at all. But then to update things while the page is still here, it hasn't refreshed, hasn't reloaded, to get new information, new data, and update what I see, that's done with JavaScript. Here's another example, Netflix, right? I can click around, I can play something, that's all done with JavaScript. I can select different seasons. BoJack's a great show, by the way. Don't let the animation turn you away if you're not a big animation fan. I can select something, I can move through all the different categories, different menus here. This is all done with JavaScript and HTML and CSS, of course. Here's a much more complicated example. Instacart, one of the options for getting groceries delivered from different stores, very JavaScript heavy. You'll notice that the page actually never refreshes. I'm never getting new content. We have the ability to add items to our cart and to remove items from our cart. Let's add some, how about some lemonade here? I'll add that to my cart, and you'll see this thing appears out of nowhere. I can open up my cart, and here's my cart. I have a couple of items in here. I can edit them, right? I can delete that. I can change the quantity. I can check out. All of this is very JavaScript heavy. The page is doing things. I'm interacting with it. Here's another example. This is a website for getting glasses made, ordering them. You can order them online. This is not an ad. But what I want to show you, the live chat over here. This is powered by JavaScript. I don't want to do it, but I could type here, right, and hit enter, and I will get a response. Now, that response is not necessarily just from JavaScript. There is a person on the other end eventually, but the fact that I have this window that appears, I can close it. I can, make it pop out. I can hit enter and a message will be sent. Ooh, I'm sorry. I feel like I'm wasting someone's time. Oh, no. Oh, somebody joined the chat. Okay, I got to get out of here. I can't handle this. Long story short, JavaScript does a lot of stuff for us, ranging from relatively simple creating a timer. Ooh, what is this? This is a different version of this game. Oh, cool. This lets me just inspect, click around, and see information about each country. So this is all JavaScript, right? Simple enough stuff, nice animations and UI effects, up to charts and graphs that update live, creating really complex UIs like Instacart, live chat. So hopefully you're excited to get started. Just remember that it takes a decent amount of work up front, and we can't really dive into this crazy stuff right away. It takes time and practice to get there. So hang in there. Let's start JavaScript. Okay, so this marks the real starting point of our JavaScript journey, the first time we're going to see code. Just a quick disclaimer here, I need to explain how this is going to work. Everybody wants to get to the exciting stuff, obviously, the stuff I showed you, like creating chat and games and animations and interactive effects and all of this stuff with JavaScript. The thing is, unfortunately, that those sort of applications of JavaScript require not just understanding the basics of JavaScript, but also separately understanding how JavaScript connects to HTML and to CSS and to the browser and to user interactions. So we have to learn the basics of the language first. That's step one. And that will take a couple of sections in this course to get there. Keep that in mind. I know you're going to want to get to, and I personally like to get to the fun stuff where we're all of a sudden working with forms and, user interactions and scrolls and animations. But first, we have to learn how JavaScript works on its own. no HTML, no CSS. We do JavaScript in a vacuum. Then we can take those skills and add on to them. We can learn how to use JavaScript to manipulate stuff that's happening in the browser. How do we respond to user input? We can't do any of that until we have step 1 done. So just keep that in mind. If you feel discouraged, I promise it will all come together, but we just can't do it first. We have to start with the basics. Now, what are the basics? The first fundamental thing we have to know are the primitive types in JavaScript. So primitive types are just types in general are a concept across any programming language. Whatever language you're working with will have some set of types. And when I say type, I'm just talking about the different types of information it can store, it can handle, and work with. So commonly, here's an example of a web page. This is a screenshot I took from a YouTube video. We've got different types of information that we could represent, right? We've got text, like the title here of the video, the user's name. All of this is text, of course. But if we were storing this or representing this with a language like JavaScript, we've got textual information. But we also have numbers, the number of views, the number of likes and dislikes. And those really will be helpful if they're actually numbers, because I can add 1 to it easily or subtract 1. Then we have a different type of information, whether I'm subscribed to this channel or not. That's a yes or a no or a true or false value. And you may have seen this if you use YouTube. If you are subscribed, this will show up differently, this button. I think it says subscribed or something, or it says unsubscribed. I don't know what it says, but it's a different color. It's sort of grayed out. So there's a yes or a no value here. There's numbers. There's textual values. These all are things that we can store in JavaScript. There are these basic building blocks, these basic types of information that we can store. So we're going to go through these. I'll just read them out quickly. We have numbers, we have strings, booleans, null and undefined. Those are the 5 basic primitive types, the most sort of fundamental unit in JavaScript, or they're at least the most fundamental unit that we interact with on a daily basis, or even a minutely basis as a JavaScript developer. There's really no other place to start. We have to begin here. Technically, there are 2 other primitive types, something called a symbol and big ints or big integers. Those are way, way, way less commonly used. Don't need to worry about them for now, but I just didn't want people calling me out in the comments. Okay, so in this video, we're going to begin by talking about where we type our code. So we're going to start typing our code in the JavaScript console in Chrome, which is the easiest place to start. It is absolutely not the standard place that developers type code in a professional setting. We will be writing our code in our editor and saving files and all of that, but that requires some overhead where we have to first connect a file to an HTML document and open that in the browser and make sure our script's included in the right place. And it just is more work. When we're doing these basic things like learning primitive types, it doesn't matter. So we're going to start with the console. To do this, if you have Chrome already, great. Hopefully you do. We've been using it for a while in this course. You can use Firefox. Safari has a JavaScript console. I think pretty much every browser has a console. I have not used Internet Explorer, so I don't know, but hopefully you're not on IE. So all we need to do in Chrome on any web page, you've already seen how we can inspect, but there's a couple of options. You go to inspect, and then you go to a different tab here, which is the console tab. This is our JavaScript console. Depending on the web page you're on, you may see a bunch of messages here. It might look a bit scary. You don't have to worry about any of that. That's just stuff from this web page that you're on. You can actually clear all of this by typing clear with parentheses. There's also a shortcut. I can never remember what it is. But the other option is to open just a blank window or go to one of our web pages we've made and open up the console. So you can right click, go to inspect, go to console, but that's a couple of steps. There's also a shortcut. I use it. It's on a Mac at least, Command Option J. It goes straight to the console. Another option, if you're in Chrome, go to, View, Developer, and then JavaScript console. You can see the shortcut on your machine there. If you're not on a Mac, you'll see it right there. That's the console that I'll be using. That's a shortcut I use all the time. So if you just see it appear, that's what I'm doing. So what this is right here is a place for me to type code so I can do simple things like some math here. Well, assuming I type valid numbers, I can hit enter, and that code is run, and it's repeated back to me, or the result is shown to me. This is actually something known as a REPL, read, evaluate, print, loop. So it's reading in my code, it evaluates it, it adds it together in this case, it prints out the result, and it loops, meaning it just keeps going. It doesn't just stop. Compared to most scripts and most programming languages, you type some code, you hit run, and it runs, and then you're done. The console is a place where I can just quickly and interactively play around with code. So it's a great place to demonstrate things and just to learn the basics, but we don't write long or really anything in here that we want to have any permanence, because as soon as I close this window or refresh, my code is gone. So we definitely will be working in files soon enough. The other thing I'll show you is I do like to pop this out when I'm just writing JavaScript into its own window, because we're not going to worry about the rest of the HTML and CSS. We don't care about the content at the moment. We're just going to type some code. All right, so make sure you're comfortable opening that up, and now we can begin with our first primitive type, numbers. All right, so let's dive into the first one of these 5 primitive types. There's no real order here, but we're going to begin with number, or numbers. We work with numbers a lot in JavaScript and really any programming language out there. We store numbers, we manipulate numbers, we do math with them, something as simple as incrementing a number or decrementing. Like if you upvote something on Reddit, you're adding 1 to some number. If you downvote it, you're subtracting 1 from that number. These are super important fundamental operations. And in JavaScript, one of the primitive types is simply called number. So I wrote here that JavaScript has 1 number type. Some other languages actually have more than 1. They have a number type to represent whole numbers, usually called integers, and then a separate type to represent decimal numbers, called floating points or floats often. And the reason for that is that it takes a lot more memory to store a decimal. Let's say we're storing a whole number from 1 to 100. We need some amount of space in memory to do that. But suddenly if we're storing every possible decimal, now technically there's infinite numbers in between, but let's say out to 5 decimal points or 10 decimal points, that's a lot more space. So long story short, in some languages you have 2 different types for numbers. In JavaScript, we don't. We have 1 type. And that includes both positive numbers, negative numbers, whole, and decimal numbers. So we can begin very simply in our console. Remember, open it up from the dev tools. For me, it's Command-Option-J. And we can just type a number if we want and hit enter. JavaScript just tells us, yep, I know that thing. Here it is. I'm printing it back to you, right? It's evaluating this, but there's nothing really to evaluate. It's just the existence of 89. So we have, decimal numbers. We have negative numbers. These are all just considered numbers by JavaScript. Now there is a point where we do lose precision. So if I have some, really long decimal, you'll see eventually it goes from 1.999 and so on. Add 1 more 9, it's now just considered 2. So numbers get a certain amount of space in memory. They're not permitted just to take up an infinite amount of space. Well, infinite's the wrong term, but there's a hard limit. So simply typing numbers and hitting enter is not very exciting. What I'm going to show you next may not be that much more exciting, but it is something that we can do. We have some basic math operators that are built into JavaScript. So common things like addition and subtraction, multiplication and division. So they use symbols that you're probably familiar with. They're pretty standard across programming languages and just, I guess, in the world. We can add numbers together, right? We can subtract them. I won't waste your time just showing you this, but let's do a little multiplication here. 3.5 times 2. If we divide something like 2 by 5, we'll get a decimal. If we have negative numbers, we can still do all this math with them. Now there is order of operations. The way I was taught this was PEMDAS, where we have parentheses, runs first, then we have exponents, then multiplication, division, addition, and subtraction. So it goes from left to right. So if I have something like 3 plus 1 times 9, what happens first? The 1 times 9, that's the multiplication. It comes before addition. So we get 9 plus 3 rather than, what do we have? 4 times 9. Very different. So we get 12. We could change that using parentheses. So I could say I actually want this to run first. 3 plus 1, that gives us 4 times 9. We get 36. By the way, I'm recalling previously run lines in the console with the up arrow, so I can scroll through them with up and down. That can be useful. Now you may have noticed these grayed out lines in my slides. 2 forward slashes in a row create a JavaScript comment. We've seen comments in HTML and CSS. Same sort of concept in JavaScript. A comment in the console is pretty useless, right? Because this is not a file. This is not saved. This is purely a moment in time in our browser. When this window closes, this code is gone. But if I wanted to make a comment in here, I can. This is invalid JavaScript code. If I ran that, without those parentheses, I'll get a lovely error message. It's red. It tells us reference error. Josh blah 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 is not defined. It doesn't know what that is. Okay, so comments mainly used in files, but in JavaScript, 2 / creates them. Next up, let's talk about 2 operators you may not be familiar with. You might, but you may not have seen them before. The first one is called modulo. It's also known as the remainder operator, and the character we use is the %sign. So the % here, or modulo, let's do some operation. How about 9% 2? We get 1. So here's how it works. It's called the remainder operator. We have 9 modulo, a lot of people say mod, 9 mod 2. 2 goes into 9 how many times? As a whole number. It goes in 4 times. And then what is the remainder left after that? Well, 4 times 2 is 8. So that's a remainder of 1, 9 minus 8. So if we had something slightly more complicated, how about 19 mod, and then, see, if I type a number here, it's going to show you the answer before I even hit enter. But what if I did 19 mod 4? What would the answer be? Well, how many times does 4 go into 19 as a whole number? Well, the closest multiple of 4 is going to be 16. So what is 19 minus 16? We get 3. So let's verify. There we go. So modulo is commonly used to determine if a number is even or odd. We could take any number and mod by 2. So any number, here we go, mod by 2, and that will tell us if it's even or odd. If we get 1, there's a remainder of 1 after trying to divide 2 into this number. That means it's odd. Now, if it's an even number, we'll get a remainder of 0. So any of these even numbers, there's an odd one, here's even. It doesn't matter how size, it doesn't matter how large they are, what their size is. This is commonly used in JavaScript, and we'll come across it later on. Okay, now the next and final operator we'll see in this video is the exponent, or is it exponentiation? It's 2 multiplication signs, or 2 asterisks, 2 stars, and it's just going to take our first number and raise it to some power. So in this case, I'm doing 2 to the 4th power, and we get 16. 2 times 2 times 2 times 2. Right, so I can do things like 9 to the 9th power is going to be quite large. 9 cubed, 9 times 9 times 9. That's really all that there is to it. It'll raise that first number to the second number power. 2 to the 4th, 9 to the 3rd, and so on. All right, so we have our basic mathematical operators. These are used quite a bit. You don't need to be some math expert or anything like that. Of course, JavaScript is not just a glorified calculator, but it can be. So far, that's all it is to us. We've still got a lot more to learn, though. And just to recap the other parts we saw, negative numbers, decimals, whole numbers, it doesn't matter. It's just considered number in JavaScript. One generic number. We have some other operators like the modulo or remainder operator, the exponentiation operator with 2 stars, and we saw that JavaScript obeys the order of operations. We can use parentheses to alter that order, and I think that's pretty good for now. Okay, one other important topic around numbers that you'll definitely come across is something called NaN, or not a number. So NaN is technically considered a number in JavaScript. It's basically a concept. It represents a value that is not a number. Now that sounds weird. It is considered a number by JavaScript, but it represents something that is not a number. Well, I'll show you some examples. Things like 0 divided by 0. In ordinary math, in arithmetic, dividing 0 by 0 is considered meaningless, or it's undefined, it's impossible to assign a value to it. And in JavaScript, the same applies. We get the actual value from JavaScript, which is a real value. It's called not a number. And again, it is considered a number. Now, what do I mean by that? Well, in JavaScript, we have this thing we have not seen yet called type of. This is considered an operator, actually, kind of like the plus sign or subtraction or other operators we've seen, except it only requires a single operand. Is that the right term, operand? It only requires a single thing to be passed to it or to work, right? We're not adding 2 numbers, 1 plus something else. Type of is just going to take something like 4, and it tells us that's a number. Type of 4 point blah, 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 that's also a number. So this proves to us decimals, whole numbers. In JavaScript's mind, that is a number. All numbers here. Now, if I try 0 divided by 0, like I showed, this is not a number, NaN. And if I try this type of thing I just showed you of NaN, it still tells us number. So I'm showing this to you just so you understand that technically this value is a special value in JavaScript. It represents something that is not a number, but it is considered a number type or a member of the number family in JavaScript. And I wanted you to see it just because it will come up. Not a number often will come up if you're trying to do something that you expect to work. You're dividing by something and you don't realize it's 0 maybe, or a user enters something that is supposed to be a number, but they actually enter in text, like a word, and then you're doing math with a word and you'll get not a number. Okay, so you can also arrive at not a number if you're working with not a number. So, not a number times another not a number gives us not a number. Not a number times anything is going to give us not a number. Same with all the other operations, plus, subtraction. You can't do math with something that is not a number and expect to get something other than not a number as your end result. Okay, that's enough. I'm tired of saying not a number. That's NaN. Don't worry if you see it. I mean, you should probably be concerned that something is maybe not going as expected, but don't panic. Remember, it is technically a number in JavaScript. It just means not a number. All right, so quick little quiz here. You won't need to type any code or anything. Use your brain power to evaluate this line of code. What would you see if you were to type this in the console and hit enter? So pause it if you need some time. And then here we go. Here's the answer. So this one has to do with the order of operations and just recognizing these operations in general. So the addition is not going to happen first. We'll have the multiplication and division. So we have 3 times 4, which gives us 12. We divide by 2, that gives us 6. Then we add that to 4, and we get 10. So the answer is 10 here. Next up, this one here. Mentally evaluate this. Pause if you need to. 2 other operators that we've learned. What does this come out as if you were to enter it into the console or run it in a JavaScript file? And pause it if you need to. Here's the answer. Okay, so we have modulo in parentheses that happens first. Remember, it's the remainder operator. So 13 mod 5. How many times does 5 go into 13? Well, the closest multiple is going to be 10. So the remainder, 10 and 13, the remainder is 3. So the left side is 3, and then we have star 2, which is the exponent operator. So we have 3 squared, or 3 to the second power. 3 times 3 is 9. So that's what we should end up with here. And then our final one, what does this evaluate to? 200 plus 0/0. Okay, pause if needed. Well, what happens first? Order of operations. 0 divided by 0. Well, we just saw that evaluates to NaN, or not a number. Then 200 plus not a number. Well, not a number spoils everything in math, and we end up with not a number again. So the overall answer here is not a number. Anytime you try and do any operation involving not a number, you're going to end up with not a number. All right, so very quick stuff. Now we get to move on to variables. Next up, we get to a very important concept, and I know I can only say that a couple of times throughout JavaScript. I'll probably say everything's very important. Well, actually, there's some stuff I'm going to show you that's honestly not that important, but there's a lot of these really important building blocks, and this is one of them, the variable. Variables are a way of giving some name to a value and storing it using JavaScript so that we can come back to it later and reuse it or update it or just recall it. At the moment, we're working with data, just numbers for now, right? We can do things like add them together and get an answer, but then those numbers are gone. If I want to reuse them or I want this number, I have to type it again myself. And that seems like it's not that big of a deal if you're just calculating sums, and it's not. Well, I guess it could be annoying if we had really, really large sums with very large numbers, but typically our data in JavaScript is going to be a little bit more complicated than 2 numbers that we're adding together. And it will help a lot to be able to save it using JavaScript, to be able to come back to it later on in our script, 10 lines later or 100 lines of code later, and also have English names or whatever language you're using. But for me, it will be names in English where I can give a value a name so I can refer back to it. For example, I like to use this analogy of a jar with a value inside of it with a label on it, or a Tupperware. If you work in an office with a fridge and you ever bring your food in, you write your name on the Tupperware so other people don't take it. Yeah, it's kind of like that. I don't know. That might be a stretch. So all that we're doing is storing a value with a name so that I can come back to it. Now, how do we do this? Well, the basic syntax in JavaScript is right here. The keyword let, and then a variable name that you decide on, then an equals sign, and then some value that you want to store using that variable name. So here's a more concrete example. Let year equals 1985. What I'm doing here is saying, hello JavaScript, I'm going to be storing something under the name year, and the value I want you to put in that jar is 1985, the number. So then later on in my script, I can refer to year, and we'll see 1985 is what JavaScript has stored for us. So we can do that right here. Let year equal 1985. Now, this semicolon, technically, we're going to have a larger discussion about this. You don't need in the console, certainly. JavaScript will add a semicolon if you're missing one and it thinks you need one. So don't get too hung up on them right now. But technically, anytime you are declaring a variable, which is what this is, we should have a semicolon there. So that doesn't seem to do a whole lot for us. But we're basically just registering a variable. We're saying, hey, here's this thing I want you to know about. But we're not doing anything with it. The simplest thing we could do is just recall it. Now, every time I refer to year, I'm getting 1985. Now, of course, we can have multiple variables. They do need to have distinct names. We'll actually talk more about variable naming. But let's go ahead and create two. So I'm going to create the num of hens. I'm just going to call it num hens. It's a number of chickens, of hens specifically, that I have in my coop right now. So we have 5 hens. And then I'm going to come up with num roosters, which actually is just 1 right now. Okay, so I have 2 variables, num hens, num roosters, 5 and 1. Okay, so what happens when I do this? Num hens plus num roosters. We get 6, right? It's just a name and a name for 2 values behind the scenes. JavaScript goes and finds those values in memory, 5 and 1, and it adds them together. Now, have either num hens or num roosters changed? The answer is no. They are completely unchanged. They're exactly the same. All I did was retrieve the value. Please give me num hens and num roosters. Likewise, if I did something like num hens plus 1, let's say I added a new hen to my flock, this still does not change num hens. I'm retrieving the value and adding 1 to it, but that's it. I'm just getting that value and plussing 1. I'm adding 1 to it, but I'm not actually changing it in any way. It just vanishes. We get 6, and then that's it. That number is gone. We're not saving it anywhere. Now, something that we could do is this. Let total chickens equal num hens plus num roosters. So I'm adding the 2 together, and then I'm saving that result in a new variable, total chickens, which is 6, right? 5 plus 1. So if I did want to actually update one of these values, like I get a new chicken, a new hen, I need to add 1 to num hens, and not just add it into the ether like we did here, but actually update num hens. So this does not work. That gives me 6, but num hens is still 5. I can do this, num hens equals, and I could just manually update it to be 6, just like that. And now anywhere I reference num hens, we're looking at 6. Or I could do this, num hens equals the current number plus 1. So take the current value, whatever you are, it happened to be 6, add 1 to that, that gives us 7. Store that in the slot called num hens. It's the new value. Now, something I do see come up with students in the past, if you remember, we have this total chickens variable, and we set it equal to the number of hens plus num roosters. At the time, that total was 6. But now I've updated the number of hens, right? Num hens is now equal to 7. So what happens to this total chickens variable? Nothing. It is exactly the same as it was when we created it. It's a snapshot in time. This is not linked together. If we update num hens or num roosters, this value stored in total chickens will not change. I could change it myself and say total chickens is actually equal to num hens plus num roosters as they currently stand, and now we get 8. But just, I want to be very clear about that. They're not intrinsically linked. This is just a snapshot in time. What does this number come out to? Save that in total chickens. So this is our first intro to variables. Like I said, we'll be using them quite a bit. We have some other topics around variables and updating values, in naming them, a different keyword called const. So that's all coming up. In this video, I want to talk a little bit more about updating the values in a variable. specifically updating a number. We haven't seen this yet, but we can store other types in a variable, things like text or strings, which we're about to get to, Booleans, all sorts of different values. But we're talking about numbers for now, because that's all we know. Up until now, we've only seen numbers. So I'm going to make a new variable. We'll just call it score. We're playing a game. Let's say my score starts at 0. All right, so it's 0. Now, if I wanted to add, let's say I'm playing a game, and every time I collect a coin, we're adding 5 to my score. Okay, so if I want to update score by 5, obviously I could do this, score just equals 5. But that's only going to work the first time. Now, if I want to add 5, I need to do score equals score plus 5. As we saw in the previous video, we're taking the current value, which is 5. We're adding 5 to that. That gives us 10. We take that number and save it under score. So now score is 10. So I could do this every time I need to. I'm using the up arrows, by the way, up and down arrows rather, to navigate my previous code. I could do this every time I want to update. So every time you collect a coin in my game, we're adding 5. But there's actually an even shorter syntax. And this is far more commonly used. It looks like this. Score plus equals 5. And this is saying exactly what we have above. Take the current score, set it equal to score plus 5. So it's just a condensed way of doing it. It's not as easy or clear to read when you're just starting out, but this will become second nature. So if I do that, we're now at 60, right? We look at score at 60. So if I do plus equals 10, the score will now go to 70. We also have other variants like score minus equals, let's say 50. We hit a trap, a spike, I don't know. Something got us in the game. We have to lose 50 points. Now we go down to 20. I just said score equals score minus 50. It's the exact same thing. It's just briefer. So we have multiplication. You have star equals. So I can multiply my score by 2. And we get 40. I can divide with slash equals to get 20. Those aren't as common. It's pretty common to increment something or to decrement. In fact, it's so common to increment things by 1 or decrement by 1. So for example, score plus equals 1 or score minus equals 1. This is super common in JavaScript and just programming in general. So let's make a new variable. By the way, I remembered the shortcut to clear the console, Command K on a Mac. You can also type clear like this, which I have been doing for a very long time in my videos. And then someone pointed out a couple weeks ago, there's a way that's way easier. You can just hit Command K. Anyway, let's make a new variable. We'll call this one, how about num lives? So this will be the number of lives you have left in your game. Let's say we have 9 lives, like a cat. Obviously not true. My cats have not had 9 lives, just 1. But let's say we have some number of lives called 9. And we're going to increment this by 1 or decrement by 1, right? You lose in the game, we subtract 1 life. I guess maybe you collect some power up, we add 1 life. Like in Mario, I think, what is it, the mushrooms? Certain things give you a 1 up. Anyway, instead of working with 5 or 10 or decrementing by 20, we're working with 1 at a time. So let's say you lose your life, or you lose a life, num minus equals 1. That's one option. What am I doing? Num lives minus equal 1. Num lives is now 8. But there's a shorter option, which is this. Num lives minus minus. And that's it. This is really common in other programming languages. It's just going to decrement whatever comes to the left of it, which is num lives. And we get, well, it shows us 8. This is why it's mildly confusing in the console. It's just giving us the current value of num lives before it's updated. But we can see num lives did actually go down by 1. It was decremented by 1. So if I run that again, we look at num lives, not hens, but num lives, it goes down to 6. Now we also have plus plus, which does the opposite. It increments by 1. So now if we look at num lives, once again, we're up to 7. So this is pretty common to see. And like I said, there's a lot of situations where you update something by 1, increment by 1, or decrement by 1. If you're counting things, or if you're keeping track of, let's say you're keeping your place in a long string of letters or characters, and you're moving forward 1 at a time, it's pretty common to have these counter variables, which we'll get to. So just telling you ahead of time, you will see both this syntax, something like num lives, let's say plus equals 4. That will add 4 to the current value and update num lives. And things like num lives plus plus to add 1 or minus minus, an even shorter way of incrementing and decrementing by 1. Okay, so we've seen how to make variables using the let keyword. Let and then some identifier equals some value. That's a horrible name for a variable, but it does work. It's a valid name. There are actually 2 other keywords we can use to make variables, and we're going to cover them in this video. The first one is called const. Const stands for constant. Does it stand for constant, or do I just say it's an abbreviated version of constant? Anyways, it means constant, and a constant is a value that does not change. It remains constant. So we use it the same way, const instead of let, and then a space, and then some identifier, and then an equal sign, and then some value, except there's a huge distinction in its behavior. After we create our variable, let's go with const lucky num equals, I don't know, how about 26? Sure. After that, I can recall lucky num at any point, but I cannot increment it or change it or reassign it. So I can't do plus equals 1. I get this error, assignment to constant variable. You just can't do it. A constant variable does not allow you to update the value or change that value. So I can't add 1 to it. I can't decide, actually, my lucky num is 7, just like every basic person on planet Earth who says 7's their lucky number. No, it doesn't work. Assignment to constant variable. So that begs the question, why use constant, or why use const? For now, it may seem quite limited. We could use it to do things like store the value of pi, or store things that we know won't change. If we're making some application where we need to somehow convert from feet to miles or miles to feet, that's not going to change that number. So we could make a constant for that. Const, and then, feet in mile is, 5280 or 5820. It's one of these. Let's just say it's 5280. I think it is. That's not going to change. I can use const. Now that's kind of a special case to use const for an actual mathematical constant, or a value like pi that is constant, or the days in a week, it's always 7. So that's not really the main reason people use const. We just don't know enough about JavaScript at this point to really see why we would use it. So I'm just revealing part of it to you at this point because we're talking about variables, and this is a way of making variables. We use let and const. They both make variables, but const variables cannot be reassigned. But when we get to arrays and objects, data structures in JavaScript, you'll see that const becomes a bit more useful. So for now, just know that it's a thing, and that's good enough. It's a constant variable where JavaScript will yell at you and actually prevent you from updating. I didn't show this, but lucky num, for example, is definitely 26. I tried to set it to 7. JavaScript slapped me in the face, says you cannot do that. It stays at 26. Okay, so that's const. For now, we'll be using let unless we have a constant value that makes sense to put in a const variable. But if we're doing things like, age, and we need to add 1 to age every so often, or we're doing something like score in a game, and that's going to change, we need to use let. So this brings me to the next keyword that we have not yet seen that we can use to make variables, called var. V-A-R. Now this is the old way of making variables. Originally in JavaScript, this was the only method, the only keyword we had to make variables. So everything you'll see in old code bases, in old tutorials, old videos, the previous version of this course, everything was done using var. And it still works. So I'm just going to clear. How about, I don't know. Run distance will be 26.2 for a marathon. So that makes me a variable. I can recall it. I can update it. It works very similarly to let. There are some distinctions, but it's kind of difficult to explain them at this point because we just don't know enough, once again, about some of the more advanced topics in JavaScript. So we will revisit this topic and you'll learn more about why let and const were introduced. So var was the original and only option for making variables. Then a couple of years ago, let and const were introduced. They are the newer ways of making variables, and you should use them exclusively. You should have no reason to use var. I'm just showing it to you so that you know it exists. You may run into it, but let and const are the new, fancier way of making variables. So let, for now at least with what we know, let allows us to make a variable that we can reassign. Const makes a variable that is a constant value. Eventually, we'll see that it is more useful than it may seem at the moment, but those are the two keywords we'll be using. Next up, we're moving on to our next primitive value. So we've talked about numbers. Next up, we have Booleans. Now, Booleans are very simple. We have two options for a Boolean value, true or false. That's it. So Booleans are used to store yes or no values, a true or false value. That's really all there is to it. And we actually write the word true and the word false. So these are special words in JavaScript. You'll notice if I go to my console and I just type, I don't know, if I type truth, that gives me an error. If I type fish, that gives me an error. But if I type true, different color, and I don't get an error, I get the exact same result that I do when I type a number. Well, it's not the same result, but the same sort of feedback. It just prints it back out to me. It's telling me, this is JavaScript or the console's way of telling me, I recognize that, you're allowed to do that. Versus typing something else, I get an error. So true and false, two special values in JavaScript. And later on, we'll see how we use these, how these play a very important role in performing logic and having our code have different outcomes and making decisions and all that really important stuff. But at their core, Booleans are very, very simple, just true or false values. So even though they're very simple, they're used a lot. If you think of in a typical application, just how many things you could store as true or false values. Things like if you're making a game, is the game still playing? Or has the person won or have they lost? So we can store them in a variable just like anything else that we've seen, a number, for example. I could do let is active game, for example, equals true. And then at some point that might be false. So is active game is true, but I could save it or set it to be false instead. Notice true and false are lowercase. If I do true like that, I get an error. In other languages, like Python, for example, they are uppercase, but this is not Python. It's JavaScript. Other use cases, things like let is logged in. For a website, that's a very important thing you might want to keep track of. And you could do that using a variable where you would change it from true to false or false to true. So you could replicate this functionality, right? You could do something like let is game over and use 1 and 0 maybe, and just switch from 1 to 0 and 0 to 1, and you would just have to know which one is true, which one is false. But using a Boolean makes that way, way simpler. It's built into JavaScript, yes or no values, very straightforward, at least so far. So it's another primitive type. We've seen numbers, we've seen Booleans, and this leads me to the next topic, very quick one, which is in JavaScript, we can have a variable, a single variable that changes type. If we make a numeric variable, it is not stuck storing a number forever. We could make it store a Boolean. So I have is logged in right here, which stores a Boolean right now. I could, if I wanted to, change that to a number. It's an odd choice. It doesn't really make sense. And it's pretty rare that you would do something like this, if ever, but you can in JavaScript. And I just want to highlight that. In some other programming languages, it's common that when you make a variable, if it's a number that you're storing, that variable can only ever store a number. Or if we make a Boolean, that variable can only ever store a Boolean value. And it kind of makes sense. A Boolean is very, very easy to store, right? You can store a yes or no, a true or false value with just a 1 or a 0, a single bit, versus a number could take a lot more space. So that's all I want to say there. In JavaScript, you can have a variable that changes type. It's not a big deal. It's not going to yell at you. There is something called TypeScript, which you may have come across or you may have heard about. It's sort of like an add-on or a fancier version of JavaScript that does enforce those sort of type restrictions, where a variable, if you declare it as a number variable, must remain and always store a number instead of a Boolean or something else. But on its own, regular old JavaScript does not have any restrictions like that. So to recap, Booleans, another primitive type, true or false, that's all there is to them. Very simple. We can store them in a variable just like we can store numbers or strings, which we're about to learn about. Okay, next up, I'd like to wrap up with a quick conversation around naming our variables. So when we make a variable, whether we're using let or const or, heaven forbid, var, we have to come up with some name for that variable. And there actually are some hard rules in JavaScript that we must follow. And then there are some conventions or some best practices that JavaScript developers in general follow, but you don't actually have to. So let's start with the hard rules, the things that we must obey when we're coming up with an identifier in JavaScript. So what we're doing here, if I'm going with, is logged in, I'm creating an identifier, or is logged in is an identifier. It's a variable name. I could do, something like that. I can do something like hello world, but all of a sudden if I add a space in there, that's a big problem. So we can't have spaces in there. I can have numbers in here. So I could do something like, user1 equals something, but I cannot actually start off with a digit. So I can't do something like, one user equals, this makes no sense as a variable, first of all, but I can't do that. It tells me invalid or unexpected token. So I can have a digit in a variable name, a numeric digit, but it cannot be the first character. We also, if you just want to look for a more concrete definition on MDN under identifier, it tells us that identifiers are case sensitive. They can contain letters, $, underscore, and digits, 0 through 9, but may not start with a digit. So we can use an underscore. So I could have a variable start with this. Let underscore, age equals 9. That is valid. It's just very uncommon to do that because of what we're about to talk about, which is best practices or just common conventions for how we name our variables in JavaScript. So the common practice, the stuff you'll see most frequently, is to give your variables names that are camel cased. So if you're not familiar with the idea of camel casing and snake casing, think of it this way. If you have more than one word that you need to fit in, so for example, let, logged in user or current age or date, those are 2 words. And right now I'm not casing either word differently. It's just sort of one big word. So one option is to put an underscore there. And this is valid. This is not problematic technically in JavaScript. It's a valid identifier. This is what we would call snake case, but this is not commonly used. Instead, we use camel case, where each new word has a uppercased first letter, except for the very first letter of the variable. So this is uncommon to see. You wouldn't uppercase that letter, even though you can. Just as a best practice or a common pattern, we don't do that. So lowercase for the first word, no spaces because we can't have spaces in a variable name. No underscores, although we can. It's just uncommon. Instead, we prefer camel case. So current date equals, let's do current year. Current year equals 99 or 1999. There we go. The other thing I want to mention while we're talking about variable naming is the importance of coming up with good names. I have seen so many students do things like let n equals 9. What is n? What does that mean? Is it supposed to be number? Is it a special number in any way? Is it, user number, or is it user input number? I would do something like that, where you actually know what the heck it is, even though you probably know what it represents at this point in time. If you're coming back to your code weeks later, sometimes even days later, you may not remember what you were thinking. So variable names are very important, as are other names that we'll come up with once we learn about functions. Naming your functions well is crucial. So a couple of things when you're making a Boolean variable. Generally, you want to come up with a nice name that explains what it is. So instead of something like let user or logged in user equals true or equals false, what I like to do is logged in or is game over equals true instead of just game over. Putting is in there just makes it clearer that this is a Boolean variable. Again, you don't have to do that, but that's pretty common. In general, avoid one-letter variables unless for some reason it makes sense and you feel confident in it. For the most part, I would entirely avoid that. And I think that's enough about variable naming. So remember, you can't start your variable name with a number. You can put a number in there, it just can't be the first character. And it's most common in JavaScript to use lower camel case. lowercase the first letter, and then uppercase every first letter of subsequent words. And I'd also like to end on this one thought here. It's always better to have a more meaningful variable name over a more concise one. So brevity, it's really not that important. It's not going to make your code better or more efficient or anything to have it take up less space on a line. So don't come up with a sentence for your variable names, but also err on the side of meaningfulness. Okay. All right, welcome back everyone. On to our next JavaScript section. Still some very important basics. We're talking about strings, which again may not mean anything to you, but it should by the end of the next couple of videos. So most of what we're going to cover here, pretty much, well, I won't say all of it, but most of this stuff is crucial. So understanding the basics of strings, that will stay with us in pretty much every video from here on out. Indices and length of strings, very crucial as well. Pretty short topics, fortunately. The concepts of undefined and null to other primitives, crucial to understand, but nothing terribly complex. Then we get to string methods. So this is another grouping of, 6 or 7 different things. They're all different string methods. Again, we haven't talked about that, but it is yellow just because it's a bigger chunk of content. It also is crucial. So that's probably the biggest hang up in this section, if there is one. String template literals, also very important. And then we get to random numbers and the math object. I'll put that under important, but it's not as crucial. So if you do get hung up on the end, the very last video in this section is about generating random numbers with JavaScript. It's important, but it's not going to prevent you from moving forward. So there's a lot of crucial stuff, but this section's pretty quick overall. More very, very basic, just core concepts in JavaScript. When I say basic, I don't necessarily mean easy, but basic to JavaScript, very essential building blocks that we then will add on top of. So take your time, especially around string methods. That is a bit of a change of pace in the section, so it might take you a bit longer. And with that said, I will see you I won't see you, but you'll hear me in the next video. Good luck. All right, so we've seen 2 of the basic primitive types, the fundamental building blocks in JavaScript. We've seen number and Boolean. Now we're going to focus on string, or strings. Strings are really commonly used, as are numbers and Booleans. Those 3 are probably the most important to understand right now. And a string is basically textual information, a string of characters. So they're just another primitive type, and they represent text. And the first thing you need to know is that they must be wrapped in quotes. This is how we indicate to JavaScript that we're working with a string. So we've seen already that you can't just go around typing random letters, unless you happen to type something that actually makes sense to JavaScript, like true, which is a Boolean. But if I wanted to have a string, I want text, and I want to store it in a variable. For example, somebody's name. Let username equal. I need quotes. So if I don't have those quotes, I'm going to get an error if I have, Danny or something like that. But if I use quotes, that is a string. So now I have a username variable set to a string. We look at username. There we go. We have Danny. So we can use double quotes, and you can also use single quotes. It's totally up to you on what you prefer. There are certain situations where one makes sense over the other, but what's important is that you just remain consistent. So in a single JavaScript file, you shouldn't be switching from double to single just for your basic strings. You should remain consistent. So I'll show another example. Let fave animal equal, let's do single quotes. Dumbo octopus. And we can have spaces in there. We can have all these different characters we might want, right? I can put a $sign in there. I can do any of that. It's a bit odd, but I can. I can have numbers. So I can make a string that's just the number 23. But this is a string. It is not the same as typing 23, the number. Okay? So here's single quotes. The most important thing to recognize is that you cannot mix them up. So I can't do a single quote, hello, and then a double quote to end it. That causes a syntax error because JavaScript is looking for this closing single quote. It's just waiting and waiting and waiting. It's basically the same thing as if I had done this and never added that closing quote. We get that same error. So single quotes or double quotes, totally up to you. Strings are strings of textual information. Super useful. There's so much textual data that we might need to work with in a browser. Things like username and address and state and city, so many different pieces of information. Messages you might want to send, chat messages. There's just a lot. So we're going to spend more time on strings because there's actually more than what we've covered. There's more to them than numbers, for example. Strings have some nice little features. We're going to talk about things called methods. But just to recap this video, strings are another primitive type. They are textual information. They can be a single character long. They can actually be 0 characters long. This is an empty string. So it is technically a string. It just has nothing in it. And then they can be very long. We can have long strings. You can store them in a variable. We can use single quotes or double quotes, but don't mix them up. The only time you would ever want to mix them together is if you needed to use one of them inside of the other. For example, we could do something like, I told her go away. If I want quotation marks in my string, this is problematic because that double quote is closing the quote. So instead, I would do single quotes, go away, like that. And that's perfectly valid. So that's common. Or the other way around, she said, I hate you. I don't know why. I guess this is a fight we're having. I told her go away. She said, I hate you. So here I'm doing single quotes on the outside, double quotes on the inside. So that is a situation where you would mix them, but you should never have a single quote close with a double quote or vice versa. Okay. So beyond the basic idea of making a string with quotes, the next concept we need to understand is that strings are indexed. And what this means is that every character in a string has a corresponding number associated with it. A positional number that goes in order from the beginning of the string, starting at 0. So strings are not the only thing that are indexed in JavaScript. Shortly, we'll learn about arrays. Not that shortly, but a couple of sections from now. And they are also indexed collections. So we start counting from 0, and we work our way from left to right. So in this example, we have a string, chicken, 7 letters. And then each letter, although it doesn't have to be a letter, right? It could be a space or a $sign or a period or something else. Each character has this associated index. So C has an index of 3. C over here, well, that was a horrible example. There's 2 C's. The first C has an index of 0, and then the second C, the 4th character, has an index of 3. So why does this matter? Well, we can actually access individual indices, individual characters based upon that index. So if I have a string, let animal, do I still have my animal? No. Okay. Let animal equal, let's go back to Dumbo octopus. Octopus, adorable octopus, by the way, if you've ever seen them. Now, we have these numbers, these indices I've mentioned. What I haven't shown is that if we add square brackets after our string, after the variable, animal in this case, and then I put a number in here, like 0, I'm accessing the 0th character, the index of 0 of animal, which is D, specifically a capital D. So if I did animal of 1, I'm getting U, the second character, but we start counting at 0. So how do I get capital O? What is the index I would need for that? Stop for a moment, think about it. Well, we're going to need to start counting from the beginning. 0, 1, 2, 3, 4, 5 for the space, 6 for the capital O. Just like that. All right, and then we can keep going all the way up to get to S. But what if I put a number in here that just doesn't exist? Animal of 99. We don't get an error. We get something called undefined, which is a special value, a primitive actually we'll be talking about in just a bit. But basically it's JavaScript's way of telling us, I don't have anything there, I don't know what you want. There's nothing. So we usually don't use these indices in this way I've shown you, where we know that there's an O here, and I just want to know the magic number to find that O. Typically, we'll do things like check the first character of a string. And once we learn how to do some basic logic, we could do something like, let's say we had a phone number. And our phone number looks like this, where we have an area code, and then, I don't know, something like that. Sure. Some people might enter their phone number that way. Others might enter it without those parentheses. They might just do 2, 3, 1, blah, blah, blah. So maybe we want to write some logic that will check. Is the first character here a parenthesis? Is it an opening parenthesis? Well, we could access that character by doing phone of 0 and then compare that to an opening parenthesis. Now, we don't know how to do that comparison, but that is something we could do. So normally we're not just trying to find something, I want to figure out how do I access the B in this string. No, normally we're trying to figure out what's the first character, what's the last character, what's the first half of the string, things like that. We can do that using these square brackets and an index. The other thing you should know is that every string has a built-in magical property. We'll learn more about properties, but this thing called length. So here's my animal, and I can chain on after animal dot length. You'll see also as soon as I type dot here, I get a whole bunch of autocomplete suggestions from Chrome. If I type L and E, it starts to narrow down, and there's length. And it tells me 13. So that is the length of the string, the number of characters, not the highest index. The highest index is always one less because length is sort of how we would count. It's the total number of characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But this S has an index of 12 because it starts counting at 0. So I can do index of 12 to get that S. So keep that in mind. Every string you ever type, LOL, for example, that has a length. I don't have to put it in a variable. It's just the fact that it's a string. That means it has a length property. And it means that we have indexed characters, so I can do LOL of 0 and get L. Okay, so that's really important to understand. The other thing that you should know is that we can add strings together. So the addition operator works a bit differently, right, between numbers. We're doing mathematical addition. But if I have two strings like LOL, I'll close it, and then add on LOL. Surprise, surprise, we get LOL, LOL. This is called concatenation. I'm concatenating, I'm smushing together two strings to get a new string. So I could make two variables, let first name, I'll just do, first name equal, how about river? Let last name equal Phoenix. I could add them together, first name plus last name, and we get one new string, River Phoenix. And this is a new string. If I look at first name, unchanged. Last name, unchanged. In fact, I actually can't change a string. Now, what does that mean? I can't change a string. What I mean is that if I have first name here, and I decide, actually I want to lowercase that r, I can't update one character at a time in this string. I could say first name equals river with a lowercase r, and that's fine. But this is a completely new string. And this is kind of confusing. It's actually not that important to understand at this point, but it is a different string completely than this one. They're very similar, or they look similar to us, but they're completely different in memory. So I can't update one character at a time manually. I can just overwrite that entire string and give it a new value if I want to. Now, what I wanted to show, though, is that if I wanted a space in there, I can do something like this. First name plus, and then a space, and then plus last name. And this gets kind of annoying, but it works. And I get river space Phoenix. And then I could save that to a variable. Let full name. Just like that. And now I have my full name variable, not full name. There we are. And then I have first name still and last name. All right, so that's the idea of concatenation. We're adding strings together. Now, what do you think will happen if I do 1 plus and then I add a string? How about, I don't know, hi, H-I. Predict for yourself for a moment. What do you think will happen? 1 H-I, the string. This is a string here. We can verify that. If I save that to a variable, let result. We can see the quotes, but we also saw this type of operator earlier on. Type of result tells me string versus type of 1 is number. So why do we get that? Why is it giving us a string? Well, this is something we'll learn more about, but JavaScript is going to try and coerce these to a common type. There's no logical way to add a number to a piece of text without making them both pieces of text or trying to make them both numbers. But that doesn't really work. So JavaScript ends up making them both strings, and it adds them together just like I had done this. 1 plus hi as strings, we get the same result. Okay, so not a big deal, but just wanted to show you that. Next up, we've got a whole lot more to talk about with strings. Next up, it's time to introduce a larger topic, something called methods. So every string we make in JavaScript actually comes with a set of built-in actions, which we call methods, that we can perform using that particular string. So these are like special moves for, I don't know, Pokemon. Every Pokemon has its own set of moves we can do. Every string has a set of methods, although they're all the same. So every string can do the exact same. The string hello can do the same things as the string goodbye, for example. And these methods can be found in the Chrome DevTools. If I look at one of my strings, if I do hello dot, and then we see all of these things listed here. To lowercase, to uppercase, substring, repeat, character add. These are all methods. They're actions that I can take. I can do these things. You can also go to MDN and look at string, their documentation, and on the left side, you'll see this large category. First, we have properties, right? We talked about length. There's just one property. There's just one piece of information, length. Under methods, there are quite a few of these methods, these actions we can take. So what do? Well, they do a whole range of things. They help us change the casing, make something uppercase or lowercase or capitalize something. We can replace portions of a string. We can search for something within a string. We can duplicate a string and repeat it. We can combine strings. So these are all actions that we can perform using methods. Now here's the syntax. We'll have some thing, in our case a string, and then a dot, a period, and then the name of a method, and then parentheses. So if you can recall, hopefully you can, to access length, we did something similar, hello.length, but there's a very big difference, no parentheses. This is how we access a property. If we add parentheses, we're accessing, or specifically we're executing a method. So let's try one. Let's try a very simple method. Here's one called toUppercase. And this is going to take a string and create a new version of it that is in all caps. So let's do something like let message equal leave me alone right now. I hate you. Please. Okay. A very rational normal message. Now if I call message dot toUppercase, remember I have to add these parentheses. If I don't, I won't get an error. But it doesn't actually do anything. This is JavaScript's way of telling me, yeah, there is indeed a method called toUppercase, but I didn't run it because you didn't add the parentheses. Now if I add those, take a look. We just did something. Leave me alone right now, I hate you, please. I'm not sure what that please is there for, but there's a please at the end, and everything is caps. It's all capitalized because we called toUppercase. Now this is a non-destructive method, meaning the original message, MSG, unchanged. It made a new copy for us and made it all uppercased. So I could capture that, let angry, not nagry, angry message equal message dot toUppercase with parentheses. Now we look at angry message. It's uppercased. I've captured that value. Original message, lowercase. So we also have the opposite, which is toLowercase. So I can do, LOL, a bunch of other stuff, dot toLowercase. Once again, I need the parentheses, and we get a new version, all lowercase. So here's another pretty simple one. It's called trim. And trim is going to trim off any white space at the beginning of a string or at the end. So this is actually sometimes useful if you're getting input from a user, you're dealing with data that maybe you don't have full control over, and there might be extra indentation or spaces that you want to remove just to get to the core of a string. We can call dot trim. So here's an example. Let's do, I'll clear here. That was Command K, just in case you didn't catch it last time. Let's make a string called user input. And it's going to have a couple of spaces at the beginning. Hello, my name is Tim, Tom, Tammy, Ping, Pong. Yeah, great sentence. So I've got this extra space at the beginning. And if I call trim, user input dot trim, once again, without the parentheses, does nothing. With the parentheses, there we go. It's going to eat up that space and make me a new version of the string. Once again, user input is unchanged. It stays with the space there. And I could do the same thing if I have space on the end or on both sides. Here's a bunch of space. like that, dot trim, makes me a new version of this string, a new string entirely without that space there or here. Now, this is not going to remove characters that are non-space characters. So it's not going to work here. If I do something like that, dot trim, completely unchanged. It just makes a copy of this string. So it's not like it's only going to trim, or it's only going to keep letter characters. That's not at all the case. It's going to keep everything that is not a space on the left or the right of a string. So it does keep spaces in the middle, as we've seen. It's just going to remove them on the left and right. Now, the other thing I'll show you here before I go away, for this one video at least, is that we can chain methods together. So if I have a string that's longer, or it doesn't have to be long, but let's just do hello again, bunch of exclamation points, and then a lot of space right there. I'm going to save that to a variable. Let greeting. There we go. We have our greeting. And I want to make a version of this string that is both all capitalized. So I'm going to call to uppercase, and I want to trim the space on both sides. I can do this, greeting, dot, and then I can do one of them first. It doesn't really matter. I can trim first. That makes me this new string. And I can chain on right here, dot, and then I can do to uppercase. Okay? And there we go. I get a new copy, completely capitalized and trimmed of all trailing and leading space. So I combine them into one step. I could have done this in 2 steps or more, but this is just an easy way to do it. If I don't need the intermediate and I just want the uppercased trimmed version, nice and easy. So when I chain them together like this is going to run first. Greeting, all right, well, we can replace this. We know what greeting is, right? It started out as this right here. So then we call dot trim on that. Well, what does that give us? That gives us this right here without the space. So you can kind of simplify it down to that dot to uppercase. So it works from left to right, replacing as it goes. So it replaces greeting with the actual value, and then we trim that. So it replaces that with our trimmed version, dot to uppercase, and then that completes. So I could have continued on another level, I guess, to lowercase. It seems a bit stupid to go to uppercase and then lowercase, but I can do that. And it works out. We're all in lowercase. It happened to go to uppercase first and then back to lower. So that is how we can chain methods together, which is actually pretty common too in JavaScript. Okay, so we've seen this pattern where we have a string and then some method name like to uppercase and then parentheses, nothing inside the parentheses to execute a method. Now that's sometimes the case, but many methods actually accept what we call arguments. Arguments are just inputs that we can pass into the method to alter how they behave. So as an example, if we were searching for a character, now this doesn't actually exist, but search for, if that was a method, I might want to know, is there an A in this string? And I would need to specify what I'm looking for, or am I searching for a J or a K or something else? So we need to be able to pass in those values, and we can, not to every single method. For example, when we're making something uppercase, what would we need to pass in? It's going to do the same thing no matter what. There's no input other than the actual string we're operating on. But for other methods, like right here, index of, we definitely need to pass an argument. So index of is going to give us the string index, the positional number, where a given argument occurs in a string. So here I have the example of cat dog. That's my string saved in a variable called TV show. And I call index of, and I pass in cat, C-A-T. It's going to tell me, well, that occurs at index 0. And that makes sense. C-A-T, that starts at index 0. If I look for dog, it tells me index of 3, 0, 1, 2, 3. And if I look for something that's not in there, we'll get -1. So if you ever have questions about these methods, especially the more complicated ones, uppercasing or trimming is pretty simple. But if we look for index of here, or you just search what I do on Google, index of MDN, and then click on the MDN search result, we have examples, and we also get detailed information about how it works. So it returns the first occurrence of the specified value. So it's not going to be able to give us, multiple matches. For example, if I had ha ha, that is so funny, like that, and then I call dot index of, notice the capitalization. We have to match that perfectly. Just like with a variable, we have to match it. They mean different things. It's a different identifier. So index of, and if I do h, What is the first matching index of an H? 0. It's the first character. So it's not going to give us this H here. It's not going to give us that H there. It's just the first one, index of 0. Or if I wanted to know, is there an exclamation point in here? Yes, there is. It's an index of 21. Now, is there a dollar sign in here? Or a percent sign? I meant to type a dollar sign, but there we go. No, there is not. How do we know? Well, we got -1. So simple enough, right? We pass in some value, a string, in this case, a single character, but I could also do this. Where's the first occurrence of, well, first of all, we could do a space, index of 4 right there. But how about is? Well, that occurs at index of 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for that I and then S. So we can do longer strings or portions of a string if needed. So this is commonly used to test if a string contains something. Does it contain a dollar sign? Does it contain a period? Does it contain the word hello? That sort of thing. Now there are other methods that require or that ask for arguments, including this one called slice. Now slice actually can accept more than one argument, and I definitely recommend looking at the docs for this one because you may get confused at some point. So slice is going to extract or slice a portion of a string, and it returns it or it gives it to us as a new string. So we can pass in two numbers, the two indices that we want to slice our string from. So if you scroll down, you can read more about the syntax. We can pass in what they call a begin index and an end index, and that one is optional. Just for the record, if you ever see this in documentation, this is the way that the docs tell us end index is optional. So you can pass in just a begin index, and that's how we tell slice where to begin extraction. All right, so let's try it. Let's just go with this same string we had before. Haha, that is so funny. .slice, and then if I just pass in my starting index, how about index of 5? It starts at index of 5. 1 or 0, 1, 2, 3, 4. Here's 5 to the end. It just keeps going all the way to the end. And it makes us a new copy. So if this was in a variable, which it's not, but let's put it in one, it's completely unchanged. So how about let message and then message.slice 5. That is so funny. Message unchanged. But I can also pass in this optional end index, which is the index before which the extraction will end. So it does not include this index. For example, if I go from 5, and notice we use a comma here to separate our arguments. If we have more than one input, we use a comma. This is something you'll see a lot. We'll get very comfortable with it. This is the first time we're seeing it though. So 5 is our begin index all the way up until, how about I just want to get that, and then that's it. So what is the index of this space? Well, it's not 0, 1, 2, 3, 4, right? This is our slice. So we've got to go to the original string. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's go from 5 to 9, and that gives us that. We went from the 5th index up until, but not including, the 9th. So if I did the 10th, it includes the space. How would I get, I don't know, how about is? That's a string that I want to isolate here. Well, message.slice, and then I need to find out what is this index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I want to go up to 11, 12, because I don't want to include 12. Just like that, and we get is. So that's slice. You can actually pass in a negative index. They tell you how this works. It's not as common, but if you do pass in a negative, it's treated as the length of the string plus your beginning index. So if your beginning index is -3, it's treated as the length of the string minus 3. So let me show you an example of that. Message.slice, and then I'm going to add in, how about just -1? It just gives me the last single character. -2, the last 2 characters. -5, the last 5 characters. So you can use negative numbers as well. It's working backwards from the end. And just like everything else we've seen, this does not impact the original string. It gives us a copy or a new string instead. So the next one I'll show you is called replace. Replace actually is a lot more powerful than what I'm showing you right now. You can use something called a regular expression to match patterns and replace a pattern instead of a specific string. But we're not going to do that because we don't know regular expressions, at least not at this point. So we need to pass in 2 arguments. The first is what we're trying to replace, and then the second is what we want to replace it with. So let's try it over here. I've got this message, haha, that is so funny. Let's replace haha. So message dot replace, and then the first thing I want to search for, whoops, come back here, and then what I want to replace it with. So I want to search for haha and replace it with lol, like that. Okay? And that's what it does. LOL, blah, blah, blah. That is so funny. Now, it's only going to replace the first matching instance. So if we go back to message, and I want to replace, I don't know, H's with an uppercase H or something, message dot replace a lowercase h with an uppercase H, it's only going to do it on the very first one. Now, there's actually a method called replace all. Can find it over here. This is not really meant to be a comprehensive overview of all of the string methods that we have. The one thing I'll say about replace all is that it's not fully implemented these days. It's not in Edge, Internet Explorer, Opera, so it will work in Chrome, I'm pretty sure. Let's try it. Replace all. No, it does not know about it here either. Interesting. Well, that kind of demonstrates my point. It's on the docs, but it's not recognized by most browsers at this point. Okay, so all of these that I've shown you in this video are methods that accept inputs. We call those inputs arguments. So we pass them in. We can have one, we can have multiple. We separate multiple by commas. One more I'll just show you that you may want to use at some point is called repeat. Let's just do something like lol.repeat. And then I pass in the count, the number of times I want something to repeat. There's 2, here's 10. It's making me a new string. The original, like always, is unchanged. So just another example of passing in an input. This is a pretty simple one to understand, hopefully. I should have led with that one, maybe. So again, there's plenty of other methods we have not gone into. We don't have time, and it's just not worth it, even if we did have a lot of time to do this. These are just things you can look up if you ever need them. If you ever see somebody using one of these methods, they're all listed here on MDN. You can read about them. If you want to learn more about concat, for example, you can do that here. But I just wanted to make this point of methods are a thing. Some of them require no inputs. We use empty parentheses. And some of them ask for arguments, these inputs we pass in between those parentheses that will alter the behavior. At the end of the day, a method is just an action with a name that we can call upon, in this case, a string. But we'll actually see that other built-in values and different things in JavaScript have their own set of methods. There are number methods. There are methods that work with arrays once we get to that, and to objects. And there's all these different built-in methods. We've only seen a couple of string methods. Okay, so next up, we're going to talk about something called template literals. But first, I'm going to present life without template literals. So imagine we have a variable called product, like this. Product will be a product name, like, how about artichoke? Did I spell that? Well, that's how I'm going to spell it. And then we have a price. Let price equal, I have no idea what an artichoke is. I know what it is. I have no idea what they go for. I think they're kind of expensive. Let's just say $3.99. That might be horribly off. Well, I did some research. I think $3.99 is a bit expensive. So let's update price to be $2.25 is what one costs in my area. All right. And then I'm going to create another variable with quantity. And I might just abbreviate it, QTY. That still tells us what it is, right? It's not sacrificing this, but we are losing a couple characters. So quantity, let's say I buy 5 of them. Okay, so what I want to do is print out or just create a string that says something like, you bought X artichokes, or yeah, in this case, product is artichoke, and your total is price times whatever this quantity is. So 225 times 5. And I want that to all be in a string. So with what we know right now, I can do this. I can concatenate strings with a plus sign, right? You bought, and then I need to add in the quantity. So this is annoying because I need to plus QTY, right? We saw this concatenation, but then I need a space. So I've got to add an empty space there. And then here, I need to add another space, right? And then I want to add the product name. So that's product. You bought 5 artichoke. And if I really want to get specific, I could add an S. But let's just say you bought 5 artichoke. And then after that, total, maybe a period, total price, or total is, and then I want to display the price times the quantity, like this, 11.25. All right, so that's a lot of plus signs, a lot of closing quotes and then reopening them. Adding a space between 2 variables, that's really annoying. Just look at all this unnecessary work we had to do here. Plus, quote, space, quote, plus. That's a lot. So there's a better way. Now this does work, right? I made this new well, it's not a variable, but I made this new string. You bought 5 artichoke. Total is 11.25. But what we're going to see right now is the newer way of doing this, something called a template literal. So these have not been around since the dawn of JavaScript, like concatenation has. These template literals are a newer syntax, and they're super useful. They allow us to create strings where we can embed an expression inside the string, and that expression will be evaluated and turned into a string. So you can see an example right here. I counted 3 plus 4 sheep. That will be evaluated and replaced with a string. I counted 7 sheep. So there's a couple things you must know. First of all, in order to make this work, you have to use the backtick characters. Now, you may not be familiar with the backtick. On my keyboard and most keyboards I've ever seen, all keyboards I've ever seen, which admittedly is just North American English keyboards, the backtick character is located above my tab key on the left side, top left of my keyboard, right before the number 1. So there's a little tilde above it. Here, I'll just type it here. This is what backticks look like. They are different than a single quote. This is single quote, that's backtick. So those backticks are very important. So I can just make a string with backticks, by the way. Hello, close it. That is a string. You can see it's printed out to me with double quotes. It just indicates that's a valid string. But what's really important about backticks is inside of them, if I use this special sequence, a $, and then curly braces, opening and closing curly braces, whatever I put inside of those curly braces will be treated as an expression and it will be evaluated. So I can do something like this. Hello. I don't know why I do hello. That was a waste of life there, but $, curly braces, and then inside of this, I can do some math if I wanted to. 1 plus 2 plus 9, right? That is going to be evaluated as JavaScript, not as a string. So just to be very clear, if I use single quotes here instead, I just made a string that contains that, literally contains $, 1 plus 2 plus 9. With backticks, it's evaluated, all the content inside the curly braces, and we don't see the $, or the curly braces. This whole thing is replaced. So this is really, really useful for a lot of reasons, but if we go back to this example of what we did right here, you bought quantity plus product. Let's just recreate that. I could do you bought, and then right here just a space, and then my $, and then QTY, which is a variable. We could just start with that. You bought 5. And then if I want to add the product with a space, it's as simple as another $ curly brace, product. You bought 5 artichoke. And if I want an S, I can just add it right there. So I am embedding variables directly inside a string. And let's finish this up. Total is, so why don't I add a period? Total is colon, and then price times quantity. Well, I can do that right here. Price times QTY, and total is 11.25. If I wanted an actual $, right there, I could do double $. That first one is part of the string template literal. It's escaping our string and it's replaced, right? This whole thing ends up being removed, leaving us with this original $. So that's kind of all there is to it. Just remember, you've got to use backticks above your, at least most tab keys, I think. And it's not a single quote, but if you do use those backticks, we can use a $, and curly braces inside between the 2 backticks and write whatever we want in there, a valid, I mean, it needs to be valid JavaScript, but our expressions will be evaluated and turned into a string. So that can be as simple as taking a number from a variable and replacing it and putting it right there, or it could be some math, or it could even be calling a method. For example, I could do product dot to uppercase, You bought 5 artichoke. Total is 1125. So that's string template literals. We'll be using them very frequently, and that's all I have to say, so I'm going to go away. Okay, bye. All right, so remember this slide of the 5 common primitive types, the basic building blocks in JavaScript. Of those 5, we have covered numbers, we've covered booleans, and strings. Next up, we need to talk about null and undefined, which fortunately are very simple compared to something like strings, which took, 6, 7 videos? I've lost count. So that's what we're going to do right now. Surprise, surprise. Null and undefined. Here we go. So both of these are primitive values, and they can be a little bit confusing at the beginning. They both seem like they have a negative connotation, like they refer to nothingness or to a problem, or I mean, I don't know. Maybe that's just my mind and how it works, but they're kind of similar. Both of them are single values. So null, we get this value, null. Just like true or false, right? We can type null. It's not a string. It's not a boolean. It is an actual value in JavaScript, and same with undefined. Now, we've actually run into undefined before. Let's start there. Can you remember where we've seen undefined before? Well, how about this? Hello, and then square bracket of 99, index of 99. There's nothing there. Or if we make a variable, let x, not a great variable name, but I don't give it a value. So I have created the variable, but it's initially set to undefined. It does not have a defined value. So you can kind of think of undefined as JavaScript's way of saying, I don't know. I don't know what you want. I don't know the value. It's not defined. Versus null, which is pretty different. It is the intentional lack of value. And this is something that we assign. So it's a value, we can make a variable and set it to null. For example, if we have a variable called logged in user, and initially there is no logged in user, we could set it to false or to 0 or to, an empty string, or we could set it to null, which clearly indicates explicitly there is nothing here. It's just the concept of nothing. Versus undefined is different. Hopefully you can see that undefined, first of all, is not something that we set ourselves usually, or that we use. We don't set a variable to undefined. Undefined instead is a concept that just means something not being there, not being defined. It doesn't mean nothingness. Now I see how that is very confusing, and I may have just made it far worse. Let's just simplify it even more. Null is something you won't run into really very often at all. It is something you may set as a value for a variable, whereas undefined is something that you will run into pretty frequently, especially later on. Once we start working with more methods and writing our own functions, we'll return back to undefined and we'll learn a bit more about it. All right, so those are actually 2 primitive types. They're simple, very simple compared to things like numbers and strings. So that's it. We've now rounded out our 5 essential primitives. So next up, a one-off video on something called the math object. Built into JavaScript, out of the box for free, we get access to this thing called math with a capital M. And it's just a collection of properties and methods that have to do with math in some way. So we have methods like rounding, or round. We have a method called abs for absolute value. We have constants, mathematical constants like pi, the value of pi, 3.14159, and so on, which at one point I knew the first 200 digits of. In like 4th, 5th grade. We had a competition at my school. Anyway, I've lost almost all of that. So this math object is here in the console. I don't have to do anything. I can just reference it. And I can actually just hit enter on math and expand this. So we haven't talked about objects yet. And you don't need to really understand what an object is in JavaScript, except for the fact that it's a collection of properties and methods. So one option would have been to make just a variable called pi that we always have access to, and another one called e, if you know Euler's number, or the square root of 2. That could just be available anywhere, right? So I could just do that, or JavaScript could do that. It doesn't, because instead of just polluting the namespace, which basically means instead of just having a bunch of variable names taken up, JavaScript's approach was to combine all of those into a single object, so they're all nested under this thing called math. So I have to access math.py or math.e for Euler's number. You probably won't really need either of these, at least not with what we're going to focus on for now, but they are there. But what I want to focus on are the methods. These methods range from things that you probably won't need to use at all, like, arctan, or what is it, cosine, sine, square root you may want to know about, but the ones I'll be showing are mainly around random numbers and a little bit around rounding and flooring your numbers. So you can read more about the math object on MDN. There's a page for every single method if you wanted to learn about sine and how it works. Not necessarily the math behind it, but how the sine method works and if it expects any arguments and how they work and all of that. But I'll just show a couple of these methods right off the bat. First of all, we've got one called floor. Math.floor will take a number with a decimal and chop off that decimal. So it's not rounding. This could be 9999999, which would round up to 24. It's just chopping it off. So that's floor. We also have ceiling or ceil. So I could have 34.1, and it's going to round it up no matter what. So 34.9999 is going to ceil or ceiling to 35, and 34.01 will also round up or ceiling up to 35. So those, maybe not that useful on their own, but what I'm going to show you now is how we generate random numbers. So there's a built-in method to that math object, and this is really the whole reason I'm showing you the math object in the first place. There's a built-in method called random. And random is going to give us a random decimal number between 0 and 1, but it won't actually include 1. So it's going to be between 0 and 9.999999999 math.random, just like that. So every time I call that, it is a method, I need those parentheses. Every time I call it, I get a different, very long decimal. Usually, well, sometimes that's fine, but most of the time, if we're trying to get a random number, we might be trying to get a random number between 1 and 2. We might want a coin flip, or 0 and 1, where it's just integers. The whole number 1, whole number 2, like what's your favorite number between 1 and 100? I don't want to hear, 94.1281593. I just want to hear 91 or 92 or whatever the number is. So to do that requires a bit more work. We don't actually have a method called random integer or random int or something like that. Many other programming languages do. In JavaScript, we don't. But we can do some math. We can take a number like this and then floor it in order to get a whole number. So it's a multi-step process. Let's say we want random numbers between 1 and 10. I can call math.random. So that gives me a very long decimal between 0 and 1. Then I can multiply by 10. So now I'm looking at 5.961, blah, blah, blah. Then I can floor that to just get 5. Okay, so let's try that. Let's do a number between 1 and 5. So math.random, and I'm going to multiply by 5. I want a number between 1 and 5. So that gives me 3.7 this time. Next time it's that gave me 1.8, 4.1, 4.2, 0.8. Okay. And then I'm going to math.floor that. But I want to floor the entire thing. So what I did here was put it in a variable and then floor that. But that's a bit extra. I don't really need this. I don't need this step on its own. So I'm going to do a math.floor. Remember what floor does. It chops off the decimal. So math.floor of our random number multiplied by 5. Okay, so we're getting 0, 3, 4, 3, 4, 2, 1. So I am getting 5 random numbers. The problem I have now is that it's going from 0, right? Our random numbers, just math.random in general, goes from 0 to 1, non-inclusive. Then I multiply it by 5. I'm never actually going to have 5 as a random number. I'm going to have 0 up until 4. So if I want 1 to 5, I then need to shift everything up by adding 1. So this will give me a random number from 1 to 5. Now what if I wanted to go from 1 to 10? Well, I just multiply this by 10. Now I have random numbers between 1 and 10, random integers. What if I want to go from 20 to 22? Well, all I need to do is figure out how many options, how many numbers am I trying to generate? Well, 20, 21, and 22, that's 3 numbers. And then I can shift this upwards by 20. So I get 20, 21, 22. So not that common to do that. It's most common to generate a number starting from either 0 to something or 1 to something, but if you ever need a range, you can shift it upwards as much as needed. So that is math.random. On its own, it gives us a random decimal from 0 to 1. We can transform that and use math.floor to help us get integers, where we don't have that crazy looking decimal. So we have other methods on the math object, right? Round, absolute value, power, which will raise something to a power. Although we already know how to do that, we don't really need the math object, right? We can do this. Math.power of, let's say, 2 to the third is the same as just 2 star star 3. So if you have any other questions about the math object, take a look at MDN. Remember, we have not really covered objects at all. So all that we know right now is that an object is just a place to store stuff. So it's not all hanging out on its own in the middle of nowhere. All this math functionality has been combined into a single object, a single entity called math with a capital M. Welcome, one and all, to our next section on JavaScript. Today we're talking about making decisions with code. Boolean logic. Okay, that's enough of that. Welcome. We've got a big section here, another very important core concept in JavaScript, which is making decisions with our code, and something called Boolean logic. So there's a lot of stuff in here that's just going to go straight to the critical column, understanding comparison operators. Very important. Running JavaScript from a file. That's new for us. Also very important. We'll be doing that a lot. Conditionals. So this is probably the chunkiest part of the section, is the new syntax I'm going to introduce. If, else if, and else. Different pieces of conditional statements. Without saying much more, it is yellow because it's a heavier topic. It's not difficult, but it's just more involved than, defining a simple variable with let, for example. A quick one is truthy and falsy values, so it's in green. And then we get to these 3 yellow chunks, logical and, or, and not operators. These are all going in the crucial or critical column. They're not terribly difficult, but they are new to most people who have never programmed before. They're just a new concept. So I put them in yellow because sometimes I see students get hung up for just a bit on those 3 operators. Alrighty, so we're going to go ahead and get started. I mean, that's a foregone conclusion, I guess. We always do the same thing, but it's been great chatting with you, and I hope you enjoy this section. And if you don't, pretend you do, okay? Just pretend. Goodbye. So really quickly, I'd like to take a moment to explain why you should care about this section. In this section, we're going to talk about decision-making in JavaScript, although this will apply to pretty much any programming language. If you end up learning Python or Ruby or Java or something else, the concepts here are pretty universal. Okay, so when I say decision-making, I'm referring to having different outcomes based off of certain criteria. So in a web application context, I'll show you a simple example. Once again, going to Reddit. I am not signed in, thankfully. I can't show you my Reddit account. So I'm not signed in, and what do we see up top? Log in and sign up. Now, when I am signed in, this is a clearly fake account. Maybe the name fake gave it away. That's what I see up there. I don't see that, right? Can you see that distinction? Very different. 2 different outcomes based upon whether I'm logged in or not. Here's another example. If I go down, here's a very relevant photo to my life. Chicken finding bugs, programming, very funny. Anyway, if I try and upvote this and when I'm not logged in, it's going to yell at me and ask me to log in. Versus when I am actually signed in, I can click upvote. Just like I can also leave a comment along those lines with comments on a given post. If there are comments, we see those comments. But if there are no posts, or rather, if there are no comments, like on something new, what do we see? No comments yet. So different outcomes. When I say decision making, it doesn't have to refer to, some sort of super smart AI making what we think of as human decisions. It's just having different branching paths depending on some input. So what's the input here? Something like, are there comments? If there are no comments, display this. If there are comments, then display them all so that we can see them. Anyway, we're going to get a lot of practice with this sort of logic and decision making with JavaScript. We've got to start very simply, so that's coming up in the next video. All right, so we've got a decent amount of stuff to cover here around making decisions. And the first place we'll begin are with simple, hopefully simple, comparison operators. So these are operators kind of like plus sign or subtraction or multiplication that are built in to JavaScript, except they're not necessarily mathematical. We're not adding things together, or we're not doing math. We are comparing two values, a left and a right. So we're going to start with the first couple. We're going to ignore the bottom ones with double equals, basically equality, not equal. These will be a separate video following this video. So the first four, let's just do greater than and less than to begin with. So hopefully you've seen greater than and less than before. When I was a kid in school, we took two popsicle sticks, we formed them into one of those shapes, little alligator. We put teeth on it and what do you call it? One of those wiggly eyes. It's not a wiggly eye. What do you call them? Googly eyes? It makes no sense either. And we painted them green. We made an alligator greater than and less than, and we would point it in the right direction depending on if something was greater than or less than something. For example, if we have 1 and I want to compare it to the value of 3. Is 1 less than or greater than 3? Well, let's just do 1 greater than 3. What do I get? I get false. 1 less than 3? I get true. So these return a Boolean. They give us one of two values, true or false. That's it. So I'm comparing two values. Let's do -1 greater than 20. False. How about -1 greater than -1? Also false. That brings us to the other two values, or the other two comparisons here, greater than or equal to and less than or equal to. So I could do -1 less than or equal to -1. That is now true, right? They are equal. If I do -1 less than or equal to 10, that is also true. -1 is less than 10. So these are simple, hopefully. They return, or they give us a true or false value. That's it. But they become very useful in the real world when we're working with data that is unknown, right? We don't know exactly. Let's mimic that. Let's have a variable called age. Let age equal, I don't know. I'm going to hide it from you, okay? Okay, I made my age variable. I gave it a numeric value. And let's say we're writing some software, and you have to be 18 to sign up for our website. So I could check, is age greater than or equal to 18? And it is. I don't have to know exactly what it is, but I do know it's greater than or equal to 18. What was it, 31? Okay, so very simple example, and we're still not making a decision based upon this. We're just testing. We're comparing. Is this mystery variable greater than or equal to 18? True or false? But then I can use that once we learn how to actually have those branching pathways, how we can have different outcomes. We'll use these comparisons to help us. So that's kind of all there is for these first four. Greater than, less than, greater than or equal to, less than or equal to. One thing I should highlight though, is that we're not limited to doing this with numbers, although it's most common to do that. You actually can compare two strings. I can do A less than B. It's just kind of dicey. It's a little confusing because it's not always, it doesn't work the way you might expect it. What happens is that every character, like A or B, or even the star character, an asterisk, or a period, or a less than bracket itself, they all have an underlying code, a numeric code, thanks to something called Unicode. So they all have a code, and here's just a small subset. These are the basic Latin characters. So something like the @ sign has a Unicode value of 40. Something like lowercase a has a value of 61. And B is 62. So we can compare them, but what we're comparing there is not necessarily which one comes first in the alphabet, although in this case that's true. Also notice that uppercase letters come first. So we have uppercase A and lowercase a, 41 versus 61. So I could do is uppercase A less than lowercase a. That is true. But we've got things like the @ sign. That is 40 versus 41. So is this less than uppercase A? That is true. It just gets complicated if you're working with long strings and you don't actually know the codes and the values. Most people don't. I mean, it's good enough to know that uppercase comes before lowercase, but then there's a lot of other symbols and things that aren't necessarily included in this one table. If you get into other alphabets, all of these have Unicode characters. So we could look at the Armenian alphabet. Right? I don't know any of these letters, but they have their own Unicode values. So if you are trying to compare strings, just keep that in mind. It may not work the way you're expecting, but it is possible, and we don't get an error or anything. We still get true or false. So those are the basic comparison operators, at least the first four. Next up, we've got the second four, equality operators. So next up, we're going to talk about the bottom four operators here. They are also comparison operators, and they have to do with equality. So to check if two values are the same, if they're equal, we actually have two options. We have double equals and triple equal sign. This is a pretty important distinction. Well, I haven't shown it to you yet, but there is a very important distinction, and this is a very common point of confusion for new JavaScript developers. So we're going to spend some time talking about that in this video. And the first one we'll see is double equals, two equal signs in a row. And this is going to check if two values are equal, but it does not care about their type. It does not care if they are the same type. What this means is that it will attempt to coerce two values. If they are of different types, it will attempt to coerce them to move them into or transform them into the same type so that it can compare them. And this can lead to some unexpected results. So let me show you the non-unexpected, or I guess you could just say expected results. If I do 1 double equals 1, well, that's true. 1 is equal to 1, and they are the same type, so no problem. But something like this, 1 double equals the string 1, those are not the same. 1 is a string, 1 is a number. And that might seem like it's not a big deal. You know, it's close, right? It's the string 1 versus the number 1, but that can be very problematic. So it does not care about type. So it converts them to the same type and then compares. I have a few examples just to illustrate this oddity. Something like 0 and an empty string. They are considered the same with double equals. 0 and false are considered the same. Null and undefined are considered the same. Those are completely different concepts. It still says true. Now, obviously, if we do things like 1 equals 2, false, or A equals B, those are completely different. But if we have something like, 0 equals false, those seem like they're completely different concepts. One is a Boolean, one is a number, but for some reason, we get true. Now, we'll understand more how this works and why 0 and false are considered similar enough when they're converted to the same type. We'll get to that. But for now, hopefully this illustrates this concept that a lot of the time it doesn't matter. If we are working with data of the same type, it just works like an equality operator. That's what it is. It's checking to see, is this thing equal to this other thing? But when we are working with different types, we get unexpected results at times. So that brings us to triple equals, which is also known as the strict equality operator, but almost everyone just says triple equals. It does care about type, so type and value. It's not going to attempt to coerce anything to the same type. So 1 triple equals 1 is the same as double equals 1. They're the same type. But now if I have 1 triple equals the string 1, that now is false. Remember, with two equal signs, that is true. It coerces them to be the same type. With double, with triple, it does not. Same thing with 0 triple equals false. Well, not all caps false. There we go. That is false. With double equals, that is considered true. Now we also have two operators to check for non-equality, to verify or to compare two things and see if they are not the same. We have a version. They both use an exclamation point, by the way. We have our first version, which is similar to double equals, where it does not care about type. And then we have the second version, which does care about type, which goes along with the strict equality or triple equals. So here's an example. If I want to know if 1 is not equal to 2, simple enough. This version does not care about type, so it will tell me 1 is not the same as 2. Now, if I did 1 is not the same as 2, the string, we get true. They are not the same. But what about this? 1 is not equal to the string 1. Well, it tells me false, because it does not care about type. It converts them so that they are similar type. It compares them, and what do you know? They are the same. It's the opposite of doing this. Whereas if I use the strict equality version, like that, with two equal signs, 3 characters though, so it goes along with triple equals, even though we don't have 3 equal signs. We have 3 total characters. Here, I get true. They are not at all the same. They are not equal. So this can get a little confusing to talk about with all the equal signs and double and triple. The takeaway that you should leave here with is pretty much always use triple equals when you're comparing things to see if they're equal. Always use triple equals. Maybe there's a time where it will make sense for you to use double equals, but if you get to that point, you'll be a skilled enough developer that you're able to decide on your own. Until then, always use triple equals. Remember, it does care about type, and it's important that it cares about type. That is something that can really trip you up and cause issues later on. And then along with that, if you're checking to see if two things are not equal, use this version, which also cares about type. It is the strict non-equality operator. So it goes along with triple equals. So no, double equals is a thing. This is a thing as well, but you should use triple equals and strict non-equality. Those are the two operators you should use for equality and non-equality, and I'm going to shut up now. Keep that in mind. Just cement it as a rule in your brain for now. Triple equals always. So we're about to learn how to run code from an actual JavaScript file. Not just our good friend the console, but actually from a script that we then include in an HTML document. We open that in the browser, kind of like the way we include a CSS style sheet in an HTML document. But before we do that, I need to mention a couple of things, a couple of important methods that you'll want to know about. And the first one is called console.log. Now, console.log is not very exciting. In other languages, it would just be called print. I don't know why it's console.log. It's just the JavaScript way. And this is going to print whatever arguments we pass in to our console. So if we run this in the console, it seems kind of ridiculous to do console.log hello. It prints out hello, right? We don't really need that if we're working in the console. If I want to see the value of something like 1 plus 4, I can just type it in and get 5. But when I'm working in a file, that file is completely disconnected from my console. I don't see anything that I'm typing in that file. I don't see live feedback. Remember this term REPL, read, evaluate, print, loop? Well, this is a REPL. When I run my code in a file, it's more like read, evaluate. So in order to print anything out, we can use console.log. You can pass in multiple arguments. So I can do something like 1 plus 4, hi, and true. Those all get printed out separated by spaces. Now this console thing is actually an object. Remember how we had math? And there's a bunch of these methods on math. Math dots, a whole bunch of stuff. Ceiling, random, floor, power. Well, console's not as complicated. Console dot. But we have things like console dot, clear, console dot error, console dot warning, console dot time. Console.log is the most common one. I think I said warning, it's warn. But if I do warn, warning, it's going to print it out differently, right? It makes it clear that it's a warning, gives us this little warning sign. And I can do a console.error. Here's my error, and it prints out just like I would see if I did something like this. I mean, the error message is different, but it's showing up in the same color, in the same way in my console. So console.log is what we'll be using. And then also, while we're here, another method that you might care about, another two. First one is called alert, and alert is going to print out something to the user, but not in the console. So if I do something like hi there, and I hit enter, can you see I get this pop-up? It's really annoying when websites do this, so I don't recommend you do this in any production apps, but it is a thing that you may see. And another option is something called prompt. So prompt is going to accept an argument. How about this? Please enter a number. And if I hit enter, it actually pops up and asks a user to enter a number. So let's enter 13. Okay, so it just now shows me the string 13. Normally what we do is save that to a variable, like let num or user input equal prompt. So now enter a number, let's go with 97. And if I look at user input, we have the string 97. So that is something that may be useful for us for some of these early exercises and sort of, I won't say project, but little demos where we need to get some user input. Typically, if you need user input, you make a form, right? We make an input in the browser with HTML, and we can use JavaScript once we learn how to connect the two. But we don't know that yet. So prompt is an easy way to get some user input, to prompt a user. And then it gives us a string. So if we're trying to do math with this, for example, I wanted to compare it to a number, or I want to add something to 97. I want to add 1. Let's say it's a birth year or birthday. I want to add 1, so we go up to 98. Well, I can't really do this, right? I get 971. I'm concatenating two strings. Well, this is a number, but it's going to be turned into a string, and then it will be concatenated. What we want instead is to turn this into a number. And there's a way of doing this. Parse int, user input. That gives us the integer 97. So it accepts a string and will parse an integer from it. So I can have parse int of the string 101, right? I get 101. If I have letters in there, it's going to try and find the integer. It can be a little bit janky at times, but it's trying to extract a number, and actually it will give you a number instead of a string. So I can now add 1 to that. I can do parse int of user input plus 1. We get 98. All right, so those are a couple of methods. Really, console.log is the key one for now. It seems useless, but in the next video, it will become a lot more useful when we're actually running code from a file. Okie dokie, it's finally time to run our code, our JavaScript code that is, from a separate file that we can save and revisit. Typing our code in the console is great for, one-off things. We're just quickly testing what is 1 plus 3. Great, we don't need to make a file and save a script and execute that script in the browser. Let's just do it in the console. But if we want to write more than one line at a time, technically you can do multiple lines if you hit Shift-Enter. You can type multiple lines there. But still, the point remains that as soon as I do hit enter, or I close this window and come back, or my computer dies, I thought the charger was plugged in and it wasn't. Happens to me all the time. My code is gone, right? This is not permanent in any way. And most websites, most applications are going to consist of hundreds, if not thousands of lines of JavaScript. So this is really not where we want to write real code. It's a great place to test things out. It's a great place to debug your code to figure out what's going wrong, but it's not a real editor. That's why we have VS Code. So to run a JavaScript file, what we have to do is make a JavaScript file. So we can start there. I'm in a new folder here. I'm calling it running JS script. And the only requirement here is that our file ends in .js. So why don't we go with script.js or app? I like app.js, but whatever works. Notice VS Code gives me the little JavaScript logo, the icon. Yours might look different. So in here, we can put some code like, 1 plus 3, but remember, this is not going to show up anywhere unless I print it out. So we'll do a console.log, as we just learned. Hello from our first file, our first JS file. Okay? Now I'm going to save this file. Now in my index.html, I need to connect this script with the HTML file. So I can't just open this in the browser, unfortunately. To connect it, what I need to do is use a script element. So in HTML, we have a script element. It does kind of what I've already said. So the script element accepts an attribute called source, src, just like we have on an image. And this source needs to be the path to a script. So app.js, just like that. Okay, and then I can open this in the browser. So I'm just going to give this a new title, first JS script. I'll open this in the browser like we've opened everything else. I can put an H1 or something in here if I want, but we're not going to be working with the HTML. We're simply using this HTML document as like a vessel to carry our script. It's just a conduit so that we can actually run our script, but our script won't be interacting with the elements, not yet at least. So I've got my H1, first script. Now I'm going to open this up. Here it is in all its glory, a beautiful web page. And I'm going to open the console. And there we go. So it's up to you how you want to manage this, if you want this to be collapsed as a drawer in the actual browser web page. But since we're not interacting with this content, I usually just pop it out like we've been doing. This is now where we'll go to see the result of our code running. So I just want to emphasize this one more time if I wasn't clear enough. Doing something like 1 plus 3, that is going to run, but we won't see any output. I'm refreshing the page here, which is what we need to do anytime I change my file. Just like an HTML or CSS file, if I change this, I need to save and then rerun it in the browser or just refresh. So I don't see that, even though it actually did execute. It's just not there. Now, what I could do is make a variable, let total equal 1 plus 3, and then refresh over here. I still don't see it, but I do have access to those variables I've declared over in my script, assuming that the page is open. So it's not like every browser window ever will have access to total. It's just in this file that I've made right now. So I can put multiple console.logs in here, of course. Console.log, hello from a file. Console.log, goodbye. Refresh, and now we get both of them. The other thing I want to make clear up front, you'll learn, or we hopefully will learn together as we progress through JavaScript, that this is actually not the ideal placement. It's not the ideal place to put a JavaScript script in our document. Usually, we put these down at the very end of our body. Now, it's not going to make a single, I was going to say a wink of difference. I don't know if that's a real expression. An iota of difference. It's not going to matter right now. Because the reason we do this has to do with when we're writing JavaScript that interacts with HTML elements. Like if I wanted to have a button in here and I could click it and it would run some JavaScript code, I want those elements to be loaded. I want them to be acknowledged by the browser before my script. But right now we're not doing it, so it really won't matter, or doesn't matter right now. But it's a good habit to get into. You can add your scripts at the bottom of the body. Not outside it, but at the end of the body. And I think that's pretty much it. So make a file with .js as the extension, put your code in there. We'll be doing this all the time. Connect it to your HTML document with script, the script element with a source attribute. Make sure that path is correct. File name matches. If you have something like JS/ if it's in a folder. And then open that file in your browser. I have it open right here. And then open up the DevTools, and our console will print out, it will show us whatever we've printed out from our JavaScript file. Okay, so that's the recipe to follow. Okay, so we've seen how to run our code from a file, and we've seen how to do some simple comparisons. How to do something like, where's my console? Here we are. Is some variable, let's say age, greater than 18? But we haven't seen how to do anything using these comparisons. So I can check if this is true or false, but what if I want to have one outcome if it is true? Something as simple as printing good versus bad, or, enter the bar, or I'm sorry, kid, you got to go home. You're not 18. Two different outcomes. How do we do that? Well, that's what we're going to see right now. We're going to talk about conditional statements. So making decisions with our code. And the first thing we'll see is the if statement. So down here, if, and then parentheses, some condition. Now this condition is simply anything that evaluates to true or false. So if it evaluates to true, the code in between these curly braces will execute. Now if that condition is false, nothing happens. Well, it's not necessarily true that nothing happens, but this code will not run. In other words, this console.log only runs in this scenario if the rating variable is exactly 3. And it's very stupid because we know it's 3. But imagine this is coming from a database or from a user or, some library or some fancy website where we don't know what rating is. This is a way of saying if rating is exactly 3, do this. So this syntax is incredibly commonly used. We'll see it all over the place. If, parentheses, some condition in that parentheses or inside those parentheses. So let's try it. I'm going to make a new file just to get a little bit more practice here. Conditionals. And just so we're clear here, this is an if statement, but we can combine this with other pieces like else if and else to form a full conditional, but it doesn't really matter in terms of terminology. I'm going to call this conditionals. I'm going to include a new script that doesn't exist yet. New file, app.js. I'll put some code in here. I always just like to make sure it's working. Console.log. It's working. Include my script. Script, source. Well, I did the wrong autocomplete, but we can add source ourselves. App.js. Open it in my browser. Here it is. Refresh the page. Go to the console. Perfect. It's working. Okay, so let's now actually do our own conditional. Let's create something really simple, like if, and we can do something trivial. If 1 plus 1 triple equals 2. Curly braces. Console.log. How about math still works? Okay, so if that's the case, 1 plus 1 is 2. Well, hopefully. I refresh, and we get math still works. Now, if I put something else after here, console.log, after conditional, and I'll do one before as well, console.log before, and I save, I cannot spell, but that's okay. I refresh, we see all 3. But if I change this condition to now be if 1 plus 2 equals 2, well, We know that's false. We just get before and after. But I want to be very clear, if this is false, only the code inside the curly braces does not run. It doesn't stop everything. Our code still lives on afterwards. It's just this stuff doesn't run. And I can have as many lines as needed in here. So instead of doing if 1 plus 2 equals 2, why don't we do something more like, let's pick a random number, okay? So math.random. Remember, that gives us a tiny little decimal between 0 and 1, math.random. And let's pretend I'm flipping a coin or something. So I'm going to save that math.random to a variable. I'll call it let rand, or random, equal math.random. Now, I'm not going to be able to do a comparison with equality. I mean, I could, but our random number is something crazy like that. So I'm not going to be able to say if random equals that. We'll be here all day. But what I could do is just say, is random less than 0.5? So if random is less than 0.5, it's between 0 and 1. So roughly half the time it should be less than 0.5, and the other half it should be greater than. If that's the case, I'll do something like console.log, your number is less than 0.5, right? And then I could console.log the number too. Why don't we do that? Console.log, our random number, not the actual digit 2. Console.log random. All right, and let's just get rid of before and after. You already saw how that works. Let's refresh. Nothing. So that must mean that our random number was not less than 0.5. One more time. Nope. Again. I'm still refreshing. Hey, finally worked. Your number is less than 0.5. We got 0.416, blah, 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 blah. Try again. Here we go. Your number is less than 0.5, 0.09, small one. Okay, so this is the basic syntax of a conditional. We can have as many as we want. I could do something like this. If random is greater than 0.5, I should do greater than or equal to, technically, just in case there's that magical chance that it actually is exactly 0.5. If that's the case, let's just duplicate this. Your number is greater than. Now this seems kind of silly to do it this way, and it is. I'll show you a better way in the next video, but this will work. If I refresh, now we get your number is greater than 0.5, and here's the number. Greater, less, greater, and less. So we have two different ifs, two things that we're checking. Is random less than 0.5? Do this. Is it greater? Do this. All right, so this is our first piece, the if statement. Simple enough, hopefully. We have if, and then in parentheses, something that evaluates to true or false. We'll see more and more complex stuff that can go inside of those parens, but at the end of the day, they all evaluate to true or false. A binary, Boolean, yes or no. So next up, another piece of our conditional. Okay, so that's the if statement. Next, I'm going to show another piece that we can chain on. It works in conjunction with an if. In fact, it only works if it's preceded by an if. It's called the else if. So you can think of this as, if not the first thing, if the if part was false, then maybe try this other thing. Else if. So in this case, once again, it's very, very stupid to have this variable rating. I'm setting it to 2. It's kind of redundant to then check if it's 3 or 2. But imagine it's random or it's coming from a user or something. We don't know what it is. Put your finger over it and pretend it's not 2. We check if rating is equal to 3. That's false here. So this does not run. And we instead move on to this one right here, else if. So this will only run if the first thing was false. So only one of them will run. Let me demonstrate that over here. Why don't we start with a simpler non-random thing. So I'm going to comment this out in VS Code in case you don't remember. It's the same shortcut to comment CSS or HTML. For me, it's command /. So let's do something involving the days of the week and strings. So I'll make a variable here. I'll call it day of week. I'll use const because I'm not going to be altering this. So const day of week equals, and then I'll start it off as Monday. All right. Which I think most people agree is if you work a 5-day a week typical schedule, it's a pretty bad day if you had to pick one. So we'll add an if day of week equals Monday. And if that's the case, we'll console.log ugh, I hate Mondays. All right, so we can just verify that works. I'll refresh the page. We get ugh, I hate Mondays. But there's other days, some that are better, some that are terrible. Let's say Saturday. If we get a Saturday, I want to say, yes, I love Saturdays. So I can do an else if day of week equals Saturday, console.log, yay, I love Saturdays. So notice I put this on the same line as the closing bracket for my if. You don't have to do that at all. It's just a habit that I have. It's not a bad habit. It's just a style or a convention that you can follow. But please, by all means, don't feel like you have to do that. All right. So these are linked. Remember, only one of these will ever run. Only one console.log will print. And in this case, it's ugh, I hate Mondays. If I change it to Saturday, hopefully, Saturday, and refresh, yay, I love Saturdays. Now I can chain these together. I can have as many else ifs as I want. I just put another else if afterwards. So I could add another one on here. I'll duplicate this. What should I check for? Monday is not great. Saturday, Sunday is good. Sunday night though, it's a little, people get that Sunday night blues thing going on. How about Friday? If day of week is Friday, we'll go with Fridays are decent, especially after work. All right. So we now have 3 possible options, 3 possible outcomes. Let's change this to be Friday. So the first one, not true. It's skipped. Next one, not true. It's skipped. And our final one, it is true. We print this out. So if I have something else like Friday, nothing will be printed out unless I had some other stuff down here. So this one seems okay. It seems hopefully clear enough how this works. But let me just demonstrate one more example. I'm going to comment this out again. Let's go back to Friday, though, just in case you run that yourself. And let's make a variable called, how about age? And I'd use this example a lot. I know it's not very exciting, but let's say that we're running a theme park or something, and we have different age brackets. If you're 0 to maybe 5 years old, you can get in for free. If you are 5 to 10, you pay a child price, which will be, how about $10. And then if you are between 10 and, what else do we have? 10 and 65, that's considered adult. And then, 10 is kind of a weird cutoff, but whatever, I already committed to it. So your price is $20. And then if you get to 65 plus, you're going to be a senior, and you get in for $10. You get a discount. Okay, quite a lot there. So to implement this, if I wanted just a simple conditional, I'm just going to comment this out because it's all completely invalid, but we'll leave it there to follow. If I had some conditional or some variable, we'll call it age, const age, and I'm using const again just because this won't be changing after I create it, just like with day of the week. I can alter it here, but it's not going to be updated after the fact. I'm not adding to age. So age will be, how about 8 to begin with. So I can start if age is, how do I want to do this? If it's less than 5, I could start with that. If age is less than 5, console.log, you are child. I don't know why I do this in all caps. Let's just do, you are a child, you get in for free. All right, let's verify it doesn't work, right? Because price or age is 8. So then I can add in my else if, and this time I can do else if you are under 10. And the reason this works, remember, it's all hinging upon this order. This code only runs, this conditional here will only be attempted if the first one was false. So that means if we make it to this point, we're already guaranteed not to be less than 5. So else if age is less than 10. This is really saying, all right, if you're not less than 5, are you less than 10? And for this to be true, you would be between 5 and 10. Hopefully that makes sense. I'm trying to demonstrate that these are linked together. It's not just 2 things we're testing. This thing is only tested if this is false. So console.log, you are a child. Oh, I think I went with child And then this is also child. Why don't I rename this? You are a baby. You get in for free. You are a child. You pay $10. Okay? And then let's check that out. I'll refresh. You are a child. You pay $10. Let's try it with 2 years old. You are a baby. You get in for free. Now I can add another one. Else if age is less than 65, console.log, you are an adult, you pay, and then what did I say? $20. Alrighty, so let's make this about 34 years old. Refresh. You are an adult, you pay 20. We go back to 3, you're a baby. So hopefully that demonstrates how these are linked together, right? In order for this to be true, we already know to make it to this point, this was false and this was false. So we know for sure age is not less than 5. It's definitely not less than 10. And then if this is true, we know, all right, well, it's somewhere between 10 and 65. So the order matters, at least with the way I've set this up right now. But I'm shortly going to show you some other options for how we could rewrite this. But really my point I wanted to make clear right now is just that these are linked. If you use an else if, it's got to come after an if. Or it could come after another else if. And they are sequential. So this thing is tried. Is that true? Well, then we're done. We just completely leave this whole chunk. If it's not true, we try this. And if that's not true, we try this. We could have as many as we want. I could have had 7 different ones for each day of the week. But I just didn't want to waste your time with that. All right, so next up we'll see another piece to our conditional, the final piece, which is else. All right, so let's revisit this day of the week thing from earlier here. Const day of the week is Friday, and then I'm checking if it's Monday, if it's Saturday, or if it's Friday. Now we've got a whole bunch of other days, and let's say for each of the other days, so if day of week is equal to Tuesday, I want to console.log meh, like meh, not a great day. And then I want to do the same thing for every other day. So that leaves us, let's see, we've got Monday, Tuesday, I've got Wednesday, which I can never, Wednesday, is that right? Oh boy. And then we've got Thursday, and then Sunday. Well, you know, Sunday's not really meh, but if I wanted to, I could put that in here too. They all have the same outcome. This seems a bit redundant. It's not redundant, but it seems unnecessary, and that's because it is. There is a better way of doing this, but just to show what I mean, right? I have Thursday as the day of the week. We get meh. If I have Tuesday as a day of the week, we get a big fat meh. So it would be great if I could combine them. They're kind of the otherwise, the last case, right? I'm checking, singling out Monday, Saturday, and Friday. Everything else, I just want to print out meh. So we have a way of doing that. It is the else statement. It's part of our conditional here. So else is going to be the last part. If you have an else, you don't have to, but if you do, it's the last piece of the entire conditional. And we don't specify any condition. We don't have parentheses. It's simply a catch-all. It's going to run as the last thing. If nothing else matched first, if nothing else was true along this journey, then do this. Think of it as just, if nothing else was true, do this. All right, I'm here. Nothing else was true. I'm going to run. But if anything was true along the way, then our conditional is done. We never hit that else. So here I'm using it. In this case, rating is negative 99. I'm checking, is it 3? Nope. Else if 2? Nope. Else if rating is 1? No. And then instead of having else if 0 and negative 1 and negative 2 in every possible option, I can simply add else. If it's anything else, then print out invalid rating. So I could rewrite what I have right here. Instead of doing Tuesday, Wednesday, Thursday, and singling them out, I can simply do else. It's just a catch-all. Console.log meh. So I don't have to specify if it's equal to Tuesday and Wednesday and Thursday. I don't need that at all. I'm simply saying otherwise. So now we still get meh, right? I can make it Tuesday. I could even prompt a user if I wanted to. Prompt, enter a day. Now, one thing to consider is that I have these uppercased, so we'll need a user to either enter it uppercased. So here it's prompting me. I'll enter Monday, uppercased or capitalized. I'll refresh again. Let's do Wednesday. I get meh. Refresh again. I'll do Friday. Fridays are decent, especially after work. Now, one thing that is, it's not problematic, but to be aware of, I can type anything in here and I'll get meh. So we're not checking to see if it's, Tuesday, Wednesday, Thursday, if it's a valid day of the week. I'm just looking to see if it's Monday, Saturday, Friday, or literally anything else. It could be 0, and I'm still going to get meh. So keep that in mind. And another way we could improve that is by downcasing everything or by uppercasing everything. So we can eliminate any user capitalization. So we know how to do that. Let's do 2 lowercase. So whatever the user enters, they might type Monday like this for some reason. We're going to lowercase it, and we'll end up with all lowercase Monday. And then we can compare that to all lowercase right here. So Saturday, lowercase, Friday. We're sort of getting everything on a level playing field. We're neutralizing all of the capitalization. And we could go the other way. We could capitalize everything and make it all caps. So now I should be able to type in Monday like that and still see, ugh, I hate Mondays. Or Friday in all lowercase except for a capital A. Fridays are decent. Okay, so that's the basic concept of else. It's a catch-all. It's a little bit, it's not a great use here because we're not ensuring that your day of the week is valid, right? You could type 0 or pink or something. The other thing I'll show you is how we could rewrite this here. Here, this is kind of silly to check if one number is less than 0.5, do this, and then just right afterwards, check if that exact same number is greater than or equal to 0.5. Well, it's only one of these, right? It's either or in this situation. So I could simplify this whole thing by deleting that if, and then just adding my else right here. Console.log, your number is greater than 0.5, right? If it's not less than, technically, I guess your number is greater or equal, is possible, than 0.5. So I don't need that second if statement, right? These are links. It's only one or the other. And then if I really wanted to do this nicely, so I could print the random in both places, or what's nicer is just to print the random after the fact so that I don't have to duplicate that code. I want it to happen no matter what. So only one of these runs, and then this always runs. So let's see what we get. Got to refresh my page here. Your number is less than 0.5. Less, greater. There we go. Less. So it's just either or. But that's not always the case, as we've seen. We can have as many else ifs as we want. We don't have to even have an else. You can just have an if on its own. You can have an if and an else if. But if you want to catch all, we can use an else. So I could update this code here for our age. Comment this out, where we're checking for a user's age or somebody's age. And I have a couple of options. So right now I'm saying if you're greater than 65, you're an adult. And then I could do else. Anything else? We'll say console.log, you are a senior, you pay $10. Okay? Now, we technically have a small issue here, which is that age could be super, super massive. It could be 55,000 kajillion billion. Not a real number, but it could be 500, right? And it's going to hit this else. But we can worry about that later. So let's do 89. Refresh the page. You are a senior. You pay 10. So yes, we're still not accounting for every possible situation, right? Our age could be, technically right now you could have a negative age and it's still going to trigger this right here because negative 100 is less than 5. You are a baby. You get in for free. But we'll learn how to tighten these things up. There's a lot we could do. First of all, we're not even checking if age is a number. Then we're also, allowing super large ages. You could have 890. And you'll still be considered a senior. We can have very tiny ages. You're considered a baby. This is kind of silly in the first place, but we'll see better ways of combining logic together to make more complicated statements. But the core mechanic here of having an if, and then optional else ifs, and an optional else at the end, that is never going to change. So just to be very clear, we can have an if on its own. We can have an if and then an else. We can have an if and then else ifs. We can have an if with else if and then an else. In all cases, if we ever have an else, it comes at the end, just a pure else. It's the last thing. And if we ever have an else if, it must come after the initial if or another else if. So I could have something like this. So I don't know if that was at all, that might have just confused you more. But we always have an if. at a bare minimum, if we're going to have any sort of conditional, there's got to be an if. We can't have an else on its own or an else if. They are relative to our first if. Then we can just have an if else for a yes or no, sort of binary, this or that. We can have 10 else ifs and then an else at the end. Anyway, I think hopefully that's clear. We'll get a lot of practice with this stuff. So that's the basics of making decisions. Now what we're going to add on are just fancier stuff inside of those parentheses. There's a lot more that we can do in there other than just checking to see if one thing is greater than or one thing is equal to another. We can start chaining things together and adding more complicated logic. Next up, we don't have any new syntax. I just want to show you a really important concept, which is that we can nest conditionals inside other conditionals. So I've got two requirements here for our little demo. We're going to ask a user for a password. So enter a password. And we don't know how to connect an HTML form with JavaScript and all of that, so we're going to use prompt. So let's make a variable, const. Once again, it's not going to change, so it's fine to use const. Const, let's do password or user input equals prompt. Please enter a new password. Something like that. All right. And then these are the two requirements. I need the password to be at least 6 characters. So we can do that part pretty simply. And then I want to make sure it does not include a space. So hopefully we know how to do both of these. You may not remember exactly how to do this one. We could check if there's a space inside of the string by using index of. That's one option. That would be probably the simplest. And then to check the length, well, we can just use the length property. So let's begin there. Password must be 6+ characters. So we can do password.length, and we want that to be greater than or equal to 6, right? So let's just do an if. If password.length is greater than or equal to 6, then, well, we can put something here if we want. We can do a console.log, long enough password. And then we could have an else right here, console.log, password too short. Must be 6+ characters, right? Okay, so we can begin with that. Let me just make sure everything else is commented out in here. Let's execute this. Please enter a new password. Let's do, cat. Password too short. Must be 6+ characters. Let's refresh. Enter a new password. How about just gibberish? Long enough password. Great. Okay, so now let's work on the second part. Password cannot include space. So I could just add this down here as a separate conditional. I could do this. If, well, let me keep the comment there. There we go. If password, and then after that, we could do, just to refresh your memory how this works, we have a string like hello.index of, and then I check to see if an h is in there, right? It's going to give me the index, 0. But if I look for something that's not in there, like a space, it gives me -1. So we want the password to have an index of space of -1. We want that -1. That means there is no space. Okay? So what we can do is do that down here. If password dot index of, and then space equals, triple equals -1. If that's the case, we can console.log. I mean, what should we console.log? You don't have a space. Good job. Good job. No space. Else, console.log, password cannot contain spaces. All right, so a totally separate conditional. And let's see what happens. So I'm going to hit enter, or refresh the page rather. Enter my password with no space. So I'll make sure it's long enough. How about that? It says long enough password and good job, no space. Now let's try one that is not long enough, like cat. All right, password too short, but we're also getting good job, no space. One more time, I'm going to have a long password with a space in it. Long enough password, password cannot contain spaces. So right now I have two totally separate pieces of logic. But really, if this was a real website, which it's obviously not even close to being, but if it were, we usually just give the user one piece of feedback at a time. Here's one problem, right? We're not going to say, good job on this and bad job on this. We're probably just going to say password cannot contain spaces. And then we'll say good job or, valid password or something if both of these are valid. So if the password's long enough and the password does not contain a space. So I can nest this. I could say if password.length is greater than or equal to 6, if that's the case, let's not just print something out. Let's check to see if there is a space or not. So I can copy this and just put it right there. So now this code only runs to even check if there's a space if the password is long enough. If the password's not long enough, we immediately print that out. Too short. If it is long enough, we look for a space. And now instead of saying good job, no space, we'll probably say something like valid password. If we make it to this point right here, it means this was true because that's the only way we get to this code. And then this has to be true to make it to this line right there. The only way that happens is if line 50 and 48 both evaluate to true. If anything goes wrong along the way, we either hit this one or this one, depending on what the issue is. So let's try it now. Let's enter a valid password. How about butterfly? Valid password. And how about one that is long enough but contains spaces, or just one space? Password cannot contain spaces. Okay, so this is working, but it's a little bit clunky having to manage this nesting. Not that nesting is necessarily bad, but really what we care about is if the password's long enough and it does not contain spaces. And there's another way that we could combine this logic, because that's basically what we're doing here. We're combining this logic by nesting it, but there's another way that we'll see coming up very shortly. All right, quick little topic here, but an important one. We need to talk about truthiness and falsiness, or just truthy and falsy values, or inherent truthiness and falsiness. I don't know how to even spell truthiness and falsiness, honestly. It doesn't matter. I don't think they're official terms, but most people recognize them. Anyway, let's talk about what they mean. Every value in JavaScript, every single one, has an inherent truthiness and falsiness. That obviously does not mean they are true and they are false. There's only two values that are actually true and false. We know them. Exactly true and exactly false. But every value, whether it's the string algar or the number 98 or the value null, they all have an inherent truthiness or falsiness to them. They all have either a light side or dark side, or good or evil, or just true and false, right? And we don't need to assign inherent moral to them either. It's just, are they truthy or falsy? Now, this matters for a couple of reasons we'll see as we make more progress, but let me just lay out the rules. Every single value in JavaScript is considered truthy except for the following. False. Okay, that one makes sense. It should be falsy. 0. Empty string, null, undefined, and not a number, or NaN. Everything else is truthy. So let me show you what this looks like, or how we could see this in practice. I have a new script, a new HTML document, and I'm going to do something right here. I'm going to prompt a user, enter something. Save that to a variable, const input, or user input, or something like that. Okay. Now, if a user enters nothing, if it just pops up right away, refreshing, here it is, enter something, and I just hit enter right away, the value of user input, if I look at it, it's an empty string. And we've seen that empty strings are inherently falsy. So I can do this right here. If user input, and I don't have to compare it to anything. I can literally just say if there is a user input. Because if it's any string other than an empty string, that will be truthy. So console.log truthy, otherwise console.log falsy. Okay? So I'm going to try this. I'm going to type something, anything, a string. Truthy. All we wrote was if user input. I didn't say if it equals something, if it's greater than something. I just said if user input. So we know user input is not true or false, the actual value true or false, but it's going to be coerced into a Boolean, into its truthiness or inherent falsiness. It will be revealed. So if it's a string that has anything in it, it's truthy, and we see console.log truthy. But if I just hit enter right away, no text, we get falsy. This tells us, well, it doesn't really tell us anything because we already knew this, but it shows that an empty string is considered falsy. So I'll show you a few more examples. We can do something like if false. Well, we know what happens with if false, but if we do if 0, console.log 0. Let's just do truthy there. Else console.log falsy. And we should see falsy because 0 itself is considered falsy. So if we do if 0, it's like doing if false. That's just not going to be true. And the same goes for some of the other values we've seen. For example, null, falsy. If I have any other number, by the way, I didn't show that, but they're truthy. Even a negative number, -1. Truthy, it's just 0 and not a number. So let's try not a number. Falsy. And the last one we have after null, we've got to do undefined, which is inherently falsy as well. So anything else, a string, a number, what else do we have? The Boolean true, any number, any string that is not empty, even if it's just a space, that's truthy. The falsy here is because I didn't comment this one out. Okay, so this is something we can take advantage of often in a situation like this right here, where we have some variable, some input, or something that's coming from somewhere else, and we're going to check just if it exists, or if there's a value inside of that string, or if it's an empty string, or if a value has been defined. If a variable actually has data in it and it's not undefined or it's not null, I can simply write if user input. I don't need to do if it equals or if it's not equal to an empty string. I can simply do if it's inherently truthy, do that, otherwise do that. And this will come into play in a little bit because next up we're going to learn more about logical operators and combining pieces of logic, and often this inherent truthiness and falsiness will come into play. Next up we're going to cover logical operators. So logical operators are operators that allow us to combine different expressions. So we can combine more than one piece of logic together to form one larger piece of logic. And there are 3 core logical operators built into JavaScript and every other programming language I've ever heard of. They are right here in front of us: and, or, and not. 3 of them, and, or, not. So we're going to begin in this video by focusing on and. So and, which we write using 2 ampersands, 1, 2, 2 ampersands, the character located above, at least on my computer, the 7 key. 2 of them together is logical and this is going to join an expression on the left and an expression on the right. And in order for the entire thing to be considered true, the left and the right must be true. So both of them have to be true for the whole thing to be true. That is the rule of and. So we could start nice and simple. Without any complicated expressions, we can just have something like this: true and true. Is the left side true? Yes. Is the right side true? Yes. The whole thing is true. But if any one of them, there's only 2 of them, if either one becomes false, the entire thing is false. So we have false and false is false, false and true is false, and true and false is false. The only way to get true from the end result, the output, think of it as like a machine. We're putting 2 things in, a left and a right. A true and a true, we get true out. Otherwise, we get false. I read an article a while back where the author was trying to explain this in terms of asking his mom to go play outside on a school night. After school, the mother would say, you can go play outside with your friends if you have if you finish your homework and you have done the dishes or cleaned your room or whatever it is. So you have to do both of them. And if either one of them is not done, you can't go outside, right? Okay, so soon we'll see or, and you probably can get where I'm going with this. The or logical operator behaves differently. Now, typically we're not going to do this, false and true or true and true, at least not directly. We would have some expression like 1 equals 1, also very stupid and trivial, and 2 is less than 7. That whole thing is true. Why? Well, the left is true and the right is true. So a better example of when we would use something like this, if we come over here, I'm in a new file, logical operators, app.js, is something like this. If we ask for an input, let's say a password again, so prompt, enter your password, const password, or password is fine. Remember what we had last video, 2 videos ago, where we wanted to make sure a password was of a certain length and that the password did not contain spaces. Well, I can combine those two pieces of logic just like this. If password.length greater than or equal to 6 and password.index of space is, so if we're checking to see if it's greater than or equal to 6, it needs to be long enough, and it should not contain a space. So we want to see if the index of a space is equal to -1. If that's the case, both of those things have to be true in order to get here. Console.log valid password. Otherwise, if either one is wrong, here we'll console.log, incorrect format for password or something like that, right? So if we make it to this console.log, it means our password is greater than 6 characters long or equal to, and it does not contain a space. So let's try it. Refresh the page, enter my password. Let's do something that is correct. So I don't know, this is stupid. Password 123. That is long enough and it has no spaces. Cool, valid. Now let's try something that's too short. Invalid. Something that has a space. Invalid. So we've combined those two pieces of logic into a single statement using AND. That's kind of all there is to it. We have our left and our right. They both need to be true for the whole thing to be true. If either side evaluates to false, the whole thing is false. In fact, if this first part is false, JavaScript won't even bother looking at the second part. If the left is false, it won't look at the right because there's no point. It's called short circuiting. It's never going to run this code inside of these braces if the first part is false. It just knows it's a lost cause. Both parts need to be true. Okay, so next up we'll see our second operator, which is logical OR. So the next logical operator we have is the OR operator. So OR, just like AND, is going to join two different expressions. The symbols we use are two pipe characters. So these aren't ones, they're not L's. They are the pipe character, which for me and most keyboards I've worked with, it's located above the return key on the right-hand side of my keyboard, sharing a key with the backslash. I need to hold shift to make it. So it looks like this right here. Those are pipes. Again, it's not a 1, it's not an L or a capital L or something like that. Two pipes. All right, and the OR operator behaves differently than AND. It does not require both sides to be true in order for the whole thing to be true. It just needs one. It only cares if one of the two is true. So going back to this thing that I'm stealing from a blog post I read a while back, with AND, if you're a kid, you want to play outside, and my mom says, you can only play outside tonight on a school night if you have finished your homework and you've cleaned your room. If either one is not true, then I can't go outside. On a Friday night or a weekend, she might say, you can go play outside with your friend if you have finished your homework or you've cleaned your room today. So one of them, or both, sure. But if I've done only one of them, I'm still in the clear. So here are some demos, right? If we have something like 1 not equal to 1 or 10 equals 10. Well, this part's false, definitely. 1 is the same as 1, but 10 is 10. So this is true. So 1/2 is true, that's all we need, right? So let's try another example. If I just do true or true, that evaluates to true. True or false, whole thing is true. False or true, whole thing is true. And then false or false. This is the only situation where the OR operator gives us false if both inputs, the left and the right, are false or falsy. So let's revisit an example from earlier where we had our theme park that you could get into, and we had a couple of age ranges where we decided a price. If you were 0 to 5, I think it was, you were free. Is that right? Well, if not, I'm just making this up again. So let's say if you're 0 to 5, you get in for free. If you are 5 to 10, you have to pay $10. And if you are 10 to 65, you pay $20. And if you are 65 or older, let's say that you're free. Okay, so what I could do, as we've already seen, make a variable age, set it equal to some number. Let's just go with 90. And we can write our first conditional, if age, and I can actually do a couple of things here. What we started with last time was if age is less than 5, we'll do this. console.log. I'm just going to print out the price. I won't bother with anything else, so just free. Else if age is less than 10, console.log $10. I need quotes there. And I should be consistent, as I've always said. I'll use double or all single quotes, but I shouldn't really mix them up. Else if, okay, so age is less than 65, right? And we've already been over this and how this works, where I'm relying on the order of things. So if age is less than 5, well, technically what I'm doing here is saying if it's anything below 5, it could be negative 1,000. So we should come back and fix that and say if it's between 0 and 5. But first, what we can do is combine this where we have age is greater than 65, you should get in for free. Or if age is less than 5, you should also get in for free. So we can do that just like this. If age is less than 5 or age is greater than or equal to 65, you'll get in for free. If that's not the case, what if you're less than 10? Well, you'll get in for $10. That means you're between 5 and 10. Otherwise, if you're less than 65, we'll console.log $20. Okay, so let's verify that this works. It's 90, so we should see free. Now, if we change that to 1 year old, we should also see free. But if I go up to 11 years old, you're $20. If you are 9 years old, you should be $10. And if you're 100 or 1,000 years old, we should be free. So that's the basic concept. Here's our example of using or. If this thing or this thing is true, both situations, you get in for free. But these can't both be true at the same time. Like, it's logically that can't happen in this scenario, right? We can't have one number that is less than 5 and at the same time is also greater than 65. But that's fine. This is not and. We have or. We just need one of those scenarios. Now, if I really wanted to be complete here, I would make sure that, we were using normal ages. For example, 0 to 5. We don't want negative ages. This allows for a negative age. If I did negative 10, we get free. So what I can do is actually make this left side another expression using a logical operator. So I can join two things, because really what I want to say is if you are between 0 and 5, or you are greater than 65. Well, how do I say between two numbers? Well, I want to make sure you're greater than 0 and less than 5. That brings us back to the previous video, logical and. So anytime we're trying to use a range or check against a range of numbers, if something is inside of a range, we can use and. So I can do this. If age is greater than, I guess I'll allow 0, greater than or equal to 0, and age is less than 5. This whole thing is one expression, right? So you're between 0 and 5. That means you're free. Or on the other hand, if you're just greater than 65, that also means you're free. Now, this still doesn't really fix our negative age issue. It does mean you won't get in for free with a negative age, but that doesn't mean you won't get in at all. So which one of these will match if I pass in negative 10 as age? Well, this won't. Negative 10 is not between 0 and 5. It's not greater than 65. But it is less than 10. That is the next thing that will be tried. So what I would do is probably rewrite this. What the age bracket really is if you're between 5 and 10. So I could do this. If age is between 5 and 10, so if you're greater than or equal to 5, I didn't say, 5 was inclusive for free or for $10. It doesn't really matter. If your age is greater than or equal to 5 and your age is less than 10, you get in for $10. And now let's see what we get. So I'm going to refresh with my negative value. All right, negative 10. Oh, we get $20. Why is that happening? Same issue. Here I'm checking to see if your age is less than 65. What I really want to check is if your age is greater than or equal to 10 and also less than 65. And now we get nothing if your age is negative. And then finally, we can add a catch-all else that will just be console.log invalid age. All right, and there we go. So let's try changing this. We'll go with 0 years old. You get in for free. 99 years old, free. How about 7 years old? $10. And then 10 years old, $20. 50 years old, $20. And then we go back to $10 when you get above 65. or sorry, you go back to free when we get above 65. All right, so here we're combining and or to create these ranges. So we're using and to make a range, a valid range we're accepting from 5 to 10 or 10 to 65. And we also saw a more complicated example on this first line here where we have two logical operators working together. Now, something I did not bring up is the order that this runs in. The and is going to run before or. It has precedence over or. If you prefer, though, you can add parentheses just to make it clearer to you, how you want this to run. So if you want this to run first, it already does run first. But if it didn't, or if you just wanted to make sure, put parentheses. This will evaluate first to true or false. And then we have this side. Okay, so I know this got a little bit crazy with these symbols, and it might look quite foreign if you've never seen this before. But we'll get lots and lots of practice with this stuff. We use these all the time. And, comma, or. I was going to say and or, but it's confusing to do that. So and, comma, or. All right. Next up, we've got our third and final logical operator. The final logical operator we'll see is the not logical operator. Now, this one actually doesn't really combine two expressions, but it operates upon an expression. It is going to negate the value. If it's something that's false, it turns it true. If something is true, it turns it false. But what that really means is that if we put the exclamation point, which is the piece of syntax we use, just like we use two ampersands for and, we use a single bang or exclamation point for not. We put that in front of some expression. It will return true if that expression is false. So here's an example. Here's a very simple expression, false. It's just false, the Boolean false. But if I put not, I am flipping it, and it's now true. Or I could do something like this. Is 1 equal to 1? Well, we know that is true, right? But if I put not in front of it, we get false. Another example, we can do things like this. If I have null, which is a falsy value, if I just hit enter, we see null. But if I logically negate it using exclamation point, it's actually going to flip the Booleanness of it. That's a horrible way of putting it. But we know that null is inherently falsy. So it flips it to truthy. So if I flip it back to false, again and again and again, not that you would really do this, but you can. It's absurd. So there's a lot of ways we could use this, but here's a simple one. We'll ask a user to enter, a name. Enter your first name. Right? So const first name equals prompt. And then right afterwards, if they don't enter a first name, we could just ask them again. And we could do this long thing, right? If first name is equal to exactly an empty string, that means they didn't enter anything. We could ask them to enter it again. Or I can just say, if there was not a first name, if first name is falsy, remember, empty string is falsy and a bunch of other values. So if that's the case, well, then if I just did that, if first name, this is going to be if there is a first name. That's not what I want. I want if there is not a first name. And then in here, I can do the exact same thing. I'll update first name. Whoops. Or maybe I'll do it again. Try again. Right? Let's run it. Enter your first name. So I'm going to type my first name. That's not my first name, but I type that in and we don't get a message. But if I leave it blank, try again. Now that only happens once. We're not doing it over and over and over. We'll soon see how to automate that or how to loop our code so that does occur until you actually enter a valid first name or you don't leave it blank. But this is a common situation. If not something, where normally that thing would be a truthy thing, first name, we're looking to run this code when first name is falsy. So we flip it. Other situations where you can use this, you can negate an entire complicated expression. So here we go. If I only wanted to target, I'm just going to copy this down here. I only want to target people who are not getting in for free. So I'm going to go with const age equals, 45. So I'm right here, I'm targeting people who are between 0 and 5 or greater than 65. That means they are definitely getting in for free. Let's say I want the opposite though. I want everyone else. What I can do, and this is going to be quite ugly, but I can do this here. I can negate the entire thing. So I don't need these parentheses here. But I do want to wrap parentheses around this entire thing and then flip it. So if age is between 0 and 5 or age is greater than or equal to 65, not that. And here I can console.log, you are not a baby or a senior. Let's try it. And we get you're not a baby or a senior with 45. If I do 0, we don't get anything. If I do 100, we don't get anything. But if I do something in between, how about 8 years old, you're not a baby or a senior, right? So using not there is negating this entire long expression. This whole thing in parentheses is going to evaluate first. We'll get true or false, and then we flip it. So all of these work in conjunction. I mean, here's an example. We're using logical not, logical and logical or all together in the same expression. It's a long one, and it doesn't really look like English at all, but it is valid JavaScript. So that is logical not. It's going to return true if the expression we are applying it to returns false, or it evaluates to false. We saw logical or. It only needs one side, left or right, to be true, and logical and requires both sides to be true in order for the entire outcome to be true. So these are foundational for logic. We use them all the time. We combine things together. We're still starting simple, but you will see lots and lots of situations where we use these operators together to build more complicated logic. So bear with me, hang in there if you're struggling with it. We'll get a lot of practice, and over time, this will become second nature. Don't be off-put by the symbols. Yes, it's annoying to use the pipe character if that's new to you, but you'll get used to it. Okay, so at the end of this section, we've got one last topic here, something called the switch statement. And honestly, I have shoehorned it in here. I didn't even have this video in the course originally when I launched it, but a couple months later, I've decided, well, I haven't decided. I got feedback from students that I actually used a switch statement one time later on in the course, and I had never explained it, which was an oversight on my part. But with that said, I'm not a crazy fan of the switch statement. It's kind of crazy looking syntax. It's hard to remember, and it's not all that commonly used. So I will be very blunt here. I think it is the least useful or the least important by far of the concepts we cover in this section. Please, please, please do not worry about memorizing this syntax. It's something you'll come across one time in this course, but in the real world, occasionally. But it's nowhere near as common as typical conditional if, else, else if, all that stuff. Okay, so the way that a switch statement works is that there's actually a couple pieces of syntax. There's the keyword switch, and then we have another keyword called case. So I think the best way to explain this is just to demonstrate it first. Imagine that, we're doing what I have in this example. I have a variable called day, a number. And for each number, I just want to print out a corresponding day of the week. And for this example, let's set day to be, 2. If I use a regular conditional if, right, and I wanted to print out, like if day is 1, I want to print out, let's say Monday, although depending on where you live in the world, the first day of the week is a Sunday or a Monday. Let's just say we're doing the work week, so 1 through 5. So for the number 2, we want to print out Tuesday. So if I did this with a regular if, right, I could do this, if, and then day equals 1, console.log, Monday. And then I could add an else if, day equals 2. Hopefully you see where I'm going with this. I'll just quickly fill this out. So console.log Tuesday, and then I'll do the rest of the days through Friday. Okay. So there we are. If day is 1, Monday, else if it's 2, Tuesday, all the way down to Friday. And then we could add an else, something like for any other number. I don't know that. Okay, so nothing crazy here. This does not involve a switch, but this is actually a scenario where we could benefit from using a switch statement where we're checking one value and making a bunch of comparisons against that same value, right? Day, is it this? 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 Otherwise, do this. So just to verify it works, we do see Tuesday over here. And if I change it to something else like 29, we see I don't know that. Okay, so I can rewrite this with a switch statement. And the syntax again looks like this. Switch, and then in parentheses, the thing that we are evaluating, in our case, the day variable. So I'm going to go back to 2, and I guess I'll just write it here. So I'm going to comment out this version. So we write switch, and then in parentheses, day, and then our curly braces. And then inside, this is the part that throws off a lot of students, we write these things called cases. Case, and then a value. So for us, we're going to have a case for 1, where day is 1. So whatever code we put right here, if I do a console.log, hello, this is only going to print out when day is equal to 1. So we're saying, here's one case for this variable day. In the event that it's 1, do this. So if I try this right now, we won't see it printed out because we have day set to 2. But if I change it to 1, there we are. So then we can add a second case in, right? Case 2, and I'll just console.log the days of the week like we've been doing. So we've got Monday. If day is 2, we'll do Tuesday, just like that. And now I'll show you. If I refresh, we get Tuesday printed out. But if we do something else like 20, we get nothing printed out. All right? So I could continue writing this, and I'll just fill it out quickly. Same idea for 3, 4, and 5. Okay, so there's an issue, or there's a thing about switch statements and cases that throws people off, including myself sometimes, which I'll just demonstrate. If we have day set to 2, for example, we should see Tuesday printed out. Okay, so let's see what we get. What on earth? Tuesday, Wednesday, Thursday, Friday? So we didn't get Monday, right? Let me demonstrate this again. If I switch to 4, if I use day set to 4, we'll see Thursday printed out, but we also see Friday. So it's half working. When day is 4, we don't see this printed out or that, but when we get to case 4, this is printed out, but then so is this one. Why? Well, the default behavior of a switch is that whenever there's a match, so if day is 4, right here, case is 4, that's a match. So whenever there's a match, the switch starts executing the code from inside this case, and then it keeps going and going until it hits a break. So there's another keyword we add in called break. So it keeps going and going until it hits a break. Well, it never hits a break. So it runs this and it runs this. Or if I say, as I showed you, if day is 2, it doesn't have a match, so it skips this, but then it does have a match here. And then it just keeps running like a car without brakes until it hits the keyword break. It never does. It just hits the end of the switch. So this is why we see Tuesday, Wednesday, Thursday, Friday printed out. We don't see Monday. So that's a long way of saying we generally want to put a break at the end of each one of these cases. Okay, there we go. So now if we try this, what do we have again? Day is 2. This is going to be a match. It will run this code and keep running code until it hits a break. Well, it hits a break right there, and that's it. Let's see what happens. That's all we get, Tuesday, right? So if day is 1, we should get Monday. And that's what happens. If day is 5, we get Friday. Okay, so the last thing I'll add in is this other piece of syntax. We can add a default case at the end. Think of that as an else. If nothing else matched, default, how about just console.log, I don't know that. Okay, so now if we have something like 50, we get I don't know that. But if it does know it, like Friday, well 5, which is Friday, then we see that printed out and we don't see this. Okay, so again, the syntax is somewhat hard to remember, not my favorite. One thing that we can do is actually have multiple cases match a single chunk of code. So for example, maybe we want to add weekends in. Sure. So I could do case 6 and I'll console.log weekend, right? Let's just say we don't care if it's Saturday or Sunday. And then I could also do case 7 weekend like this, and then add a break to both of them. I could do that. If I want the same outcome for both of them, I can actually rewrite it this way. Case 6 and case 7. So whenever this is matched, it's going to start looking for the first line of code to evaluate. nothing, nothing. Oh, here we go. Keep going until you hit a break. Or if this is not matched, but this one is, then it just behaves like all the others. It runs this code and it hits a break. So I'll demonstrate that. If we set it to 7, we get weekend. But if I set it to 6, we also get weekend. And then if I set it to something else, we don't have a case that matches that. We get I don't know that. So that is a basic intro to the switch statement. Again, I can't emphasize this enough. Don't worry about this right now. I had to put this somewhere in the course. I figured I should group it with the rest of the conditional logic. But I'd say 1 out of every 50 or maybe 1 out of every 100 conditional statements that I write, I'm using the switch statement. Pretty much every other time, I'm going to be using if, else if, and else. You can see, this could shorten things up significantly. Or if you had a bunch of things that you were trying to check, a bunch of different cases, this can be nice. But a lot of the time, just the logic we're trying to do doesn't fit this situation all that well. So that is a switch statement. Switch, parentheses, curly braces, and then cases with a colon. I think that's what throws a lot of people off. And I'll stop here. Okay, so it's in the course now. Not my favorite. I don't mean to trash talk it, but you just won't see it all that frequently. You will see it at least one time, I think exactly one time in this course, which is why I added this video in, but I'll shut up for now. Okay. Welcome back, everyone. Another new section here. Still more JavaScript basics. This time we're talking about arrays, our first data structure. Kind of leveling up a little bit with our JavaScript here. I will say, just right up front, I have seen some students stumble a bit with arrays. When I say stumble, I don't mean, they get stuck and never make it past arrays. Just that sometimes it can slow students down a little bit. Basically, arrays are a data structure that allows us to store multiple values together in one variable. So it is kind of the next level. And sometimes that just trips people up. So take your time here. There's a lot of important content. Understanding how arrays work, creating, updating arrays. It takes a bit of time to talk about and to just get practice with. So that's yellow, but it's also critical, very important. Same thing with push and pop and shift and unshift. These are built-in methods. It might sound like nonsense at this point, but they're built-in methods that come with arrays in JavaScript. And those 4 are crucial. I'll say that these, concat, index of, slice, and splice, are important, but definitely not critical to understand before you move on. And the same goes for multi-dimensional arrays. That sounds intimidating. It sounds like, I don't know, something out of Star Wars or some sort of like crazy weapon mounted on a spaceship.
Prepare to fire the multi-dimensional arrays.
But they are important, just not critical. So also 2 yellow topics here. Again, just an indicator of how much time I expect them to take you, but really focus on these topics here. The basic creation and updating of arrays, and then push and pop and shift and unshift. Again, that will mean something to you if you make it through this section. All right, here we go. All right, so let's begin with JavaScript arrays, our very first data structure. Now, a data structure simply is a collection of data. So we've seen little tiny pieces of data, right? The number 7, the Boolean value true. We've seen strings, right? That's not a collection. We could have 10 different variables. Let's say I wanted to represent the members of the Beatles. I could have 4 different variables, one called, I'll just do one very quickly, but how about bassist? And set that equal to not Paul, but Paul, right? And then I could do the same thing for the other 3 members. But they're not connected in any way. They're 4 separate variables. So data structures, specifically arrays, which we're seeing or we're about to see, allow us to group data together. And we could store 4 different strings, as an example: Paul, John, Ringo, George. Geez, I don't know why that took so long. We could store those 4 strings specifically in a single array, a single collection. Now, I like to visualize arrays like this pillbox here. If you've ever seen these, there's usually 7 days of the week, 7 spots here, Monday, Tuesday, and so on. And you put the pills for that day in that slot. I've also seen ones that are broken down into different times, like morning and afternoon and evening. But the main concept here is just a bunch of slots, and there's an order. This box, you can't actually see the labels, I don't think, but there is an actual order here. Monday is on the far left, and then Sunday is on the far right. Or, it might start, depending on the part of the world you're in, it might be Sunday is the first day of the week, but whatever, it doesn't matter. Arrays are kind of like this, just a bunch of slots that we can put stuff in, but there's an order. So that's really the key the two key concepts for an array. One, it's a collection of values. Two, it is an ordered collection of values. So in the real world, we run into arrays all the time. We may not, you probably don't think about it, but behind the scenes, there are ordered collections of information all over the place. If you ever look at the comment section of anything, an Instagram post, a Facebook photo or album, a Nextdoor post. There's some crazy garbage on Nextdoor that I'm just learning about now as I live in the suburbs. So you can find these comment sections all over the place, and they are a collection of data. There's a bunch of comments that are grouped together, but they're also ordered, often by recency. So the most recent comments are at the bottom or the top, or sometimes by the number of votes or hearts or likes or whatever. Other examples, collections of levels in a game. So just a simple game to start, like a clone of Mario, or even a Sudoku game where you have different levels where there's an easy one and then level 2, level 3 that get progressively more challenging. There is an order there. So there's a bunch of levels and they are ordered. Songs in a playlist. That's a collection of things. We could even just represent our songs as strings. Here's song 1, song 2, song 3, whatever they are. And then there's an order. So ordered collections. So how do we actually make one of these things? How do we make an array in JavaScript? Well, it's actually pretty simple. We use the square brackets. Now we've seen another situation where we use square brackets. Can you recall what it is? Well, when we are accessing a character in a string. So I have this basis variable. If I want the first character, basis of 0. So those are not, or this has nothing to do with an array right here. This is purely a string and an index using square brackets to access a character. Now, when we have two square brackets on the right side of an equal sign, we're assigning some variable to an empty array. So it's like one of these pillboxes here with nothing in it. We can add stuff after the fact. We'll see how to do that shortly, but for now, we can make an empty one. So I could do that just like this. Let, I don't know, how about colors equals an empty array. And if we look at colors, notice this is a bit different than anything we've seen so far. I have this triangle. This is just from the Chrome DevTools. I can click to expand. And long story short, we don't need to care about this, but it does say array. So there's some proof that we're working with an array. Just a little side note, if you try this type of, and then opening and closing, or type of colors, we know that's an array, but it's telling us object. Just a little teaser for something we'll cover later on. Don't get too tripped up and don't try and check if something is an array using type of. You're going to have a bad time. Okay, so here are a couple more examples. Here I've got an array of colors that actually has colors in it, red, orange, yellow, and I put them, in order. So the left one comes first. This is the first thing in the array. So even if these values don't necessarily need to be ordered, they are ordered purely by the way they appear in this array. So this is first, that's second, that's third. Or here's another example, lotto numbers. So maybe this is a lottery where it's just 5 random numbers, there's no order. But a lot of times in the lotteries, I haven't really played in many, but there is an order and your card has to match the order that the numbers have been drawn in, not just the numbers. So let's make another, we'll talk about why const is commonly used, by the way. So you can use let or const, but let's just go with let for now. Let's make a days of the week. So days equals, you can see I already did this. I may have recorded this video once and thrown it all away. Here's a days of the week array. I just put 3 elements in it, Monday, Tuesday, Wednesday. I hit enter. Let's take a look at days. Here's our little expando triangle thing. Click on it, and we see our 3 elements, our 3 values in there. It's a container, and it's an array. And one more thing, it has a length. So just like a string has a length, I can do this, days.length, and that will tell me how many things are in there. We have 3. If I do empty array.length, 0. There's nothing in there. It's just an empty shell of an array, much like I am an empty shell of a human being most days. And then the last thing you should know here is that we can put in any sort of collection we want. So it doesn't have to be homogeneous, all strings or all numbers. We can mix everything up. I could put Booleans in there. I could just do let kitchen sink equal a Boolean. How about undefined? 12, 9.999. How about not a number? False. What else am I missing? Null and a string. High. Accidentally hit the volume key. We'll hit enter, and that is a valid array. It makes no sense. You probably would never have this collection of data, but you can. In some other programming languages, an array consists of basically one type. It has to be an array of strings or an array of numbers, and you have to explicitly declare that up front. With JavaScript, I can do whatever I want inside of an array. I can even put other arrays inside, which is something we'll see shortly too. All right, so we've seen how to make an array, how to initialize it with the initial stuff in that array. It might be empty, square brackets with nothing inside, or it might have a couple of values, square brackets with values separated by commas. But we haven't seen how to access information after the fact, after creation, and we haven't seen how to modify, add things in, remove things, switch the order. All of that is very important with arrays. So that's all coming up. So now that we've created arrays, let's talk about getting data out. So we put our data in, we put it in order, or at least there is an order. Sometimes we don't really care about the order, but it's there no matter what. So when we put that data in, each element is assigned an index, just like with strings. So with strings, each character in the string has an index. In an array, each individual element has its own index. So this thing right here is the first element. It has an index of 0, true index 0. Then we have a number, 68. Well, that's the second slot, and it has an index of 1, and then 2, and then 3. So just like with strings, we start counting at 0. So here's an array, a hypothetical array of the 7 dwarves, which I actually Googled. I thought it was 7 dwarves, but the official spelling is 7 dwarfs, not V-E-S. I don't know. Anyway, Doc, Dopey, Bashful, Grumpy, Sneezy, Sleepy, Happy. The first one in this array is Doc, and then we have Dopey, then we have Bashful. Now, these indices are important because we actually use them to refer to specific elements. Just like I can ask for the first character in a string, using this syntax here, if we take a look at, any string, how about Monday? I want the first character, I use square brackets 0. Well, I actually do the exact same thing for an array. We just use an array here instead of a string. So we have our days array. It has 3 elements. And if I want that first value out of there, the very first thing, whatever it is, it's days of 0. And remember, days has a length. Every array has a length. And the length is always 1 greater than the maximum index. So the maximum index here is 2, right? 0, 1, 2. So if I want Wednesday, or whatever that element is, days of 2. So it's just a way, just like with strings, of using a positional number to access an element. Rather than a character in a string, it's the entire element. And that could be a string itself, that could be another array, it could be a Boolean, it could be false, it could be not a number, whatever it is, we're using that number to access it. And so this is where the order comes in. Every element has this associated number, this index. So we can use them to access a value out, so to read something out like days of 2 equals Wednesday. I should also show what happens if we try and access something like days of 3. There is no index of 3. We get undefined, which is the same value I would actually get if I did days of 30 or days 3, whatever that is, 300,000. There is no index 30,000. Why can't I do numbers? There is no index 300,000 in this array. There's not even an index of 3. We get undefined. So there's not an error. It's not a problem, but we just don't have anything there. There's nothing to see. There's nothing defined. Now, if we do go back to this days, let's go with Tuesday, which is the index of 1, the second element. This gives me the string Tuesday. Now, I actually can chain on. This is kind of bizarre to do this, but if I wanted that first letter, I could do this right here. So this is more of just an exercise to show you that this is possible. It goes from left to right. So what does days evaluate to? Well, it's the array. It's a thing in memory, this collection. And then we're asking for index of 1 from that array, which gives us Tuesday. So then I'm basically asking for Tuesday, square brackets 0, which gives me capital T. Now we can use that same syntax using the square brackets to update an array, to actually change something at a particular index. For example, here I've got a colors array and I've messed up the first color. I wrote rad. What a disaster. It's supposed to be red. What an idiot. Well, if I want to change that, I know that it's index of 0. It's the first element, and I can set it equal to red. Now this is important to understand. I actually can't do this with strings. So if I have a string, let's just go with first name equal, and then I'll set it equal to my name Colt, And then I realized, I want to capitalize the first letter. First name of 0 is C. I cannot reassign that. It doesn't give me an error, but if I look at first name, I'm actually not changing it in any way. Now with an array, we have a totally different outcome. So let's make my array of colors. I'll just do a couple. We have red, orange, and yellow. And let's hit enter here. I realized I want to change that first one. So colors of 0 is red. No, now it's going to be red. Now if we look at colors, I did actually impact that array element. So unlike with a string, I can't change particular characters. In an array, I can change the entire element. So I could make it a number instead if I wanted. So let's fix yellow. How do I fix that? What is the index I need? Colors, square bracket, 2 equals yellow. Just like that. Now we look at colors, red, orange, yellow. So I can also do things like, as I've mentioned, I could change, let's say I change orange to be, I don't know, the number 70. I don't know why. Colors of 1 equals 70. That was stupid, but it works. So I can change type, I can change the value. I also can try something. Let's see what happens here. Make a prediction. What happens if I do colors of, how about 10 equals indigo or some other string or just anything? What do you think my array will look like? First of all, can I do this? Can I add all the way at index of 10? Okay, let's look at colors. I didn't get an error, so no issues. Wow. Red, 70, yellow, 7 empty slots, and then indigo. So if I open this up, what we actually end up with is an array with a length of 11. It has 11 slots in it. They're not all full, but what happens when we make a slot that doesn't have a value in it? Well, let's look at colors of, how about 5? It's undefined. 6, undefined. 8, 9, 10, whoops. We get indigo. So our array elongated, took up a whole bunch of extra space so that it could fit something in at index of 10. Is that what we did? Yes, index of 10. So everything else is filled with undefineds. So it's kind of a weird thing to do. Not that you would, but you can do it. Now, if I did have an array and I wanted to add something to the end, let's do like, I don't know, let the Beatles equal an array with Paul, John, and George, like that. And then I want to add Ringo to the end. Well, one option is just this, Beatles of, and then I figure out, all right, what is the current highest index, 0, 1, 2, and then I add 1 to that, so 3. Alternatively, I could just use the length, right? What is the length? 1, 2, 3. So if I use that, it gives me 1 more than the highest index. So Beatles of 3 equals poor Ringo. And there we go. Let's take a look at the Beatles array. Now Ringo is at the end. Now this is kind of annoying, having to figure out that index and put that number in there to add to the end of the array. So we'll see a nicer way of doing this shortly. So to wrap up what we've seen so far, arrays are indexed. Every element has a corresponding number starting at 0 all the way up until the end of the array. The highest index is always 1 less than the actual length. And we can use that index to access particular elements or to assign new values at those slots. So like we did here, we fixed red and made it red. Now that we've seen the basics, we can create an array, we can access elements using an index, we can modify elements using an index, we've seen the length property. It's time to move on to some of the built-in array methods. If you recall, for strings, each string comes with a whole bunch of different methods. Let's just take a look at one. LOL, and then if I type that dot here, we get a bunch of methods, including things like to uppercase, to lowercase, slice, split. What else do we have? Substring, trim. We didn't go over all of these, but they're all here. They are all pieces of functionality or little actions that we can use at any point on a given string. Well, with arrays, we can do the same thing. Now, the set of methods is different, but they all come with a bunch of methods. In fact, if you go to MDN and you look at an array, or just the array documentation, standard built-in objects, and then you can click on array. Where are you? I just search on Google array MDN, but here it is. And then on this left-hand little sidebar, there are a list of methods. There is a list of methods. There are quite a few of them. And every single array has access to these. So in this video, we'll take a look at a couple of them. They kind of go together, push and pop shift and unshift, but then we'll also take a look at some of these others, some of the more commonly used ones. So let's begin with push and pop. Push and pop allow us to add and remove from the end of an array. So from the very end, not the beginning. So this is actually very common. We'll often have some array which is ordered, right, as we know, and often we want to maintain that order, so we add to the end of an array. For example, if I wanted to make a line of people waiting to get into the movie, right, I could have something like let movie line equal, and then have an array. Let's just say there's 2 people in there, Tom and Nancy, sure. Then if I want to add someone to this line, if Tom is the first person, then Nancy, well, I want to add to the end. And I could figure out the length or figure out the correct index as we did in the last video and do something like movie line square bracket 2 equals, who else are we adding? Tom, Nancy, how about Pablo, right? And that does work. I'm adding to the end, but that's annoying having to know that index, especially if we have a very long array or something that we're not really in control of ourselves. So what we can do is use push, movie line dot push, and then this is a method, so we need those parentheses, just like we do for to uppercase or repeat or any of the string methods we've seen. And then we pass in the items we want to push to the end of this array. So who else is coming to see this movie? Tom, Nancy, Pablo, how about Oliver? Just like that. Now we look at movie line, and you can see it has 4 elements. Oliver was added to the very end. Now, this is very different than what happens with string methods. When I call to uppercase on a string, the string itself is not changed. Just to recap this, let cat equal blue, that's one of my cats. If I call cat.to uppercase, it gives me the uppercase version. It's a different string, but cat remains unchanged. With arrays, when I push onto movie line actually is updated. And what it gives me, or what it returns, is a technical term, is the new length of the array. So if I push something else on, let's see, Tom, Nancy, Pablo, Oliver, how about Eva? It gives me 5. That is now the current length of movie line. Now, I also can push multiple things on, not as common, but I could. Let's see, how about Harry and Hermione. I think that's how it's spelled. Hermione, whatever. It tells me the new length is 7. We look at movie line, and Harry and then Hermione have been added to the end. All right, so we're preserving the order here of our line of people entering the queue. They're added to the back of our array. Now, we also have this method called pop, and pop allows us to remove an element from the end. Now, that seems kind of stupid in this example here, where the last person who joined the line would then be removed if we use pop. But let me just demonstrate that. So movie line dot pop. Now, pop does not require any arguments. We don't pass anything in between those parentheses. It's just going to give us the very last thing from the array. It returns it, so it gives it to us, and it removes it from the array. So we get Hermione. And if we look at movie line, now it's only 6 elements long. And I can capture that in a variable, just like I can capture an uppercase string, the result of to uppercase in a variable. So I can do that here. Let person equal movie line dot pop. We look at person, not performance, person. It's now Harry, and movie line is 1 item shorter. Now here's an example where it might make a little more sense to use push and pop in conjunction instead of just our movie example where we just took people from the back of the line first. If you've ever lifted weights or seen someone lifting weights with a barbell where, it's a bar and you put the weights on from the inside first, right? You add the first weight on and then you put another weight on top of that. You sort of stack them. So if I wanted to create let's say it's just an empty barbell and I'm going to add on a 45-pound weight, so I could push that on, and then maybe another 45-pound weight, and then a 25-pound weight, and then you usually do the smallest ones last, a 10, and then how about a 2.5 pound? I'm sorry if you use kilograms. Then we're looking at our barbell here. If I need to swap something out, if I need to remove this 45, if I'm using an actual barbell, I need to remove this, and then this, and then this, and then I can get to this one, right? Sort of stuck in there, sandwiched. So I could use pop to simulate that. So not something we'd really do with code, unless you're building some sort of weight simulator, I guess, or gym tracking app. But I just wanted to show this relationship. Sometimes there are situations where we want to remove something that we just added in. So it's not always like a line where the first person in line is the first person to get out. I'm actually alluding to these concepts called a stack and a queue in computer science. We don't need to worry about them for now, but push and pop and then shift and unshift, two methods we're about to see in the next video, they come from these traditional computer science structures, a stack and a queue. So think of this as a stack of papers on your desk, a stack of bills. You pull off one from the top. That is the most recently added one. You add to the top of that stack of papers, you remove from the top. Same idea here. We add to the end, and then if I use pop, I can remove from the end. Anyway, we're getting a bit in the woods here, but I just wanted to make a point that there are times where you use push and pop together. Pop removes the one thing at the very end. Push will add one or more to the very end of an array. Okay, so we just covered push and pop. Push adds to the end. It inserts a new element at the very end of an array, and pop removes the very last item from an array. Shift and unshift are also a pair who operate at the beginning of the array, the start. So the terminology is often a little confusing to beginners, and truth be told, to me at times. I still have been known to mix up shift and unshift. If I'm a little sleepy, if I'm not paying attention, I often will think, okay, unshift sounds like it removes something. Even though I know if I reflect just a little bit longer, I'll remember, oh, actually you have it backwards, and you have it backwards pretty much every time you're ever tired. Anyway, these names, push, pop, shift, and unshift, again, they come from other computer science structures, stacks and queues. We don't really need to concern ourselves with them, but that's where it comes from if you're wondering why it's called shift and unshift. So let's take a look at them. Let's start with shift. Shift removes from the beginning of an array. So it's like pop, but it removes from the beginning. So we have this movie line, which is just a line of people who have been waiting to see our movie. Tom is first in line, then Nancy, Pablo, Oliver, and then Eva. So to remove the first person in line, which is normally how we would do this, if you're the first person waiting, you usually are the first person to be helped or to get into the movie. So we can use shift, movie line dot shift. And this returns to me that element that it removed. In this case, it happens to be a string. If we look at movie line, it now has 4 people in it, or 4 elements. So I could shift the next person, save that to a variable, let next patron, right? And then next patron is Nancy. And movie line is only 3 elements. So I can use that to remove from the beginning. And if we really wanted to mimic this idea of a line, well, then the first person who's been waiting is the first person to be helped. The last person added in would be the last person to be helped. So if we had someone else come in, let's say I join late, movie line, where would I go? If I'm going to the end of the line, I should be pushed. If we're being consistent here, we'll always add to the end and remove from the beginning. So now everyone else will be helped before me. Pablo, then Oliver, then Eva, and then me. And now it should be empty. And by the way, if I try and shift or pop from an empty array, we don't get an error. We just get nothing. We get undefined. All right, so that's shift. Unshift is how we add a new element to the beginning of an array. So let's add some stuff to our movie line. Let's just push a bunch of times, or even just one time. How about push Jerry, and then how about Dennis, Kevin, and Carly, all right? So nothing involving unshift yet. There's our line of people waiting to get in. Jerry has been waiting the longest. But then we have a special VIP come along, and this VIP gets to go right to the beginning of the line. Well, how do we do that? We can use unshift, and then we'll just call them VIP. Now we look at our movie line, and VIP is at the front, and now if we shift from the front, we get VIP. So these are sort of silly examples I'm showing you here, but they show the 4 core things that we can do so far. We can add and remove from the end of the array, or we can add and remove from the beginning. So push and pop work on the end, and then shift and unshift work on the beginning. You can use them in conjunction to mimic things like a queue for a movie. I used the term movie line instead of movie queue, but what we're mimicking is a queue of people. So if you want to do a bit more research into stacks and queues, I've really shown them to you without using the terminology very much. We saw earlier a stack of weights. We used push and pop to create a stack structure. So that's shift and unshift. We add and remove from the beginning. Push and pop operate on the end. These are really, really commonly used. And if it takes a little bit of time to get used to them, if you are like me and you occasionally stumble over shift and unshift, it's not a big deal. You'll get lots of practice. These 4 methods are probably the most common, or at least top 10 most commonly used array methods. So next up, we're going to take a look at some of the others. Next up, we'll take a quick look at some of the more commonly used array methods. So we're not going to go into these in a ton of detail, but I'm just going to break it up with a couple of chunks of these methods. And in this first video, we'll start with concat. So concat, if we go to the MDN docs, you just search for concats, or you look at the array page, click on concat, or you just Google concat MDN. Click on it. We get great documentation with examples. Really, if you remember the idea of concatenation and concating or concatenating 2 strings, we're adding them together to form a new string. With array.concat, we are concatenating 2 arrays to form a new third merged array. So here's how it works. We call it on one of our arrays, .concat, and then we pass in a second array to concatenate with that initial array. And that will make us a new third array. So let me just show you this here. Let me clear this. Let's do 2 different arrays. Let's do cats. This will be my 2 cats. So I have Blue, and I have, yes, her name is just Kitty at the moment. Then I'll have our dogs array. And both of my dogs no longer with us, sadly. We have Rusty, and then Wyatt. All right, and then if I call cat.concat dogs, that makes me a new array. So I'm not actually updating cats. If you look at cats, it's exactly the same. But it makes me a new array that combines the 2. And since I did cats.concat dogs, we get the cats first. If I did dogs.concat cats, we get the dogs first. And I could save that, let combo party equal dogs.concat cats. And there we go. That's all you need to know about concat for now. So it's combining the arrays, but it doesn't modify either of the originals. The next method we'll look at is includes. Includes is an example of a Boolean method, which means it returns true or false. It's very simple, at least its return value. It's going to tell us if an array includes a particular value. Does it include this? Does it include dog? Does it include cat? So I could try it on my cats array. Does cat or cats include, how about Blue? The answer is yes, true. Now, if I misspell that or if I use capital B, right, they're entirely different strings. It's simply going to go through and compare if at any point any element in our array, cats, which is very short, if any element is Blue with a capital B, and we know that's not the case. So I'll get false. And that's kind of it for includes. It's a Boolean method. It returns true or false. Then we have index of. Very, very similar to how index of works for a string. If you can recall, right, if we take a string like Blue and I ask for the index of capital B, we get 0. What's the index of E? It's 3. And what about if the character is not found? Index of 0? -1. There is no 0 in Blue. So same idea, except the indexes here, or indices, refer to the indices of an array, not of a string. So let's try it. Let's take our combo party array, and let's figure out what the index of Rusty is. It has to match capitalization. It's index of 0. What's the index of Kitty? It's 3. And if I misspell something or just something that's not in the array, we get -1. So this is an easy way to tell if some element is in an array or not. We can just quickly check, is index of that thing equal to -1? If so, it's not present. And then the last thing I'll show you for now is reverse. When I say for now, I mean in this video. So reverse is going to reverse an array. And the very important thing to understand is that it actually does it in place. It's known as a destructive method. It does change the original. So here is my combo party array, Rusty, Wyatt, Blue, Kitty. Let's reverse it. Combo, not bombco. Oh my goodness. I can't talk and type at the same time. Combo party dot reverse. Remember, that doesn't do anything. I always need those parentheses. At a bare minimum, empty parentheses, and a lot of these methods do require us to pass something in. But reverse doesn't. It's just going to reverse it. Okay? So we get Kitty, Blue, Wyatt, and Rusty. The opposite of what we had here. And if we take a look at combo party, it is now reversed. So it's not just returning me a reversed copy, it destructs, well, it doesn't destruct. It's destructive to the original. It reorganizes it, it reorders it entirely, and it reverses it. That's really a better way of putting it. It reverses the original array. All right, so those four hopefully are pretty straightforward. We have concat to combine two arrays. We have includes to tell if a single element is in an array or not. Then we have index of, which we can use to tell if something is in an array or not, but it's also useful because it tells us where that thing is, if it is in there. So includes is a simple yes or no. Index of will say, oh yeah, the first time that occurs. That's actually something I didn't make very clear, but I'll quickly do that. If I push onto my combo party, another example of blue, I have two cats named Blue, okay? If I do index of blue, it only gives me the first match, just like it does for string.indexof. So it won't tell me that there's two blues in here. It only finds the first one and tells me the index. And then after that, we saw reverse, which is straightforward. It reverses an array in place. So next up, we'll take a look at a few more methods: slice, splice, and sort. So let's focus on slice and splice. They sound very similar. We'll begin with slice. So slice is a way of getting a copy of a portion of an array, a slice of an array. So if we have an array with 10 elements in it, and I just want the first 5 or the first 3 or the last 4, whatever it is, I can use slice. So I'll show you how it works. I'm going to clear all of this. So I'll make a new array here. I'm calling it colors, and it has 8 colors in it? Roy G. Biv? No, 7. 1, 2, 3, 4, 5, 6. Yeah, okay. Anyway, if I call colors.slice, and I just pass in one number. If you see here, Chrome is giving me a hint. It says, well, you can pass in a start and an end, and that question mark actually means they're optional. So technically, I could pass in neither. And what this will do is make me a copy of colors. So this is a new array that looks exactly the same. We'll learn how to test that, if they're actually different or if they're the same later on. But for now, that's one thing we can do with slice. But if I just pass in a starting point, like 3, this is going to go from the index of 3, so what is that? 0, 1, 2, 3, green, to the end of the array. Or if I do colors.slice 5, it goes from index of 5, which is indigo, to the very end. Index of 1 goes from index of 1 to the end. So if I only provide a start, I can get a portion of the array until the end. So that start index to the end. For example, if I wanted the cool colors, so red, orange, yellow, I think are considered warm, so green onwards, and I wanted a new array, I would do, what's the index of green? I think it's 3, and then I can save that to an array. Let cool colors. We look at cool colors, there we are, and colors is completely unchanged. Then if I pass in a stopping point, so that's the second argument, colors.slice, let's go from index of 2 to index of 4. What does it do? Well, it starts at index of 2, which is yellow, 0, 1, 2, and it stops not at index of 4, or not including 4, but it stops up to this number. So index of 4 is blue, right? 0, 1, 2, 3, 4. So it includes the start, but it does not include the stop. So I could use this. Let's say I just wanted to get the warm colors, red, orange, yellow, in a new array. How would I do that? Well, we'll start at index of 0. Where do we stop? We'll stop at index of 3, which is green. 0, 1, 2, 3. Just like that. Save that to a variable. Let warm colors. There we are, and colors is still unchanged. Now, another thing you can do is actually use a negative index. If you give it a negative index, it will start from the end of the array. So if I want the last 2 or the last 3 elements, I can do colors.slice of -3. And that gives me the last 3. If I want the last 2, -2. Now let's talk about a similar sounding method, which is splice. Splice does a little bit more. It's going to change according to MDN, changes the contents of an array by removing or replacing existing elements and or adding new elements in place. Oh boy. So think of the term splice. Traditionally, I don't know why I said traditionally, but when we splice something outside of programming, we're inserting it or we're sort of like joining it to something else. It's the same idea here. So we have an array in this example called months, and it's missing February, January, March, April, June. So to get February, it's also missing May, to get February between January and March, we can use splice. And the syntax is a little clunky if you're new. We need to specify a couple different things. Where we're starting our splice, and then how many things to delete, which is this number, and then optionally something to insert. So everything we do with splice operates in place. It is destructive to the original array, it doesn't make a copy. So why don't we try an example? Here's our colors array that we have. It has 7 colors, and remember with splice, we can insert things and we can remove things. So why don't we start by removing something? What we need to do is call splice, and there are 3 different things that we can pass in. The starting index, and that's required. Where are we starting the splice? Are we deleting things? If so, how many to delete? So there's a number here. It can be 0 if we don't want to delete and we just want to insert. Or if we want to delete, let's say we're deleting one thing. Let's say I want to delete indigo. We're going to go with the traditional rainbow I learned as a kid before chemistry or physics or whatever class it was, where it's just red, orange, yellow, green, blue, purple. So I'm going to replace violet with purple eventually, but let's do indigo. I'm going to get rid of, either one. Let's get rid of indigo. So colors.splice, what is that index? 0, 1, 2, 3, 4, 5. So index of 5 is the starting point. How many do I want to delete? I'll delete 1. Just like that. Okay, so it returns to me, it gives me back an array containing what I deleted. And I can delete more than one thing, which is why it gives me an array instead of just indigo. I might delete 5 things. So if we look at colors now, take a look. There's no indigo, and that wound has healed. Where indigo used to be, it has squished together, and now we have blue and then violet. So I could remove multiple things. Just as another example, do I have this days array still? Okay, if I did days.splice, starting from index 1, I want to remove 2 things. I get back this array with the 2 things I deleted, and days is mutated. It's updated to only contain Monday. All right, so let's go back to colors. So now let's see how we can insert something new. Let's insert a value between red and orange. We'll call it red, orange, I guess. Nothing crazy, or maybe dark orange, or I don't know. Red, orange is fine. So I need to do colors.splice, and then I need to specify the starting point. Where is this happening? At index of 1, right? I want it to go after red, which is index of 0. So index of 1, delete nothing. I don't want to replace something. I just want to add this in between. And then the color, or in this case, the string, red, orange. Okay? So I'm not replacing. I'm just inserting between. Let's see if it works. Let's look at colors. Red, red, orange, orange, yellow, green, blue, violet. Awesome. So I can also use it to replace. I also can insert multiple things. So let's say I want to insert, after green. What's between green and blue? Or between yellow and green? Let's do a green, yellow, and then a light green or something. Let's do 2 or 3 colors in between. So I'm going to do colors.splice, and then the index here that I want to go after. So 0, 1, 2, 3, right there, 3. So after 3, delete nothing. And I want to insert, let's go with, these are horrible color names, aren't they? Yellow, green, and then maybe forest green, which, I don't know. This seems stupid to do those 2 colors, but whatever, we're doing it. Let's look at colors, and there we go. Oh, well, I got the index wrong. We want to do it after index of 3, not at index of 3. So that's a good learning experience here. As you can see, what just happened. We did red, red, orange, orange. I was trying to go after yellow, but instead of doing index of 4, which is where I want the insertion to happen, I specified index of 3, which was the old index for yellow. But we inserted 2 new things there. So now we have index 3, 4, and then index of 5 is yellow. Anyway, it's not that common to use splice to insert things in the middle of an array. You'll learn more, well, we'll cover more later on. It's actually not terribly efficient to update the middle of an array. It's better to update the end of an array whenever possible. Sometimes you can't avoid it. And this can be useful to delete things as we've seen. And also, if I do the same thing, let's do colors.splice. And I'll just pick an index here. How about index of 2? And I'm going to delete 2 things. And then we can insert something. How about deleted? All right. So we start with red, red, orange, orange, yellow, green, blah, blah, blah. Let's look at colors now. We have red, red, orange. And then at index of 2, 2 things are missing. Orange and yellow, green have been removed, and we replace them with a single element deleted. All right, so that's enough for splice, for now at least. Don't feel like you have to commit it all to memory. It's definitely the most complicated method we've seen. It has the most uses of the method so far, but it's also not something we necessarily use every single day. Now finally, sort, the array sort method. In the real world, we do sort arrays pretty frequently, but with what we know so far, the array sort method is kind of, I don't want to say useless, but for now, it's not going to be terribly useful because the default way that it sorts things, if you think about it, in order to sort an array, there has to be some comparison, right? If we sort numbers, are we sorting from lowest number to highest, ascending, descending? What about strings? Is it alphabetical order? What about when you have strings and numbers? Oh, geez. What about if you have things that are more complicated, like arrays of arrays? How do you sort that? Well, this is the kind of stuff we haven't really gotten to. We need to understand functions, and just as a sneak preview, we'll be writing things like this, where we pass a function into sort. But we're not there yet. So I just want to show it to you because this comes up usually when I'm teaching in person. Students start to use sort. It seems like it should work. But the default way that it sorts, if you just call array.sort with empty parentheses, it is going to convert everything into strings and then compare their UTF-16 code unit values. So these underlying code numbers, basically, for each string, behind the scenes, it compares them. And that's very janky compared to other programming languages. So even if we have an array of all numbers, which we can do, let's make an array of nums. So let's call this scores. We'll have 1, how about 70? We'll have 100. 100. We'll have 2,500 and 9, and then negative 12, 0, and 34. Okay? Now, if I call scores.sort, you would expect, a lot of people would expect this to sort at least consistently ascending or descending numerically. But that's not what happens. Take a look at this. All right, we have our smallest number, negative 12, then 0, then 1. So far, so good. But then 100, 2,500, 34, 79. So it's basically using that first digit, right? Negative 1, 0, 1. And then 1 plus 0, or 2, and then something. 3, and then something. 7, 9. So this is not a reliable numeric sort. So this is more of a warning just around sorting. There is a way involving functions where we can write a sort and customize it and say, I want you to sort numbers ascending or descending, or I want you to sort based off of X piece of an array, or whatever it is. But we're not there yet. So that's sort, and that wraps up our basic survey of common array methods. Now, if you do look at the documentation, there are quite a few methods on MDN that we are ignoring. That does not mean that they're not used. There's really 2 groups. There are some that are not commonly used or not as commonly used. Things like toString. If you really wanted to, you can turn an array into a string. Sure, if that's something you need, it's here. But I didn't want to spend a lot of time talking about it, although I just did talk about it. The second camp for these methods include things like reduce, and let's do filter. These are things we will learn more of later. They require us to understand functions and to be, I won't say more skilled, but more knowledgeable around JavaScript. So just keep that in mind. We're not done with array methods. We're done with the simple ones. And we'll revisit some of these for each, filter, sum, any. These are things that we'll learn. Map, I don't know how I forgot map, once we have functions under our belt. So that's coming up later. But for now, that's a good start. Next up, we need to talk about our friend, the triple equals operator, and our kind of friend, the double equals operator, in terms of arrays. So if we have 2 numbers, or let's do strings, right? I have the string hi, and another string that looks exactly the same, hi, they are the same. They are considered triple equal to one another. So they are, they're equal to each other. I don't know what else I was going to say there. Now, if we have an array, and this array contains, let's just say, hi and by, two strings. And if I triple equal that array to the same exact array, or what looks like the same array, we get false. So why is this happening? Let's try it with numbers. Just the array 1 equals 1. Okay, what about double equals? No? What about just an empty array? Still no. Why? Well, what happens here when we work with an array, what you have to understand, and it's a little bit tricky, that sounded forceful, what you have to understand, but what's important to understand is that we're not comparing the contents. JavaScript actually doesn't care about what's inside, at least with arrays. What it's comparing instead are the references in memory. So let's take a step back. I'm going to clear my screen for a moment. When I store a number, like let's do lucky num as 87. When I store that number there is a certain amount of space allocated in memory for this number. In fact, every number is going to get a certain amount of space because there is a maximum size for numbers, right? As I get to, where is it, right about here, I'm out of space, and now this number basically just turns to 1. There's a maximum amount of memory allocated for every single number in JavaScript that I make. But with arrays, that is not the case. I could have an array that has 10 numbers, or an array that has 10,000 numbers, and they're all super long, or 10,000 strings, or 10,000 arrays of arrays of arrays, where it could take up a lot of space. So the way they're stored is a little bit different. Instead of, you can kind of think of as what we have right here, 87 being stored in lucky num, which is not exactly how it works. But instead of lucky num just being the spot in memory where 87 is, which is kind of what happens here, with an array, if I do something like let lucky nums equal this array, and I'll just type some random numbers in here. What JavaScript does is, instead of trying to associate lucky nums with all the contents of this array, we don't know how big it is. JavaScript doesn't know how much space it takes up or how much it could take up because it can change and all this stuff. So instead, what is stored and what's associated here with lucky nums in this array is a reference. So behind the scenes, you can think of almost like a social security number or a home address that corresponds to this container, to the array. So when I do something like this, 1, 2, 3, that is making a new array in memory, and it has its own address, its own reference, its own social security number. And then when I do this here, 1, 2, 3, I'm making another new array in memory, a new spot, a new social security number, whatever you want to refer to it as, and they are distinct. They are not referring to the same thing in memory. The contents are the same, but that doesn't matter here. So I can demonstrate this. If I make a variable, let nums equal 1, 2, 3, same thing that we've already done here. And then I make another variable, let nums copy equal nums. So I'm saying nums is equal to this array in memory. And then I say, make a new variable and set it equal to whatever nums is equal to, whatever they're referring to. Okay? Now if I do something to nums, let's just look at nums copy first. Nums and nums copy, they look the same. If I do something to nums.push 4. Let's look at nums. It has 4 on the end. Let's look at the copy. It also has 4. They both are referring to the same thing in memory. I didn't make a new array here. I just said nums is equal to this array in memory, and I want a new variable pointing to the same thing. So think of an arrow. Nums has an arrow pointing to this. Nums copy has another arrow pointing to that same array. So when I change one, the other is altered. If I go the other direction, nums copy dot, and then I'll do pop. Nums is also changed. So they are linked. Nums copy. They are the same exact reference. So now if I triple equal them, nums triple equals nums copy, what is being compared is the reference. Do they have the same arrow? Are they pointing to the same thing in our memory? Not our memory, but in JavaScript memory. And they are. So trying to compare arrays in JavaScript is really only a thing if you're trying to check if they're the same array, if they're referring to the same thing. But it's not going to help us if we're trying to compare the contents. There are ways of doing that, but they involve a lot more work, and we're just not there yet. So double equals, triple equals are just going to check for the reference in memory. Are they the same? They're not looking at the insides. It doesn't matter at all. So very early on in the course, when I first introduced let and const, I talked about how const does not allow for reassignment, right? And with what we knew at the time, we could do things like const pi equals 3.14159 or whatever our sequences for pi. And that makes sense because this should never change. It's always the same. And that's why we're using const, right? If I try and do something like pi plus equals 1, I get an error. But then I also mentioned, once we get to things like arrays and eventually objects, we'll see that const has other uses. And now that we're dealing with arrays, let's talk about that. So in the previous video, we talked about how variables really refer to, there's a reference to an array, sort of an address. And it's not the contents necessarily that are stored in the variable itself. Unlike with a primitive, where things are a lot simpler and they take up a finite amount of space, an array could grow to some obscene size, or it could be very small. So it all has to do with these references, and I use this idea of arrows pointing. So when I make an array, we actually can use const, and it's really common to do that because we can still change the contents of our array. What const cares about is that the variable itself is not reassigned. So when we store an array using const, let's do const, just nice and easy numbers. Nums equals 1, 2, 3, right? What I'm storing with nums is not the contents, it is a reference. So as long as that reference to the array does not change, think of it this way, if the shell remains the same, the contents can change. I could delete everything in here. I could add 1,000 new numbers, or I could just change the order. I could reverse it entirely. None of that impacts the address of this array, the reference. So there's an arrow pointing from nums to this. So I can do things like nums dot push 4, and it changes. I don't get an error. Unlike with a primitive like a number, when I use const and I try and reassign or update that variable, there's a big problem. I can't do it. With an array, we're in the clear as long as I'm changing the content. So in this example, my eggs equals the array brown comma brown. I have 2 brown eggs in my carton. As long as this arrow pointing to the carton, which is our array, as long as that stays the same, I can do whatever I want. I can push on a new egg. I can change one of the eggs at the beginning, change the color, reassign the value in the array. But as soon as I try and set my eggs to something entirely different, a new reference, we get an error. So if I try to do, nums equals 1, well, that's clearly a reassignment. I'm going from an array to a number. Can't do that. But I also can't do this. Nums equals, let's just take a look at what nums is. 1, 2, 3, 4. I can't do this. Nums equals 1, 2, 3, 4. Why? Well, as we saw previously, this makes a brand new array. Completely different in JavaScript's eyes from the one that's currently in nums. They look the same to us. They have the same contents, but they are different in memory. So I get an error. And this is generally something we want if we're working with arrays. We want to be able to rely on the fact that our container will remain the same, right? If we have a list of chat messages we need to respond to, or let's say we're making a customer service app where we have, a queue of people we need to reply to, and we want to be able to sort them and order them. I want that queue to always be there. It might be empty. It might have 1,000 entries if it's a busy day, but I don't want to be able to just reassign that to something else entirely. I don't want to be able to set it to, false or null or something. I want it to always have that same shell, that same reference to the array, and then the contents can change. So it's just a safer way of working with arrays. You don't have to use it, but just keep in mind that it behaves differently than you might expect based off of what we've seen with const so far. Const with just a primitive, you can't change it at all. Const with an array, or as we'll see with objects, you can't change the reference, you cannot reassign, but you can alter the insides as much as you want. Get an interior decorator and completely renovate the interior, but that exterior, that shell is still the same. I mentioned this early on, that arrays can store whatever we want, right? They can store primitives like strings and numbers and booleans, null and undefined, but they can also store other data structures like more arrays. They can store objects when we get to objects. So here's an example of a nested array. It's just 2 levels of arrays. Colors is our top level. It's an array that contains a bunch of arrays, and each one of those arrays is a pair of color strings: red, crimson, orange, dark orange, yellow, goldenrod. I don't really know what the meaning of this is. I think what I was going for is like, here's a common, just a color everyone knows, a category like red, and then here's a detailed, more specific crimson, or here's a, blue and navy blue, or green versus olive. I don't know. So let's do a little demo here. This is a tic-tac-toe board where I'm storing the state of the board using nested arrays. So we have our main array for the entire board, and then 3 different rows, which is each a sub-array. And inside of that, the first one I've got an O, and then null, and then X. So it kind of is visualized or represented by what you can see over here. O, nothing, X. Null, X, O, X, O, null. So in order to work with nested arrays, we can do our own game board. Let's do const game board equals. We need our first array. And then we can nest as much as we want. So let's just do an X, O, X like that. And then I'll do our second row, which will be O. Let's do null. It's empty. Nobody took the middle spot, which is rare. X. And then here's our third row. We've got, I'm not even visualizing this to see if anyone's winning, but let's do O, O, X. So I think X should win. Is that correct? Let's take a look at game board. Now, if I open it up, first of all, what we see before I do that is just array of 3 items, array of 3 items, array of 3. It's not going to show it to me, the contents, but I can expand it and see, here we go, X, O, X, O, null, X, O, O, X. So we have a winner here, which, we're not really computing. We don't have logic for that or anything. But we can visually see it, but that doesn't really matter. What matters is how we would access each one of these letters. So I have a question for you, which is, how would I access null out of this array? I want the center spot. I want to just see what is the center spot of this game board. Well, think about it. I need to go through 2 levels of arrays. So the first level is going to give me this array. There's only 3 elements in this top game board. Here's the first one, the second one, the third one. So I need to use an index of 1, 0 versus 1. So game board of 1 gives me that first array, or technically second one, index of 1. Then I want the second element inside, which is also index of 1. So I can chain that just like this. So if I had 3 levels of arrays, I could continue to go on and on and on. Now I don't, but if we had a Rubik's Cube that we were modeling, then I would have 3 different levels. So that's all I wanted to demonstrate here is, 1, it's perfectly valid to put arrays inside of arrays. And more than that, it's really common, especially in situations like a game board. And then once we get to objects, which is right around the corner, we'll see that we often work with objects and arrays together. We could put objects inside of an array or arrays inside of an object, and that's really, really common. And then in order to access data out of a nested array, we just chain together square brackets, right? This happens first, and that will simplify to some array, and then we're accessing some index of that new array that we've accessed. So don't get too tripped up. It's common to be confused by nested arrays, but don't be intimidated, okay? All right. Well, I hope you're still hanging in there. I know it's been a lot of JavaScript content, and we haven't really made anything yet with JavaScript. We will. That's the whole point. We just have to go through these basics. As I mentioned a while ago, it is a much larger topic. There's a lot more we have to get through before we can make something that you would say is a thing versus HTML and CSS. In the first hour, we could make a very simple website. With JavaScript, in the first hour, we could make a variable. We could make a conditional statement. It's not that exciting. I fully recognize that, but hang in there. This section is pretty quick. It's on something called objects, JavaScript object literals, another data structure, similar to an array in the sense that it stores information and can combine multiple types of data together and multiple pieces of data. There's honestly not a ton to discuss in this section. There's just 2 big topics: creating, working with, accessing, modifying object literals. That's going to be going under crucial. And then working with arrays and objects together. Another yellow topic it will take a little bit of time potentially to get comfortable with. And it's also crucial, but there's just 2 of them. So this section should go by relatively quickly. There's not a lot of methods we have to cover, none of that push, pop, shift, unshift, concat, index of, all that craziness. With arrays, objects are generally simpler. So take a breath, take a break if you need it. We've got a lot of JavaScript to go, so I hope you're not trying to sprint through this section or through this chunk of JavaScript. It deserves at least a couple of days of time. All right, I hope you're doing great. You can do it. Goodbye. So let's talk about JavaScript objects, our second data structure after arrays. So just like arrays, objects are going to help store multiple pieces of data together in some sort of structure. But unlike arrays, where the whole point is to order our data, right? If there's a first thing, a second thing, a third thing, that's not the case with objects. Instead, our data is stored using what we call key value pairs or properties. So a property is just 2 pieces of information, a key, like a label, and then a value. And they form a pair. And an object is just a bunch of these pairs. So on the right side, you can see this diagram. An object obviously does not look like this. It doesn't really look like anything to us, but I like to imagine it as this wiggly amorphous blob, a sack full of these properties, little pieces of data where there's not an order, there's not a priority, it's just these pairs. So we can store whatever we want. There are restrictions, we'll talk about that, but we can store things like age is 20, city is Tulsa, zip is 91003, is admin is true or false, favorite color is purple. Whatever these pieces of information are, key value pairs, we put them in an object, and then we can access them back out using a custom key, whatever we store them in under. So imagine we needed to store this sort of data here. This is information from a Fitbit or something similar to a Fitbit application, where it stores different types of data, or it tracks different types of data, like the number of floors you've climbed, the number of total steps, the number of total active minutes, the total miles, how restful your sleep is. How would we store this using JavaScript? We could use an array, but it'd be kind of janky to do something like, what would we do? We'd just put the numbers in here, so 308,000 would be first. How do you know what that is? 308,000. And then let's say you burn 1,200 calories. Okay, this is not very helpful to see. We just have to know for sure that the first thing, I already forgot, what is it, steps? And the second thing is calories? It's just not practical. So this is where an object comes in. We can instead label things. There's not really an order here that matters. It's all about labeling our information, giving it a name. This is total steps. Total floors, 1,800. Total miles, 211. So here's how we would do that using an object. We'll go into the syntax in more depth in the next video, but notice how we have a key and a value. Total steps is 308,727. Total miles, 211.7. Average calorie burn, 5,755. Workouts this week, 5 of 7. Average good sleep, 2 hours, 13 minutes. These are all properties. They are a pair, each one. We have 5 pairs of information. There's no real order. The order doesn't matter at all. And they're all floating around inside this one shared object. And we stored it in a variable called Fitbit data. So remember, a property is a key and a value. And we need to use that key to get our data back out. Here's an example of some other key value pairs. These are things we could store. Maybe we're modeling a person or a post, a blog post, or a comment. I think this is actually a comment here, where there's a username for who created it. So username, Crazy Cat Lady. Number of upvotes, 7. The text of the comment, great post. Maybe we have the time. Maybe we have the is admin or security level or something like that for the user. All of these are pieces of data that wouldn't really make sense to store in a list or an array, right? You could store whatever you want in an array, but structurally it just doesn't make sense. Some things definitely do, right? When there's a clear order, when it's a collection of especially homogeneous or very similar things. But this is just a collection of different pieces of information. They're related in the sense that they all have to do with a comment or a post or something on a website, but that's kind of it. So an object lets us do that. An object lets us create these key value pairs where we don't need to use a number to access a piece of information, right? If I have an array with certain things in it, I'm going to need to access that data out using an index of 0, index of 2. But if I have an object, I can access my data by saying, hello, Fitbit data, please give me average good sleep. please give me total steps. And assuming it knows what I'm talking about, and it's a property that exists, there's a key called total steps, it will fetch it for me. It will return it to me just like it would if it were an array and I used an index. So in the next video, we'll start creating some objects and see how we can access data out. All right, so let's see how we create our first object literal. Now I'm using the term object literal because an object, the term object in JavaScript, is a bit of a loaded term. You may have noticed things, well, hopefully you noticed, I showed this to you early on. When we do type of on an array, for example, it's telling me object. So without going into any detail at all that I'll say is that objects are, they pop up in a lot of places in JavaScript, even if they don't necessarily look like objects. That's something we will cover. For now, when I say object literal, I'm referring to these key value pair data stores, this data structure we create using curly braces. So I could make my very first one. Let's just mimic, or let's model a person, a very simple person. So we'll do const person equals, and just like with arrays, we commonly use const. Objects are also reference types. So think of person as having an arrow pointing to my object. So this makes me an empty object. If I hit enter, it makes me an empty object, but I'm going to start by populating it with at least one or two key value pairs. So why don't we do first name, and then we need a colon. And then after that, I'll do a string. How about first name, who's a person we'll do? How about Mick? And then last name, Jagger. 2 G's? I think so. Okay, so we have two key value pairs. Each pair is a key, a colon, and then a value. Separated by commas. Separate the individual pairs by commas. You can do this on separate lines like I did here. That just makes it easier for a longer object. But for something short, this is fine. So I'm going to hit enter. Now if we look at person, here we are. We have two different properties, first name Mick, last name Jagger. Cool. Now when we create an object, we can store all sorts of data in there as values. I can put whatever I want as a value. Keys are something separate. We'll talk about that. But remember, a value is the right side of that colon. Also here you can see I'm formatting it differently just to make it clean-ish. It's not perfect, but you don't have to do this at all. You can have it formatted however you want, but I thought this just fit nicely on the slide. So I've got a string for a value, sillygoose420 for username. Downvotes is a number, 19. Upvotes 214. The net score is 195. Comment text, tastes like chicken, LOL. That's a string. Tags, that's an array of strings. Is gilded is false. So this whole thing is supposed to represent a comment, like on a website like Reddit. So there's a username, there's votes, there's the text, all that stuff. So the point here is that we can have different types of values in an object. It's not, or it doesn't have to be all the same. Not that an array has to either. But the key distinction, of course, is that arrays are ordered. Here, there's no real order. All that matters is what we store a value under. What is the name of that key? So we could make something else completely different. We'll just go with const kitchen sink. I'll do this one on multiple lines. I'm just in the console. If you hold shift and then return, we can have multiple lines in here. So let's do, I don't know, fave num will be that number right there. And then let's do is funny will be true. And then let's do colors, red and orange. And let's see, we've got a number, a Boolean, an array. I think that's good enough. There we go. We have an object with different types of values. So we can put whatever we want. That's really the main takeaway. In fact, I didn't show this, but you could actually put another object in there. We'll see some examples of that later on. Next up, we need to talk about accessing data out. All right, so let's talk about getting our data out of an object. How do we access something? With an array, we use square brackets and a number, right? If I have an array of nums, let me just copy one of these. Oh, I've already declared it. So we have nums. And if I want the second thing, it's index of 1. There we go. I get 45. With an object, like with the object I have here called person, if I want last name out of here, I use something similar, or at least one option is to use the square brackets as well, which is kind of confusing. You might think we should use the curly braces. Unfortunately, with objects, the only time we use curly braces is when we're declaring that object, when we're creating it. But then to access data out, we use square brackets. That's one option. And then this is what's kind of confusing. I need to use quotation marks here. First name. I can use single or double quotes, or I'll get last name out. I just need to match what I have here. But this doesn't look like it's a string. We will come back to that. But this is one option. Person, square brackets, last name. That gives me Jagger. Or what was the other object I made? I've already forgotten. Kitchen sink. If I want to get colors out of there, square bracket, colors. Notice if I misspell it, if I do something that's not in there, what are we going to get? Undefined. Just like accessing an array at an index that doesn't exist. So colors, quotes, gives me the value. This is the key. I'm unlocking that value using a key, assuming the key is in there. So there's another syntax, though, to access information out of an object. So I'll go back to person. The first was to use square brackets and then quotes. The second is to use the dot syntax. And it looks like this. Person dot first name, where I don't need quotes. In fact, I can't add the quotes here. I will break things if I do that. I'm not going to get anything. It tells me unexpected string. But if I do person dot first name or person dot last name, just in the same way I would do an array.length or a string.length. It's the same concept. So this is another option, and this seems nice and easy, and it is easy. We don't have to worry about these quotes, but there is an important distinction. And to help us understand what's going on, first let's talk about what happens when I make an object. So when I make an object with a key, let's do const years, and then make our object literal. I'm just going to do something really easy. Let's say year 1999. I'm just going to make up whether they were good or not. So I'll just say good. I have no reason to say that year was good or not. I'll say 2020 though. Definitively not so good. All right. So I'm using numbers as keys. These are clearly numbers. 1999, 2020. Those are numbers. When I look at years, okay, they still kind of look like numbers. They look the same as any other property or any key that we've set so far. But what actually happens behind the scenes is that every key we make in an object is converted to a string. There is a little star here. We haven't talked about symbols. They're not super common. Technically, though, you can use symbols as a key and they'll stay a symbol. But everything else is going to be converted to a string. So it doesn't look like a string, but this is a string right there, 1999, the string. So to access it, I can do this, years 1999, good. Years 2020, bad. Now what if I do this, 1999 right there? It also works. Why is that? It's going to convert this to a string and then look to see if there's the corresponding string in my object. So I'm showing this to you because it's important that you understand what we're actually doing here. This is not making a number as a key, or if I made some other, let's just call this dumb, I don't know why, it makes no sense, but if I set true as a key, true dat is my value, and then how about null as a key? I actually don't know if I've ever used null as a key. Let's see what happens. Does it allow me to do that? Yes, it does, because if we look at dum, these two properties, these two keys are turned into strings. So I can do dum of, in quotes, the string true, and I get dat. Same thing with null. All right, so if we accept that every key is turned into a string, whether it's a Boolean, or looks like a Boolean, or null, or a number, or an actual string, they're all turned into strings, okay? That's the first thing we need to accept. Now, let's talk about the difference between the dot syntax, if we go back to person dot first name versus person square bracket first name with quotes. I cannot do this without those quotes. Just to be clear here, this is not valid. It's expecting, or it assumes this is actually a variable name, and it's not. I don't have a variable called first name. So that's the main difference. If I do person dot first name, just like that, I'm always going to get Mick, and that's great. This is exactly what I'm looking for, first name. But if I do person with square brackets, I have the ability to put an expression in here. So this is ridiculous to do, but I could do something like this, first plus name. And this is going to run first as code. So first concatenating with name gives me first name, and then that is used as the key. Why would you do this? Well, you wouldn't. But what you might do is create a variable. You might have a variable that you're using. So let me show you an example. We have our years demo. Well, imagine I have a variable called birth year. And I'm going to hide it so you can't see what it is, okay? So I have this birth year variable, and if I'm trying to use it to look something up in years, I cannot do this, years dot birth year. Geez, can't type there, huh? There is no birth year property. This gives us no flexibility. It's looking exactly for something called birth year in my object. But if I do this instead, years, birth year, and it's just come to my attention through an error that this is actually lowercase. I wasn't paying attention and did not camel case things. Notice what we end up with. Birth year is going to be evaluated and turned into whatever the result is of that variable, whatever it's holding. And it just so happens it's holding 2020. So that is an important distinction. The dot syntax is nice, but if you're ever trying to use something dynamic, like a variable, as a key in an object, you can use the square brackets. If we use the dot notation, it just doesn't work. Even if I use the correct capitalization here, birth year, which is the same thing, it looks in the object, there is no birth year. What are you talking about? Square brackets, it will run this code first. Okay, so I've gone on long enough about that. I'm sure I've lost a lot of you out of boredom, but hopefully that distinction is clear. All right, so we've talked about accessing data out of an object or retrieving information, but what about adding new information or updating information? So let's say that I have a new object. I'm a teacher and I have a classroom of students, and we have, midterms. We just took midterms. So I'm going to make an object called midterms, and I want to keep track of the scores for my individual students on the midterm test. So let's say I just have a couple of students. Let's go with, Danielle, and her grade, let's see, do we want to do numbers? Yeah, let's just use numbers. So she got a 96 out of 100. And then I'll add in, how about Thomas, who got a 78. Okay, so let's start there. We look at midterms, 2 properties in there. Remember, these keys are turned into strings. Normally, this is not valid in JavaScript, but inside of an object, this is totally fine. But on their own, right, if I just type Danielle like that, it thinks, or JavaScript thinks, I'm talking about a variable or some identifier that does not exist. But inside of this object, it's turned into a string. Okay, so if I want to update one of these things, let's say I want to change Thomas's score. I was wrong. It's actually a 79. I can do this, midterms, and then dot Thomas, or square brackets Thomas with quotes, but I like to use the dot notation whenever I can. It's just shorter, but remember there's a distinction. The square bracket notation allows you to do more. We can evaluate something before you access using that key. Anyway, midterms.thomas equals 79, and that's it. So midterms.thomas is 78. I can change it. It's now equals 79. So just like with an array, when we use the keyword const to declare an object variable, the container, in this case the object itself, needs to stay the same. But the insides can be swapped. We can remove things. We can add new properties. We can update properties. No problem. So I just set Thomas to be 79. If we look at midterms now, midterms, Thomas is indeed 79. I can also, change it to be a string if I wanted to. I could go through and say, actually, I want to do it this way. Midterms, I want letter grades. So that will be a C+, at least in the US grading scale or whatever you want to call it. And then let's do Danielle. This time I'll do the other syntax just for more practice. So she has a 96. Is that an A or an A+? I think it's just an A. I think A+ is 98. I don't know. It doesn't matter. So now we've updated those two. And if I want to add something else in, all I have to do is use the exact same syntax. And that's it, actually. It's just the same syntax. So let's do midterms of, and who's our next person? Thomas, Danielle, how about Ezra? And set that equal to something. It's not in there at the moment. It's totally undefined. Totally undefined. It's undefined. And then I can set it to be, how about Ezra gets a B+. And I can do midterms of, let's add one more person. Let's do square brackets this time. How about Antonio? And Antonio got a A-. Sure. just like that right there. All right, so we use that syntax, both options, square brackets with quotes or some expression in here, or the dot syntax to access values as well as update or create new properties in there. So we added in Antonio and Ezra, we updated Danielle and Thomas, same exact process. We do this all the time. So it's just like updating an array, except we're not using a number. You can you can think of arrays as objects where the keys are numbers. So we still have a key value pair, but we're associating the position, so whatever we have here, with 0. That's the key. 0, the value is ASD, ASD. And then the key is 1, and the value is ASD, ASD. But here we're using people's names as the key, and then the value is a letter grade. All right, so this basic syntax is something we'll see all the time. Key value pairs, use the dot syntax, use the square brackets, and then assign a new value. We're just updating something in this object. So inside of an array, we can store really anything we want. We can store other arrays, numbers, strings, booleans. Inside of an object, we can store whatever we want as the values. We can store numbers, strings, booleans, null, undefined, other objects, and arrays. So we can mix and match, and often we do work with arrays and objects together. And that's what I want to talk about in this video. This is a really common pattern, to have an array of objects, or to have an object with an object inside of it, or an object with arrays inside of it. The combination of the two is far more powerful than either one on their own. Often we have some ordered data, but not every single thing makes sense to put in an array. And other times we have data that makes sense to store as key value pairs, and sometimes some of it's ordered, so we'll use an array. So on the left, I've got an example of an array that consists of a bunch of objects. So this is an array, it's called shopping cart, or the variable is, and then inside each one of those elements is an object. It has a product name, Jenga Classic, a price, $6.88, a quantity, 1. Product, Echo Dot, price, $29.99, quantity, 3. So we get a bunch of information, and this is super abbreviated. For a real shopping cart, there'd be a lot more information in here for each item, but this pattern would hold true. And then over here, I've got an object called student, and inside of it, this is kind of a silly example, but I'm storing strengths, which is an array. I'm putting an object inside a nested object for exams, midterm 92, final 88. All I want to show you is that this is incredibly common, and we should get some practice working with them. So let's make it really simple. Let's do this first example of an array. Let's go with comments, and this will be an array of objects. So I'll do this in the console still. Just use Shift-Enter here. So each comment is an object, which will have, let's say, a username of the person who made it. Let's just go with Tammy. And then her comment text will be, I'm just going to do really stupid stuff. And the number of votes is 9, okay? And then let's add another person, or another entry, rather. We don't have to indent like this at all. I'm just doing it so you can clearly see what I'm doing. Typically, we would follow the same pattern. I can put whatever I want in each object, though. I don't have to be consistent and do username and text and votes. But in most applications, we want to have a consistent pattern. Everyone has a username. I don't want to suddenly call this, username like that, or just name, or I don't want to omit it entirely. So let's go with username. This time we've got Tammy. How about fish boy? That doesn't mean anything to me, but it just came to mind. And then the text of the comment will be, what sort of noise does a fish make? Like glub, glub? Is that the right way of writing that? And then votes will be, how about really high? Everybody loves that comment. Everyone loves fish boy. Let's just start with that, okay? So now we have an array of comments. Let's say 2 comments on one post. This is the first comment. That's the second comment. How do I access glub, glub? Think about it for a moment. Okay, here's what we need to do. Comments, and then I need to access this element of the array, which is the second element, index of 1. And then I need to chain onto that text, dot text, or I could use square brackets, and I get glub, glub. Let me show you an example of something slightly more complicated. So this is data that I took from reddit.com. This is actually their underlying data structure that they use. So we've got this massive object. I put it in a variable. It was not in a variable. We'll actually learn more about this later. It's something called JSON. We haven't considered APIs and servers and anything like that yet. But if we take a look, we've got a lot of object brackets, a lot of array brackets. So let's scroll down and just take a look at what represents a single post on Reddit. So this is a single post right here. There's a list called children, an array of children. And then this one ends somewhere all the way down here. So all of this information corresponds to a single post on the homepage of Reddit. So there's a lot of stuff in here. Like, I don't even know what kind means. T3, I don't know. But then we've got the full name of the author. We've got, if it was gilded, it looks like it has not been gilded. 0 times it's been gilded. Is it hidden? It's false. Have I clicked it or someone clicked it? Have I saved it? False, false. So those are Booleans. Here's the title. Here is, let's see, there's no thumbnail associated with it, so they're null, I believe. The number of upvotes, I think they just call it ups. It's a public subreddit. All of this stuff here, lots of information. But then take a look at this. On Reddit, you can award people's comments or people's posts. So there's an array called all awardings. And I don't really know how this works, if it has awards or not. Does it? I'm not sure. I honestly haven't taken a look at this in detail, but there's a nested structure, an array with objects inside once again. And remember, we're inside of an object, inside of an array. So we've got an array with an object, with an object, with an array, and it's just nested, and it's super common to have that. So here's an example. I think this one has an image on it, whatever this post is, and it has this preview property, and then an array called images. The property is images, there's an array, and then each image is a large object which has all this information about it, different resolutions in a different array. So I hope I'm not scaring you, because that's not the point. If I was faced with this data structure, it takes time. You got to get used to it and get comfortable with how it's set up, right? You don't just memorize this, but you should be able to hopefully leave this video understanding that it's really, really common to mix and match arrays and objects together. They are far more powerful in tandem than they are on their own, because most of our data in the real world is a mixture of key value stuff and ordered lists of information. You put it all together, you get a mess of arrays and objects all nested, and it makes everything a lot easier to represent. Even if it can be a little intimidating to follow, it is a super common pattern. So there we go, arrays and objects living in harmony forever. Welcome back, everyone. Another JavaScript section, no surprise there. What might be a surprise is that we have some red on the right over here. We've got some red pieces, which I think is the first time in one of these videos where I have called something out as potentially taking significantly more time for you to comprehend, or for some people to get through. Remember, this does not mean something is designated as extra difficult. It just means that something might take more of your time to fully understand. But it doesn't have to be conceptually like super hard or something that, is going to challenge you. Some of them will. But in the case of loops, I've just found that this is a topic that can trip some people up. And if you're just trying to speed through this JavaScript content, I recommend that you take a couple of days to really go through all of this and not just try and, sit down in an afternoon and get through all of this stuff, because this is curriculum that would be taught over the course of probably about a week of in-person classes, the JavaScript intro content. So that means, 4, 5, 6 hours a day, 5 days a week. It's a lot of time. So don't speed through it. Anyway, we're going to talk about loops here. How do we repeat code? How do we, I won't say automate, but yeah, how do we write code that does something over and over again without us having to duplicate it manually? So we're going to talk about for loops, which are crucial. They are red. They take a bit more time. That's all I'll say about it for now. So definitely don't feel bad if you need to watch that video again. There's a couple videos. Or if you struggle with the exercises on your first attempt, it takes some practice. The syntax is a bit clunky. Nested loops. I'll put that under important. It's also red because it can trip students up, just like all these things, honestly. But I don't want you to think it's as important to understand as the basic syntax. While loops. Crucial, not as difficult. Break keyword. We'll say that's crucial. For of, very, very important. Iterating arrays. Looping with arrays. This will all make sense once you get through the section, hopefully. I'll say that's crucial as well. Iterating objects, nice to have. Not that crucial at all. So there's a decent chunk of stuff in here, right? Some yellow, some red. This is going to take some time for the average student. Keep that in mind. That's why I'm doing these videos. There's a good number of exercises, little tiny demos that we build together. Go through them. I highly recommend you treat them all, as if you were in a class doing them with a teacher or you were assigned them, because this is a big topic. It's an important one. So here we go. Loops, 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 loops. All right, so let's start learning about loops in JavaScript. The whole point of looping is to repeat some functionality. So instead of having to have, the same thing happen 10 times in a row by writing it 10 times, we can instead, it's not really automating it, but we can instead repeat it using a loop. So a loop is simply a way of repeating some functionality, and that can be something simple. Print the word hello 10 times. Instead of having to copy and paste console.log hello 10 times myself, I could use a loop. Or I could sum every number in an array, and that might be 2 numbers, but that could be 10,000 numbers. And if I didn't use a loop, that would be a lot of work. So there are multiple types of loops: for loops and while loops, for of loops, for in loops. We will see them in this section or in this unit. Here's another example of where loops are used. This is Reddit, once again, the backyard chicken subreddit. This is a cute photo. Some person just had 3 silky chickens. These fluffy white chickens just show up in their coop one day. They don't know how they got them. Anyway, there's a bunch of comments, probably a couple hundred different comments here, and they're stored in an array somewhere. And then each comment needs to be displayed as we can see it here. The title, or rather the username is posted, the number of points, how many days ago, the actual comment text. All of that stuff has to be displayed, and we don't know how to do that yet, but we will. But anyway, imagine it takes 5 lines of code for one comment, just to display it. Well, then we have hundreds of comments. Does that mean that there's, 500 or 1,000 or 10,000 lines of code just to display this stuff? No. Instead, we don't do this, but the developers at Reddit use a loop where they can do something like, for every single comment in the array of comments, do these 5 lines. And that drastically shortens the amount of code that has to be written. So we'll get our first taste of loops in this video. We're going to talk about the for loop. And I need to warn you a tiny bit that the syntax for loops, if you're brand new to this and you've never heard of a for loop, might be a little intimidating. So buckle up, not because it's hard, but it's just a little bit unintuitive at first. This is the technical for loop syntax, the pattern for every for loop we write. Now, this probably looks like nothing meaningful to you, so let me show you an example. This right here is a for loop. This for loop is going to print all of the numbers from 1 to 10. So I've got a script over here, new app.js, new index. There's nothing to look at, just an empty page. And I'm going to go into my app.js and do a console.log 1. And then I'll fast forward through this, but I'll have 10 numbers here. So 2, 3, and so on. Okay, so silly, but I'm printing the numbers from 1 to 10. And that takes 10 lines. Now, if I had, I want to print 100 numbers or 1,000 numbers, it's going to scale with that number that I'm trying to print. If I'm trying to print 10,000 different numbers, that means 10,000 console.logs. Let's just take a look at this, though. Refresh it. Okay, 1 to 10. Now, if I want to do this using a loop, I can rewrite the whole thing in 2 or 3 lines. And that's exactly what this for loop does. So I'm just going to write it out first, and then we'll go over each piece. So I'm going to comment this out so we just have a record of that. For, and then for let I equal 1, I less than or equal to 10, I plus plus, console.log I, with my parentheses. Okay, so let's see if it works. I'll refresh, and it looks exactly the same. The main difference now is that, can you see this over here? It says line 13 from app.js. All of these are coming from line 13, which is right there. Whereas before, they were coming from 1, 2, 3, 4, 5, and so on, because each one of them is on a separate line, each console.log. All right, so let's take a look at the syntax here. How does this work? Well, what I'm doing is making a new variable for this loop. I'm calling it I. It can be named whatever I want, but it's really, really common to use I in a for loop because this variable doesn't really do anything anywhere else in our code. It exists for the purpose of this loop, and that's it. So I think it stands for index originally, but I'm not even sure if that's true. It's just a little counter variable. It doesn't really mean a lot. It's just going to be a number. So in this case, I started off at 1. All right, and our loop runs, and it console.logs 1. So that's what we see. If I refresh, we get 1. Now, we have these two other pieces, separated by semicolons. This middle part is a Boolean expression, and as long as this evaluates to true, the loop will continue running. So I is 1. Is 1 less than or equal to 10? Yes, it is, so we're still looping. And then the third piece here is called the increment expression. This is where we update the value of I. So I begins at 1. Is that less than 10? Yes. We add 1 to I, so now it's 2. Is that less than or equal to 10? Yes, it is. So now we add 1 more. We go 3, 4, 5, 6, 7, 8, 9. We get to 10. I is 10. Is that less than or equal to 10? Yes, it's equal. So we console.log 10, and then we add 1 to I. It's now 11. And then this is run again, and it returns false, and our loop finishes running. So these three pieces are always there. We come up with some variable, often called I, but again, you can name it whatever you want. Just be consistent. If you name this, num, then you need to write num less than or equal to 10 and num plus plus. Console.log num. That's all fine. You just need to be consistent. So we have this variable. It starts at 1. While we are less than or equal to 10, while num is smaller or equal to 10, do this. And after each iteration, add 1, num plus plus. We could also do num plus equals 1, right? Same thing. So like I said, this can take a little bit of time to get used to or to get comfortable with, but it's a really, really common idea in JavaScript. So 3 pieces, create a variable, do something to that variable after every loop while something is true. So separate them by semicolons, and then whatever code I put in here, I could put something else like console.log, I'm in the loop body. Whatever code is in there will run each time my loop executes. So this is where I could do something like, display Reddit comment and then have that happen 10 times or 1,000 times or 100 times. I don't know why I did it 1,000 then 100. I meant to say 100,000. So that's what we could do inside of a loop. We could repeat that very lengthy thing that might be 10 lines of code or 100 lines of code. We're doing something very simple right now. We're just repeating 2 lines of code that are kind of useless. But this idea of a loop comes up over and over again. You might say over and over and over and over and over and over and over, like a loop. Okay, so we'll get more practice with for loops in the next video. Okay, so we've seen our basic introduction to a for loop. They all follow this pattern. Some initial expression with some variable. It's like a counter. And then we have our condition that dictates how long or when the loop should run until. And then we have our increment expression, which is really not a great name for it. That is what the docs use on MDN, but you can decrement. You could do something like divide your number or multiply your number, but typically we are going upwards and we're incrementing. So let's make another variation. Let's make a loop that prints out even numbers. Even numbers from 0 to 20. Okay, so it would be, let me just comment this out so we don't get a whole bunch of numbers. 4, let I, which is pretty common to use I, as we've seen, will start at 0. And we want to go while we can do less than or equal to 20, or we could just say less than 21. Really, for some reason, my brain prefers less than or equal. I don't know, maybe it just seems more explicit to me, but it is an extra character to put that equal sign in there when we could get away with less than 21. Anyway, then after that, we need to figure out what we're going to increment I each time through this loop. If I just did plus equal 1, I console.log I. We hopefully know what to expect, 0 to 20. But I want even numbers. So I want 0, and then I want to skip 1 and go right to 2, and then go to 4, then go to 6. So I'm going to plus equal 2. So I will start at 0. Is 0 less than or equal to 20? Yes. So we console.log 0. Then we're going to add 2 to I. So next time through, it's 2. And we keep going. We print out 2. We add 2. And eventually we hit 18, we add 2, we get 20, we print out 20, and then we add 2, that's 22, and this is no longer true. And we're done. And that's what we get, 0, 2, 4, 6, 8, and so on. All right, now if I wanted to skip that 0 and just do 2, 4, 6, 8, how could we do that? Well, it's just the starting point. We'll start at 2. Now what if I wanted to do odd numbers? So 1, 3, 5, 7. Well, I could start at 1. And now we're adding 2. and that doesn't mean something's even. If you add 2 to it, it's just 2 more than what you had before, right? So 1 plus 2 is 3, 5, 7, and there we go. We have odd numbers. Okay, so let's do one more example. Let's do something pretty different. Let's count down from 100. And I want to print out 100, and then 90, 80, 70, 60, all the way down. Whoa, I was trying to do ... Autocomplete got in the way. All the way down to, should we do 0? Yeah, let's end at 0 or 10. Let's do 0. Okay, so we're going to need to make a variable. Often, we'll call it I, and it will start at 100. And in our loop, we'll print out I. We want to run while I is less than or equal to 0. No, while I is greater than or equal to 0, because we are going to be counting down and subtracting from I. So here we're incrementing. We're adding 2 each time, but I want to subtract. So 4, let I equals not 0. Gosh, it's just ingrained in my brain because that's the most common thing we do. We'll start at 100. I needs to be greater than or equal to 0 if I want to include 0. And then I minus equals 10. So each time through, subtract 10 from I. Let's see what happens. Console.log I. Refresh, and it worked. 10, 90, 80, 70, all the way down to, 100, 90, 80, 70, all the way down to 20, 10, 0. Cool. So those are a couple more for loops. You can even do really weird things that, honestly, this is incredibly uncommon. But I could have my variable I start at 10, and I want I to be greater than or equal to, let's do less than or equal to 100. And I'm going to multiply I each time. I equals I times 10, or I can just do I star equals 10. So let's do it while we're less than 1,000. So this will be very short. We'll start at 10. We print that out. We multiply by 10, so we get to 100. And we print that out. And then we multiply by 10 again. So just wanted to demonstrate that we can do this. We could use multiplication or subtraction, even division, but it's almost, I won't say guaranteed, but more likely than not, what you'll see is just incrementing I, adding 1, sometimes adding something else, but usually you're just adding 1, honestly. And I'll show you some situations where this is a lot more useful than just printing out numbers like we're doing here, but we have to understand the foundation, the basic syntax. Okay, so the 3 pieces separated by semicolons are the variable that we create for the loop, the expression that needs to be true for the loop to continue running, and then the increment portion or decrement or whatever we're doing, we should be changing the value of our variables in some way so that eventually this becomes false and the loop stops. Otherwise, our loop will never end, and that's something we're about to talk about. Next up, we have to confront the grave, disturbing, and dark reality of infinite loops. They're real, and they will cause you infinite pain and suffering. Now, they're not that bad, but they are frustrating, and there's something you should know about. So let's talk about them. An infinite loop is basically what it sounds like. It's a loop that does not stop. It runs, technically it doesn't run forever, it doesn't run ad infinitum, because your browser and JavaScript are going to run out of memory, and things are going to come to a crippling, crushing halt, but they will run on and on and on and on and push your machine to a place it does not want to go. Sometimes it will just cause your browser window to just lock up entirely. I've had it where my Chrome console my Chrome browser has just force quit unexpectedly. These days, the tools have gotten a bit better so you can halt them. But yeah, infinite loops are not good. You're basically using up all the memory that JavaScript has for you because your loop just never stops. So the important thing to keep in mind when you're writing any loop is always pay attention to how is this loop going to stop, and is this correct? Am I actually going to hit this stopping point at some point? So here's an example. We start with I at 20. This loop runs as long as I is greater than or equal to 0, and we add 1 each time through. Well, that's going to be a huge problem because we're starting at 20, we're adding 1, so we're going to be 20, 21, 22, 23. And this loop just runs as long as I is greater than or equal to 0. Well, it starts out greater than 0, and it's only getting further away from 0. We're adding 1 each time. So this is never going to be false, this condition. And our loop will just run and run and run. So make sure when you're writing your for loops that you stop for a moment, you think about it. Is this condition going to be false? If so, Eventually, it might be one iteration away. It might be 1,000 iterations. It's fine to loop thousands and thousands of times, but you don't want an uncontrolled infinite loop that is never going to stop, or at least is going to barrel through all of your computer's memory. So let me show you an example just so you can see what it looks like. So let's start with I set to, what should we do? Let's go 20. And then let's go I'll just recreate what I had there. I greater than or equal to 0, I plus plus, console.log, I. Oh boy, here we go. I actually don't know exactly what my browser's going to do while I'm recording. Here we go though. Start at 20, add 1 each time. We're always greater than or equal to 0. I'm going to refresh. Oh boy. All right, so already things are sort of jumping around. And it seems like it stopped, right? It seems like it stopped at 7,000. But if I try and do something else in here, I'm typing. I'm hitting delete. Look at how laggy this is. I'm holding delete. I mean, it's barely working. And if I try and run some code, like, what is 1 plus 1? I hit enter. It's not working. Nothing is working. So I can't actually do anything in this window. If I go to the actual window it corresponds to, can you see how it's just, oh boy, this is not good. It's not the end of the world, but it is running still. And the console has just decided to stop console.logging things, but that does not mean that the loop is actually done. So don't be deceived and think it only ran 7,259 times. It's still going. So I'm just going to close this window and hope for the best. Now, I don't know if you can hear my computer fan. It is kicked in full blast. Let me try moving this closer. Can you hear that? It's not good. My computer is not happy with me. It's going to be fine. We'll need a little bit more therapy. We need some time away from each other, and we'll come back and, Okay, so I just reopened the file in a new window, and we're good to go. I can start using my console again, and my computer will eventually cool down here. So it's not the end of the world, but it can be very problematic, and they almost always catch you off guard or catch you by surprise. If you're predicting them, I mean, I guess I just did because I'm teaching infinite loops, but if you're predicting that you're going to have an infinite loop, you're almost always, I don't know why you wouldn't, you're just going to fix it ahead of time because it's really a nuisance. So I'm commenting this out and making it very clear that this is an infinite loop. I'll leave it in the code so that you have it. Just, I don't know if you want to follow along, if you want to just test your browser and turn your computer's fans on for no reason, go ahead. But I'm just going to comment that out. The good news about infinite loops, right, to fix them, generally it's not a lot of work. You usually have just made a logic mistake or you're thinking about things in the wrong direction. So here, if I'm trying to, let's say I wanted to print out numbers from 20 to 0, well, I should have gone down, I minus minus. Or maybe I wanted to do something else, like as long as I is less than or equal to some number, not 0, but I need to figure out some way of making this work where it's not going to run forever. And this is only 4 loops that we've seen so far, but infinite loops are also common when we talk about while loops. We'll see some more examples where things could go wrong. It's just a part of working with loops. So be careful, but don't paralyze yourself in fear. It's really not a huge deal. You just want to avoid it whenever possible, and just pay attention to your code, right? There are some repercussions. If you screw up a variable name or you have a typo, you get a little error in your console. It's not the biggest deal at all. It's pretty quick. If you have an infinite loop, sometimes it can be obnoxious and cause you a minute or two of grief. So looping over and creating a bunch of numbers to print out is not all that useful, but we do use loops all the time when we're interacting with arrays. Now there's more than one way of doing this, and we'll see some others that are a little bit nicer later on, in just a few videos actually. But one option to loop over an array, we also call it iterating over an array, doing something with or for each element in an array, is to use a for loop, and to create a number, usually called I, that we'll use to refer to an element's index in the array. So indices start at 0, and then they go up to the end, the length minus 1, right? So there's 3 elements here. The highest index is 2. So we could loop from 0 to 1 to 2, and then use that index to access the element in the array. And that's exactly what I'm doing here. I starts at 0, while I is less than animals.length, whatever that is. That could be 3, it could be 100, I plus plus, and then I'm printing out I just so you can see it, and animals square brackets I. So animals of 0, lions. Animals of 1, tigers. Animals of 2, bears. Oh my. So this is a pretty common template let I equal 0, I less than some array.length, I plus plus, in a for loop at least. That will iterate over every index, right? It doesn't give us the element itself. We have to plug that I, the number, into the array. So here's an example with a much larger array. I found an alphabetical list of some popular animals, although some of them are kind of obscure. It's unclear why we have just lion, generic lion, and llama, right? We don't have like specific subspecies of lions. And then we end up with northern right whale, or Przewalski's wild horse. I mean, some of these are pretty specific. Anyway, lots of animals, right? I don't know how many are in here. So I'm not going to be able to hard code a for loop that runs 20 times or 1,000 times. I'm not going to be able to determine, just by looking at this, how many elements I need to iterate over. So if I want to print out each animal in here, I need to do for something. So for let I, we'll start with index of 0. And then I'm going to go while I is less than, and my array is called animals. There it is. While I is less than animals dot length. So, I mean, I could also do less than or equal to animals dot length minus 1. That's our greatest index, but this is shorter here. So whatever that length is, let's say there's 500, probably 250, 300 elements in this array. The highest index, if there's 300 elements, the highest index is 299. So we want to stay less than the length, not equal to. Otherwise, we'll get an undefined at the end. And then we add one to I each time. And then here, why don't we just console.log I, and then, well, let's just do I first and see what we get. Okay, so 312. It wasn't that far off. So the highest index is 312. The lowest is 0, of course. And now if I want to print out the animal itself, animals, square bracket, I. Just like I myself would do animals of 0 to get the first one, and animals of 312 to get the last one. Zorilla. What is a zorilla? Interesting. African weasel. It looks like a skunk in my backyard. Oh, so cute. All right, so that's a zorilla. Anyway, let's run this now, where I'm using that index, a new index each time through the loop, to access animals at that index, refresh the page, and here we are. So I'm printing out the index just so you can see it. 0 is aardvark, 1 is aardwolf, 2 is African elephant, 3 African tree pangolin. Oh, pangolins. If you ever want to just really be deeply disturbed and saddened by the state of the world, just look at photos of pangolins being illegally trafficked. It's just sad. There's little cute armored animals stuffed into a box. Anyway, on a lighter note here, I don't have a lighter note, do I? It's very sad. Okay, on a coding note, let's go in reverse. I'm iterating from the beginning to the end of the array. Let's go the other direction. So stop and think about this on your own if you would like. What do we need to do? Well, we need to start with the highest index. So what is the highest index? I equals animals.length. That's not quite it. Animals.length is going to be, 313. If the highest index is 312, it's one more. So we want this. Animals.length minus 1. Then I want to keep going while something, we'll come back to that, and I want to subtract 1 from I each time. So we start with 312 as our I, and then 311, 310, and we want to keep going while I is greater than or equal to 0, or just greater than -1, right? We want to have 0 be one of the indices that we actually use because there's an index of 0. That's the first element. I minus minus, let's do a console.log animals of I. So don't forget, you've got to access the array with I. I is just a number. We're generating a bunch of numbers, the indices, but we have to plug them into the array. Okay, so let's see what we end up with here. Looks good. Let's make sure we start with Zorilla all the way down to aardvark. And there we go. So super common to iterate over arrays. And this used to be one of the more common ways of doing things. But actually, in the last couple of years, there's an even easier way of iterating over arrays. We will see it shortly. But you should still know how to do this. It's just a for loop. We're just plugging our I, or whatever we name this, into an array. All right. Next up, we've got to talk about nested loops. So next up, we need to talk about nesting loops. So having one for loop, in this case for loops, instead of another for loop. We can nest all sorts of loops. Once we get to while loops, I could nest one inside of another, or I could nest a while loop inside of a for loop, or vice versa. But today, right now, we're talking about nesting for loops. So the idea here is literally putting a for loop inside the body of another for loop. But in practice, what this means is that for every single iteration of the outer loop, let's say it runs 5 times, the inner loop is going to have its own full cycle. 5 separate times it gets a full cycle. So let me try and illustrate that in a better way. Let's make a simple for loop. For let I equals 0. Let's go from 0 to maybe 10. So I less than 10, or maybe we'll do 1 to 10. Okay, so less than or equal to 10, and then I plus plus. And we'll print out console.log I. Let's use a string template literal. I is, and then let's print out I. Okay, so let's just make sure that works. I didn't screw it up. Cool. 1, 2, 3, 4, 5, all the way down to 10. Now, I'm going to nest a loop afterwards. And this time, I'm not going to use I, I'm going to use J, which is pretty common to use. Just other single letters. Usually it's I and then J. And if we had a third level of nesting, we could use K. That's the alphabet, right? H-I-J-K-L. Yes. You don't have to do any of that. You could name this first I and second I, or sometimes people use inner and outer just to make it easier. Because honestly, I is easy enough to keep track of when it's one loop, but when you have I and J and maybe K, it's a big headache to wrap your head around. But we'll just do I and J because that's really common. And I'm going to start with J. I'll do this. Should I do the same thing? Maybe we'll just do from 1 to 3. So 1, I less than or equal to 3, or we'll do less than 4 maybe. I plus plus. See, I already screwed it up. See how I did I here? I'm supposed to be working with J. I think I'm going to leave this in the video just to illustrate the perils of working with nested loops. One of the issues here, at least for me, is it's so easy to mix that up. Trust me, I edit a lot of stuff out. It's very easy for me to do that, but I think I'll keep it in here because that's very real, at least to my experience writing nested loops. Okay, so in here I'm just going to console.log J is, let's do a string template literal. Just like this. So J is, and then we'll put J there. And I'm just going to add a bunch of space in here so that we can see it visually printing out differently. So I'll fix that string template literal, and let's take a look. Okay, so that's why I indented it so we can see that's the J inner loop a little bit clearer. So let's walk through what happens. Our outer loop runs 10 times. So I is going to be 1, and then it will be 2, and then 3, and so on. But while I is 1, we have this entire nested loop, which runs for J, starting at 1, up to, but not including 4, so 1 to 3. So we end up with 1 iteration for J, 2, 3 for J, all while we're on the first iteration for I. And then we get to the end of this line, or the end of this loop, and then we move on, and I goes up, and I is now 2, and the whole process repeats. So we end up with 1, 2, 3 for J, and this happens 10 times total because this outer loop runs 10 times. So you can see what we end up with. I is 1, and then here's our 3 loops, 3 iterations on the inner loop. I is 2, 3 iterations on the inside. So whenever you have nested loops, you end up with a lot of iterations. It's very, very different from just 2 side-by-side loops. This runs 10 times roughly. This runs 3 times. 13 total console.logs, right? If I just ran that right now, I'm not going to count. Let's just say roughly 13. I might have messed up the inclusiveness or exclusiveness. Now, when I put this inside, now we end up with 10 iterations, and on each iteration, we're doing 3 things. So roughly to calculate the number of iterations, we would multiply 10 times 3 here. So we get 30, although that's really the amount of inner iterations here, or the console.logs. We have 30 of these, and then we've got 10 of these. So it's more like 40 total. The specifics don't matter. I just want you to understand that it's a lot more. One common area where nested loops come up is when we need to traverse or iterate across nested arrays. So I've got an example here. I'm calling it seating chart, this variable. It's an array full of 3 subarrays. And it's supposed to represent, if you're, a middle school teacher or something, you have to make a seating chart of the different chairs and desks and all of that and figure out who sits where based upon a whole bunch of criteria. who works well together, who are the mortal enemies and the best friends who are going to chat too much. And I don't know. I've never taught middle school, but I remember there being a seating chart. So each one of these subarrays could represent a row, right? So we've got our first row, second row, and third row. And let's say that I want to print them all out. Just something simple. Just print out every student's name like I'm doing roll call or something. Okay? So to do that, one loop is not enough. I could do for let I equals 0, I is less than seating chart dot length I plus plus, and then if I console.log seating chart of I, what will I see? What will be printed out here? Well, I'm printing out the entire array. So if I wanted to instead print out each individual name, what I need to do is now loop over seating chart of I. Seating chart of I is just this. The first time through, I is 0, so seating chart of 0. Then next time through, seating chart of I is 1. So it's this subarray. And then I is 2, and it's this, and then I is 3, and we're done. There is no index 3 in this array. So then I need to iterate over seating chart of I. And what I like to do at least is save that to a variable. Seating chart of I, that represents a row. So let's just make a variable called row, right? This is our first row. It's smaller, only 3 students, 3 desks, and then our second row and third row. So now we need to iterate over row. So for, most commonly you'll see j, let j equal 0. J is less than, and this is where you have to be careful. We're not working with seating chart anymore. We're working with row because I made that variable. So j is less than row dot length, j plus plus, and then let's console.log row of j. And up here, let's do, well, we can just start with that and make sure it works. There we go. We're getting every student from Kristen down to Erica. And I could do a console.log row. Why don't I do like row 1, row 2, row 3? So I could actually print the row number. So I'll do row, and then I can add I in here, but there's a problem, a small problem, which is that my numbering starts at 0 because I needs to begin at 0. So why don't I make it row 1, 2, and 3 by just adding 1 to what we print out right there. So row I plus 1, and maybe I'll put a number sign, a little hash symbol right there. There we go. Row number 1, Kristen, Eric, Hinamata. Row number 2, Jeffrey, Juanita, Antonio, Kevin. Row number 3, Yuma, Sakura, Jack, Erica. Cool. So if you're at all lost on this bit, nested arrays, first of all, know that you are not in the minority there. When I teach this in person, nested arrays is, in particular, looping and iterating over nested arrays is always a little bit tricky. So take some time to go over it and break it down. I mean, you can literally write out what I and J are at each step. I do this often on a whiteboard with students. We'll make like a table like this. What's I? What's J? What is row? What is seating chart of I? All of that stuff, write it down and iterate mentally through this process, and it generally will become clearer. If not, practice and time will help that as well. So don't panic if you're feeling it all stuck here. It's a really normal place to hit a little bit of a speed bump. Roadblock, speed bump, whatever. Okay, bye. So next up, we move on to our second type of loop, the while loop. So a while loop is actually much simpler than a for loop to understand. There's just one piece of syntax. While, and then inside of parentheses, a single condition. And as long as that condition is true, whatever it is, if it evaluates to true, your loop will continue to run. If this ever evaluates to false, the loop is done. So this is a simple example, basically recreating what we've already done with a for loop, printing numbers from 0 to 10. So let's try that out. I'm in a new file once again, just to keep things separate. We have our for loops video, or files, and then while loops here. And I've got an app.js. Let's loop starting at 0. So we could do I, we could do count equals 0, and then while count is greater than, or let's go less than 10, and then my curly braces. And whatever code goes in here will be run each time through the loop. But with while loops, it's very easy to make an infinite loop if you're not paying attention, because count is 0, count less than 10, that's always going to be true, and there's no part of the syntax where I actually add or subtract or alter count in any way in the loop statement. Instead, I do that down in the body here between the curly braces. So I need to make sure I'm doing something like count plus equals 1 or count plus plus. I do that separately. So let's do a console.log count and just see what we get. Okay, so there's 0 through 9, and that just happens because of where I'm console.logging. I'm incrementing count after I print, so I could do it the other way around, and now we should end up with 1 through 10, just like that. So this is just another form of what we've already done, right? The equivalent here is for, and I'll use I, let I equals 0 or 1, I less than 10 or less than or equal to 10, I plus plus. It's the same idea. We have some initial value. While some part is true, some condition is true, do this and add 1 to I, or to count. So this is not where most people use a while loop. I mean, you can, but generally for loops are preferred for things like this, where we have a set number of iterations. It's always 0 to 10. Or if we have an array, whatever the length of that array is, we're always going to iterate n times. If the array is 20 items or 1,000 items, that is kind of set in stone. Where a while loop is more useful, in my opinion, is when we have something that is truly variable. We may not know how many times it iterates, and that could involve user input. That could be something like a game loop, where we have a board game like the chess or checkers. We want to continue looping as long as nobody has won the game. So we could write something like while, and then, game is not over, or game over is not true. And then in here we would have, player 1 move, and then player 2 move. And then after this loop, we would have something like congrats, because if you made it to this point, somebody won the game. So game loops are very common, and it's very hard to know. It's impossible to know how many times you'll need to iterate for a game of chess or checkers. It could be very, very quick if somebody is really smart playing against somebody who's never played before, or it could take a very long time. And we're not setting any sort of defined number of iterations. So I'll show you a simple example of this sort of while loop. Why don't we ask a user to enter a password? So our secret code, let's just make our secret code here, const secret code, I'll just do secret, is going to be, how about baby hippo, one word, camel case like that. Okay, so what I'm going to do now is have a while loop where I ask you to enter, or I ask a user to enter the secret code. And as long as you don't get it right, as long as it's not a match, I'm just going to keep asking you over and over and over. So I'm going to come up with a variable. Let's just go with guess equal prompt, enter the secret code. Okay? And then while your guess is not equal to secret, I'm just going to say guess is equal to the exact same thing, prompt, enter the secret code. And that's going to happen over and over and over until you get it exactly right. Because at that point, this line inside of the parentheses will evaluate to false and our loop will be done. So if I put something else down here like congrats, you got the secret, that's only going to run after this loop finishes, and that means it's only going to run after you enter baby hippo correctly. So let's see what happens. Enter the secret code. I'll enter something wrong. Nope. Enter the secret code. Okay. How about baby? No. Now I'll enter it correctly. We are not ignoring case, so I have to match it exactly. Baby hippo. Congrats, you got the secret. So a while loop works here because I don't know how many times this could take. It could be the first try, or somebody might never get it, and we're just going on and on and on and on, hundreds or thousands or more different times. So there's not a set number of iterations, and this is where a while loop really shines. It's just easier to make a loop like this that runs an unknown number of times using a while loop. It's nice and short here. While guess is not equal to secret. So while the guess is wrong, get a new guess. And we could print something out if we wanted to, but I don't think we need to do that. We'll just keep it simple like I have right here. In the next video, I'll show you another example of this sort of loop where it's not really a game loop, but it's kind of the same idea. While you have not won the game, while you have not guessed correctly, that sort of thing, continue this loop. So that's coming up. So while we're talking about while loops, I should also introduce the break keyword. The break keyword is most commonly used with while loops, although technically you can use it with other loops. It's just really, really rare. And what it will do is inside of a loop, if it ever actually runs, so with some condition, in this case, if the guessed number is equal to a random target number, if they're the same, we break out. And that is going to stop the execution of the loop immediately as soon as break is encountered, and then code just resumes running after our loop. So whatever is down here, if anything, would be executed. So let me show this with a simple loop. We'll do a while true as well. While true, and I'm not going to run this, otherwise we'll have a bad time if it's just constantly running. And we're going to make a really annoying program, I guess, where whatever you type, let's say I type hello, our computer, the code, is just going to repeat exactly what I said back to me, hello. And then if I type something else, it's going to repeat it to me. And the only way to get out of it is by typing maybe quit or stop copying me or something. Let's do stop copying me. All right. So I'm going to start by asking a user to enter something. I'll do let input equal prompt. Hey, say something. And then in here, I'm simply going to spit that back out. So I'm going to prompt the user again using that input, so whatever we captured here, and then save that back to input. So basically I'm just, the very first time, hey, say something. Let's say enter hello. Then we're going to prompt hello. That will be the argument to prompt, and then we'll capture that value, whatever I say that time, goodbye, or I hate you, or haha. That will be saved in input, and the process repeats. And if I ran this right now, it would be an infinite loop. But I can check in here if input, let's just say if it equals stop copying me, just like that. If that's the case, we can break out of the loop. And down here, I'll put something like console.log, okay, you win. Just like that. So if this is ever encountered, the loop will stop running and this code runs or whatever comes afterwards. The only other thing, I guess we can make this .2 lowercase maybe, just so that I don't have to type it perfectly. Stop copying me. Let's see if it works. Oh boy. Also, actually, while I'm here, I could just put this break on the same line. It's such a short bit of code that I'm running inside of this conditional. So I would just do that. Just like that. All right, I'm going to refresh. Say something. Hello. And it says hello back to me. LOL. Bye. It's going to keep going forever until I type stop copying me. And we're done. And if I open up the console, we see, okay, you win. But that only showed up here, you'll have to trust me on that, once I hit that break right here. So, while true, seems like it should happen forever, and it would if not for break. It's a way of escaping a loop. While we're here, I guess I could show, let's do a for loop, let I equal 0, I is less than, let's do 1,000, I plus plus, console.log I, and that would just go to 1,000, which is not really a big deal to print out all of those numbers. I can just show that here. Let's move this over. There we go. Oh, it doesn't go to 1,000. I can't do math. But we get to 999. But in here, if I do something like if, let's do it afterwards. If I equals, what should we do? If I equals 100, break. So it will work in here. It's just kind of odd to do it in a for loop, because most frequently we use break in a situation where something is not running a set number of times. We don't know how much something needs to run for. Otherwise, we would just make our loop run. In this case, if we're going from 0 to 100, let's just write our loop to go from 0 to 100. Why do this weird structure? But I just want to show that we can. So that's the break keyword. So next up, let's make a relatively simple guessing game. This is a demo of how it will work when it's done. So it starts by asking us to enter a maximum number. So basically a difficulty. Let's go from 0 or 1 to 20. And then I need to enter my first guess. Let's go with, 10. That's too low. So it tells me I need to guess again. Okay, so let's try guessing higher. How about 15? Too high, 13. Too low, 14. And then it tells us it took you 4 guesses. Also, if I refresh and I try entering, a really large max, like 1,000, it could take me a long time. So if I'm getting frustrated with that, I can type Q, and I just quit the game immediately. So let's try building it. The first thing I want to do is ask a user to enter in their maximum number. So if we're going from 1 to 10 or 20 or 50 or 1,000 or whatever it is. So I'm going to prompt enter your, the maximum number. And I'll save that to a variable. So we'll go with let, and I'll tell you why I'm using let in just a minute. Maximum equal prompt. You would think this doesn't need to change, right? It's a one-time thing, and then we should just take that value and save it. But there's a possibility that I enter something in that is not actually a number. Well, everything is going to be a string technically, even if it's 3. It needs to be converted into a number. And so if I try and call parse int, which is how we're going to do that, on something that is not a number, we get not a number. So it will work on things that can be converted, even like that contain an integer. So I just want to check and make sure that a user has actually entered something in that is valid and that can be parsed. So I am going to parse it here, parse int. Just do it on the same line. Parse int on whatever we got from prompting the user. And then let's assume that it works to start. Let's assume that that's a fine number. It's 90. How do we generate our random number from 1 to 90? Or 1 to whatever maximum is? Well, remember how we generate a number from 1 to 10. It's math.random. We multiply by 10, and then we floor that entire thing, and then we add 1 at the end. So we're going from 0 to 1 as a decimal. We multiply by 10. Then we chop off the decimal. And then we add 1. Okay? Now this is going to give us 1 to 10. But if I want 1 to our maximum, it just looks like that. So let's save that in a variable. Const target num. This is what we're trying to guess. And let's just console.log it so we can see it. Console.log target num. All right, so I'm going to refresh. Enter our maximum number. Let's do 4. Ooh, maximum is not defined. What did I call this? Oh, well, I can't spell. Wow, there we go, maximum. Try that again. We'll enter 4. Okay, so the random number was 1. If I enter 1,000, the random number is 643. If I enter a much larger number, there we go, we get a much larger random number. So technically, we're not really testing to see that the entire range is working. We're just picking one random number. But there is a problem, which is if I enter something that is not valid when we parse it, I get not a number as my random number. Because parse int gives me not a number, and I'm multiplying by not a number, so the end result is always not a number. Anytime we do math with NaN, we get NaN. So I want to make sure that we actually get a valid maximum that is a number before we move on to this line. So I could just do this if there's not a maximum. Remember that not a number is falsy. So I'm checking right here. If maximum happens to be falsy, why don't we just get this line again? Right, I could update maximum. How about enter a valid number? So I could do that. So I'm going to enter something invalid. Please enter a valid number. Okay, and that works. If I enter something valid right away, we skip that step. But the problem is we're only checking one time. So I could enter something incorrect, invalid, like that, and then again, and we move on. But that's not what I want to do. So I'm going to use a while loop. I'm just going to replace this. While there is not a maximum number that is valid, so while there's a falsy max, just update max and keep asking. So why don't we console.log target number again? I don't know why I got rid of that. Now take a look. Not valid, not valid, not valid. We're all stuck in that while loop. And now I'll enter in something that is valid, and we're good to go. Cool. So that's the first step. We have now made it so that a user has to enter in a valid number. Technically, this also screens out 0 because 0 is considered falsy. And we're not going to worry about negative numbers for now. All right, so now I want to actually make the game. So now that you have picked your number, the maximum number, and we have our own random number, your target here, what we want to do is ask you to enter a guess. And then as long as that guess is incorrect, we're going to tell you if it's too high or too low. So to get that guess, we could just prompt you. Let guess equal prompt. Enter your first guess. Cool. And then we'll write our while loop. While your guess is not equal to target num. But there's a problem here, which is that your guess is going to be a string, and we're comparing guess and target num, which is a number, those are not going to ever be equal, or that's going to be problematic for comparisons. So I could parse int like this, as we've seen. Cool. So we're parsing your prompt, whatever you enter, and while they're not the same, let's check. If your guess is greater than target number, let's prompt you again. Too high, enter a new guess. And save that to our guess variable. And then otherwise, we'll do too low. Because if we're in this loop at all, right, if we've made it into this loop, we know they're not equal. So it's either greater or less. We don't have to worry about the case of equality. And let's just at the end down here, do a console.log. You got it. Let's see what happens. Hopefully no infinite loops. Oh, there is going to be a problem actually. We're parsing it one time, but then assuming you don't get it right on the first guess, we're going to ask you again, enter a new guess, and we're not parsing int. So we could do this here, parse int on both of them, just like that, and then parse int over here. Let's see if that works. So, oh, I need to enter a valid number still. Enter a max. Okay. So, what is our maximum number going to be? Let's go from 1 to 10. My first guess will be 5, 7, 9, 10. Oh, it happened to be 10, and it ends. All right. So that seems to be working. The next thing I want to do is, well, there's really a couple things. Let's keep track of the number of attempts that it takes you, the number of guesses. So let's create a variable. Let's just call it attempts. And it starts at 1 because that's the bare minimum, right? You've already made one guess. We'll start it at 1. And then every time you make it in this loop, we just add 1. We could do plus equals 1 or just plus plus, because the fact that you've made it into this loop means that you're guessing again. And then at the end, we can do you got it. Let's do a string template literal. So we'll say like, you know, it took you 5 guesses or 10 guesses. You got it. It took you. And then $ attempts. And we're not going to pluralize correctly, so I'll just say guesses. We'll assume it took you more than 1, but there's a chance you get it right on the first time, and it will say it took you 1 guesses. It should be 1 guess. So let's see if that works. So my first guess, 5. Too low. First guess, 5 again. Too low, 10. Too high, 8. Too high, 7. 6. Okay. 5 guesses. Awesome. Now the last thing I want to add in here is the ability to quit early, because I could enter in a very large number like 1,000 or 10,000, and I could be here for a while trying to end this game. So to make that work, all that we'll do is check to see if your prompt at any point is equal to Q or quits or something like that. So if guess equals Q, how do we get out of this loop? We can break. But there's a problem with this approach as it stands. Guess is never going to be Q because I'm parsing int as soon as we get your prompt. So even if you enter Q, I parse int, we get not a number. Now, there is a way around this, which is that we just don't parse int right away. We'll save your input, the result of prompt, as a string, and then when I compare the guess to target number, I can parse int then. This is just one approach at least. So if I enter Q, that's fine. It will stay in our variable guess, and then we can parse int here, but we're not actually changing the variable guess. We're just parsing it, see what it looks like, compare it to target num, but if it happens to be Q, it still stays Q in the variable itself. So let's verify that. I'll enter in a large number, 100. I don't want to deal with this. So I'm going to type Q, and I get out of there. Technically, yeah, it's going to tell me you got it. It took you 3 guesses. We could add a little conditional at the end. We could do something like if guess equals Q down here. We can console.log okay, quitting, or okay, you quit, or something. Otherwise, we'll display congratulations, you know, this sort of thing. Maybe 2 console.logs. Console.log, congrats, you win. Okay, So we're just checking to see what guess is equal to after this entire loop finishes. Let's try one more. So let's go to 40 maybe. My first guess is 20. Too high. How about 10? Too high. 1. Too low. 5. Congrats, you win. You got it. It took you 4 guesses. Now let's do the same thing. 1 to 100. My first guess is 50. Too low. Let's just enter 2. Well, that makes no sense. But let's quit. Okay, you quit. And we're all done. So this combines a lot of what we've learned so far. Conditionals, a while loop, another while loop up top to make sure we're getting valid inputs, as well as the break keyword. So that's our simple guessing game. Next up, a brand new loop we haven't seen, the for of. So for of is newer in JavaScript. It's not just new to us in this course, but it's also newer in JavaScript. And unfortunately, that means that it is not supported in Internet Explorer. But that should not stop you from using it. At least it should not stop you from learning it, because it is a lot better. It's a significant improvement for iterating over arrays and other iterable. So we'll get into what that means. Here I have an array of different subreddits on Reddit. It's just a bunch of strings, doesn't really matter. Now if I wanted to print each one out with what we know, I could do a for loop. For let I equals 0, I is less than subreddits.length, and then I++. And then let's do, maybe I'll print out a string. So we'll do console.log, and that string will be a template literal that will say, visit reddit.com/r/ and then the subreddit name goes right in here. So $ curly braces, and then I want to put cringe or books or chickens right in there. So I need to access subreddits square bracket I, right? Inside of those curly braces, that should do it for me. Let's see, refresh the page, open up the console, and it does work. Now, that's kind of a lot of, it's not a huge amount of work, but it's kind of a lot of like weird syntax just to iterate over an array, right? We've got to work with I. So that does work. It's just not as clean as the for of loop, which we'll take a look at right now. It looks like this. For, and then in parentheses, some variable name that we come up with, of, the actual word of, some iterable thing. So to start, that iterable thing will be an array. So I could rewrite this like this, for, let, and then I need to come up with a variable name, and it's actually going to represent the individual elements in my array. So for let, let's go with sub of subreddits, just like that. Now this is a significant difference. I'm making a variable here called sub, and if I just console.log that sub, let's just make sure that works. There we go. It's actually representing, it's storing each element in the array. We don't have to worry about I, the index, because right here we're just making this I variable, the index, for the sole purpose of accessing individual elements out of the array. We're never using I to do any math, or we don't really care about what I is, except for the fact that it helps us get out each element. But here, this is shorter, but it's also a lot easier to read. Let sub of subreddits. I can come up with, I could name this subreddit, I could name this anything. This is just a variable that will exist each time through the loop, and it will store, at the first time through, cringe, and then books, and then chickens, and then funny. So if I wanted to just match what we have here, I would just add sub right there. Or if I name this subreddit, make sure I have 2 Ds in there, subreddit, just like that. I just need to match what I have, and there we go. We get the same outcome, but this is a lot nicer in my opinion. For of is certainly an improvement over regular for loops. Not in every situation, but for situations where you're iterating over something like an array, and you don't need the index, you don't care about it. If you do need the index, and sometimes there are situations where you need that index, it can be better to use a for loop. So here's an example, though, where I'm using 2 for loops, nested. I and j are the 2 variable names I came up with. Very standard, very boring, and honestly not very easy to read. If I rewrote this using for of loops, all that I'm doing is looping over the seating chart where we have 3 different rows. I'm looping over into each row and then over each student and printing them out. Nothing very exciting. But I could rewrite it like this: for let row of seating chart, just like that. And then inside of here, for let student of row, and then console.log student. So a lot easier to read, because I can actually write a variable that corresponds to the individual element, not a variable that corresponds to an index or just a number that I then have to plug into the array. Here I don't have to plug anything into the array. Row references each element in the parent in the first array, and then for let student of that row array, student references this, and then this, and then this. And I think overall that's pretty easy and just way better to look at, way better to write. It's a far better experience. We can verify that it does give us the same outcome, and it does. So here's the first batch all the way down to Erica, and then here's the second batch, exactly the same outcome. So for of loops, massive improvement. Now let's revisit what I said about iterable objects right here. Oh, here we go. A nice and easy way of iterating over arrays or other iterable objects. So there are other things that we can use a for of loop with. I'll show you another example, which is a string. For let's do char for character of, and then I don't know I guess hello world. It's not very exciting, but we can do that. Console.log char, sure, just like that. And there we go, HELLO space blah, 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 blah. Each character is being iterated over. So char is going to be H, and then it will be E, and then L, and then L. So that's just one example of iterating over something that is not an array. Now there are other iterable objects. If you go to MDN, you take a look at the page for of. There are things like maps and sets, which we have not yet talked about. One thing that I see a lot of students attempt to do is work with objects in for of, and that's actually the subject of the next video, so I'm not going to get ahead of myself. But long story short, most commonly for of is used with arrays. You can use it with other things that are considered iterables by JavaScript, like strings. That's really all we know so far. And the syntax is super nice, compact, for some variable of some iterable, do something, usually using that variable. Cool. Okay, so we just talked about for of and how it works with any iterable object in JavaScript. And that might make it seem like we can use it to iterate over an actual object, an object literal. But unfortunately, objects, actual object literals with curly braces, like this one right here, right, key value pairs, they are not considered iterables. Yes, they are objects, but they are not iterable objects. An array, behind the scenes, is technically an object. A string actually is an object too. Lots of other things like maps and sets, which we have not yet covered. Those are considered objects behind the scenes. So long story short, the term object is a bit of a confusing one in JavaScript. But when we're talking about an actual object literal with our curly braces, key value pairs, if we want to iterate over them, this is not going to cut it. For let's just go with person of test scores. You'll see what I get here, console.log person. This is exactly what we just saw in the last video. I've got this test scores object. I just have students' names and then their score on the test. If I refresh and I look at my code, uncaught error, test scores is not iterable. So we do have an option to iterate over an object. There is a loop that's been around for a very long time in JavaScript, which is the for in loop. It's kind of confusing, right? To have for of and then also for in. Just know that for of is used all the time. For in is pretty uncommon these days. But for in is going to iterate over an object. Now, what does it iterate over? There's two pieces of information. It's just going to give us the key. So if I take a look at this now and I refresh, we get Keenan, Damon, Kim all the way down. So it's just giving us the key in the object. If I want the value, well, I already have the key. I can get the value out. So I can do something like this. Let's do a string template literal. And let's have the person's name. So we'll do person, scored, and then the value, which would be test scores, right? Square brackets, person. Okay? Let's see what happens now. Refresh. Keenan scored 80, Damon scored 67. All that, all the way down. So key and then value. So that's one option. Another option, if you did need to iterate over an object, is to use special methods that we have not yet seen. These are new. There's a method capital O object dot keys, and then you pass in an object like test scores. And this gives us an array, an actual array made up of the keys from the object test scores. And there's also a values So we get the values out of that object. And there's also one called entries. And this gives us a nested array of key value pairs. So these all are object, capital O object dot keys, values, and entries. So they just give us an array. So if I needed to iterate over the keys, for example, I could just turn it into an array. Well, I'm not turning it into an array, but make an array from those keys and then use a for of, because that does work over arrays. Now, if I just needed the keys, I could also just do what we saw here. But let's say I was interested in the values and I wanted to sum up all of these values, so all of the scores, and average them maybe. Well, I could do this, for let score of, and then I can do object dot values test scores. I can do that once again because this will give me an array, as we saw here. Object dot values, you give it an object inside, it returns to you an array of that object's values. So now I can iterate over that with a for of. Let's just do console.log score first. Refresh. And there we go. We're getting all of our scores. Now, let's sum them up. So I'm going to make a variable here. Let total equal 0. And then we'll add to total plus equals score inside of our loop. So each time through, we'll add 80 and then 67 all the way down to 60. Let's see what we end up with for total. 797. So to average, now I just want to take the length of my object.values test scores. I just want to know how many items are in this object. Now, unfortunately, objects actually don't have a length. So if I do test scores.length, it's not going to work for me. It's not an array or a string or something with a length. So what I'll do though, if I have this array that has all the values, right? Every value is in this array. I could just take the length of that. So if I wanted to, I could just do let scores equal that for let score of scores. Then at the very end, I can console.log the average, which is our total divided by scores.length. Scores is the array of scores, right? It looks like this, where it's just whatever the scores are. I already forgot the order, but whatever that is. And then we're just taking our total that we summed up thanks to our loop and then dividing by the total length of that array called scores. And the average is 79.7. All right, so that's kind of all I wanted to show you. Iterating over objects is not as common, nowhere near as common as iterating over arrays, but we do have a couple of options. We can use a for in, and that will give us the key, but we can use each key to access the value. Or I can use special object methods, capital O object, .values, .keys, .entries, to create new arrays that are based upon the keys or the values from some object that we pass in. And then I can use a regular old for of with that because I'm working with an array. Welcome back, everyone. Next up, we're going to build, I don't want to say an app. It's a very simple little demo that combines a lot of what we've learned so far. So variables, working with loops, arrays, and different array methods, and some conditional logic as well. We're going to build a very simple to-do list that is all command line based. So we still don't have any of the tools to actually make a to-do list, with our mouse and buttons and forms and all of that. But I'm just displaying here the commands just in case you forget them. I've listed them here in an HTML page, and then I included, a single script, todos.js. Now, let me just show you how it will work. So I'm going to refresh the page. Everything is done via prompt, that method that asks a user to enter something in. It's really obnoxious, right? This isn't all that usable. Although I do see real people who use command line based to-do apps. So they're all based in the terminal, not the JavaScript console. And they're all just text-based, and they might seem really unusable to the majority of people, but some people actually use something like this, just not based in the browser. Anyway, here's how it works. I can specify, a command. Am I adding a to-do? Let's start there. So I type new, and I'll hit enter. Then it says enter new to-do. So let's do something like, how about collect eggs from my chickens? Okay, and then it tells me collect eggs added to the list. Now I can specify something else. Let's just add one more. How about feed chickens? And then I'll type list, which is another command, and it prints me out the list somewhat in a okay looking format. We've got the stars up here just to separate things out, and then it shows me the index and then the actual to-do. Now that index, that number there is important because if I want to delete a to-do, which I'll do now, I'll type delete, it's going to ask me to enter the index of the to-do I want to delete. So I will delete index of 0 by new turtle. It says to-do removed, so let's list again, and you can see it's gone. Now we just have those two. And then I can also type quit to get out of here. Before I do that, if I type anything else, nothing happens. So you could add on a feature that says, I don't recognize that, or I can't do that. Please try again. But for the simple MVP, just keep asking, what would you like to do? And then as soon as I type quit, we're done. And you can see it prints out down here. So if you want to try and build this on your own, I highly recommend at least trying to. I can give you some tips up front. The first one is that we're going to have a loop, right? And this is going to be a while loop. I just refreshed the page. Basically, you're going to ask for some input, and while the result of that input, whatever the user types, while it's not equal to quit, you just keep looping. Now, I highly recommend you make sure you get the quit part to work before you implement anything else, because you don't want to deal with infinite loops, as we've already discussed. So that's going to be one important piece, just looping while a user has not entered quit. And remember, the specific function we need is prompt. That's how we ask for an input like this. Next up, the actual storage of the to-dos will be done using an array, or at least that's how I recommend you do it, right? It's in a collection of pieces of data, a collection of strings. It makes sense to use an array. So basically, we'll have an empty array at the beginning, give it some variable name, to-dos probably, or to-do list. And then if a user enters the input that they would like to add, or I guess new is what I said, if they enter new, then we prompt them again. So there will be a conditional inside the loop. If command equals new, or if input equals new, then ask them again, or ask them a new thing. What is the to-do text? So whatever I put in here, walk dog, if I can spell that, then we take that and we'll just add it on right there, right? Walk dog. And then same thing, if I enter another to-do, we just add it on to the end of the list and keep going. If I ask to list all of the to-dos, what will you do? Well, I have caps lock on. You will iterate over all of the to-dos and print them out. And remember, we want that index there so that I can delete. Now, delete might be the trickiest piece. If you don't remember how we can remove something from an array, if we have the index, the easiest option is to use the splice method. So that's all I'll say up front. If you want to tackle this on your own, I definitely recommend trying it instead of just watching me build it in the next video, because this is really the first time we have multiple pieces coming together, arrays, loops, both two different types of loops potentially, a for loop and a while loop. We also have conditional logic in there. So I recommend you attempt it, but I don't expect everyone to be able to get this if you're brand new to programming. So that's why I'm going to go through it step by step in the next video. Also remember, this is useless and not at all an attractive product for anyone to use, but we've got to start somewhere. Okay, so let's go ahead and make our files before we can begin. I've made the basic HTML file. Nothing crazy. We've got, our basic boilerplate, and then some text, or an H1 rather, and then a UL that just explains the commands. Again, not necessary, but just a reminder to us, and I guess hypothetical users that probably will never exist, of how the app works. So I've got that done. Now I'm going to make a file. I'll call this maybe todos.js, and I'll include a script. And I'm going to do source equals todos.js. Okay, there we are. So this should include my script. Let's make sure it works. If I put maybe an alert in here, I always just like to, test out that connection. So now I'm going to head over to my browser. I have the file open. I'm just going to refresh, and we get the alerts. Okay, good news. So now we basically need to implement everything. So why don't we start with a basic game loop, if you will, this while loop that continues to ask over and over and over, just to jog your memory, right? This is the solution. What would you like to do? It's just going to keep asking me. Let's just keep entering gibberish. And then the one thing it knows is quit. So if I enter quit, if that's the case, we print out you quit the app and we stop bothering you. We stop asking. So to do that, basically we'll want some form of a while loop, right? And while something, is not equal to quit. Now, what is that something going to be? Well, let's start by asking a user to enter, let's prompt them. What would you like to do? And then save that to a variable. And I'm going to use let, not const, because I will be updating this variable. So let, what should we, maybe just input? And then here we'll say while input is not equal to quit, we will just continuously ask you. So I'm going to say, input equals prompt. What would you like to do? So in other words, at the very beginning, ask one time, what would they like to do? Now, if they happen to type quit as the first thing, then we're just done. But if they enter anything else, ask them again and again and again and again. And then at the end, let's do something like, okay, quit the app or something. I don't remember what we actually printed out over here. What was it? You quit the app. All right, close enough. So let's see what happens. What would you like to do? Just typing anything. But as soon as I type quit, hopefully, should open the console. There we are. We see quit the app. Okay, next up, let's quickly check to see if input is, basically we want to quit if you type the letter Q. So how would I do that? Well, with what we have right here, while input is not equal to quit, the string, I could add on another condition, but what would it be? Basically, I want to keep running this code while you have not entered quit and you have not entered Q. So that can be confusing because we're doing a while loop with not equality, right? This loop runs as long as you don't enter this. Some people might think, oh, we want or, while your input is not quit or your input is not Q, but that's not the case. We only want this loop to run. This is the, continuing to bother you and ask you questions. We want to keep asking you questions as long as your previous input was not quit and it was also not Q. If it was either one, then we're done. So I'm going to do and input is not equal to Q. Okay, so let's see if that works. Refresh the page. Let's type Q and we're done. Try it one more time. I type quit. Oh boy. This is what happens when I have a mic in my face and I can't see the keyboard. There we go. Okay, quit the app. So next up, let's implement the adding a to-do and listing a to-do feature. So first, we need a place to store the to-dos. And I'm going to make a to-dos list, specifically an array. So I'm going to use const, as we've talked about. It's most common with arrays. So const to-dos equals empty array. Or to help us out, let's just put something in there to begin with. How about collect eggs? And let's just do one more. Collect chicken eggs and, how about clean cat litter box? So just litter box. Put whatever you want in here, obviously. Okay, so now that we have two to-dos in there, why don't we focus on listing the to-dos? And remember how this is supposed to work. We list the to-dos. If I just list the default, we have this console.log, that's easy. But then we also have the index that we're printing out because we use that when we delete something. So it's nice to show the user that index. So let's implement list. Let's add some logic in here so that when a user types list as their input, so that would be in the loop, instead of just asking them, what would you like to do? First, we're going to check, well, what if their input was exactly equal to list? Also, you know what, this is sort of a silly thing to point out, but I'm realizing I'm being sloppy with mixing double and single quotes. Personally, I like to use single quotes, or at least I need to be consistent. I don't have to, but style-wise, I like it. So I'm just going to quickly change that. Okay, so where was I? Yes, if the input that a user types is equal to the string list, what do we want to do? Well, why don't we just start by recognizing it? Console.logging, maybe just the stars to begin with. So just a list of stars, a string of asterisks, just like that. So let's just make sure we can see that if I do type list. So I'll type something that's not list. I'll type list. Okay. And then I'll quit. So now what we actually want to do is print out each to-do from the to-dos array. but I also want the index. So a for of loop, unfortunately, is not going to work for me. What I'm going to use instead is a for loop, a regular old for loop. So how do we loop over the array? For, I'll use I, starting at index 0, while it's less than todos.length, add one more to I each time. So we start at index 0, and then we keep looping, incrementing I until we hit the highest index in the array, and we stop before we hit the length of the array, because remember, this array is a length of 2, but the highest index is 1, 0, 1. Okay, so then we'll print out a string, and the easiest option, I think, is a string template literal. So we'll show I, and then a colon, and then the actual to-do. Well, how do I get the to-do? I use the index, to-dos, square bracket, I. Just a quick note, later on we'll see another option for how we could achieve this, where we want the to-do itself, the string, and the index. There's a method built into arrays called for each. So if you know about that, that is one option, but I'm not going to show it now. But we'll get to it, and you'll see what I'm talking about in a couple of sections. Okay, so let's see what happens now. Does it actually work how it's supposed to? Let's do list. Looks good to me. And then quit. So now let's implement new. So I can make a new to-do. We'll just add in another conditional, a check. We'll do an else if input is equal to new. Just like that. What we're going to do is prompt the user again, and this time ask them for their new to-do. So I'll use const because we're only going to ask them one time, right? The reason I used let here for input is that we're reassigning input over and over and over. So I'll use const. So const new to do probably is what I would call this, or new text or something. Yeah, new to do equals prompt. And we'll do something like, okay, what is the new to do? And then we'll take that result, which will be a string, and we'll just add that on to the to-dos array. Now, how do we do that? We use push. That's one option. To-dos.push new to-do. And then I like to provide some basic feedback. So let's do a simple console.log. On the solution, if I type new, I enter new to-do. Okay, it says blah, blah, blah added to list. So let's do that. Let's print that out. String template literal. New to-do. Added to the list, just like that. Okay, let's see if it works. I'll refresh the page. Let's do a new. Okay, what is the new to do? How about walk the dog? Walk the dog added to the list. Now let's actually type list. And there it is. Okay, let's do one more. Walk the cats. Show them all with list. Walk the cats is there. Okay, so now all we have left is delete. So we'll just do another else if input equals delete. Now, this is the most annoying one to do because, first of all, we need to ask, what are you trying to delete? So we'll use prompt. We'll call this index prompt. Okay, what is the index, or enter an index? Enter an index to delete. Great, let's just make sure we see that. And then I'm going to console.log the index. Okay, so I'll refresh the page. Let me quit, refresh. Let's list, and then let's do a delete. Make sure we see, okay, we do. Enter an index to delete. If I enter 1, okay, it looks good. Looks like that's working for us. We see 1 here. So now we need to take that index and somehow remove the element at that index. How do we do that? Well, we use the splice method. That's one option. So just to recap splice, let me get out of here. If I have an array, like what we have to-dos, if I do a splice, it works to remove a section of an array. So if I do something like splice, from index of, well, let me add on to to-dos a bit. To-dos, or maybe I'll just do numbers. Const nums equals 1, 2, 3, 4, 5. If I do nums.splice, then I specify a starting index, like index of 2, how about? And then a number to delete. Let's say I want to delete 1. What happens? Well, let's look at nums. I just deleted element 3, which is index of 2. It's kind of confusing, right? But 0, 1, 2. And I just deleted 1 item. So that's basically what we want to do. But this, the initial index that we're starting to delete at, it's not going to be 2, at least not every time hard-coded. It's going to be whatever the user enters. So we're going to splice, do it right here, todos dot splice from the user's index and only for 1 element. Now, we are trusting that the user enters a valid index, right? Which is fine at this point. We haven't talked about, handling errors, because potentially there could be an error, especially if the user enters something that's not a number. We'll just trust that a user can do it. And then let's console.log something different instead. This will actually give us the result that comes back, right? Inside of an array. If you recall, you can see right here when I call splice, it gave me back this array with the element that was deleted. So if I wanted to, I could save that deleted stuff, or just deleted, equals todos.splice. Okay. And then I'll console.log something like, okay, deleted. And then we could actually add in the thing that was just deleted. Now that's an array. So I'll do index of 0. Now you don't have to do this, right? This is above and beyond, but let me just demonstrate it first. So let me add something new. Let's not do something dumb. How about cook dinner? List. Okay, index of 2. Let's try deleting it. Or let's actually do clean litter box, index of 1. So I'm going to enter 1. It says, okay, deleted clean litter box. Now let's list. And it actually was removed. We can see here, the array has now shrunk. Just to recap what's happening here, right? We're asking for an index. Now, again, a user could enter something that is invalid. Let's see what happens there. Let's try and delete with a string index. And, oh, look at that. Deleted collect chicken eggs. So here's what's going on. Just as a demo, I've got an array of strings. And if we, splice from index of 1 to 1, right, we remove B. But if I have a string in here, well, first of all, if it's a string containing a number, it will, try and convert it to a number. And so that still works. But if it's a string like this, it just defaults to 0, index of 0. So that could be problematic. If we want to, I guess I can show this. We can add an extra step in here where we can attempt to turn this string, it's always a string from prompt, turn that into a number with parse int. Like this. Parse int of index. Now, honestly, I'm embarrassed. I can't remember if we've covered it yet or not. If not, parse int, again, it takes a string and it returns, if I can just get out of here, parse int, like that, a string, like 23, it gives us the actual number 23. But if we do something like that, we'll get not a number. Okay, so basically what we want to do now is check if we got not a number, we're not going to try and delete something. That means you entered a string, or, well, they always entered a string, but you entered letters or something that does not contain a valid integer. So unfortunately, checking to see if something's not a number is actually kind of complicated. It's not hard, but we just haven't talked about it. But there's a method called number dot, is not a number. And then if we pass something in, like a number like this, we actually get false. But if I pass in not a number, we get true. So again, it's kind of weird. But what we can do is check to see when you parse that int on that index. So let's call that, const. Let's go with, this will be, how about string? What should we call this? Index string str. And then this will be const index equals parse int of that index string. So we'll get the string version from a user. You know what? Actually, what I would probably rather do, I'm sorry for being a bit scatterbrained here, is just do it in one go. Ask them and then immediately parse int on their input. All right, so now we have index, and we're just going to check if number dot is not a number of index. So if it is not a number, I think I'll actually reverse it or negate it and just put this code inside. So if the index that you entered when we converted it to an actual number, if we did not get not a number, meaning it's valid, we will try and delete from your to-do. Otherwise, I'll do something like maybe unknown index, and we'll just leave it at that. Okay, so a bit of a tangent, more complicated than I wanted to make it. But now, hopefully, if a user enters an invalid index, let's see actually if it works, of course. So let's add a new to-do, blah, blah. Here's another new one, boo, boo, and then list them. And let's delete blah, blah, index of 2. So delete, and then 2. Okay, let's list them, and it's gone. But now if I try and delete something like this, unknown index. Great, and hopefully it didn't delete anything. Well, I just typed delete again. I meant to type list. Let's do another invalid index. How about, something else you could do is add a check-in to make sure the index was a valid index in the array. Because what happens if I enter, 88? Deleted undefined. So we didn't actually delete anything. So that's something you could consider adding in. But for the sake of time, I'm just going to stop here. Let's get out of this. Whoops, Q. There we are. We quit the app and we are done. All right, so this is definitely the longest thing we've really written so far. Still not that impressive, I know, but it's a lot of pieces, especially once we talked about, parsing ints and, working with arrays and splice and string template literals and conditionals and a for loop and a while loop. There's a lot going on here. So whether you got this on your own or a small part of it on your own, or you just followed along with me, either way, it's definitely an accomplishment in this course. The one thing I would recommend is making sure that you can walk through this code and explain, what's going on here. What does this mean? Why is there an and? Why 2 not equals? What's going on here? What's I? What's the square brackets, to-do's I? What's splice doing? Anyway, congrats. We've made it through a decent chunk of JavaScript, but as you probably have noticed, we've got an even decenter chunk to go. All right, I'll shut up. Welcome back. It's a new section once again, and we've got another one of these videos where I walk you through what's important and what's not important. So, spoiler alert, everything in this section is important. We're talking about JavaScript functions. It's more than important. It's crucial, critical. You've got to understand this to really understand JavaScript. Now, that might sound like a bit of an intimidating preamble there, that you have to understand this in order to move on. That does not mean you need to master everything right now. It just means to be a master of JavaScript, you have to have mastery over functions. Functions are really the one thing in JavaScript that you use the most, that sort of JavaScript is structured around, which will make sense as we continue on in the course. You'll see once we get to things like Express and Mongoose, and we talk about callbacks and asynchronous functions. Functions are everywhere, and they're just very, very important to JavaScript. Anyway, in this section, we're just introducing the very basics of functions, so nothing terribly complicated. Everything in here is going to go into the crucial column. Working with arguments, defining basic functions, that should come first, returning values from a function. Basically, we'll learn how to define our own reusable pieces of code, like what we do with a string method or array.pop. We'll learn how to define our own similar versions, our own named processes that we can execute. But anyway, I'm not supposed to teach in this video. I'm just supposed to set your expectations. Now, there is one red block here. At the end of this section, after learning about functions and watching some videos, I'm going to give you lots of opportunities to practice. And usually I don't put the exercises on their own card, but this is probably the most important, or one of the most important chunks of exercises of practice opportunities. Please, I highly recommend you go through all of the exercises. As I mentioned, working with functions is super important, so I want you to get a lot of practice before you move on. This is one of those moments where if you just go through the videos and then immediately jump to the next section and keep going, you could kind of just blow through this topic and not take the adequate time required to fully let it soak in and to really understand it. So in person, I would prescribe a problem set that would take the rest of your, let's say, this is right after lunch, teach functions, and then you have a problem set for the rest of the day. And then tomorrow, we would move on to the next topic. So anyway, take your time, please do the exercises. Functions are incredibly useful, and they're just a key part of JavaScript. So here we go. All right, next up, JavaScript functions. The last of the big topics in JavaScript we have remaining, at least the big fundamental topics. So there are lots of other things we need to cover, smaller pieces of JavaScript, more advanced things, but functions are right up there with stuff like arrays and conditionals and variables. We will use functions all the time from here on out. So what are they? Why don't we start there? Functions are just reusable chunks of code that we've wrapped up and given a name so that I can use them at any point. So these are super useful for reducing the duplication in our code and just making our code easier to look at, not just to look at, but easier to understand. And we use them a lot. I'm talking a lot, all the time. Every single thing, like I've mentioned from here on out, you're bound to, almost guaranteed to use functions in your code. So here's a situation where we would benefit from a function. We've seen this a lot, right? Generating a random integer. Unfortunately, in JavaScript, we get math.random. That gives us a decimal from 0 to 1. So then we usually multiply it, and then we often floor it to get an integer, and we shift it. In this case, I'm trying to get a die roll from 1 to 6. So let's say, I save that to a variable, die1. That's not bad. I need to run this code, right? I don't have an option. That's it. This gives me a random number from 1 to 6, hopefully. Let's take a look. Die1 is 1. I'm refreshing. Now it's 5. Now it's 6. Okay. But let's say I'm making a game where I need 6 random dice. So I don't need it just once, but I actually need 6 more of these. Well, I would have to write this line every single time, right? And this isn't that bad. This is a pretty short line of code compared to some of the things that we'll encounter, but it's a simple example. So then I would need, die 2, die 3, die 4, die 5, and die 6. And this will work, or it should work. Let's take a look. Let's look at die 1. We got 4, die 2 is 6, and so on. All right, so that's working. But it would be much nicer, in my opinion, if we could do something just like, instead of having to do all of that, just roll die. And then duplicate that a bunch of times. Anytime I needed a new number from 1 to 6, I could just call roll die, assume that these were 2 and 3 and so on. So we'll be able to do that shortly once we learn how to write functions and we talk about return values. But there's actually another level that we could take this to. If roll die gives us a random number from 1 to 6, maybe there's another part in our game where we use, let's say this is like a Dungeons and Dragons sort of clone, or I don't know if you could clone that, but let's say it's a role-playing game where you actually have like a 12-sided die at some point, and you have some 6-sided dice, and it's been a long time since I played D&D, but whatever, there's different sizes of the dice that you use. So we could even make this a fancier roll die that actually is going to accept a number of sides. So here we could roll a 20-sided die, and this is rolling a 6-sided die. And this could be rolling another 20, and here's a 12. So we could make a function that does exactly that. It actually accepts an input. It allows us to modify its behavior. So that's our real end goal, is to make functions that are just nice, reusable chunks of code, but also write these functions in a way that they're sort of modular or reusable, where we can pass in some sort of input that will impact the output that we get out. And again, roll die is a simple function, relatively. But there are so many things that you'll see later on in the course where writing functions might save us not just one line at a time, but maybe 20 plus lines or 40 or 50 or 1,000 lines for some of these nasty functions that actually call other functions, which call other functions. I'm getting ahead of myself, but we'll get there soon. But let's start with the basics, of course. In the next video, we'll tackle writing our first silly function. Okay, so let's learn how we actually write these functions and use them. It's a two-step process. We need to first define the function, sort of like registering it, telling JavaScript about it. And then later, after the fact, at any point, we can execute that function, or we can run it. We might run it once, we might run it 1,000 times. So we have to register it as a thing. Hello, JavaScript, here's my function called roll die, but that won't actually run it. The code in that function won't be executed until I run it later on. So let's start with step 1, defining a function. There are actually multiple ways of doing this, but here is one of the most common, the easiest to start with. Function, the actual keyword function, and then a space, and then the name of our function we're registering or defining, and then parentheses, and then curly braces, and then we put our code inside those curly braces. Whatever code is in those curly braces will not run right away. It will only run when we execute our function, which we do later on. So let's define our first very simple function. Here's a demo of a silly one. It's called grumpus. It just console.logs 3 times. Ugh, you again for the last time. Leave me alone. Maybe it's, oh, you again for the last time.
Leave me alone.
Anyway, it's a simple function. Yes, not very useful. Just prints these 3 lines again. But let's try defining our own simple function. So we could define how about just a function called sing. Sure, sing. Remember, function, that keyword. Notice it's purple here, right? Just like let something. The keyword let is purple, keyword function. And then a space. And then our function name. Now, if this is multiple words, like sing song, it needs to be, that's a complete lie. It does not need to be camel cased, but conventionally it's camel cased, just like with a variable name. The first letter is lowercase, and then the first letter of every subsequent word is uppercased. So sing song or sing song loudly or something like that. You should always try and come up with descriptive names for your functions, of course, and then our parentheses, and then opening and closing curly braces. And then inside of these curly braces, we put our code, whatever code is in here, whether it's 1 line or 1,000 lines. That's the code that will be executed when our function is actually run. So let's do something simple like console.log do re mi. How do you spell re in do re mi? I think it's me like that, do re. Yeah, I looked it up. It's just re. All right, so do re mi. Let's just start there. 3 console.logs, nothing crazy. If I head over here and I refresh, we won't see anything printed out, right? Just by putting the code inside of those function curly braces, JavaScript ignores it for the moment. It doesn't actually execute it. If I had those 3 lines down here, of course, they would run. So important to understand that. When we register our function, when we define it, it does not run. So if I hop over here again, we will have this thing called sing song. If I type that identifier, JavaScript tells me, yeah, I know about that. Much in the same way it does when I just type alert without the parentheses. It tells me, yep, that's a thing. It says native code, right? It's built into the browser. It comes with JavaScript. Unlike this is one that I actually wrote, but it's the same idea. It has that little F to indicate this is a function. I know that function. Versus if I just type something that it doesn't know about, I get an error. So we have successfully told JavaScript about our function. Now we need to execute it or run it, step 2. So we've seen this before. We just write the name of the function. It has to match exactly, of course, and then parentheses, opening and closing immediately afterwards. This will execute that function. So sing song, like that, parentheses, and that will execute it. There we go. Do, re, mi, our 3 console.logs. Every time I call sing song with parentheses, we get do, re, mi. I can do it in here. Let's sing, 10 plus times. Refresh the page. There we go. It runs 10 plus times. We get 30-ish console.logs of do, re, and mi. So it's the same exact principle we've seen before. If we want to call anything console.log, right, I have to add on those parentheses at the end. Console.log without them, we just get, yep, that's a function. I know that. I'm JavaScript. I know it. But if we add those parentheses, then it's actually going to execute it. We just didn't pass in anything, but if I did, it prints that out. Same thing with alerts. That doesn't mean much. It's just JavaScript echoing back to us. Yeah, I know that. But I add something in here. Inside parentheses, it actually alerts me. So this process, that 2-step process is critical. We define the function, and then we execute it afterwards. Now, in general, you should only attempt to call your function after it's been defined. However, you'll see that if I tried to call it beforehand, for some weird reason, I don't have any issues with that. You would think there'd be an error, right? It's like if I defined a variable after I tried to use it. This is a wonky sort of, I won't even call it a feature, a wonky part of JavaScript. We will learn more about it, but if you really want to get ahead of yourselves, you can look up something called hoisting. But just because this does work does not mean that you should do this. You should always, at least for now, define your functions before you use them. And there are other syntaxes we'll see for defining a function where what I just showed you would break everything. But honestly, I kind of regret even mentioning it because we're so new to functions. I just want you to get in the habit of defining your functions first before you actually use them. Anyway, that's our first attempt at writing functions, or a function. We've got a lot more to cover, so that's all coming up next. All right, so next up, we get to talk about arguments. So arguments in JavaScript is basically a fancy way of saying inputs to a function. And currently, our very simple functions do not accept any inputs. They don't do anything with inputs. They behave the exact same way every time. Sing song, it just sings a song. It doesn't even sing a song. It just does do, re, mi, right? It's kind of a bleak function, a simplistic and tuneless song, do, re, mi. So there's no input that we would pass in. It's just the exact same thing every time. Here's our grumpus function from earlier, right? It just prints out, ugh, you again for the last time. Leave me alone. I like to diagram and imagine functions as a little machine where we call it. We pass nothing in this case. There's no inputs to our grumpus machine, but we get out these angry console.logs. Or here's another example. We could write a function called greet, be nice and simple. And this greet function greet, accepts nothing. It doesn't really do anything except it console.logs hi. Okay? I'm going to just comment out all of our sing songs here. And if we were to execute greet, I refresh the page, we get hi. Every time I call greet, it's exactly the same thing. But what I'd like to do, a lot of the time at least, is write functions that accept inputs. So I could do something like greet Tim, greet Anya, and we get a different output from our machine. Hi Tim, hi Anya. So nothing revolutionary, but that input does impact what we get out. Or if you go back to that example I talked about, the roll die function, if I could specify I want to roll a single die. Jeez, keeps tripping me up. A single die that's 6-sided or 20-sided or 12-sided, that would be an input, and that would have a pretty significant impact on what we get out. So again, this term arguments refers to the actual value right here. This is an argument, Tim. Anya is an argument. Or here's another example of a function. This is one we could write called average, and we can pass in multiple arguments. And it should give us as its output, the average of those values. So 20 and 25, we get 22.5. 3, 2, 5, and 6, the average of that is 4. Assuming that I didn't screw up my math here when I was making these slides. So the concept here, again, arguments, is nothing actually new to us. We've been working with arguments. We've passed arguments in to built-in methods, things like index of, right? That is an argument right here. What we're looking for in this case is the letter H. What is the index of H in hello? What is the index of O in hello? Index of. There's so many things we've done, like, some array. Let's do 1, 2, 3, dot push 4. Oh my goodness, can't even get the syntax correct, right? We just pushed on 4. Or 4, 5, 6. Technically, we can't actually see it because I didn't save it to a variable, but we've seen this before, where we have things like that, nums.push 5, 6, 7. All of those values have now been pushed on to an array, nums. That is an example of passing inputs to a function. In this case, it's not one we wrote, it's just push. Console.log, right? We use that all the time. When I console.log something, that is an argument I'm passing in to the method called console.log. And we'll learn more about the distinction between methods and functions. All you need to know is that every method is a function. So console.log or string or array.push or string.indexOf, those are methods, but they're also functions. Don't get tripped up on it for now. Focus on this concept of arguments. They are inputs we pass in. So how do we do this? How do we define our own arguments? Well, inside of our function definition, inside of the parentheses, we add in some variable name. It's actually something we call a parameter. And we can give it any name we want, but it should be something, first of all, that is allowed in JavaScript. So don't do function or if or let. But it should also mean something. So generally, I would avoid something like X or Y or Z. Sometimes there are situations where that makes sense. Like if you're just adding two numbers, X and Y, I guess it's okay. But whatever we put in here, it is just going to hold the value of an argument that is passed to our function. So in this case, greet accepts a person or a name or whatever we want to call this right here. That has to be passed in when you execute greet. So if we call greet Arya, person will be Arya. If we call greet Ned, person will be Ned. So let's try that. Let's define greet so it accepts a first name. So this still has no meaning to anything outside of this function. First name does not exist down here. It only exists in this function. I could start by just doing console.log. Why don't I do first name is, and then we can just $ curly braces instead of our string template literal. We'll add first name. Okay. And then I'll call greet. So I'll refresh the page, greet, and I'll pass in, how about Elvis? Just like that. And there we go. First name is Elvis. So whatever name we put here, I could call this something else. I could call this, I don't know, idiot person. It's very rude. As long as I use idiot person, really it should be camel cased if we're being consistent with JavaScript conventions. Whatever is passed in here will be stored under idiot person and accessible in the function. So we'll try that one more time. This time, if I greet Elvis, still the exact same thing. Although I wrote first name, it technically is not first name anymore. It's idiot person. But let's go back. That is just so rude of me. Now, it's important to understand that this has no sort of smartness or logic about it. It's just going to hold whatever we pass in first. So I could pass in something like that, a big number. And it's still going to tell us that first name is that massive number. So it's purely based upon the order things are passed in. We'll see how we can have multiple arguments in just a moment. But there's no intelligence to it. So the name matters for us. The name does not matter to JavaScript in any way. So let's, instead of just doing first name is first name, let's get rid of that and do a console.log where we just greet somebody by their first name. So, hey there, comma, and then $ in a string template literal, curly braces, first name, and then maybe an exclamation point at the end. So now when I call greet Elvis, we get, hey there, Elvis. If I call greet on our massive number, hey there, massive number. What happens if I don't pass anything in? Do we get an error? If I just do greet, what do you think? Nope, we get undefined. So if an expected argument is not passed in, if it's not provided, it's going to have a value of undefined. Now we'll learn how we can change that, how we could give a default or a backup value in a little bit. But that's just another situation where undefined comes up. Now, a little bit of terminology just to review this. When we define our function, this right here, this first name is what we call a parameter. It is the value in the function definition that we use. So first name here, first name there, that is a parameter. When we actually call greet and we pass a value in, like this right here, Elvis is the argument, or it's an argument. So it's not a huge deal, but it's just something to pay attention to. So argument is what we pass inside the parentheses when we execute. And the parameter, or a parameter, is just this placeholder-y variable that we define for use inside of our function definition. So next up, we'll get a lot more practice with arguments. Next up, multiple arguments. So we can define functions that expect more than one argument to be passed in. So not just person, but maybe it's first name and last name, for example. And to make that work, we just need to tell our function, when we define it, that there's more than one parameter that we want to work with. So let's do first name, comma, last name. And that's kind of it. We define our two parameters here. We separate them by a comma. But what's most important to understand is that everything is decided by order. So if I pass in two arguments to greet, like this, and I do something like, I don't know, George Clooney, right? George, oh my God, Gerog, George, comma, Clooney. Is there an EY? Is it just, I don't know. Let's say it's like that. That would be first name and that would be last name. And that makes sense to us, in just terms of language and English. George is a first name and Clooney is usually a last name. But that is not what JavaScript cares about. It cares about the order. George comes first, so it's matched to first name. Clooney comes second, so it's matched to last name. So if I switch them up and did Clooney, comma, George, inside of this function, first name would hold the value of Clooney and last name would be George. So if I wanted to do something, I don't know, what should we do here? How about hey there, first name, and then we'll use the initial of your last name. So, hey there, George C, or hey there, Colt S, or something like that. So we'll do first name. Then how would I get the first letter of the last name? I would do last name, square bracket, 0, just like that. And then let's put a period there maybe so it looks like an initial. And then let's try calling this. So save it, refresh my page. We'll greet Elvis, and then I think that's how you spell Presley. And we get, hey there, Elvis P. Cool. So that's working. Let's try another one. Just remember, if I did it this way, Presley, Elvis. This is going to be first name. That's last name. It's all about the order. So we get, hey there, Presley E, which I do know somebody with the first name of Presley. So I guess it's not that ridiculous. But of course, usually we're not doing something as simple as printing out, first name and then the first initial of your last name. Often there's a huge difference between one argument and another. They might not even be the same type. We might actually write a function that, expects a string and then a Boolean and a number. It's not that common, but it is something we can do. So that order really does matter. So let's try an example that's a little bit more complicated. Let's write a function. We'll call it repeat. And I want repeat to accept a string like hi. And then I want it to accept a number like 3. And then I want it to print out hi, 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 like that. So it should accept a string and then a number, and repeat that string n times, and just print out a single line. So how do we do this? Well, we need to define our function. We'll call it repeat. And then we need 2 different parameters, and again, the order matters. So the first one, let's go with a name that makes sense, like str. I wouldn't do string, but probably str, or message, or whatever you want. Let's just go with str. And then after that, let's go with num, or you could do repetitions. It's a bit long. So maybe just num times. And then in here, how do we repeat a string num times? Well, there is the repeat method built in to strings. We're going to ignore that. So we're not going to use that. We're going to do it the old-fashioned way using a loop. So we're going to loop num times. So whatever that is. We could just do a for let I equals 0. I is less than num times, then I plus plus. And let's do something very simple like console.log hi. And let's just see what happens if I call repeat, whatever string, we're not using it, 5 times. We should see hi 5 times, and we do. Chrome collapses it for me into just a single line, but we see 5. All right, so instead of printing out hi, what I want to do is take this string and concatenate it 5 times. So that whatever our str is, let's say it's just a letter, or how about just a $sign, we end up with 5 or 10 or whatever $signs in a row. So I'm going to add them all up into a string. So let's make a new string. We'll call this result, and it will start as an empty string. And then in here, each time through the loop, we will just do a result plus equals str, which is the string that's been passed in. So whatever that is, let's say it's a $sign. We start with our result as empty. We loop a certain number of times, 10 times. Every time through, we add onto the result string with our $sign, whatever str holds. And then at the very end, let's console.log results and see what we end up with. Okay, so let's call repeat. Sure, we'll do a $sign. And then 5. And we get $5. All right, if I do something else like I love my chickens, and I repeat that, let's add a space after that 10 times. There we go. I love my chickens, I love my chickens, I love my chickens, and so on. All right, so I just wanted to show you that we can define a function that expects different types of values to be passed in. So a string and then a number. And if I mix that order up, it's problematic, right? If I did it the other direction, repeat 10 comma, I love my chickens, what happens? Well, it does not look very good. It looks like nothing was printed out. Why? Well, because our loop never actually ran. We had let I equals 0, I less than, and then I was supposed to be less than a string. Well, that's going to prevent the loop from actually executing at all. This will never run. So we're just console.logging an empty string, and that's exactly what we see here. So that order does matter. Okay, so that's multiple arguments. We can have more than 2 arguments if we wanted to, and often we will. All we need to do is separate the list of parameters by commas inside our function definition. The order matters, blah, 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 as I've said a million times. It's really the exact same pattern. So whatever parameter name you define first, that will hold the first value. The second one will hold the second value. The third one will hold the third, and so on. And I should mention, we don't have to pass in our second argument, just like we didn't have to pass in a first name here. Let's leave one of them off and see what happens. So if I call greet, let's just do it the right way first. Let's do Arson Banger, like that. Hey there, Arson W. Now, if I instead left off his last name, and we just did this instead, we get an error. But why are we getting that error? It says cannot read property 0 of undefined. So the error is not because we didn't provide, or it's not from JavaScript yelling at us about missing an argument. It's instead the result of last name being undefined. So we made it through this hurdle. It's just that this is a problem. We can't do undefined square bracket 0. So I just want to be clear there, right? We can ignore arguments or just not pass them in. JavaScript doesn't care until that argument is used in a way in the code that could cause an error. All right, so I'm going to stop here. We can have multiple arguments, and that's kind of what we just saw. Bye. Next up, the return keyword. So we've talked about writing functions that accept inputs. I showed that little diagram of a little machine here where we have our inputs on the left. Now let's talk about the output of a function. So far, we've been console.logging things, right? And you can think of that, I guess, as an output, but it is not an output that we can capture or reuse. Compare that to other built-in methods, things like toUpperCase or index of, where they return a value, and we can capture that value in a variable, for example, or we could pass it on to something else. We can chain methods together, as we've seen before. That is a different idea. That's a completely different concept than just printing something out using console.log. If we tried to write a function like add, which we can do right now, our function add will accept 2 numbers. We'll just go with x and y. You could go with num1 or num2, but at the end of the day, they're just both basically number placeholders. And then we'll console.log x plus y. So we can do that, and if we call add 9 and 4, we get 13. But if I try and save that to a variable, let total equal add, what is total? It's undefined. So even though we printed out 13, that is not a capturable value. We're only console.logging it. Whereas if I called something like, math.random, for example, if I save that to a variable, let r equals math.random, r actually captures that value, the output of this random function. So to write these functions that actually have a concrete output that's not just printed, but something that we can save, kind of put in a jar and bottle up, we need to use the return keyword. So return is a really, really important part of writing our functions. We have our inputs, and then we have our output, which we can output using the return keyword, just like this. So now if I return x plus y, I could also do this on 2 lines, right? I could do let sum equals x plus y. There's no reason really to do it this way, and then I can return sum, but I just want you to understand that they're separate. Adding them together and then returning. Let's try calling add now, 9, 4. We get 13. Let's save it to a variable. Const sum, and let's look at sum. It now holds that value. It holds 13. So we're exporting our value out of the function. So that's the first bit about the return keyword. The second thing you should know is that the return keyword actually stops the execution of your function. So whenever it's encountered, if I have something afterwards, like console.log end of function, this line will never run. Never, ever, ever run. And actually, VS Code tells me unreachable code detected. See how it grays it out? That's because there's a return right in front of it. And this return runs no matter what. So if I try running add, we get our value out, but this never prints out. But there are times where we might put a return in a conditional block, and it might not run every time. So let me just show an example of that. Let's check to see if x and y are numbers, or if they're not numbers. So if, let's do type of x equals number, if you remember how type of works. So let's actually do if it's not equal to number, or if type of y is not equal to number. If that's the case, what do we want to return? Let's just return maybe false or 0 or not a number. I don't know let's just return false just to be distinct, so we know that that part's running. Otherwise, we'll do this code. So we could put an else here like that and then return our sum. But we actually don't need that else, because the only way we ever make it to this code, the only way this line and this line ever run, is if this never ran. Because remember, return stops the execution of our function. So let's see if that works. Type of x, type of y. If either of them is not a number, we return false. Otherwise, we'll return the sum. So let's just try add 9 and 4. That's good. 9 and a, we get false, because we returned false because this was true. And we never made it to this line here or to any of this code. So most of the time, we just do this inline, just like that. The other thing you need to know about return is that we can only return a single value. Now that value could be an array, it could be an object that has a whole bunch of stuff in it, but we can only return one thing and only one thing. So I'm not returning two things here, right? Only one of these ever runs. I'm just saying when you actually have your return statement, only one value can be returned. So this will be evaluated to be a single number. It will be returned. We could make a pair if we wanted to and put two things in an array, but it has to be a single array. So to summarize, return is how we get values out of a function so we can save them and capture them. So instead of just printing something out, I could do something like this: add 9 comma a. Well, let's not do a. Let's do add 1 comma 5. And I'm actually going to pass that in to another example of add. Let's do add 1 comma 5 comma 9. So what's happening here? Well, this code is going to run. That will evaluate to 6. And then I'm adding 6 plus 9. And when I say it evaluates to 6, I mean it returns the value 6. And then we can add them together. Just like this returns the value 15, and I can save that into a variable, total, and it's not just gone forever like a console.log, it's actually saved. And this is something we've seen this a lot with other built-in methods and functions, things like math.random, that returns a random number between 0 and 1. ToUpperCase returns a string that's been capitalized, it's all in caps. It returns that value and we can save it or use it in some way. So very different from printing. Then the other things we saw about return, we can only return a single value, and importantly, return whenever it's encountered in a function stops the execution of that function. So when I say encountered, remember that means whenever it actually runs, not when it's just physically written in the function, but it has to actually run that line. And if that's the case, the entire function stops. It's done. Welcome back, everyone. Now that we've had our first intro to functions, and hopefully you did the problem set, as I pleaded with you to please do, now it's time to learn a bit more about functions. This is a section that is a little bit tricky, and I hesitate to say that because I don't want to scare you away, but there's a lot to talk about here, and this is really a full day of content from an in-person bootcamp, although when I say a full day, I don't mean 8 hours. We have, lunch and exercises and sort of homework review and all this other stuff, but it's at least a couple of hours that we give students to really work with this material. So why do I say it's a little bit tricky? Well, we're going to continue to talk about functions, but we're diving into some details, some important aspects of how functions work, and then some common patterns in JavaScript, something called higher order functions, passing functions to other functions as arguments, returning functions from within a function as a return value. It gets a little bit tricky. It gets headache inducing. We talk about the keyword this, a very notorious phrase, a notorious keyword in JavaScript. So I'm going to break this down here in terms of what matters the most. All right. So understanding scope here, this will be relatively quick, hopefully. Those are all going to be crucial. Function expressions, quick, just a single short video, definitely crucial. Then we get to higher order functions, returning functions, and the keyword this. So I'm going to say that higher order functions is crucial. Understanding the fact that we can pass a function to another function is something that in the next couple of sections you will see a lot. Now, what I will say is that you don't need to be able to write the same code that I'm writing in this section. You don't need to master every single thing in the videos on higher order functions. They're just dense. They're honestly tricky. I'll be honest about it. I hate saying it, but it's a challenging topic at times. So when I say it's crucial, the concepts are crucial. Pretend you were to get up in front of a class and have to explain how something works. That is the goal, not necessarily getting up in front of the class and being able to write it from scratch. Returning functions I'll put under important, but not crucial. The keyword this is very important to JavaScript. It's very central to a lot of stuff in JavaScript, but in this section, we're really just touching on it for like 10 or 15 minutes max. So I don't want you to think it's the most important takeaway. This stuff is definitely more important. Understanding functions in general, scope, function expressions, higher order functions. So these topics, 2 red topics, are important but not crucial. Again, that doesn't mean you should ignore them. I just don't want you to get hung up on these 2 things and just not move on, because this is such a dense chunk of JavaScript content. And I think the HTML and CSS stuff move pretty quickly. Once we get here, it's very easy to get discouraged. So don't let these 2 topics discourage you. It's okay to take a break and return to them later on. And then adding methods to objects, I'll also put that under important for now, not crucial. We'll get more practice with these topics as we move on, but really the main takeaways are going to be these 5 topics here. And these 3 you could collapse into just one called scope. So take a deep breath, pace yourself with this section. I don't want to scare you or intimidate you, but please, just recognize some of these things may require you to rewatch a portion of the video. You may not be an expert by the end. Be patient, and just remember that when something's taught online, it often seems like you're just supposed to get it immediately. That is not the case with this content. Okay, good luck, Godspeed, I love you all. Next up, we're going to talk about scope, which is sometimes a topic that strikes fear in the hearts of some of my students in person, but I promise it's not that bad. Scope refers to what I like to call variable visibility, basically the fact that where we define a variable in JavaScript impacts where we have access to it. So if we put a variable in a function versus putting it out in the open versus putting a variable in a nested function inside of a function, which is actually something we can do, we haven't seen that yet, those all impact where we can use that variable later on. So I'm going to go through a couple of examples. In this first one, I'm just going to demonstrate over here. We'll play a little game here. Imagine I have a function called, how about collect eggs? I'm collecting my chicken's eggs. I have to do this every morning. And in here, I define a variable. Let total eggs, and let's say it's equal to, I got 6 this morning, okay? So let's say I got 6 today, and then I console.log total eggs, just like that. I run my function collect eggs, and we get 6. That makes sense. That's printed out, right? We define that variable. I'm printing it. Now, what about if I tried to access and print total eggs down here? What do you think happens in this case? Well, if I run my code, I immediately get an error. Total eggs is not defined at app.js line 4. Why? Well, it's in a function. This function hasn't even been executed yet. So what if I ran the function first? Maybe that's the problem. So let's call collect eggs and then print out total eggs, because now we know this function will actually run at least one time. So total eggs will be initialized. It will be defined and it will have the value of 6. Then I'll print it out. Okay, so what happens now when I refresh? Same thing. Total eggs is not defined. So what we're seeing here, we're running up against function scope. Variables we define inside of a function where we actually use the let keyword and we define that value and that variable in the function, they are scoped to that function. So I don't have access to total eggs after the fact. It's like a little bubble. This function between those 2 braces is its own little world with a glass dome around it, if you want to think of it that way. And total eggs only lives in there. So if I really needed access to total eggs out here, this is not something you see very often at all, but I could do this. Let total eggs, set it equal to 6 or 0 or whatever it is. And then in the function, Instead of using the let keyword, I'll just update total eggs and set it to 6. And then let's see what happens now. So I will print total eggs at the beginning. Right here, it should be 0, right? It starts at 0. Then I execute collect eggs, and we're setting it to 6. Notice again, I'm not using let. That will make me a new variable. And we get 0 and then 6. So this is not super common to update an existing variable, what we would call a global variable, from within a function. Usually in our functions, we have our own internal variables. Like I use this example of a glass dome or a bubble surrounding this function. That's really common. Most functions behave as sort of a standalone machine where they take some inputs and they give you some outputs, but they don't necessarily impact the world around them, except that they give you some sort of output that you can capture. So that's an example of function scope. In this diagram, I'm using a different variable. It's called message. I'm on fire. It's declared inside of help me. It is not available. We can't access it outside of that function. So here's my next question. Let's define a variable here. I'll call this one bird, and it will be a scarlet macaw. And then I will define a function called bird watch. And in here, I'm going to make a different bird variable. I'm using the let keyword. Let bird equal, how about, what's another bird that I like? A great blue heron. I sometimes watch these guys in my backyard. They eat gophers just straight out of the ground, swallow them whole. It's quite crazy. They look like dinosaurs. Okay, so if that's what I've done, I have my bird variable up top, scarlet macaw, and then inside of birdwatch, I have another variable with the exact same name. What happens? So if I start by just console.logging bird right there, we see scarlet macaw. We never even executed birdwatch. I could execute it, birdwatch, just like that, but it's not going to make an impact because this variable is scoped to that function. But now, what if I print out bird in here? Just like that. What is the value going to be? Refresh, and we see great blue heron. Now, what if I just got rid of this line entirely? Do we have access to bird inside of this function? Well, it's defined outside of it, and we do. So, if there is a variable defined with the same name in the function, in this scope here, in this glass dome, then we will reference that variable first. When I reference bird, if there is a closer version of bird, that one wins out. That's what we see first or we encounter first. So that's how we end up with great blue heron. But if not, if no bird is found here, well, here's a different bird variable. We'll use that one. So we get scarlet macaw. So that's another example of function scope, where I use different birds here, but our bird variable is scoped to this birdwatch function. So next up, we're going to talk about a different type of scope, something called block scope. So next up, a little bit more on the topic of scope. So I'm going to type up a very simple example. Let's have a variable. We'll call it radius is equal to 8. And then I'll have a conditional. Really, this is just a dummy conditional. It could be anything. If radius is positive, if it's greater than 0, let's make a variable in here called pi. It will be declared with const 3.14159. And we could make another one, I guess. Let, I don't know, message equal hi, not jai. Okay, so this is pointless. It's silly. It means nothing to have pi and a message and radius. But what I want to illustrate here is that down here, if I try and print out radius, hopefully we know that we'll have access to it, right? There's no function involved. It's just a variable I declared, and then I'm using it. So let's see what we get. We get 8. But what about this? What if I console.log pi? Oh, pi is not defined. What's going on? This might make sense, right? If this was a function like we saw previously, you declare a variable in a function, it's scoped to that function, but this is not a function. It's a conditional. Same thing with message here. It's scoped to this block. So that's a new word for us, block. Block refers to basically anytime you see those curly braces, except for a function. So a block includes things like conditionals most commonly, but also loops. So if I declared a variable, well, let's do just a regular for loop. I equals 0, I less than 5, I plus plus. And then in here, if I declared a variable, let message equal that, if I run this code, okay, no problem. If I look at message, it does not exist. I have no access to it after that loop. Console.log message, it doesn't exist. Inside that loop, though, I do have access to it, as you can see right there. So this wasn't always the case with variables. If you can recall all the way back when I first introduced variables, I talked about the old way of making a variable using the var keyword. Now, when we use the var keyword, our variables are scoped to functions, but they are not scoped to blocks. So if I run this now, we actually do have access to our message after the fact. Even odder, if I used var here for my I counter variable, I could console.log I long after my loop ended. It still exists. It's still in scope. And we get 5. But if we use let or const, our variables are block scoped. So in this case, our I counter only exists in this block. It does not exist after the fact. And if I go back and change that to let, it does not exist after the fact either. So that happens with both conditionals. It happens with different sorts of loops. And this is important to understand. This is something that it's one of the main reasons let and const were introduced, was to add in variables that followed these sort of scoping rules, this idea of block scoped variables. It might seem kind of annoying or counterintuitive, but trust me, they exist for a reason. You can quickly run into issues around scoping, especially if you're still using the var keyword, which you shouldn't be. All right, so far we've seen this idea of function scope, where if we define a variable in a function, it is scoped to that function. If we have sort of a conflict, right, there are two different variables, one defined outside of a function called bird, one inside the function. Well, outside the function, we have no choice. We don't have access to this version. But inside the function, we will be using, or JavaScript uses, the closest version, which here is golden pheasant, a beautiful bird. So are mandarin ducks, by the way. Look them up if you've never seen them. Ah, beautiful. Then we got to this idea of block scoping. Now, block scope is a similar concept. It just means that instead of dealing with a function, if our variables are declared inside of a block, those variables only exist in that world of those curly braces, between the curly braces rather. So it's kind of the same exact idea as function scope, except we're talking about conditionals. We're talking about loops. This variable pi only exists in this yellow box. Circ, for circumference, only exists in here. Radius is available here and everywhere in this code that we can see, whereas these two variables only exist in that yellow box. Now, if we had used the var keyword, which you shouldn't, but we would have used 5 years ago, in that case, our variables would not be scoped to this block at all, and I would have access to pi and circumference down here. So that's block scoping. So the last little bit of this incredibly fun topic of scope is something called lexical scoping. And this basically means that if we have some outer function, let's call this one bank robbery, and then some inner function defined inside of it. For example, if I have another function here called cry for help, and let's say I have a variable called heroes, const heroes equals, and we'll have a couple heroes in here. How about Spider-Man, Wolverine, Black Panther, and how about Batwoman? Just like that. Inside of cry for help, let's try and access heroes. So let's do for let hero of heroes console.log something like please help me. How about help us? And then the hero's name. And let's do 2 uppercase. All right. So if that's what we have, first of all, what happens if I run this code right now? Absolutely nothing. Well, we don't see anything at least. Why? Well, we never executed bank robbery. So what if I execute bank robbery? What happens then? I need to execute it. Also, nothing. Why? Well, I declared a variable called heroes, but this is just another function. I never ran it. I still have to execute that function if I want to use it. So if I called cry for help in here, and this is kind of a weird thing to do, but soon you'll see that actually nesting functions is not that odd. It's totally valid. It's just one function inside of another. And the point that I'm making here has to do with scoping. So now what do you expect to see? Cry for help is called, And in this function, cry for help, we're referencing heroes. Heroes does not exist in this function, but it exists in the parent function. So do we have access to it or not? Well, let's see. Bank robbery, and it looks like it works. Please help us, Spider-Man, Wolverine, Black Panther, Batwoman. So what this tells us is really this concept of lexical scope. An inner function nested inside of some parent function has access to the scope or to the variables defined in the scope of that outer function. So we could further nest things even more if we wanted to, just to make this, this is silly, but let's write a function called, just inner. All right, it's not a very good name, but let's put all of that in there. That all goes inside of inner, and then in here, I'm going to execute inner. So bank robbery, I call that. It makes a variable. Here's a function. It doesn't run it until we get to cry for help. That runs cry for help. We define a function inner. We execute it. Inside of inner, we are referencing heroes, which is not defined in here or in here, but it's defined 2 levels up in the grandparent function called bank robbery, and we still have access to it. So that's all there is to lexical scope. And a nested or an inner function has access to the same stuff as the parent function or grandparent or however many levels up. So if something exists in bank robbery, we have access to it inside of inner. If something exists in cry for help, I would have access to it in inner as well, but it does not work the other way, just to be very clear there, right? If I defined a variable in cry for help, like let color equal purple, I'll have access to that inside of inner, but I don't have access to that up top inside of bank robbery. I know it's not the most riveting topic ever, but it is important. All right, goodbye. Next up, something called function expressions, an entirely different way of defining a function. It's not really entirely different, but it's conceptually a different way of defining a function. So far we've seen this, right? Function, let's do add x and y, and then we can return x plus y. Okay, nothing crazy. This is called a function statement. We are defining a function using the function keyword. And if over here, I take a look at add, well, first of all, it's a function, as we know. So it's a function, and then if I call it add 3 and 4, we get 7. But there's a different way of defining a function, and it actually involves storing a function in a variable, just like this. So here I'm making a variable. I'm calling it square. And then I'm creating a function, but this function doesn't have a name. If you can see that, it just is function and then parentheses. So if I try that on my own, just right here, function like that, I'm going to get a syntax error. It's expecting an identifier. But if I instead, I'll leave that one there, if I instead made a variable like const add and set it equal to function, and then my arguments x and y, return x plus y, that's not a problem. This is a function expression. So this right side after the equal sign creates a function, and I'm storing that in a variable just like I would store an object or an array or a number. It's the same exact concept. And to use this, it's no different than using any other function we've made. So let me just refresh the page. Here's add, it's a function. And if I call add 3, 4, we also get 7. So same syntax for executing or for running our function. We use the name of the function, but this time it's actually not the name of the function. That's what's confusing. It's the name of the variable. This function does not actually have a name. So technically functions are objects behind the scenes. We really don't need to go into it. I regret mentioning it, but every function has the option of having a name, an actual name attached to it. In this case, we're storing a function with no name inside of a variable. In this case, we're actually making a function with the name of add. Now they both behave the exact same way when we call them. It's not a big deal, but it's just something to point out. Just like if I were to store the number, I don't know, how about, well, pi, sure, 3.14. I've been leaning heavily on that example, but 3.14 is just a number. It does not have a name, but the variable, the container, does have a name. Same idea here. Now, the reason I'm showing this to you now, there's really two. One is that it's just good to know about, and you'll encounter it, and I didn't want you to feel nervous or panic if you see it. It's just another syntax for defining a function, saving it in a variable. But the second reason is that it actually demonstrates something that is going to come up a lot in this course, which is functions are values in JavaScript. We can store them, we can pass them around, just like we could pass around and store a number, or an array, or an object. JavaScript basically considers functions just like any other value, like an array. So this is our first example of that. We're storing a function in a variable. But soon we'll see we can do crazy things. We can pass functions as an argument. We can return functions as the return value, just like we could return a number. So this is our first little preview of that. It demonstrates that concept that functions are treated just like anything else. They're just a value. So that's it for now. Those are function expressions. So next up, we get to talk about higher order functions, which is a fancy way of saying functions that work with other functions, or they operate on or with other functions. So this really comes down to two main things. Functions that accept other functions as arguments and usually do something with them. And then also functions that can return a function. As we saw previously, a function is just a value that can be stored in a variable. It can be passed around. So if we can put it in a variable, like let do, or how about just greet, equal function, curly braces. I'm just going to do it on one line, console.log, hi, just like that. I now have stored a function in this variable, and I can execute it. Great. Hopefully that's review from the last video. Now, if I can store that function in a variable, I can also pass it around as an argument. And that's what we're going to start with here. So we can define a function like this one right here called call twice. And call twice is going to expect a function to be passed in. So I'll show that here. Function call twice. And what I want it to do is accept some argument that is a function. Now we're not going to guarantee, we're not going to verify that it actually is a function, but we'll expect some argument. We could call it func or f, or really anything, as we've already seen, but func makes sense. We don't want to call it function because that's a reserved word, but func. And then to execute this, imagine that it's just a variable holding a function, just like this right here, greet is holding a function. Whatever is passed into our call twice function will be stored in this func. So let's try executing func. There's our first time, and there's our second time. So if I call twice like this, and if I were to pass in 1, that's going to cause problems because it's going to try and execute 1. If we try and do that, 1 with parentheses tells me 1 is not a function. But I could instead pass in a function. For example, let's define a function called, how about just roll die. And we will return, or maybe we'll console.log so we can see it. Console.log, and let's just get our roll equals math.floor. I'm just going to do a random number, math.random times 6 plus 1, like that. And then we will print out that roll. So let's just verify that part works. Roll die. Not a number. Nope. I screwed it up. Math.floor of math.random times, what am I missing? Parentheses here. We have to execute math.random. Try that again. Okay. So now if I call twice, just like this, and I want to pass in a function like roll die, so that it will be called twice, which admittedly is very silly, but it at least demonstrates this principle. We need to pass roll die through as an argument, just like we would pass a string or a number. So roll die. Now I've seen a lot of students who are tempted to do this. That is very different. This is going to execute our function immediately and give us some random number like 5, and then that's passed through to call twice. What we want to do is pass through the value of the function, roll die, so that inside of call twice, it can be executed. So watch this. Refresh the page, and there we go. 1 and 2, 5 and 4, 6 and 4. Or I could write another function. How about this one? Function call 10 times. It will accept some function. We'll just call it f this time. And then in here, how do we run something 10 times? Let's do a for loop. For let I equal 0, I less than 10, I plus plus. What are we doing here? I'm just going to execute whatever function f was passed in. So now if I refresh the page here and I do something like call 10 times of roll die, we get 10 different rolls of our die. So that's just our first example of passing a function as an argument. So we invoke that function. We're calling that argument, or that parameter rather, func. Then we invoke it, we add the parentheses twice, in this case, to execute it twice. It's a simple and silly example, but we will see many, many functions that expect us to pass other functions into them as we make more progress here. All right, so that's our first type of a higher order function. They're just functions that operate on or with other functions, and we just saw one that accepted a function as an argument. Next up, we'll talk about returning a function as the return value. Okay, so we've seen that we can pass functions as arguments to other functions. Now let's talk about the second bullet point here, which is returning a function as a value from within a function. So we could have a function that does one of these things, or that does both of them, or as we've seen in a lot of examples up until this point, we can have functions that do neither of these things. But the point here is just to illustrate that functions are just regular old values, and we can pass them around, whether that means returning them or passing them as arguments. So to show you some examples of how this works, it's a little challenging because I can show you a very simple, obvious example, just proof that this is a thing we can do, but it's not going to seem immediately useful. So that's what I'm going to start with, but then I'll try and show you an example that makes a bit more sense. So let's start by defining a function, and I'm going to call this function makeMysteryFunc, and it is going to randomly return either a fun, happy function or a sad, depressing function or an annoying function. So we'll pick a random number in here. So first we need our random number, so let's do math.random, const rand, and then we'll just check if it's greater than 0.5. What do we return? We're going to return a function. And there's a couple ways of doing this, but the easiest one is just to declare it in line right here. We've seen this before, right? A function expression, that's a value. I could capture that and put it in a variable, or I can just return it, which is what I'm doing here. But I will actually capture it in a variable on the other side when I execute this function. So inside of this function, it doesn't need a name, but let's see, return function, how about console.log? This will be our good function. Congrats, I am a good function. How about we'll say something like you win $1 million. You win $1 million. Okay, so there's our silly good function. And then otherwise, we'll return a different function, and this will use alert and say, you have been infected by a computer virus. Another alert. Stop trying to close this window. How about that? Nice and annoying. Okay, so depending on this random number, we are returning one of these two functions. Neither of them have a name. And so if I were to just call this function, it's called makeMysteryFunc, makeMysteryFunc, and I execute it. I didn't execute it there. I accidentally hit Shift-Enter. There we go. It returned to me this function. At least this time we got the bad function. Let's try it again. I got the good function. Good, 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 bad. So I'm still never calling that function. It's simply just the return value. I need to capture it. Just like any other return value, if I want to save it and use it, I need to capture it. So I would do something like this, const func or myfunc, or maybe just mystery equals makeMysteryFunc. Now our variable mystery holds a function, and I can execute it like that. Congrats, I'm a good function, you win $1 million. So let's try it again. I did use const here, so I'm just going to refresh and try it again. What's mystery this time? We got the bad one. We call it, you've been infected by a computer virus. Stop trying to close this window. Stop trying to close this window. Stop trying to close this. Oh my goodness. And there you go. So that's a silly example. We are returning a function, but it seems kind of useless to do that. But I'm going to show you another example here that maybe is a bit more useful. It's still very simple and honestly not at all useful, but it's a pattern that is useful. So sometimes what you'll see in some code is a function that generates a function based upon some input. So here's a function that it does generate, it returns a function to us, but it's the same thing every time. I mean, there's two choices, but it's the same exact thing every time. There's no inputs that we pass in to influence that. But we can make a function. I'm going to call this one, my example, make between func. And it's going to accept two numbers, a min and a max. And here's how I want it to work. When I call make between func, and I pass in 5 and 10, I want it to return to me a function. And that function is going to test whether a value is between 5 and 10. If I were to call make between func of 50 and 100, it should make me a new function. And that function should tell me if a value is between 50 and 100. So actually, why don't we start with that? How do I just make a function that tells me if something is between 50 and 100? Well, function, let's just call it like is between. It takes a number, right? N or num. And then if I want to know if it's between 50 and 100, I could do return. And then how about num is greater than or equal to 50, and num is less than or equal to 100, right? That makes me a function. It's nothing fancy, nothing new, no higher order anything. It's just a function called isBetween, and it tells us if an input we pass in is between 50 and 100. So let's verify. IsBetween. 30, that gives us false. But how about 80? That gives us true. So now what if I wanted another version of this to test if a number is between 1 and 10? So I could call this, is between 2. It's stupid, but I could do 1 and num is greater than 10. Or sorry, other way around. Num is greater than or equal to 1 and num is less than or equal to 10. So if I call that is between 2, we get false if I pass in 80, but if I pass in 5, we get true. So I'm writing these functions myself every time I need them, a new isBetween function. But I could make a factory function. A factory function is just a function that will make a function for me. So here's how it's going to work. Again, function make between func, and I'm going to pass in a min and a max. And it's going to return to me a new function. And this function is going to accept an argument. We'll call it num, just like we did here. And then all we do from within this function is return. Same exact pattern we have, except instead of hard coding 50 and 100 or 1 and 10, we'll use min and max. So is num greater than or equal to min, and num is less than or equal to max. So I would need to call make between func, and I'm actually going to do this from the console so you can just see it. Make between func, and I'm going to pass in, let's do, I want to know if a number is between 100 and 200. So that returns to me a function. Now what's hard to understand, or what might be hard to understand, is that min and max have a value, right? In this case, 100 and 200. This function, make between func, is going to return to me this function here, where min and max are actually the same value that they were in the scope of this function, basically whatever they were at the time we returned this function. So min was 100 in this case, and max was 200. So it returned to me this function, and I could save that in a variable. So I could do, const test range equals this function. But then I could also turn around and make a second one and a third one. So let's try it. Let's call make between func with 100 and 200 and save that to a variable. We'll call this one const, I don't know. What about, let's actually do ages. So let's say you're between 1 or 0 and 18. That function that tells us if you are between 0 and 18, we'll call that isChild. Okay? Let's look at isChild. It's just a function, and if I pass in a number to it, like 40, we get false. But if I pass in something between 0 and 18, like 7, we get true. Now I could turn around and make another one. Let's call this isAdult, and that's if you're between, make between func, if you're between 18, and technically the way we implemented this, I guess it needs to be 19 because the range is inclusive. That's beyond, well, that doesn't really matter. So let's just do 18 up to 64. Okay. And then let's do one more, is senior. And that will be make between func from 65 to, let's say, 120, just to be extra safe in case some adults live to that age. I don't think they do, but just in case. So now if I call is senior, right, I have a new version, a new function that was returned to me that is different from this one. Is adult and is senior and is child. They all follow the same pattern, but the factory function called makeBetweenFunc made me a different version based upon my min and max that I passed in. So this is one situation. It doesn't seem useful, at least here, right? These simple functions that are just telling true or false a number is between x and y, or min and max. Not amazing. But this is a common pattern to set up a factory function, and maybe it's not that common, but it's something that you will encounter at some point if you continue pursuing JavaScript. Also, it's just an illustration of this concept of higher order functions and returning functions. So let's check it out. Just make sure it works. Is senior of 40 should be false. 90 should be true. Is adult of 90 should be false, but 50 should be true. 0 should be false, and then we've already seen is child of, let's do a 17, that's true, but 19 is false. So we've made this factory function. It returns a function. That function doesn't have a name, right? It just kind of is returned as a value. It's passed around, like, here's this thing, do with it whatever you want, and it's up to us to capture it in a variable, which is exactly what we did. Cool. So that's returning a function as a value. Next up, we're going to talk about functions and objects and how they intersect to form methods. So I've used the term method before when we do things like, hello dot to uppercase. That is a string method. Or, we've seen a bunch of other ones, an array method like push, right? Where we can do something 1, 2, 3 dots, or maybe index of 2. Gives us that answer of 1. That is an array method. That's a string method. And then I've talked about things like when we define a function add x and y, and then we return, just doing it on one line here, x plus y. That is what we call a function, right? Hopefully that's review at this point. So what's the difference between a method and a function? Well, a method is simply a function that has been placed as a property on an object. Basically, if we access a function by using a dot in front of its name, like something dot index of string dot to uppercase, it's a method. But it's also a function. So every method is a function, but not every function is a method. So we can actually add our own methods to objects. Here's an example. We can add a function as a property value. Just like we saw in the past few videos, we can store a function in a variable. We can pass a function as an argument. We can return a function from a function. We can also use a function as the value in a property in an object. So here I've created my own math object. I don't know why I didn't lead with that. The math object itself, it mainly consists of a bunch of these methods. They're just functions and they're stored as properties. So we could make our own little math object. We can try that over here. Const math, how about my math equals an object. In here, I could add, a simple property like pi, 3.14, that's not a method, 159, and then I could add in, how about square? Square is going to be a function, and that function will accept a single argument, we'll call it num, and we'll return the square, which is num times num. And then if I wanted something else afterwards, I could add another method. How about square? I guess we could do something simple like, well, let's just do cube. Let's start there. Same idea. So function will accept a num, return, and then we could do num times num times num, or we can do num star star 3, which is num to the third power. All right, so let's try this out. We've made an object called myMath. We can access .pi. That's just a regular, they're all regular properties, but that's just a number that we're storing. But then if I do .square, that gives me the function, but I didn't execute it. I still need to call it. So I can do that here. Let's pass in a number like 2. The square of 2 is 4. myMath.cube, that will give us, if we do 2, it gives us 8. 2 times 2 times 2. So hopefully you get the picture here. That's kind of all there is to this idea of a method. It's just a function that's been added as a property on some object. Now, when we talk about string methods and array methods, right, those aren't functions we're defining on those objects. And this is where it gets kind of confusing because technically arrays are objects in JavaScript. strings even. We don't need to go into it, but they're wrapped in an object when you use them. I regret mentioning that, but it's there. I've said it, and I mean, I guess I could edit that out. But I'm kind of joking. What you really need to know is that objects are everywhere in JavaScript. Whether it's an object we're actually creating, like this right here, my math, the object's literal, or it's an array, or it's a string that is wrapped in this weird, mysterious object temporarily. Methods are simply functions added as properties on objects. So we access them. I mean, technically, you don't have to use this dot syntax. You could do this, as we've seen before. This is odd, but we could do this and then execute just like that, my math of cube, and then execute it with 4 as the argument. But that's a very weird syntax to see. Normally, you would just do this. All right, so that's the main idea of adding methods to an object. Simple enough, hopefully. It's just a property. Now, there is a nice shorter syntax that has been added to JavaScript more recently. Because this is something we do relatively commonly, there's a shortcut or a shorthand, and it looks like this. So instead of having to do some function name or some property name colon a function, we can just write add, and then our parentheses, and then curly braces, or multiply, or whatever the name of our function or the name of the property should be. So I could rewrite this. This whole thing is just square. I don't even need the function keyword. Same thing here. Cube, I don't need the function keyword. Now, definitely, I do need those commas because we're in an object. Sometimes I see people get confused. They forget you're in an object, and if you leave that out, we'll have a lovely syntax error, so you can see there. So we need that. But this is a nice shortcut or a nice shorthand syntax. It still works exactly the same way. We can do mymath.cube of 2. We still get 8. Same thing. It's just a shorthand. So if we just verify that, look at my math, it still has cube set to a function and square set to a function. And that's all there is to it. So next up, we get to talk about the keyword this, a riveting and important part of working with methods in JavaScript. So that's up next.
Next up, let's talk about the dreaded keyword this in JavaScript, which hopefully we can make a bit palatable and not too scary. So I'm going to keep this brief. There's a lot that we could go into, but I'm going to just go over the main essentials at this point. In JavaScript, there's a keyword called this. Just like we have other keywords, right? We have things like return and const and let. This is another one, THIS, and it also makes it kind of hard to discuss because we use the word this a lot. So I'll try and be very clear about that as we make our way through this video. So the keyword this is something that we typically use inside of an object in a method. That's at least the most common situation to use this. And I'll show you an example of that. So let's make a new object here. We'll call this my cat, or just cat. And my cat is going to have a name, which is Blue Steel. And then what should we have? We'll have a color. She's sort of a gray cat. And she is a Scottish fold. And then I'll add a method. And this method will be meow. Okay? And I'm going to use that shorthand syntax we just saw. So meow is just going to console.log. I don't know. Meow, meow, meow. All right? It's nothing crazy. So if I run this code over here, and I take a look at my cat object, and I call meow, we see meow, meow, meow. Okay, not too exciting, but it does work. Now, the keyword this is going to refer to, inside of this method, it will refer to the cat object itself. So this is useful if I want to be able to access things like Blue's name, or her color, or her breed inside this method. And that's a really common situation, to create an object that contains different properties, different pieces of information, as well as different methods or pieces of functionality. And we often want those methods to have access to the data in the object. So, meow, maybe I wanted to say, Blue Steel says meow. To do that, inside of here, I can't just access name or color or breed on their own. You'll see I get this error. If I try running cat.meow, color is not defined. It's looking for a variable called color. It doesn't exist. But there is a special property called color on this object. And in order to access that, I can do this dot name or breed, or let's do color to start. I'll run that code now, and we get gray. So if I wanted to do this, I don't know, let's do this dot name instead of a string template literal, says meow, like that. Now if I execute this, Blue Steel says meow. Okay, so the keyword this is going to refer to this object. But that's actually not always the case, and this is why it's somewhat dreaded, why it can be confusing, because I think this is relatively straightforward. If we're in a method and we write this dot some property, it refers to the object that this method is defined on. And that's great. But, as I mentioned, that's not how it always works. The value of this actually can change, and it depends on the invocation context of the function it's used in. So what does that mean? It depends on how we actually call the function. So in this example, I'm calling cat.meow. The keyword this, as we saw, refers to cat. It refers to that entire object. But if I change things up just a tiny bit, and this is going to seem kind of weird to do, but I just want to prove a point here. If I make a new variable, let's call this, I don't know, how about meow2? I'm going to set it equal to cat.meow, just like that. I'm not actually executing it. I'm just referring to that method. We've seen how to do that before, right? I'm just setting a reference to this thing. It happens to be a function. So now if I call meow2 and I execute it with parentheses, it is a function. If I look at it, there we are. It's that same function that we wrote earlier. I've now just captured it in a variable. And now I'm calling it with parentheses. What the heck? Blank says meow. But when I did cat.meow, the same exact code on the inside, it now says blue steel says meow. So what's the difference? Well, the difference is in that invocation context. When I'm invoking the function here, it's a method on cat, and I'm actually writing cat.meow. This refers to that object to the left of the dot. When I ran it here, without the cat.meow, it's the same function, but I've just called it in a different way. I've invoked it differently. The keyword this is not going to refer to the cat object. Instead, let's see what it refers to. Let's console.log. This is, and then we'll just print out this. Let's see what it refers to. So we'll do this again. Cat.meow. This is the object, cat. That makes sense. So that's where I can access this.name, this.color. Now, when I call meow2, which is the method that we just captured in a separate variable, what is this? What the heck? This window thing. What's going on here? Well, if you are not familiar with the window object, we haven't really talked much about it. Built into JavaScript. Every time we open up a new browser window, and we're working with JavaScript, there is a special object, the top level object. Think of it as just like the main object that everything lives inside of, called window. And if I look at it here, I don't know why I capitalized it. There we go. All of the functions we use, things like alert, they actually exist inside of the window. It's just a big old object. It's a huge object. And we'll see some of these things once we talk about DOM manipulation. You'll learn more about them. But it's huge. It contains lots and lots of things. And actually, if I define a function, like function scream, and it, what should it do? Just console.logs, just like that. We call that by calling scream and executing it, right? But actually, it's added to the window for me. Even though I never wrote the word window anywhere, there is a method now on the window called scream. It's exactly what I just wrote. So by defining something here, defining it just out in the open, if I had done it in a file, it's exactly the same. It just exists on its own out here, and it seems like it's just floating around, but it's actually in this top-level object in JavaScript called the window. So to be more specific, if I wanted to, I could do window.scream, but nobody does that. It's actually the same thing with alert. I could do window.alert that, and it works, instead of just doing alert. But it seems stupid, and nobody does that. Now, I bring this up because, as we saw, when I called meow2, wherever you are, it said that this is referring to the window object, instead of what we had here, where this was referring to whatever came to the left of that dot, the left of the period. That is what this referred to. The keyword this referred to cat. But here, the way I invoked it, nothing came to the left of meow2. But that's actually not true. You can think of it as the window object is over here on the left-hand side of meow2. It's really just the default value for the keyword this. For example, if I just type this out here, I don't get an error. I'm just in the middle of the nothingness in the console. I'm not in an object, or at least not an object I've created or defined. It's set to the window object. Same idea here. So if this is confusing you, I don't blame you. If this is confusing you, don't blame yourself. Don't feel bad. Spend a little bit of time on it, but honestly, this should not be a roadblock. It's one of those things that you can put aside or write a note about, revisit. I have a pretty comprehensive YouTube video on the keyword this if you want to learn a lot more about it. It's something that will come up every so often in the next couple of sections and units, and we'll see actual applications of it where it makes more sense, where it's not doing stupid stuff like a cat meowing and referring to this.name. But I just wanted to illustrate the basics with something simple, and then we'll start to see some actual useful stuff once we pick back up with building things. We've been on a bit of a, more than a bit, a long JavaScript just syntax tear, and I know it's not that exciting, but very, very soon, I can actually see it on the horizon in front of me. I'm looking at my outline. We're very close to getting back to building interactive things with HTML and CSS and then adding JavaScript in. Anyway, long story short about the keyword this, if you struggle with it, please do not let it derail your hopes and your dreams. Almost every new JavaScript developer has to confront the keyword this at some point. And not to scare you, but I've only shown you some of its weirdness and how it changes. There are other times this can even mean something else or be evaluated to something else. But that shouldn't deter you. It's just part of JavaScript. So don't ignore it, but don't go down a rabbit hole and don't stress out about trying to understand every little bit of this, at least not until we've got a bit more practice with it. So I'm going to be quiet. I'm just rambling on at this point. Okay, so that's the keyword this. Okay, bye.
Next up, just a one-off video on a topic that doesn't really have anything to do with functions, at least not directly. We're going to talk about a statement in JavaScript called try catch, or I guess they're two statements, but they go together, and they have to do with errors or exceptions in JavaScript. Specifically, they have to do with catching errors and preventing them from breaking or stopping the execution of our code. Sometimes you might anticipate, okay, this could go wrong, there might be an error here, and if there is, I want to grab it and stop it from propagating outwards and crashing everything. So let me just show you a very quick example. We'll generate an error deliberately to start. So I'm just in a new app.js. An easy way to generate an error, something that doesn't exist, like hello.toUppercase. There is no hello. And if I try executing this code over here, uncaught reference error. Hello is not defined. Notice the term, uncaught. Try catch, past tense of catch, caught. So if we want to, or if we anticipate that this might result in an error, we wrap it in a try block or a try statement. It looks like this. Try, and then curly braces. And now if I move this code in there, it's going to complain to me. Unfortunately, just to try on its own is not enough. I believe, actually, do I get an error? Yes. It says missing catch or finally after try. So we can't just have a try. We need to also add in a catch, which is the block of code that will run if something went wrong, if there was an exception or an error generated inside of this try. So it just looks like this. I'll do a console.log error. Okay. So let's try refreshing the page. And you can see my code is not stopped or it didn't break. Just to prove that, I'll put some code down here, console.log after, and that code still runs. Whereas if I didn't have the try catch and I just ran this code that generates an error, everything stops, right? This line never is executed. So if I use try and then catch any error that arises, I can ensure my code continues to execute. And also I can handle my error. There might be different things you want to do. This is very silly, right, to deliberately cause an error. But there are times you might try something that could result in an error. In fact, when we get to Ajax and making requests and async functions, this is going to be really, really important using try and catch. We'll introduce a lot of unpredictability into our code. We'll be connecting to APIs and, trying to connect to the internet. And there's a lot of reasons things could go wrong. The internet could be down. The API you're requesting might not exist anymore. Permissions denied. All these things could go wrong. So we try. And then if something goes wrong, we catch. So I'll show you a quick example just of a function where this might be useful. So imagine we have a very simple, another very silly function called, how about just yell? And it accepts or it expects a message to be passed in. And we'll just do a console.log or maybe just return or something, message.toUppercase. And then we'll repeat it 3 times maybe. So let's start by just console.logging that. And if I call yell of hello. Okay, there we go. Not great, but that works. But of course, there's a problem if I don't pass in a string. If I pass in a number, like that, we get an uncaught type error. Message.toUppercase is not a function because it's a number. There is no toUppercase method. So I can use try catch here. At least that's one strategy that I can use to handle the situation where a message is not a string. I mean, one option is just a straight up check, is message a string? But this is just a different approach. So what I can do is just wrap that whole thing in a try catch. So try that. And then if something goes wrong, I actually have access in catch to the particular exception or error. So I could just console.log that out if I wanted to, console.log e, or I can do something else like console.log, please pass a string. And now if I try refreshing the page and I call yell again with a number, we caught the error, we print it out, and then we also say, please pass a string next time. So, I could do something else. I'll just probably do this here. Please pass a string next time. And that's pretty much it. We are successfully catching the error, the potential error, at least in here, that we're trying this code. We're assuming it's going to work. And then if it doesn't, that's okay. We'll catch any sort of error and then just print this out. So I should verify, right? If I do call it with something valid, like hello, it still works. It's just when I do something invalid, like I pass true, or I pass an array, or something that does not have two uppercase, really anything that's not a string, please pass a string next time. Now, I'm not saying that's the best approach for setting up this function. Returning a string that says please pass a string, or console.logging a string, that doesn't really make sense. It's just a simple illustration here, but you would probably return, false or null or something. So that's a basic idea of try catch. I think you'll find it a lot more useful when we get to async functions, and also when we get to express and node, we will be using try and catch all the time. Okay, if something goes wrong in between the braces of try, whatever it is, we will be able to catch it and then handle it however we'd like. Hey everyone, it's another section and another one of these videos where I walk you through what actually matters. I would say, doing something you love, being surrounded by friends or family that you care about, those really matter. For me, doing something creative in my life matters. Very funny, right? Very funny. Okay, I'm done with that. Let's talk about what actually matters in this particular section. We are talking about array callback methods. Basically, JavaScript arrays come with a set of methods, things like for each, map, sum, and every, filter, and reduce, that are array methods that require you to pass a function into them. So that's why everything is yellow here, plus reduce we'll get to in a moment. It's a special case. It's not as simple as just passing like a number or a string into a function. You need to be able to pass functions around into other functions using some of what we just talked about in the last section. So if you recall, I said that higher order functions are important to understand conceptually. Now we'll get some practice passing a function to another function. We don't need to worry about returning functions. That's a whole other headache, as you saw previously. The focus here is just passing functions in. So of these different methods, for each, these days, not that crucial, but I'll put it under crucial just because you'll see it a lot in the real world. Map, probably the most important of these methods we'll take a look at. Map is super useful and it's just used all over the place. Sum and every, nice to have, to be honest with you. Filter, I'll say, is important, but don't stress about it as much. Arrow functions. So this is actually a standalone topic that does not have anything inherently to do with array methods. I'm just grouping it in here. Arrow functions, you may have heard the term, it's a shorter syntax for defining function expressions. So that's crucial. Just to be a modern JavaScript developer, you need to be comfortable working with and writing arrow functions. So that's relatively easy to understand. I think, most students they don't love them. They are happy to use them because it's just a shorter syntax for writing functions. And then reduce. Oh, reduce. You will see when we get to reduce. It is a useful method, an array method, but it can also be quite intimidating or difficult to remember or difficult to wrap your head around. I've put it in red because it can take more time. It certainly takes me more time when I'm teaching this in person. I get a lot more questions about it compared to something like map or filter. So it's worth knowing about, but it's not worth derailing your progress in the course just so that you can master reduce. Reduce will come up maybe one or two more times in the course, and each time it does, I'll take the time to explain it or remind you how it works. So please don't panic about reduce. Don't let it be the thing that holds you back here from moving on, because we're almost on to the union of HTML, CSS, and JavaScript. We're almost done with our basics of JavaScript. So yeah, reduce is great, but don't freak out about it, okay? Focus primarily on map, arrow functions, and for each. Those are the crucial things to understand. Alrighty, here we go. Bye-bye. We just wrapped up in the previous section talking about passing functions to other functions or returning functions from within functions, and there's a reason I covered that first. This section is about a subset of array methods, built-in methods that we have access to on every single array in JavaScript, and those array methods require us to pass in functions. So it seems a little odd, but it's a very, very crucial part of working with arrays in JavaScript, and arrays are very crucial to JavaScript. So let's just simplify that and say that this pattern, these array methods I'm going to introduce, are critical to understanding JavaScript. Though, as I said in the previous video, they're not all created equal. You don't need to master all of them. You don't need to worry about things like reduce, but that's what binds all of these videos together, all of these methods, is that they are array methods that require us to pass in a function. So as an example, here is one called filter, and if I show you on the documentation, here is filter being called, and this is a function, is prime, that's being passed in. Or here's another example, filter. Take a look at that function being passed in. So we'll spend a lot of time in this section talking about that pattern and talking about different methods. And we're also going to talk about a very particular type of function that we haven't really seen yet, a newer, fancier, modern syntax called arrow functions. So that is, I won't say an interlude, but it's sort of a separate topic embedded in this section because arrow functions happen to be used all the time when we're using these array methods. So I know it's not the sexiest topic ever, but it is very central to JavaScript. So array methods that require us to pass in functions. That's really the central idea here. So let's get started. So the first of these fancy array methods that accepts a function as its argument is called for each. Now for each actually used to be a lot more commonly used before the advent of the for of loop. Basically what it does is it allows us to run a function, run some code once per item in some array. So whatever function we pass in, that function will be called once per item, where each item will be passed into the function automatically. So I've got an array here, it's called numbers, it's very simple, just a bunch of numbers. And if I wanted to print out each number, I could use for each, numbers dot for each like this, and then it expects us to pass in a callback. So we could define this function separately, like function print. It just accepts some element, and then it console.logs that's element, just like that. So I can call print myself, I could do this, print of numbers 0, right? And print numbers 1 and so on, and hopefully we see both of those printed out, and we do. We see 1 and 2, right? The first and second elements. Now, I'm not going to do that. I'm going to use for each, and for each is going to do it for me. So I'll just pass in the function I want it to call for each element. So it will execute print once per element, and it's not just doing it one time per element, but it's passing in the element. So it will pass 1 to print, 2 to print, 3 to print. So let's try it. And there we go. We get every element printed out. So nothing crazy there. But this is pretty uncommon to do for each and just pass in a function that you've already defined. What we most commonly see is defining a function inline here. We've seen this before, an anonymous function expression like this right here. We need to come up with our parameter name. Let's just call this L. And then inside those curly braces, console.log L. So this is incredibly common, this format, this pattern here. Something like for each, we could pass in a named function we've already created, but most of the time we'll just pass in a function that exists solely for this moment in time. So it's not something we plan on calling again. So let's just verify this works. And it does. We get the same outcome. So it seems kind of silly, especially for something like for each, because we know how to print out each element now using a for of, just as an example. For let's element of numbers, console.log L. And that's easier to read, right? It's shorter and just it doesn't have to involve functions, which is nice. But this has not always been a thing. This is newer. So for each for a long time was people's first choice for printing out, well, not for printing out, but for doing something once per element in some array. So instead of just printing things, right, we can do something a little bit more complicated. Let's print out the even numbers. So if, and then L mod 2, that's how we tell if something is even. If it's cleanly divisible by 2, if that's the case, we will console.log the element. Refresh. Now we only see 2, 4, 6, 8, and so on. All right. So that's one example of for each. Let's do another one though. I have a slightly more complicated example here, or data structure, a movies array, and it contains objects. So each movie is an object with a title and a score. What I'd like to do is print out something like, maybe just the movie. So let's say Alien, and then 90 out of 100 will be its score. Okay, so I want to do 90/100 or 95/100. So I'm going to call a function once per element in this array. So movies.forEach, and as we talked about, most commonly we use an anonymous function expression that exists just for this purpose. And then we need to come up with our parameter here. What do we want to call this? Let's call it movie. So movie is going to be each element one at a time from this array. It will be passed in automatically to this function. So I'm simply providing a function to for each, and I'm saying, hello for each, here's a function I would like you to call. We're not executing this function, right? We're just defining it. If we wrote this out here, I mean, technically it needs to be saved in a variable, const f. This defines a function, but it never executes it. I still would have to use parentheses to execute it. So we're not calling this. We are just writing it. So for each movie, we'll do something simple, console.log, and if we just print out movie, it will just be the entire object. Each element is an object. So I wanted to print out a string that had the movie title and the movie name or the movie rating. So I'll do something like this with a string template literal. We'll do the movie title, movie.title, dash, and then another $sign curly brace, movie.score, and then I wanted to do it out of 100. So here we go. And that's kind of it. So for each these days, not actually used very often because we do have access to for of. But it's our first and simplest example of these array callback methods, these methods that expect a function to be passed in. So I want to start here. Next up, we're going to talk about one called map. The next of these callback array methods we'll see is called map. So map is similar to for each in the sense that it accepts a callback, a function, and it runs that function once per element in the array. But what's very different is that it then generates a new array using the result, using the return value of that callback. So it's a way to map an array from one state to another. We could double every number. Or in this example, I have a text array with some lowercase strings, and then I'm calling text.map. We pass in our callback function, and I'm using t as a parameter here, return t.to uppercase. So whatever that return value is, coming back from this callback function, map is going to take that and add it into a new array that it creates, and it returns, and I can save it under the variable caps. So I'll show you some examples here. Here is numbers, once again, our lovely array of just consecutive integers. And let's say I want to double every single one. I could do this, numbers.map, and then I pass in my callback. For each num, I said for each, but we're not actually using the function for each. I'm just saying do this for each num, and then create a new array with it. Thank you, map. That's what you're supposed to do. So for num, that's our parameter here, num, I'm going to return num times 2. So it's going to call this function on every element. So it's going to call it on 1. So num will be 1. We return 2. And it sticks that in a new array. And then we pass in 2, or it does, map does. So 2 is passed to this function. Well, that returns 4. And that's added to a new array that it constructs based upon our initial array, numbers. So it doesn't mutate numbers. It doesn't change it in any way. But it makes a new array for us. And then I can save that to a variable, const doubles. Let's take a look. Here is doubles, 2, 4, 6, 8, 10, and so on. So we've taken every element, and it's been run through this function that we passed into map, and that generates a new array with the results. So let's try working with the movies array this time, where we've got our objects, and maybe I just want to form an array just of the movie titles. That's it. So to do that, I could use map, movies.map, and then my function, movie, and all I'll return is not the movie object, but movie.title. So I'm mapping over that, each element in this array, and then I'm just saying return the title, and put that in a new array, return the title, return the title. So if I save that to a variable, const titles equals movies.map, let's take a look. There we are. We have an array of titles. Or I could do something entirely different. I could do movie.title.to uppercase, just like that. Take a look at titles. Now we've got our uppercased movie titles. So we're just taking data in an array, a starting array, and usually transforming it as we map it into a new copied array. So we could just use map to make a direct copy. I could literally just return movie in this case, but there's easier ways of doing that. So it's typically used when we need a portion of our data, or we want to, doubling something's not very common, but when we need to transform every element in some starting array and create a new array based upon that starting array, map is often a good choice. So it accepts callback, it runs that callback on every element, and it takes that return value we get back and it shoves it in a new array that it returns to us that we can then save in a variable or do something with. So that's an intro to map. All right, so now we get to the main course, delicious arrow functions. They're not delicious, but they are super useful, and they are really the main thing I hope you take away from this unit, although everything's pretty important here. Okay, so arrow functions are a newer syntax for defining functions. Unfortunately, no Internet Explorer support. Probably not a surprise at this point. Anytime I say newer syntax or newer feature, there's almost always this little Internet Explorer logo crossed out. So it's a newer alternative that is more compact to a regular function or compared to a regular function expression. It allows us to write functions without actually having to write the keyword function. And they're really useful, especially when we're doing things like this, where we're passing a function in that it only exists to be passed into this other function called map. It's just an argument. We're never reusing it. It's like a one-time thing. So making this shorter would be great. And that's where arrow functions come in. So newer syntax, more compact, but they do the same thing. They help us make a function expression. So this is what it looks like. At least this is an example. We have parentheses, and then our list of parameters there, one or more, as you can see here, and then an arrow, which is an equal sign and a greater than sign, and then curly braces. So arrow functions are used to create function expressions. Basically, anytime we have this, right? Function, let's do const add equals function x and y, return x plus y. This is a function expression. It can't exist on its own. It's a value. We can save it in a variable. We can pass it as an argument. We can return it. But we can't just declare this function on its own. We have to use a function statement and give it a name, like add, like that. Anyway, arrow functions are exactly the same. We can't write an arrow function just on its own like this here. If I had x and y and I wrote this same syntax, we get an error. JavaScript's not happy with me, or in this case, VS Code's not happy with me. But I can save it in a variable. So I'll do that here, const add equals, and then instead of writing function, I just need my parentheses and then my parameters, x and y, and then my arrow, and then curly braces, and then return x plus y if that's what I want. So now to execute add, it's exactly the same. I call it just like any other function, because it is just like any other function. We just created it with a nicer, I don't even know if I'd say nicer, but a more compact syntax. So these do the exact same thing. So let's try a few more examples. Let's write an arrow function. We'll call this one, how about just square, right? Nothing crazy. Const square equals, you don't have to use const, but it's pretty much standard. We don't plan on reassigning or updating the value of square or add. They're just functions. We declare them once and that's it. So we'll accept a number, x or num or something, and we'll return x times x or x star star 2. We'll run this. What's the square of 9? 81. All right, so there's another example of an arrow function. Now, if we have an arrow function with no arguments, so we haven't seen that yet, but let's just do something silly like, well, actually, it doesn't even need to be silly. How about roll die? Roll die. I want it to be an arrow function, but there's no arguments that need to be passed in. You might think we could do this, but we can't. We have to have the empty parentheses. And then in here, I can do a return math.floor, math.random. As we've seen many times before, shift that up by 1. Let's call roll die. And we get 1 and 2. And yeah, there we go. It's working. So you have to have those empty parens if there is no arguments or no parameters that you want to declare. You still need them. And then on the other side of things, if we only have one parameter, like this example here of x, those parentheses are actually optional. So I could have written it this way. But that only works when there's a single argument you're expecting to be passed in, like square. It will not work if we have 0, as we've talked about, or if we have more than 1. So this gives me a syntax error if I get rid of the parens here. It does not like that, and I'll have a bad time if I refresh the page. But when there's just a single parameter like x, which I don't even really like x, let's go with num, it's a better name. When there's just a single one there, parentheses are optional, and it's really a style thing. You want to be consistent, of course, and you want to be consistent across your code base, but across your company as well. And often those rules will be decided, or those conventions will be decided for you when you're working somewhere, and you won't have a choice. Your engineering team or somebody will decide, we definitely don't want those parens there, or you have to have those parens there. But from JavaScript's perspective, it does not matter at all, as long as there's only one parameter. 2 or more, you've got to have them. 0, you've got to have them. So that's the basics of arrow functions, a syntactically compact alternative to a regular old function expression. In the last video, we saw that arrow functions are a more compact alternative to your typical function expression. So arrow functions are already compact compared to a typical function expression. But there's actually a way to make them even more compact, to shrink them down more, at least in certain situations. We can take advantage of implicit returns. So this is something we can only do with arrow functions. It does not work with a typical function expression. Basically, we can leave off the return keyword in certain situations. So if we have this arrow function roll die, all that it does is it returns this single value. There's nothing else that happens in here. It's just a one-liner. What I can actually do is eliminate that return statement. So I'm just going to comment that one out so we have it as a record. Eliminate the return keyword, but that's not good enough. If I just leave it at that, and we take a look at roll die, and I execute it, I mean, there's no error. We're just not returning anything. It's the same as if I had just done, 1 plus 1. It just vanishes into thin air. But if I replace these curly braces with parentheses, this is the new syntax with arrow functions to make an implicit return. This tells JavaScript, I'm just returning this one thing. I don't need to write the return keyword, just automatically, implicitly return it for me. So let's try that now. Refresh, and now it's working. We actually get that value returned, even though I never said return it. So implicit returns are useful, just to shorten code up. But what's extra useful, well, I shouldn't say extra useful, but what's nice is that with a short one-liner, let's say we had a function called, add, and it's an arrow function with a and b, and it returns a plus b. Like that. I can use an implicit return with my parentheses, and that's better. Whoops, there we go. But I actually can get rid of these parentheses entirely and do it on one line. So this is equivalence right there. This is making a function called add, or that's the variable it's stored in. It has 2 parameters and it returns the sum of them. So I can do it on one line. Now, you can technically do this for any of these implicit returns. I could do this on one line, but you have to make a determination, is this worth it to put on a single line? I think it's on the borderline. It's starting to get a little bit long, and personally, I would probably do it like this. But then for shorter ones, absolutely, put it on one line. Or here's another example. I have this isEven function. Here it is as a regular function expression, no arrow involved whatsoever. Now here's an arrow function expression. Now here's the arrow function with no parens, they're optional, around the parameter. And then here's the one with an implicit return. We use those parentheses instead of curly braces. We can get rid of the return keyword. And then here's the final version, one-liner with an implicit return. So nice improvements. You don't have to use them, but I just wanted to introduce them. You'll see them, especially as we make more progress here and start writing a lot more complicated JavaScript code. These can really shorten things up significantly. Now, one thing about implicit returns, they only work if there is one and only one statement, one expression rather, in the body of your function. JavaScript is just going to take whatever that one thing evaluates to. This one, in this case, it's a single line. What does it evaluate to? And it returns that. But if we had something else in here, like just a variable, let's just do something silly. Let's message equal that. All of a sudden, we get an error. It tells me it expected an end to my parentheses because these are supposed to go around just a single expression. But I have two. I have two things going on. It doesn't know what to return. It's very confused, and it's not going to work. So implicit returns only work in a situation where there is one value, very clearly just a single expression to be evaluated and returned. And that works a lot of the time, but we also frequently create functions that definitely are not that simple, right? They take up multiple lines. There's multiple things going on. We need variables. So for one-liners, for short functions, arrow functions with an implicit return is a great feature, but it's definitely not something you need to use or that you even can use for every single function. All right, so that's implicit returns with arrow functions. So now that we've learned a bit about arrow functions, let's revisit things like map and for each and see how we could use arrow functions there to shorten things up even more. So here's our movies array once again with our 4 movie objects. And let's say I want to map over them. We'll use a typical function expression first. And for each movie here, what should we return in our new, in the new array we're creating with map? Let's do basically the same thing that we did earlier. Maybe instead of doing out of 100, let's divide by 10. So we'll get 9.5 or 9.0, that sort of thing. So we'll return our template literal string here, backticks, and then the movie title. So right there, movie.title, and then the score, which is movie.score. Let's try dividing by 10. So let's see what that looks like. Save that to a variable const, what should we call this? Just, I don't know, new movies. And that's what it looks like right there. Amadeus 9.9, Stand By Me 8.5. Okay. Alrighty. So if I wanted to rewrite this using an arrow function, it's pretty simple. I can really shrink it down. So I can do const, I'll just comment it out. New movies is kind of a terrible name. Movies.map. And then my arrow function. And what is my parameter here? Well, I'll just call it movie still. Movie like that. And then in here, I can just copy this string if I wanted to. So that's a little bit of an improvement. Also remember, I can get rid of those parentheses. And also remember, I can get rid of the curly braces, replace them with parens, and get rid of the return keyword. Like that. Now we have our implicit return. We can just verify it still works. Take a look at new movies. Okay, it's still good. And I could even do this on one line if I wanted to. Just like that. Now, I personally think it's too long to do that when we're doing this long string template literal, so I wouldn't, but it is totally valid and it still works. So I would probably keep it at this right there. Still, definitely shorter than what we had before. You don't have to write the function keyword. You don't need return. It's just a little bit cleaner. So this is where arrow functions pop up a lot. It's when we're passing a function into another function or a method. So we're passing in this function here to map or to for each or to some of the other methods we're about to see. It just really cleans things up. All right, that is pretty much it. That's a wrap on arrow functions.
So next up, we're going to take a look at 2 functions that expect you to pass a callback function in, but they are not array methods. They have nothing to do with arrays. They have to do with delaying or waiting, pausing execution, and postponing execution for a later date, or basically scheduling something. So the first one we'll look at is called set timeout. And before I show you that, I just want to explain how this would work in some other programming languages. Imagine you have something like you're printing some string, okay, hello, and then you want to wait 3 seconds before you print hello again, or maybe you'll print something like, are you still there? Okay, so this is not JavaScript. This would be closer to something like Python or Ruby. Print, are you still there? And if I want to wait in between, in some languages, it's as simple as sleep for 3,000 milliseconds, or pause for 3,000 milliseconds. I mean, it depends on the specifics of the language, but there are specific functions that you can call that just stop execution. Nothing happens until this finishes. Well, in JavaScript, we don't quite have the same interface. We can print, are you still there, after 3 seconds, but it's a little bit clunkier, and we'll go into why and sort of the mechanics of this when we talk about asynchronous JavaScript. We have a whole designated section on it later in the course. For now, I'm just showing it as an example of callbacks. So the first function, as I mentioned, is called set timeout, and it expects you to pass 2 things in. First, a callback. Second, a number of milliseconds to delay the execution of the function. So here's how it works, set timeout. And you can see VS Code is explaining the 2 expected arguments, a timer handler, a function basically, and then a timeout number, how long something should take or how long the delay should be. So I'm going to pass in a simple function. I'll do an arrow function to keep it simple. Console.log hello. Okay. And then the second argument, so this is the first argument. The second one is going to be a number of milliseconds. I'll do 3,000. So 3 seconds. If I refresh my page now, where I've included this script, we wait 3 seconds, and we get hello. So that's kind of all there is to set timeout. It's just going to run one time. After this number of milliseconds, it will execute this function. So we have to pass in a callback. Otherwise, if we just passed in console.log, for example, that's just going to execute right away. That's going to break things. The whole point is that JavaScript is going to wait. The browser will wait to call whatever this function is until the appropriate time. So if I wanted to do something like, print hello first, and then after 3 seconds, do something like, are you still there? So I'll do hello, and then 3 seconds later, are you still there? And just to show you this, if I put something else after it, console.log, goodbye, this is going to run immediately. So this will run, this runs, or the set timeout is called, but it doesn't call this function until 3 seconds later. So it just keeps going, and it prints goodbye, and then 3 seconds later, this function will run. So let's refresh the page. You can see, hello, goodbye, both there immediately, and then 3 seconds later, are you still there? Okay, so that's set timeout. Another option, or another function, pretty similar, is called set interval. And set interval will call a function that we pass in. It will call a callback every X number of milliseconds. So we can repeat something at an interval. I'll show you an example. Let's do something like, if we console.log just math.random. Because if we console.log the same thing every time, Chrome just sort of collapses it, so you don't actually see it as a separate line. But if I do math.random, it'll just be a random decimal. And if I call set interval, and then pass in a function, arrow function or not, doesn't matter, and then I specify an interval. Let's do every 2 seconds. So 2,000 milliseconds. Exact same signature as set timeout. Pass in our function, and then comma, second argument, number of milliseconds. What you'll see after 2 seconds is that it continues over and over and over to call that function. So this is not as commonly used, but there are definitely situations when you want to do something at an interval. Now, one thing that's important to know is how to stop it. So I actually said we were going to see 2 functions. We're actually going to see 3. But the function I'm going to show you right now is very straightforward. It's called clear interval. And all that we need to do is actually save the return value of set interval. Every time we call it, it gives us an ID. It returns the ID corresponding to whatever interval we set up. So there, we could have like 5 or 6, 7, a whole bunch of these different set interval function calls running at different intervals. And we can specify which one we want to stop by using this ID. So if I save that ID, just call it const ID. I'm going to refresh the page. If we look at ID, it's just set to 1 for this particular interval. But if I call set interval again, I'll get a different ID. So now what I can do is call clear interval and then pass in that ID. And it should stop, and it does. So not as commonly used, but it's definitely worth knowing. And if you're going to know set interval, you should definitely know clear interval, so you don't have something just going forever while the page is open. Now, if you close the page, it's not like the browser just keeps printing that until the end of time, but as long as the window's open, you're going to be printing a lot. Okay, so that's it. Set timeout is something we will learn more about. It will play a pretty pivotal role in our async JavaScript section. But for now, it just serves as another illustration of passing functions to other functions. So we pass that function in. It's not called right away. It's called after X number of milliseconds. Same thing here. Pass a function in and pass in an interval. The only difference is that set interval will repeatedly call my function at that interval. And then it returns an ID that we can use to clear it. So I'll just put that down here, clear interval, and then we'll pass that ID in. But if I ran this right away, we won't see our console.logs occur. So I'll leave it commented out. Okay, that is pretty much it for set timeout and set interval. All right, so the next of these callback methods, array methods, we'll see is called filter. So filter is used when we have some array of elements where we want to filter out or make a subset in a new array. Now, that sounds like we're actually changing the original array. We're not altering it in any way. But let's say I have this array of numbers, all even and odd numbers, and I want to pull out just the even numbers or just the odd numbers into their own array. To do this, we pass in a callback. And this callback needs to return true or false. It needs to be a Boolean function. And if that callback returns true for any element, that element will be added to this filtered array that we get at the end. Otherwise, it's ignored. So I'll show you a simple demonstration. Here is our array, numbers. I can call numbers.filter. And then I'll use an arrow function, so for each number n. And I'll do it the long way first. Let's return if n is exactly equal to 4. So this is silly, but if I did this, all that I'm doing is saying run every element through this function. And let's say we start with 1. Well, n is 1 triple equals 4. No, that's false. So it returns false. Nothing happens. The only time anything happens is when we get to 4. Because 4 is equal to 4. And that element will be added to the new filtered array. So if I just run this over here, I'll just paste it in. We get an array with 4. So simple. Now, I could do something a little bit more complicated. What if I do return n less than 10? So all of these numbers are going to pass that test, right? They're all less than 10. They will make it into the new filtered array. And there we go, 1 to 9. Now, if we look at numbers, completely unchanged. I'm just making a new array using filter. So this is really useful when we're doing things like trying to filter the highest rated things or filter old items or new items. So I've updated this movies array so that each movie now has a year, in addition to a score and a title. And I've added in some movies that aren't as critically acclaimed. Sharknado, 13 going on 30, Waterworld, Jingle All the Way, what a classic, terrible Christmas movie. Notting Hill, nice, comforting, romantic comedy. None of them are amazing. But then we have things like Parasite and Stand By Me and Amadeus in here. So let's say that I wanted to get an array with just the higher rated movies. Well, I could do this, filter on movies. Can't forget that part. And then for each movie, I could do return movie dot, and then I want the score greater than what? Let's say any movie greater than 80. And I'll save that to a variable, const good movies. Just like that. And let's take a look at good movies. And we have 4 elements: Amadeus, Stand By Me, Parasite, and Alien. Now I could even shrink this down. I could compact it using an implicit return. I could do movies.filter. I'll do m here. I'll do a one-liner, m.score greater than 80. Just like that. Thank you, arrow function. Look at how nice and cute and compact that is. And we should get the same result, and we do. Now I could also do something like bad movies, right? Let's make bad movies where I'm looking for the score less than, 70? I can't remember the scores I gave them. Let's take a look. Bad movies. Sure, that has Sharknado and Waterworld. Alrighty. I can also do things like recent movies. Const recent movies equals movies.filter m, where m.year is greater than, let's say 1990? It's not that recent, but let's see. Recent movies. Okay, so maybe I should have done 2000. There we go. We have Sharknado, 13 going on 30, and Parasite. Alright, so hopefully you can see how filter is useful. We pass in a function that needs to return true or false. If it ever returns true for a given element, that element is added into the new filtered array that is created. The term filter makes it sound like we are filtering something out of the original, like we are impacting the movies array, but we're never changing it. We're just forming a new array that includes those elements, but movies is unchanged. Now the last thing I'll mention, this is a good situation where I can demonstrate that we often actually combine things like map and filter. So let's say I want to get the good movies, but I want just an array of their titles. So right now, what I'm getting is an array of objects. I just want the titles in an array. So I can filter good movies equals movies.filter, and then I could do const good titles equals good movies dot map for each movie. Whoops, there you are. I just want movie.title. And that should work if I look at good titles. There we go, we get our array of titles. But I could also do this without this intermediate step of making a variable for the result of filtering and then another variable for the result of mapping. I could do it in one go like this. Movies.filter, movie where m.score is greater than 80, and then .map immediately afterwards where m, I want the title. Gosh, that's annoying. Get out of my way, come on. Okay, there we are. So this will do it for me in a single line. I'll just run this here and you can see we get the exact same thing. Amadeus, Stand By Me, Parasite, Alien. So we can chain them together. And if they get really long, you might see people do something like this, where they indent it. This is totally fine too. These are nice and short. It actually fits on a single line just fine. But sometimes we have longer bodies for the actual callback function. They're not one-liners. There's not an implicit return. We can still chain them together. So I just wanted to show that here. We often use them together. So I'm filtering to get the objects out that have a good score. And then I just want the title in a new array. And so I'm using map. So that's filter.
The next two that we'll look at are kind of a pair, every and sum. I usually would say sum and every. I don't know why I put every first. Both of them are very similar. They are Boolean methods, meaning they return true or false. So unlike map or filter, which return a new array, these two always return true or false, and they are ways to test if every element in an array passes some test. That's what every does. We pass in a function, and if every element, when passed into that function, returns true, then the entire every function call returns true. So, for example, here I've got a bunch of exam scores, and let's see if I want to know if everybody passed, and let's say our passing score is 75. So I could do this, exams.every, and then I pass in a function, and every element in here, well, that's confusing, each element in here will be passed into that callback. And this callback is supposed to return true or false itself. So I could do something like score greater than or equal to 75. Okay? So each one, like 80, will be passed in. And that should return, in this case, true. That's true. 80 is greater than or equal to 75. All of these should return true. And because of that, every will return true. So let's try it out. We get true. But now, as soon as I change one of these scores to go below, let's say this is 70, and I run this again, now we get false. So as soon as one of them returns false from this callback, the entire every is false. Now we also have sum, which is very similar the way that it works, except that it's going to test if any of the elements or if some of the elements pass the test. So it doesn't care like every does, where every single thing has to return true from that callback. With sum, it's only one or more. So if I used sum here, instead, we're just seeing, is there any score, is there at least one score that is greater than 75? And of course there is. Whoops, I didn't copy that, and I'm not printing it. So we get true. So instead of doing that, why don't we go with our movies example down here? And why don't we see if there are, if there's any movie created after the year 2015. So movies dot sum, and then our callback. So for a movie, we want to see if movie dot year is greater than, what did we say, 2015 or something? Let's see. Is there at least one? Yes, there is. So it doesn't tell us which one, right? We could use filter if we wanted to make a new array only containing those movies. All that we're saying is take this callback and tell me if it returns true at least once when you pass in each element from the array. And it does, because one of them, at least, Parasite, is 2019. And if I had changed that instead to be 2010, all of a sudden, this whole thing returns false. There's not one element where this callback is true or where it returns true. So sum and every go with one another, hopefully relatively straightforward. They both are Booleans, they return true or false. And the function you need to write, the callback that you pass in, should return true or false as well.
Next up, we have reduce, which is definitely the most intimidating. It's the one I've seen students struggle with the most. It is useful, but it takes a little bit of time to get used to. So don't feel bad if you need to rewatch this video or continue reading about reduce or looking at the examples. It's just not as simple as something like map or filter, but it is useful. So what it does, really its main goal, is to take some array and reduce it down to a single value at the end of the day. Now, how it does that is up to us. So it's not like it's automatically going to sum every element in an array together. It can do a lot more than that, but we have to understand how it works. So I like to visualize it as a nice science experiment. We've got a lot of liquids, we're combining them all, and then we get one drop out at the very end. It's kind of what we're doing here, but with an array. So I'm going to show you an example first and walk through what it does. Basically, we have to provide a reducer function, which is really just a function that follows a particular format where there are two parameters. You don't have to name them this, obviously. You can name them whatever you want. But the first parameter represents what we call the accumulator or the total. It's basically going to be the thing that we're reducing down to. So in this case, I'm summing all elements together. This accumulator variable, or this parameter, will hold the sum. And then I have current value or each number, whatever we want to call it. This represents each individual element. And then from my function, this reducer function I wrote, I return some value, in this case, the accumulator plus the current value. And whatever I return from here will be used for the next iteration's accumulator. So at the very beginning, our first call, the accumulator, starts at 3. Our current value starts at 5. And then I return 3 plus 5, which is 8. So I returned 8. Now, next time through, my accumulator is going to be equal to 8. So that's just how it works. Whatever I return from here will be used on the next iteration, the next go-around, when my function is called. So if 8 is accumulator, current value then moves to 7, and I return the sum of those two, which is 15. And then the process repeats. The first parameter, accumulator, will hold 15. And then the current value will be 9. I sum them together. That's 24. And so on until eventually the final return value is 35. So let me show you this in practice. Let's say I have an array of prices. Okay, so we'll have $9.99, $1.50, $19.99, and $49.99. It's a lot of 99s, huh? Let's do 30.5. Okay, so that's my array of prices, const prices. And let's say I purchased all of them. And if I wanted to figure out the total for what I owe, without reduce, I could do something like this, right? For let price of prices, I could have a total variable up top. Let total, I'll start it at 0 for each price in there. total plus equals price. And that should do it for me. I could console.log total. And let's see what we get. 111.97. Okay. Now if I use reduce, it's really the same idea. I'm just going about it in a different way. Prices.reduce. Remember, I pass in a callback, and this callback needs to have two parameters. The first one is often referred to as the accumulator, but in my case, it represents the total. So I'm just going to call it total. And then the second one represents each individual element in the array. What are they? I'll just call it probably a price or element or number or something like that. And then I'm going to return that total plus the price of each element. So that will start at $9.99. I add $150. That's the new total. Next time through, we have that sum, whatever that is. We add $19.99, and we keep going until eventually, I could do something like this. Const total equals that. And let's see what we get. What is total? It's $111.97. Same exact answer, just a different format. And I could shrink this down more, right? I could use an implicit return. I comment that out, get rid of you, get rid of the return here, and just do that. It's okay. It might be a little bit, I think it's okay to do in a single line, but either one works. They're doing exactly the same thing. So in this case, we've been summing together every element. If I wanted to, I could multiply every element together to get a product. It's a lot larger. I can do really any sort of mathematical operation. I could do all sorts of weird things. But that's not all we're limited to. We're not limited to multiplying or adding or dividing or anything like that. We can write things that will find the maximum value in an array or the minimum value in an array. So here's how that would work. Let's say I want to find the minimum price in this array. We know what it is. It's very easy to see, but imagine there's 1,000 elements in here. So one option is to use reduce and do something like this, prices.reduce. Now, we're not really accumulating any value that's going to be totaled or summed or multiplied or anything like that, but what we are accumulating is the minimum value as we go through the array. So our accumulator, the first parameter, we're not going to, well, we could call it total, but it doesn't really make sense. It's just going to hold the value that is currently the smallest as we make our way through. So we'll call it min. And then the second value, the second parameter, is the individual element, the current element, so I'll just call it cur price or price. And remember how reduce works. If I return a value, or whatever I return from this callback, will be used as the next version of the accumulator, or the next min here. So basically, what I want to do is return either the current minimum value, or the new price that we're accessing. So if we start at $9.99, that will be the min. We look at $150, well that's smaller, so we will return $150. And that will become the next min. And it will stay the next min until we find something smaller, but we actually don't. So that could look like this. If price is less than min, we can return that new price, and that will be what we return here. That's the next min next time through. Otherwise, we can just return min. So let's take a look at what that gives us. Const min price. And, oh, I don't have it over here. Min price, 1.5, and that's accurate. I could do it the other way around if I wanted the max. I'm still calling it min, but here I'm just seeing if the current price, the element that we're looking at, one element at a time, if it's greater than what we saved or what we returned last time, then return that new element. So here we get the maximum, which is $49.99. Is that correct? Yes, it is. Okay, so let's do one more example with the movies from the last few videos. Okay, so here's that movies array, and let's say that I want to find the highest rated movie, just as an example here. This time we're working with objects, so it's still not very complicated compared to what we just saw, but there's an extra layer we need to pay attention to. So we have our movies. If I want the highest rated movie, movies.reduce, and then here we'll go with, highest rated or something, or best movie. Let's do that, best movie, and then cur movie, like that. And what we want to do is check if cur movie, it's not just cur movie greater than best movie, because we're looking at the score. So if the current movie we're looking at, dot score, is greater than the best movie, dot score. If that's the case, we will return our current movie. Otherwise, return best movie. So let's take a look at that. What is our best? Oh, I didn't save that to a variable. So let's save that to a variable. Highest rated. Okay, so highest rated is Amadeus, as it should be. That's just a great movie if you haven't seen it. It's not for everyone, but, it's funny. It's about classical music, but it's funny. It's got great, huge set pieces, amazing costumes. Oh, you just got to see it if you haven't seen it. Anyway, so that's a couple of applications for reduce. Still pretty simple stuff, but hopefully you can see it's not just about reducing things down to a single value via math. It could be via comparison like we're doing here. It could be addition or multiplication. But really, the point of reduce is to just boil things down to somehow end up with a single value. It's up to us how we get there. The last thing I'll show you is that we can specify an initial starting point for our accumulator parameter. So I've got a very simple example. Evens, it's an array of 2, 4, 6, and 8. And let's just start by summing them all together with reduce, as we've already seen. Evens dot reduce. And then we'll add our callback in here with our sum, and then each individual number, and we will return, I'll just use the implicit return, sum plus number, or num. Okay, so if I just run that right now, we get 20. But I can also pass in a second argument to reduce. So not a parameter that we're adding to the reducer function. This whole thing is a function we wrote. I'm talking about a separate second argument for reduce. So that's the first argument, a second argument, and that argument will be used as the initial value for sum. So right now we're starting just by adding these all together, we get 20. But if I started with 100 and then we add everything to that, well, I guess I'm not printing it out. I'll just copy it over here. We get 120. Or if I started with, 40, we get 60. So just know that there's a second argument we can specify, and it will be the initial value for this reducer function. Okay, so that is a quick crash course in reduce. There's definitely a lot more you can do with reduce. It's pretty powerful, but it can be overwhelming when you're starting out. So get comfortable with the basics and this basic pattern, the signature of these reducer functions, before you start to worry about all those other things you can do with it. All right, so that's reduce.
All right, so next up, we're going to quickly return to arrow functions. I'd like to tell you one very important aspect of working with arrow functions that has to do with everyone's favorite keyword, the keyword this. I know that's sort of tongue-in-cheek. A lot of people don't like the keyword this, but this is an important topic here. Arrow functions behave very differently in terms of the value for the keyword this inside of an arrow function versus a non-arrow function or just a traditional function. So let me show you an example. I've got a very simple object. Person has two properties, first name Vigo, last name Mortensen. If I add a method on here, we'll call it full name, and we'll start with a regular old function, and I'm just going to print Vigo Mortensen, first name, last name with a space in between. So I'll do a string template literal, this dot first name, space, this dot last name, right? Okay, if I execute this, it's very confusing when I say the keyword this, but if I execute person dot full name, oh, I didn't return anything. Serves me right. Okay, try that again. Now if I execute it, there we go. It works, right? The keyword this refers to whatever, in this case, comes to the left of the function. So that means the object person, right? This dot first name, this dot last name gives us Vigo and Mortensen. But if I replace this with an arrow function, exact same logic, and I refresh the page, and I call person.fullname, undefined, undefined. Okay? So what happened here is that inside of an arrow function, the keyword this is just going to refer to the scope that it was created in. So in this case, that means the keyword this refers to the window object. Console.log this. Try it again. We can see it's the window object. So when it tries to do window.firstname, right, it doesn't find it and it gets undefined. Versus when we use a traditional function, a non-arrow function, the keyword this has nothing to do with the scope where the function is created. It has to do with how the function is executed. That is not how arrow functions work. Now this is by design. Because there are times where it can be a little bit annoying having to worry about the execution context and how that impacts the keyword this. I'll show you an example. If I wanted to delay, I don't know, how about after 3 seconds, I wanted to call full name. So down here, I could add a separate method. We'll call this shout name. Shout name is going to be a function. And then I wanted to call set timeout. And inside of here, we'll do something in our function here where we wait 3 seconds before we console.log this.fullname. Okay, so the idea is if I call shout name, we're going to set a timeout for 3 seconds. And then when those 3 seconds are over, we're going to call this.fullname, which is right there, and then print out the result. So what happens? Well, let's try. Got to refresh the page. I want person.shoutName. We wait 3 seconds. And, oh, this.fullName is not a function. So what happened? What was the keyword this? Well, again, it has to do with the execution context. And setTimeout is a method on the window. So it's implicit. We don't actually see that window there, right? But window.setTimeout So the keyword this in our set timeout callback, if I print it out, it refers to the window object. So I'll try that again. We wait 3 seconds, and you can see it is indeed the window. So this is kind of annoying, this nebulous, weird value that changes even within, just the same function. Well, it's not the same function, it's nested, but it may not seem like, the execution context changed, but it did. But if we instead use an arrow function here, this is definitely one situation that's common enough where arrow functions just make sense. And again, I mentioned arrow functions were designed to behave this way because this is obnoxious. So if I use an arrow function in here instead, in my set timeout, remember, their keyword this, inside of any arrow function, it's just the same value of the keyword this in the scope of where the function was created. So that means the keyword this is exactly the same as the keyword this in this function. So now if we try it, refresh our page, shout name, we wait 3 seconds, and there we go. You can see the keyword this refers to the person object. And we are successfully calling full name, but recall that I set this using an arrow function, which means that the keyword this is not set to the individual object, which is not what we want. So I'm going to set that back to a regular function expression. We're kind of mixing and matching here, which is common. So to summarize or to conclude here, the keyword this behaves differently in arrow functions, and sometimes we can use that to our advantage like we did here, but other times that's a problem. For example, you wouldn't use an arrow function to define a method, or at least not commonly. As I showed you here, if this was an arrow function, this.firstName is just undefined. The keyword this does not refer to the object. But in other situations, like we had here, where dealing with the keyword this and its constant changes is obnoxious, then we can use an arrow function and we don't have to worry about getting a new value for this. If this confuses you right now, don't freak out about it. This is definitely one of the more confusing aspects of JavaScript. All that you should really take away is that the keyword this behaves differently in an arrow function compared to a regular function. That's the only thing you need to remember. Even if you don't remember exactly how it differs, just know that it does differ. Okay, goodbye. I hope you're still with me. I hope you're still alive. Take some nice deep breaths, get some relaxing tea, put your feet up, some nice cozy socks, and try and erase this from your memory.